In this tutorial series, we're going to look at the Linux command line, which some people refer to as CLI, for Command Line Interface. I know some people get intimidated by the command line, but in this tutorial series, we're going to turn that feeling of intimidation into a feeling of excitement when you open up a terminal, knowing all the things that you'll be able to do in the command line. To explain what's going on, I'm going to use this picture that I created for my XP to Linux tutorial series. Only in this picture, I did correct the typo in the word kernel. We have a girl here in the lower right corner using her Linux Graphical User Interface desktop, which is also known as a GUI desktop. When she clicks on something, it sends a command to the operating system, which sends it to the kernel, which translates that into computer code and comes back to the kernel. And then we see the results on the nice GUI Graphical User Interface desktop. When we're using the Linux command line, we're starting right here, and we're skipping over this Graphical User Desktop screen and sending the command right to the operating system. I'm using Linux Mint Mate, and we can open up a terminal by clicking on the icon down here on the bottom of the screen on the panel, or in the menu, we've got the terminal right here on the main menu, or we can go into the System Tools and find the terminal right there. Clicking that opens up a terminal. The creators of Linux Mint have made it easy to get to a terminal because they know how useful it can be. The command line is one of those things that once you learn it, you'll wonder how you ever got along without it. We have our terminal open and we see that it is prompting us or asking us what command do we want to type in. Going back to this picture for a moment, I said using the command line is skipping over the GUI screen, but we were in the GUI and opened up a terminal to skip the GUI screen. I know that sounds a little funny in this case, but that's not always the case, and often servers don't have any GUI installed, and the terminal is all that's available. So why would anyone want to type in commands when they can just point and click a mouse button? Well, Linux has a lot of different operating systems and a lot of different desktops on those operating systems. And although they're all meant to be easy to learn and use, they're all different. Most of the commands in the command line are the same, whether you're using Red Hat, Ubuntu, or Arch Linux. And it goes farther than that because Linux is based on Unix. And most of the Linux commands will work the same on any Unix-based operating system. Two Unix-based operating systems that come to mind are the Android operating system and Mac's Darwin operating system. Both of these operating systems are based on the Unix operating system, so most of these Linux commands will work on an Android or Mac operating system just as they do for Linux. They might have a few slight differences, but for the most part, the same commands will function the same on any Unix-based computer operating system. So why else might we want to use the Linux command line? It's an easy way to automate tasks, and you can schedule tasks to run at specific dates and times using cron. And we will look at how to use cron at some point in this tutorial series. Another reason you might want to use the Linux command line, fun. It can be fun, and hopefully I'll bring that out in this video tutorial series. And the last reason I'll give to use the command line interface over the GUI screens is control. In short, we're giving up that ease of use of point and click for more control. Now, there's nothing wrong with using the GUI screens, and there are times when you will want to use them. For something like editing a video, I would prefer using the graphical user interface over the command line. At the same time, there are some things that are better suited for the command line, and we'll look at them in this series. Now, we have our command line open, and to make things easier to see, I want to make this terminal window bigger. To do that, I'm going to hold Control, Shift, and press the plus sign. And actually, it's just Control plus sign, but my plus sign is above the equals, so I need to press Shift as well. And Control minus makes it smaller. We're going to type in our first command, hello world, And we'll do that by typing echo, double quote, hello world, double quote, and press enter. Now, we didn't need the double quotes. We could have used single quotes, or we could have left the quotes off. I'm pressing the arrow up, which shows me the previous command I submitted. And I'm pressing the backspace to get rid of that double quote, and pressing the backspace again to get rid of the other double quote, and pressing enter. And we've just submitted our second Linux command line command in our terminal. We will get to some more commands soon, but because we're going to spend so much time in our terminal, in the next tutorial, we're going to look at how to configure our terminal. I'm opening up a terminal and pressing Control-Shift+ as we did in the previous tutorial to make our terminal window a little larger. We're going to spend a lot of time in this terminal, so I want to customize my terminal to a way I like. I'm using Linux Mint Mate, and to see what terminal I'm using, I'm going over to Help and clicking About. And this shows us we're using the Linux Mate terminal. It's not the only choice. There are many more terminals in the Software Center, and there's no one best terminal for everyone. There may be a best terminal for you, and that would be the terminal that you like best. I'm going to use this terminal because this is the one that came with the distro that I'm using. If you're using a different terminal, you should still have terminal profiles you can customize, just like I have here, but how you customize those will probably be different. I just mentioned the word profile, and a profile is basically your terminal customization. And you may want to have multiple profiles with different settings for different situations. We can see what profiles are available by clicking Edit, Profiles. Here we see that we have a single default profile. I'm going to create a new one by clicking the New button. I will call this profile Light. It's based on the default profile, which means that it's just going to copy over all the settings from the default setting, and I can change the ones that I like. Clicking on Create. This shows me that I'm editing the profile Light, the one I just created. I'm going over to Colors, and I'm going to uncheck this checkbox. We'll talk about this in a moment. And I'm just selecting Solarized Light. And close. We don't see any changes because we're still using the default profile. I want to create another new profile, and I'm going to call this My Profile. And instead of basing this on the default, I'm going to base it on the Light profile. Clicking Create takes me into the My Profile to make any changes I like. I'm going to leave it just as it is and click Close. The other thing I'm going to change at the screen is the profile to use when launching a new terminal. I want that to be the My Profile. I'll close the Profiles window, and I'm going to close our terminal as well. Opening a new terminal, we now see that the terminal shows the solarized background. To switch the profile I'm currently using, I'm going to click on Terminal, Change Profile, and I can go back to that default profile. Clicking Terminal again, Change Profile. We can select the profile or click the Next and Previous. I'm going to select the My Profile from the radio button. The other thing we notice is that our terminal window size is smaller than when we had it a moment ago. I made it larger by pressing Control-Shift+, but after we closed the terminal, it went back to the original size. To make that screen a larger size, every time I open a terminal window, we'll want to change the profile settings. And we can do that in Edit, Profile Preferences. Clicking that opens up the profile preferences, and we see that we're editing the My Profile profile. We can change the name here under the profile name. And to resize the window as we did earlier with the Control-Shift+, I'll want to resize the font. I can do that by unchecking the Use System Fixed Width Font And then to change the font size, I'm going to click on this font, which opens another pop-up window where I can choose a different font if I like, but I'm going to keep it the same. I just want to change the size. You can click the plus and minus. They've got some dashes down here. We can move the dot along the scroll bar. I'll go with 24. That looks good. And click select. We see the change takes place right away. There are some other things we can do here, like allowing the bold text, copying selected text into the clipboard, cursor blink, cursor shape. Those are all pretty obvious. You'll have to check this box to change the default size of the columns and the rows. I'm going to leave them at the default for the moment. Other things we might want to do is change the background. If we click on background, it really doesn't change the background. It gives us the choice of going to the solid color, background image, we can put in an image, or make the background transparent. And that's done on this slider bar here, the amount of transparency you like. I usually leave this at the solid color. And then to change the color of the background, I'll click on the color bar. Now this is the checkbox that I unchecked a moment ago that I said I'd come back to. Use colors from the system theme. And depending on which theme your system is using, I'm using Linux Mint Mate. So when I check this box, it's defaulting to the Linux Mint Mate theme colors. And those are the default colors for that. Unchecking that, I can now change these colors to the built-in schemas. And I'm going to change this to green text on a black background. And that green looks a little bright for me, so I'm going to change it and click this lesser bright green. But if you don't like that, you can click on this plus sign and change it to whichever color you like by moving the slider and moving where these lines cross. Makes it either darker or lighter in that shade. And if you know the hex value, you can type that in as well. I'm going to cancel out of here and go back to the lesser bright green and select. And we see it takes place right away. The bold color is going to be the same as the text color, and our background is black. I'm going to close this window to see how this looks. To get a full feeling of what these colors look like, I'm going to type in the command ls-lah. Now we'll talk about this command in the next tutorial. For now, we just need to know that this lists out what is in our directory. Pressing enter shows us that we've got all green text, but there's blue in there as well. So I'm going back over to Edit, Profile Preferences, and the colors. And since we said the text color should be green, where are we getting this blue from? Well, that's down here in the color palette. We've got a custom schema here. We can change this to Tango, Solarized, and we see it changes it right away. I am going to go with the Xterm, and to change this blue color, I'm going to find the blue in this color palette that closely matches it. I believe it's this one right here. Let's change it to red. And when I click select, it changes all my blue text to red. I'm going to change this back. And the point of this is if you don't like one of the default colors, you can change it. And the built-in schemas are here to help you get started. Just like the schemas above, you can select one and make changes or tweaks to it, or have all custom colors. It's all up to you. So that's the basics of customizing your terminals that I wanted to go over. There's more there that you can play with and change, but that's the basics. We can change these terminals by going Terminal, Change Profile to the default. We see that drastic change there with the size and the color. Then Terminal, Change Profile. We'll go back to the My Profile, which is the profile I set it to when I open up a new terminal. In the next video, we'll start looking at the Linux command line commands. I am opening up the File Manager and moving it to the far right side of the screen which makes the window take up the right half of the screen. And now I'm opening up a terminal. I'm going to make this a little smaller with Control minus and move this to the left side of the screen, making it take up the left half of the screen. Having both of these windows open at the same time will help show that we are in the same place in the terminal as we are in the file manager. To show we're in the same place, I'm going to type ls in the terminal. ls is the command to list the directory contents. When we do that, we see the same 8 names we see in our file manager window, showing that we're in the same place in both windows. But when we're in the terminal, we don't call them folders, we call them directories. When we're in the file manager, in these GUI screens, it's okay to call them folders. Looking at them, they even have a picture of a folder to encourage the name folder. And that is great to give you an idea of what they are and how they work. But when we're in the command line, we call them directories. Unless I screw up and accidentally call it a folder, which will probably happen from time to time, but officially, they should be called directories when we are in a terminal. In the last video, I typed ls-lah, and that listed things a lot differently than what we see here when I typed ls by itself. Let's take a moment to talk about the Linux command line command. The Linux command line command is made up of 3 parts. We have the command, options, and arguments. When I type the ls command by itself, there are no options because they're optional, and the argument is the current directory we are in. We can change that directory, and we will in a future video, but for now, we're just going to work in the current directory. So ls by itself is listing out the contents of the current directory. ls is the command, and the current directory is the argument. The LAH that we saw in the last video are the options, and options usually start with a dash or a hyphen to note that they are options. So how did I know which options I wanted to use, or what options are available for this command? Or as we have in this case, we see the options and we just want to know what they mean. We can find them by using the man pages, and man just stands for manual. To use it, we type in man and then the command we want to know more about. So in this case, we'll type man space ls. Pressing enter brings up the man pages, and at the top of the screen here, we see name ls list directory contents. Then we see all the options listed alphabetically, and we have A for all. And to go down a screen, we can use our arrow keys or page down and page up keys. If you don't have those keys available on your keyboard, you'll want to view the help screens. And looking at the bottom of the screen, we see press H for help. So I'll press H. And we see right at the top, H displays this help screen, and Q or any of those options will exit. Below that, we see how to move around with the different options there. And paging down, we see there's a lot more help available. I'm going to press Q to quit out of this. And now we're out of the man help pages and back just in the man pages for ls. Paging down, we see down at the bottom of the screen here, H for human readable. And the other one I used was the lowercase l, is use long listing format. I'm pressing Q to quit out of our man pages. So ls-lah are actually 3 different options. Let's take a look at these options. I'm going to start with the -A option, ls-A. And when I press enter, we see it lists all the same files in our file manager window, but this time I have extra files and directories. And the new ones all start with a dot or a period. Typing dot before the directory name or a file name will make that directory a hidden file. We can view these files in our file manager by clicking on View, Show Hidden Files. The point of the hidden files is to hide the configuration files and system files that we will rarely, if ever, need to be changed or updated. Having them hidden will declutter our directories and make the files that we use regularly a lot easier to get to. I'm going to turn off the Show Hidden Files in our File Manager window and go back over to our command line. Now the L option, ls-l, shows us the long format. This gives us a little more information like the permissions, the owner, the group, which we will go over in detail in a future tutorial. We also have the size and the date that the file or directory was last modified. The size here is what we want to pay attention to, because when I type ls-l-h, I'm adding the human readable. So now when I press enter, instead of seeing the 4096, we just see 4K, which is a lot easier for us humans to read. Now, the options can be separate like that, -L space -H, or we can put them together, ls-LH, and they don't have to be in that order. I could have typed HL, and that works the same. And then we can add that all to this as well. I can type ls-LH-A, that works, or I can put them all together, ls-LAH, or AHL, the order doesn't matter, works the same either way. In the next video, we'll continue looking at command line commands. I've opened up the file manager on the right and the terminal on the left as we did in the last video. In the last video, we saw we are in the same directory in our terminal as we are in the file manager, and we did this by typing ls. To go into one of the folders in our file manager, we would double click on the folder we want to go into. I'm going into the Documents folder by double clicking on it. There's nothing in here at the moment. So to go back into the Michael directory, I'm moving my mouse over the arrow up, and when I hover over it, we see Open the Parent folder. And I'm clicking on this to go up one folder. Going over to the command line, we see the directories listed here. Remember, we call them folders in the file manager, but when we're in the command line, we call them directories. To change from the directory I'm in to the Documents directory, I will type CD for change directory, and then the directory name that I want to go into. In this case, it's the Documents directory. Pressing enter takes us into the Documents directory. Now on my screen, my command prompt, that's this part before the $sign here. Actually, it's including this $sign here, is the command prompt. My command prompt shows me that I'm in the Documents directory. Your terminal may or may not show that. For right now, I want you to know that it is possible for you to change the look of your command prompt. Now, we're going to focus on the fact that we're in the Documents directory. And in this directory, I want to type that command that we saw in the last video, ls-LAH. Pressing enter, here we see two hidden files. Actually, they're two hidden directories, the dot or period and the dot or period. We'll find these two hidden directories in every directory. The dot file is the current directory, and the dot file means the parent directory, the directory right above this directory. For example, if I type ls ... pressing enter shows us the list of content in the parent directory. And we're still in the Documents directory. To go up to the parent directory, I will type cd ... It doesn't matter what the name is. We're not giving it a name. We're just telling it to go up one directory. Pressing enter takes me back to the Michael directory. In the file manager, we know which directory we're in because it's highlighted here, showing us we're in the Michael directory. in the command line, to see which directory we are in, I will type pwd. Now this stands for Print Working Directory. Some people might refer to it as Present Working Directory, but the man page shows this as Print Working Directory. I'll press enter, and it shows us that we are in the Home Michael directory. Going back to this file manager, we don't see the home directory. It starts with the Michael directory. But if I click this left pointing triangle button, we then see the home folder and a picture of a hard drive showing us that we are at the beginning of our path. The path is what we call this list of directories we're looking at. Going back over to the terminal, we see our current working directory has a path of /home/Michael, which makes us think that home is the first directory, but that's not true. The first directory is actually just the / by itself. And I can get to that by typing cd /. So now we're in the first directory. Only we don't call it the first directory. We call it the root directory. The idea behind calling it the root directory is to think of that / directory as the root of a tree, and then all those directories and files being the branches and leaves growing out from the root directory. Now we can talk about absolute directories. An absolute directory is when we give the whole path, starting from the root directory. For example, to go into the Documents directory, I will type cd space, and I will type the full path or the absolute path of /home/Michael/ documents. Because I started my path from the root directory, meaning it started with a /, there's absolutely no question which directory I want to go to. And pressing enter takes me into that Documents directory. So now we're in the Documents directory. Now the other option is the relative path that we saw earlier, meaning we want to go to a place that is relative to where we are at the moment. If you have problems remembering the difference, the relative path means the first thing you want to do is just go up to the parent directory or down to a child directory. Parents and children are related, so we are using the relative path. When we start with a /, it means go to the root directory first, because we're going to give this the full path to where we want to go to. We are in the Documents directory. If we want to go up one folder, we would type cd ... go up one directory. If we want to go up two directories, I would put a / and another ... Go up the parent directory of the parent directory. And we can do this as many times as directories that we have. In this case, I want to go up one directory, then I want to go into the Downloads directory. I can do that by typing cd ... and then I'll start with DOWN, and I don't have to type out the whole directory name. I can press the Tab key, and it will auto-complete the directory name that I have. Now, if there aren't enough letters to make this unique, let's say I have just /DO, and I press the Tab key, nothing happens. I'll have to press the Tab key a second time. Now I see it asking me, do I mean the Documents directory or the Downloads directory? These both start with DO. And then it returns me to where I was with the cd ... /DO, so I can add enough letters to make this unique. I'm going to add the W, that would be enough to make this unique, and then press Tab. Pressing enter now takes me into the Downloads directory. If I want to jump back to the directory I was just in, which in this case was the Documents directory, I can type cd space hyphen or -sign. Pressing enter takes me back to the Documents directory. And this works pretty well as long as I don't go to another directory in between there, because it takes me to the last directory I was in. If I want to jump right to my home directory from no matter where I am on the system, I can type cd and enter. And it takes me right to the home directory. If I want to go to my downloads directory, I can type cd space tilde / down autocomplete, and that tilde takes us to our home directory first and then the downloads directory. Now this one is interesting because the tilde is representing the / home / Michael in this case. If the user was named user1, the tilde / would then go to the home user1 downloads directory. And pressing enter shows us that we're in the downloads directory. Now, if you look a little closer at this command prompt, you'll see the tilde right here. This is telling us that we are in the user's home directory / downloads. Now, the last thing I want to mention in this video is using the arrow up key. Pressing the arrow up brings back the last command. And I can go back as many as that we have on file. And arrow down takes me to the next. Now, once we have our command here, we can press enter and submit this command again, or I can back up and change this directory. Maybe this time I want to go into the videos directory. I can change the command, pressing enter, and now I'm in the videos directory. In the next video, we will continue looking at the Linux command line. I still have my file manager open on the right and my command line terminal open on the left. I want to add a new file to my home directory from the command line, and I'm going to do it using the touch command. How the touch command works is we type touch, then the new file name we want to create. So I will type touch new file1.txt, and pressing enter shows us on the right in our file browser. We see that file show up right away. And we can see it in our terminal by typing ls, and I'm going to add the -l option and then press enter. In the terminal, it shows the green text for the new file 1, and all the others are in bold blue text because they're directories, and our new file1.txt is a file. You may not have the text color settings turned on and won't be able to tell the difference between the files and directories by color. But we can tell which is a directory by looking in this first character in the long directory. The D in the first characters are for directories, and the dash is for a file. So this one line with the dash is our file name, and the rest are all directories. When creating files in Linux, the file name does have a file name length limit of 255 characters. Now that is an awful lot of characters, so that should not be a problem for us. There are a few special characters that Linux won't let you use, but other than that, you can name a file anything you like. Now, just because you can name a file anything you like does not mean that's always a good idea. So Unix came up with some guidelines for naming your Unix file names. The general guidelines for naming Unix files is only use lowercase a to z, 0 to 9, periods, underscores, and hyphens. The reason they suggest your file names be all lowercase is because Linux is case sensitive, meaning a file with the name myfilename.txt and a file with myfilename.txt with an uppercase M are actually two different files. In Windows and Mac operating systems, this doesn't matter. There can only be one file called myfilename.txt. If you try and copy over the two files, myfilename.txt and myfilename.txt with the uppercase M, to a Windows or Mac operating system, it will either overwrite one of the files or give you a warning that that file name already exists. Also, when referring to files you've created, you don't have to stop and think, did I use uppercase letters in that file name? Because you made them all lowercase. So that's the reasoning behind using all lowercase characters. Only use lowercase a to z, 0 to 9, periods, underscores, and hyphens. Mainly because other operating systems, like Windows and Apple, won't be able to read those file names, and it's a good idea to be consistent with your file names on all the computers you use. The computers you use today and the computers you may use in the future. Always use extensions like .txt, .bmp, and .jpg. Extensions like .txt and .bmp should be used with your file names to help you out. The computer doesn't care if you have extensions on your file names or not, but you and other humans looking at that computer will be able to tell the difference between commands, file names, and directory names just by looking at the file name. Directory names won't have extensions. Don't start your file name with a hyphen. It could be mistaken for a command option. And we already talked about starting your file names with a period if you want that to be a hidden file. That's it for the Unix guidelines. In reality, people use uppercase characters and spaces all the time. To include a space in your file name, you just need to put quotes around your file name. And I'll do that with the touch command by typing touch, quote, new space file2.txt, quote, and enter. And over in the file browser on the right, we see new space file2.txt. And they don't have to be the double quotes. They could be single quotes as well. That doesn't matter. And then the other option is to use the escape character, which is the backslash. Touch, new, backslash, that's the escape character, space, file3.txt. Pressing enter shows that that's created. So that backslash, or the escape character as it's called, tells us that the space after new is part of the file name and not the end of the file name. Now with Linux, you can create a file name of special characters like touch, quote, @ symbol, hashtag, question mark, %, greater than, quote. Pressing enter shows that that file is created. But this is really a bad idea, and I'm going to remove that right now by right-click in our file browser and delete. Now going back to the touch command, what touch will do is check to see if a file exists, and if that file does not exist, it will create it. But if that file does exist, it will update the timestamp. Let's take a look at how that works. I'm going to type ls-lh and press enter. And we see that our new file 1 was created at 4:11. I'm going to touch new file 1.txt and press enter. And now I'm going to type that ls-lah one more time. And I'm using my arrow up key to bring back that command. Now we see the file was last updated at 4:27. So the last update time has changed from 4:11 to 4:27. Now there are other ways to create files, and we'll talk about them later. Right now, I want to look at how to create a directory. Actually, before we create a directory, I want to take a look at the directory names in our home directory. Do you notice that they do not follow the Unix standard of all lowercase? All the directories in our home directory start with an uppercase or capital letter. When I type pwd, notice the home directory and the Michael directory are all lowercase. So it's only the directories in the Michael directory that start with the uppercase character. I want to make a new directory, and I'm going to keep the same standard that has been set with the uppercase letter for the first character. To make a new directory in the Linux command line, we would type mkdir for make directory, then a space, and then the directory name that we want to create. I will call this new directory. And when I press enter, we see it right away in the file browser on the right. And I'll type ls, and there we see the new directory in the terminal as well. If I want to create a new directory inside of that directory, I can type mkdir for make directory, and I want this to be in the new directory, and I'm using the tab to autocomplete there. I'll call this new directory 2. And if I want to create another directory inside there, let's say we want to do new directory 3, this will not work, and I'll show this by pressing enter. The problem is it needs to have new directory 2 created before it can create new directory 3. If I want to create both of those directories in a single command, I'm pressing arrow up to bring back my last command. To go to the beginning of the command line, I'm going to press Control A. And then Control E will take us to the end of the command line. So I'm pressing Control A to get to the beginning of the command line. And I need to give it the option -P for create all parent directories needed to create the directory we want at the end of the command. Pressing Enter has created that directory, but we don't see anything because in Linux, no news is good news. We would have to go over into our file browser, double-click, and double-click to show them, or CD into them in our Linux command line. And there's our directory 3. In the next tutorial, we'll continue looking at the Linux command line. In the last video, we created files with the touch command, but we did not put anything into those files. When adding or editing text to a Linux file, we will want to make sure that we use a text editor and not a word processor. Microsoft Word and LibreOffice Writer are word processors, and they will add extra information into the file for page formatting and the like, and we don't want any of that in our Linux text files. It is okay to use the text editor from the main menu, but most likely you will want to use something like Nano or VI to edit and create your Linux text files. Nano and VI are text editors that are already installed on most versions of Linux. In this video, we will take a quick look at how to use Nano and VI. Nano will probably be the easier text editor for people new to the Linux command line, so we'll start with that one. To edit a file using Nano, you just need to type Nano and press Enter to take you into Nano. Or if you want to edit a specific file or give a new file name, we'll put a space and type in the file name. I will type in the file name, nanofile.txt. Pressing Enter takes us into Nano. And we'll notice over in the right in our file browser that this file is not yet created. That's because it does not get created until we save the file, and we haven't saved it yet. Editing text using Nano works just like the word processors you might already be familiar with. You just need to type in your text. I'll type in the text. I used Nano to create this file, nanofile.txt. Now that we're done writing and editing our file, we want to save our changes. Looking down at the bottom of the screen, we see a menu, and we see one of the options is Write Out. To the left of it, we see a highlighted caret and the uppercase O, and we see that caret or hat symbol next to everything in that menu down there. That caret or hat symbol just means we need to hold down the Control key while we press the key next to it. To write out, we see caret O, so I will hold down the Control key and press the letter O. And it doesn't matter if I press the upper or lowercase o. And now Nano is asking me, do I want to write out this file, nanotext.txt? If I want to change that file name, I can change that name here, or I would have to type in the file name if I opened up Nano without giving it a file name. I'm happy with this file name, so I am going to press Enter. And now we see that we wrote out this file, and we see it over in the right in our file browser window. And now I want to exit Nano. Looking at the bottom, we see I'm to hold down Control and press X to exit. And once again, it doesn't matter if it's upper or lowercase x. I pressed lowercase x, and I'm back in the Bash terminal. Going back in, I'm going to press the arrow up and Enter. I'm using my arrow keys to take me over to the right, where I will insert the text TEXT, for I used Nano to create this text file, nanofile.txt. And now I want to exit out, so I'll press Control X. And now Nano is telling me that I have changes that I have not saved. Do I want to save them? And answering no will discard any changes. I want to keep these changes, so I will press Y. And we already saw this here to write the file name. I will press Enter, and it writes the file and takes us out of Nano. To edit or create a file using VI, we start off the same way as we did with Nano. I'll type vi space and then the file name. And I'll call this file vi file.txt. Pressing enter takes us into vi. And once again, looking over on the right, we do not see the file in the file browser window. It's not there until we save the file. VI is a modal editor, so we can't just start typing our text. We must first go into insert mode. And we can do that by typing the lowercase I. Now I'll create my text. This file was created using the VI text editor. To get out of insert mode, I will press the escape key. We've edited our file, but we haven't saved it yet, so we don't see it over on the right in our file browser window. To save our file, we need to be out of insert mode, in which I did by pressing the escape key. And if you're not sure, you can always press the escape key a second time. And then we save the file by pressing lowercase w, and then enter. To edit the file, I'm going to use the arrow keys to move my cursor where I want to add some text. Then press I to go into insert mode, add my text. This text file was created using the VI text editor. Now I'm still in insert mode. I need to press escape to get out. And if I try and quit out of VI with :Q, pressing enter gives me a warning that I have changes that were not saved. And I need to press the exclamation point to override. So I'll type in :Q exclamation point if I want to quit without saving these changes. But I want to save this change before quitting, so I will type :WQ so it will write and then quit out. It's good to be familiar with both text editors, so we will be using both text editors in this tutorial series. In the next video, we'll continue looking at the Linux command line. In the past few videos, we've created files and directories and put text into some of these files. Now we're going to look at how to read text files. And yes, you can use Nano and Vim to look at what's inside of a file, but there are times when you just want to take a quick look at what's inside a file. And that's what we're going to do in this video. The first thing we're going to do is cat out a file. To cat out a file, we type cat space and then the file name. I will cat out nano, and I'm pressing the tab to autocomplete, nanofile.txt that we created in the last video. Pressing enter shows us that line of text that we added into that file in the last video. Cat is short for concatenate, and concatenate means to join together. So we can cat or join multiple files together and print out their content. I'm going to press arrow up to bring back our cat nanofile.txt, and I'm going to add the file vi, and I'm pressing tab to autocomplete, vi file.txt, pressing enter, and we see it prints out the content of both of those files as if it were a single file. One of the options for cat is -n for line numbers. Pressing the arrow up to bring back our last command, and I'm using Control-A to take me to the beginning of the line, and my arrow keys to go over to the right. I'm typing in -n to show us the line numbers when we cat out these two files. Pressing enter, we see the same output as before, but this time with line numbers. With only 2 lines, one for each file, this is not very impressive. So I've created another file, which I call grocerylist.txt. And I'll put this out on my website so you can download it for free if you want to work along with me with the same file I'm using. I'll also put a link in the video description. Now I want to cat out our grocery list file. So I'll type cat-n gro, and I'm using the tab to autocomplete and pressing enter. And here we see we have more than one page of text. With more than one page of text, I want to look at that file again, but this time I'm going to use the more command. To use the more command, I'll type more, and then the file name, gro, tab to autocomplete, shows me the grocery list file name, and I'll press enter. Here we see the output from our grocery list from the top line, and at the bottom left corner of the screen, we see more. That means that there is more than one page of text. And we also see why this is called more. I'll press the space bar, and now we see the rest of the file, and it takes me out of more. Now, more works pretty well for multiple pages of text, but the more command was improved upon, and they call the improvements less. And that led to jokes about less being greater than more or less being more than more. And I think that the Apple operating system uses less in place of more. So in that case, less is more. The advantage of using less over more is the improvements they made to it. When using less, it does not have to read in the entire file to show you a single page of text. And you're also able to page backwards. Less works the same way as more. We just type less, and then the file name, GRO, tab to autocomplete, and enter. From here, I can use my page down and page up, or I can use my arrow keys to go down just one line at a time and up one line at a time. Then to quit out of less, I'll press the Q key. If we add the uppercase M option to less, I'm pressing the arrow up, Control A, and then arrowing over to add in my dash uppercase M. When I press enter, now at the bottom of the screen, we see the file name, but we also see the number of lines in the file and what we're looking at. So we're looking at lines 1 through 23 of 44 lines. And it also gives us the percentage we are through the file, which is about 54%. And again, I'm going to press Q to quit out of that file. Less is good for looking at the whole file, but sometimes we just want to see the first few lines of a file or the headings of a file. For that, we can type head and then the file name. Head grocerylist.txt shows us those first 10 lines. Now 10 lines is the default. If I want to see a different number of lines, I'll have to change the option. Pressing the arrow up to bring back the last command, Control A to go to the beginning of the line. I'm going to add the option -N and then the number 25. Before I hit enter, I want to review what I said about a Linux command line command, which is really just a bash command. I haven't explained that too well yet. We will get to that though. We said the Linux command line command consisted of a command, an option, and an argument. And here we've got a fourth item. This is really just an argument for the option, and a lot of people like to place them together by taking out this space. So that makes it a little more clear that that 25 is part of the option and not the argument itself. But you can leave the space in if you like. It works either way. I'm pressing enter, and now we're seeing the first 25 lines. Since that went over a page, I'm going to bring that down to about 15 lines. Now it's a little more clear. And that number does not have to be greater than the default. The default was 10. I'll make it 3 lines. And the last thing I want to talk about in this video is the tail command. And that is similar to the head command, but it shows us the last 10 lines of the file. For example, when I type tail space grocery list, enter, we see the last 10 lines of the grocery list file. The thing about tail is if we type tail-f grocerylist.txt, it will show us the last 10 lines of the file. But if a line is added to that file, it will show us that new line as well. To see how this works, let's tail the grocery list file. And I'm going to move this terminal over to the left and open a new one. And move it over to the right. And I'm going to go into Nano and update our grocery list file. Using my arrow keys, I'm going down to the bottom, and I'm going to add in new item 1. We don't see it on that list yet because I haven't saved it yet. To save it, I'll press Control O. The Nano prompts us, do you want to write grocery list? Which I do. Now, when I press enter, This is when we're going to see it updated on the left where we are tailing the grocery list file. I'm pressing enter and we see our new item 1 in the file we are tailing on the left. The real strength in tailing a file is when you have a problem and you need to tail a log file. Then you can repeat the action and see what comes up in the log file while we are doing that action. We're still following our grocery list.txt file. To get out of that, I'm going to press Control-C. In the next video, we'll continue looking at the Linux command line. In the last video, we saw how to create and add text to files using Nano and VI. In this video, we're going to look at how to create and add text to files using output redirection. When we type a command like cat and add the files nano file.txt and vi file.txt, and I'm using the tab key to autocomplete those file names, pressing enter, we see the output on the terminal. The output from this command is going to what is called standard out. And in this case, standard out is pointing to the terminal. We can direct that standard out output to a file using a greater than sign and a file name. I'll press the arrow up key to bring back that last command, and I'll add a greater than sign and a space, and then a file name. I will call this file name output.txt. So with this command, I'm saying take the standard out output from the command and put it into a file called output.txt. And if that output.txt file does not exist, create it. Pressing enter, we don't see any output on our terminal at this time. And that is expected because we just told it to put the standard out into a file called output.txt. I'm going to cat output.txt, pressing enter, and we see the same 2 lines of text that we just saw in the terminal are now in the output.txt file. Let's try redirecting some output from the ls command. I'll first type ls-lh so we can see what we should expect in the output.txt file. Pressing enter, we see all the files and directories in the current directory we're in. Pressing the arrow up and adding the greater than sign and the file output.txt. And again, I'm using the tab key to autocomplete the file name. Pressing enter. Again, we see no news is good news. And I will cat the output.txt file. We see it now contains the results of the ls-lh command. And because the output.txt file is a plain text file, there's no formatting for the directory name, so everything shows as plain text. Notice the 2 lines of text that were originally in the output.txt file are now gone. Redirecting the output with a single greater than sign will delete and recreate that file name, and any data that was in that file is now gone. We can keep the text that is in that file and append to it from the current command by adding a second greater than sign. I'll type cat nano autocomplete vi autocomplete, and now sending the output with 2 greater than signs to output.txt, pressing enter, shows us nothing. Again, this is what we expect. And when we cat the output.txt file, we see the text that was in the output.txt file, and we just appended it with the last 2 lines there. That was the output from our cat nano file and vi file. Now, every now and then you might want to add line numbers to a file. To do that, I will cat out the file, cat with a -n. Remember, -n adds line numbers to the cat. And I will use the output.txt file as our input, and I will send that to a file called linenumbers.txt. Now, I could have called this output.txt and added the line numbers to that same file. The problem with that is that if something goes wrong, you've just overwritten your input file. So, and even though this one's easy to reproduce, it's just a good practice to always keep your input file. Pressing enter, and then cat line numbers, shows us that the line numbers.txt is the same as the output.txt, only with line numbers. Now I'm going to cat out our nano and vi files again, but this time let's say I have a typo in one of the file names. Cat nano file.txt, but this time instead of typing vi file.txt, I type vim file.txt. And then we cat this out to output.txt. Pressing enter, we see the line cat vim file.txt, no such file or directory. And that error makes sense because there is no file called vim file.txt. It's called vi file.txt. The question is, why do we see that error message at all? We told it to redirect the standard out to the output file. The problem is the error messages don't go to standard out. It goes to standard error, which is still pointing to the terminal. I'm going to capture the standard error output into a separate file. To do that, I'm going to hit the arrow up to bring back the last command, and I'm going to redirect the standard error by putting a 2 greater than sign error.txt. So this first greater than sign is standard out. And I can add a 1 here because 1 is standard out, 2 is standard error. If we don't put the 1, it just defaults to the 1 standard out. So I don't need the 1 here, but I can add that if I like. And I could have added it every time I was using the standard out, but it's not needed, so I've left it out. So we have the 1 is going to output.txt and the 2 is going to error.txt. Pressing enter. Then when I cat output.txt, we see the single line that successfully went into it, and cat error.txt shows us the error line that went to the standard error. Now, there may be times when you don't care about the error messages. We don't want to see them on the screen, and we don't want to write them to a file. We don't want them at all. We just want to delete them. In those cases, I'm pressing arrow up to bring back the last command. We would change this error.txt file to /dev/null. The path starts with a /, and this tells us that we have an absolute path and that we are going to send our output to device null, which is exactly that, a null device, nothing. So we are sending our output to nothing, and it is gone. Pressing enter shows us no news is good news. Our output.txt file will have the single line, and device null, we can't see that because our data is gone. And this is not just for standard error. You could be testing something and want to send your standard out to /dev/null. That would work too, and your standard output would go into nothing. There are other times when you may want to write your standard out file and your standard error file to the same output file. For this, we just need to add the ampersand before the greater than sign. Cat nanofile.txt, vimfile.txt, and ampersand, both standard out and standard error, should go to output.txt. Pressing enter shows us nothing, which is what we expect. Cat output.txt shows us both the output from the standard out and the output from the standard error. I have a couple more quick ways to use output redirection. The first one is with the echo command. We saw the echo command in video 1. Echo hello world, and I will output that to a file called hello.txt. Pressing enter, cat hello.txt shows us the hello world. So if you need to create just a quick little file like that, that's one way to do it. And there is also the printf command. Now, with printf, we can do a little more formatting. Hello world. And then with this \n, we're adding a second line, and I'll just call it second line. Let's output that to hello.txt. And when we cat hello, we see the second line, we didn't add a line return after. So let's add that real quick. At the end, \n. Now, when I cat out hello, we see the first line and second line. So that's just a quick way to add a file with a line or two in it. In the next video, we'll continue looking at the Linux command line. I'm going to type ls -lh to see the files and directories I have in my current home directory. I want to move the output.txt file to the new directory. To move a file, we use the mv command. So I will type mv space, and then the file that I want to move, or the source file, and then to where I want to move it to, which is the destination. The source and the destination can either be absolute paths or relative paths. In this case, I'll use the relative path for both. So my source file is going to be the output.txt file, and my destination file is the new directory. Pressing enter, the file is moved. To see that it's moved, I'm going to type ls -lh new directory, and this shows us in the new directory we have the new directory 2 directory, and we have the output.txt file that we just moved there. And typing ls -lh to show the contents of the current file shows me that the output.txt file is no longer there. To bring that file back, I will start with the mv command again, and this time I'm going to give the absolute path. Home, Michael, new directory, output.txt. And I want to move it to the current directory, so I'll use the dot or period, meaning the current directory. This is the method that I prefer to use when moving files with long path names. One reason is when using the dot, I don't have to type out the long file name. And the second reason is if I accidentally press enter while halfway through typing the file name, because the command is not yet complete, it won't do anything. And having the long file name as the destination halfway through, if I press enter accidentally, I've just moved that file to somewhere where I did not intend to. So pressing enter, move that file back, and I will show that by typing ls-lh, and we see that our output.txt file is back. Moving directories works the same way as moving files. We type the directory source and then the directory destination. We just saw that we have new directory 2 inside of the new directory. So to move that to our current directory, I will type mv for move. Then we have that in the new directory, and it is called new directory 2. And I want to move it to the current directory, so I'll press the period key that says move it to my current directory. Pressing enter, and then ls-lh shows us that we now have the new directory and the new directory 2 directory in our current home directory. To move that back, I'll use the mv command, new directory 2, and I want to move it inside of the new directory. Pressing enter, then ls-lh to show that it's gone, and to show that it's in the new directory, I will type ls-lh new directory, and we see that it's there. Now let's say I want to rename a file. There is no rename command. To rename a file, I'll type the mv command, just like I did before, mv source and destination, and this time it would be the same directory that I'm in. For example, let's rename the hello.txt file to rename.txt. I'll type mv space hello.txt, and I want to rename it to a file called renamed.txt. Now, earlier when we were moving the file to the destination, we had a destination directory called new directory where we were moving our file to. This time there's no directory called rename.txt, so it knows that we just want to rename the file. Pressing enter renames the file, and I will type ls space -lh. And we no longer see a hello.txt file, but we do see the renamed.txt file. Now I want to rename my file and move it into a new directory at the same time. To do this, I will type the MV to move the file. My source name, or the file I want to move, is called rename.txt, and I want to move it into the new directory, but I also want to change the name, and I want to call this one output.txt. Pressing enter completes the command. I'm going to type the ls-lh new directory to show us what's inside that directory. And there we see our output.txt file, and typing ls space -lh shows us that the rename.txt file is now moved. When I type man space mv, we see that there are a lot of options there. There's only a couple that I really want to cover in this video. One of them is the -f force, the -i interactive, the -n no clobber, and paging down to the next page, the -v verbose. I'm pressing Q to get out of the man pages. So the first one I want to look at is the -v verbose. To show this one, I'm going to move with MV space -v, and I'm going to move the error.txt file to be errorfile.txt. Pressing enter. What the verbose does is shows us more information about the command. And here it is telling us that it renamed error.txt to errorfile.txt. So using verbose just gives us a little extra message that the file was renamed. Now I'm going to try and move the output.txt file to the new directory /output.txt file, which already exists. But I'm going to use the -n for no clobber, so it should not overwrite that file. Let's test this out. I'm going to type mv for move, -v for verbose. I'm adding the n for no clobber. Now I'm going to type the output.txt file, new directory, output.txt file. When I press enter, we don't see anything. And since we have the no clobber option active, as well as the verbose, we didn't get any message. And checking the current directory with ls-lh, we see that output.txt file is here. It was not moved anywhere. So the no clobber option worked and did not move the file. So let's try this same command again. The move output.txt to the new directory output.txt. And I'm going to take off that n, that no clobber option. This will use whatever the default option is. And using the v for verbose will give us a message if that output.txt file gets moved. Pressing enter. And we see from the verbose message that the file did get moved. Renamed output.txt to new directory output.txt. This command took the output.txt file and overwrote the output.txt file that was in the new directory. Now this tells us that the -f force overwrite is the default option. So you might want to keep that in mind when you are renaming files. The last option I want to talk about is the -i option. And to test that one, I will need to create a new output.txt file because we already moved the one that was in the current directory. So I will create a new one with echo new test data for output.txt, and let's move that into output.txt. Typing ls-lh shows us that the file output.txt is there. So now I'm going to try and move the output.txt file to the new directory output.txt with the I or interactive option. Move -v for verbose, I for interactive, output.txt, new directory, output.txt. When I press enter, this time it tells us, hey, there's already a file called output.txt. Do you want to overwrite that? I'll type no. And it cancels out the command, nothing got moved. Pressing the arrow up to bring that command back, I'm going to press enter. Again, it's asking us, do we want to overwrite the output.txt file? I will type Y for yes, pressing enter. There we get the message that it renamed output.txt to new directory output.txt. And in this case, overwriting the old file output.txt. In the next tutorial, we'll continue looking at the Linux command line. The copy command works similar to the move command that we saw in the last video. The word copy is shortened down to 2 letters, CP, and then we would type the source followed by the destination. Let's copy the error file.txt that we created in a previous tutorial into the new directory that we also created in a previous tutorial. To do that, we'll start with the CP for copy, space, error file.txt for our source, and then the new directory for the destination directory. Pressing enter shows us no news is good news. And we will check just to confirm the copy worked as expected. I will type ls-lh new directory, and we see our error file.txt is there. And typing ls-lh shows us that the error file.txt is in our current directory as well. If we want to make a copy of the file in the same directory, we have to change the file name in some way. When I say that, I mean we cannot just type cp error file.txt and dot for our source directory to be the current directory. If I do this, pressing enter, we see that the error file.txt and the destination error file.txt are the same file. So to make our copy, I'm pressing the arrow up to bring back that last command, error file.txt, and I will just add a dash copy. Now typing ls-lh shows us the error file dash copy as well as the error file.txt file are both there. The copy command is also similar to the move command with the options we saw in the last video. If I type cp-v error file.txt, new directory, so we're copying with the verbose option the error file.txt to the new directory, pressing enter. The verbose option shows us that we copied the error file.txt and replaced the error file.txt that was already in the new directory, which is the same as typing cp-vf, force the overwrite option. I'm going to change that force the overwrite option to the N for no clobber and pressing enter because we're now using the verbose option and we don't see the message that error file.txt was copied, the no clobber worked, and the file was not overwritten. We also have the option I for interactive, changing that N to an I, pressing enter. It now asks us, do we want to overwrite the new directory error file.txt with the source error file.txt? I'll press N for no and enter. Now this all works well as we see here for a single file. When we are copying directories, things change a little bit. We still have the new directory 2 directory inside of our new directory, and I'll show that with ls-lh new directory. And there's our new directory 2 directory. Before we copy that to the current directory, I want to add some files into the new directory 2 directory. To do that, I will type touch, new directory 2, file, and now I'm going to add a left curly brace, A, B, C, right curly brace, .txt. Now, the left and right curly brace, or opening and closing curly braces, are not part of the file name. What we're actually saying by using those is create a file called file A.txt, file B.txt, and file C.txt. So we'll create 3 separate files. Pressing enter, is creating those files. We'll see that in a moment when we copy this directory. When moving a directory, we need to tell it to move the directory and everything in that directory. So I will need to add the -r for recursively copy everything in that directory. Let's first try it without the -r and see what happens. I want to copy the source, which is in the new directory, new directory 2 directory, and I want to copy that to our current directory. And I'll use the dot for that. Pressing enter shows us the warning that we do not have the -r for recursively copy, so it's omitting the directory, new directory 2. We are not moving anything. And you will see that same message even if the directory is empty. I'll bring that command back with the arrow up, and I'm using Control A to go to the beginning of the command. And I'm going to add a -r for recursively copy. I'm using the lowercase r. It can be an uppercase R as well. Either one works. I'm also going to add the V option for verbose. Pressing enter. This is now telling us that we are moving the new directory 2, to the current directory, new directory 2. We're moving the 3 files we created, the file A, B, and C are getting moved, as well as the new directory 2, new directory 3, which is in the new directory 2 directory. I want to look at the man page for the cp command. I'm going to type man cp. And here we see the -a for archive. If you want to add a -a option, this will keep the permissions, ownership, and timestamp. Sometimes you want to keep all that, and the -a option will do that for you. Skipping down to F for force, which will copy over an existing file or directory if it exists. Note that you cannot copy a directory over a file, meaning if I had a file called new directory 2 in that current directory, when I tried to copy the new directory 2 directory with the cp command, it would have not copied and given me a warning that it cannot overwrite a non-directory. So it will only overwrite a directory with a directory or a file with a file. Paging down, we see the I for interactive. We will look at that in a moment. The next options are about links and symbolic links. Those haven't been covered yet, and they are on the short list of things to talk about in this tutorial series. And when I say the short list, I mean within the next 5 to 10 videos. I'm still working out the order of where things would go. At the bottom of the page, we see the R for recursive can be either upper or lowercase. And going down a little further, we have U for update and V for verbose. We're already looking at verbose, and we're going to look at the update as well before we end this video. Quitting out of the man page, I'm going to bring back our copy command by pressing that arrow up key 2 times. And I'm going to run that same command again. This time, notice, it only copied over the 3 files. It did not copy the new directory 3 again, because that directory already exists. I'm going to bring back that command again, and I'm going to add the I for interactive. Pressing enter, it now asks us, do we want to overwrite file A? I'll say yes. Now it's asking us if we want to overwrite file B. I'll say no. And then we get to C, and I will type Y for yes again. Now, this works pretty well because we only have 3 files in there. The -I interactive feature is nice, but it will ask me for every file. So if you're copying a directory with a lot of files in it, you might not want to use that -I interactive option. Pressing arrow up to bring back our copy command again, I'm going to change that I to a U. Now the U will only copy over files that have been updated. Pressing enter, we don't see anything because nothing has been updated. I will update a file by touching new directory 2, file b.txt. That updates the timestamp. So when I bring back the copy with updated files only and press enter, we see that it only copied over file b.txt because that was the only file that was updated. There are other ways to copy and archive files using the Linux command line, and we will look at them in future tutorials. But this is going to wrap up what I want to say about the cp copy command. In the next video, we will continue looking at the Linux command line. In the last few videos, we've seen how to create, edit, copy, and move files and directories. In this video, we're going to look at how to delete them. I am typing ls-lh to show the files and directories in my current directory. To delete a file, we will use the remove command. The remove command is shortened down to rm for remove. Then we put a space and the file name that we want to remove. In this case, it's errorfile.txt. Pressing enter will delete that file. In the last few videos, we also added the options V and I for verbose and interactive. Those options are also available for remove, and I'll show them here by typing rm-vi, and then we will delete the error file copy.txt. Pressing enter, we are asked, do we want to remove the regular file error file copy.txt? If I type N for no, the file is not deleted. Pressing arrow up to bring back that same command, enter. This time I'll press the Y and enter. And we get the message the error file-copy.txt file was removed. There is no trash file, so once it's deleted, it's gone. You may be able to recover it with some kind of file recovery software, but we don't have that here. So for us, that file is gone. Now let's look at removing a directory. I'm going to first create an empty directory to remove. So I'll type mkdir for make directory. Then I'll give it the name empty directory and press enter. I'm going to clear my screen by typing clear. And you can also use Control L to clear the screen. And I'll type ls-lh to show the empty directory that we just created. To remove an empty directory, we can type rmdir, which is short for remove directory. Then we will give it the directory name that we want to remove, and that is empty directory. Pressing enter, we get no message, which in this case means it completed okay. I'll type ls-lh again, and we see the empty directory is no longer there. Before I try the rmdir on the new directory 2 directory that we copied over in a previous video, I want to add some more files into that directory. I'm going to type touch new directory 2 /file. Then we're going to add that curly brace that we saw in the last video. I'll type the number 1.5 right curly brace .txt. We saw how the curly braces worked in the last video, and building on that, in this video, we are creating a range of files, the range being 1 through 5. So file 1.txt, file 2.txt, all the way through 5. Pressing enter, just created those files. Now, if I try that rmdir for new directory 2, we get a message that the file was not removed because the directory was not empty. Checking the man page for rmdir, we see right at the top in the name, rmdir removes empty directories. And there are times when we will want to do that, but this is not one of them. I'm going to press Q to get out of the man pages. And I'm going to clear my screen again by pressing Control L. And now I'm typing ls-lh new directory 2. And pressing enter shows us our files 1 through 5, the files A, B, and C that we created in the previous video, as well as the new directory 3 that copied over when we moved the new directory 2 directory. So this directory is definitely not empty. The rm remove command for a directory works similar to the mv move directory and the cp copy directory that we've already seen. Adding a -r, either upper or lowercase, for recursive, we'll apply that command recursively for that directory. And we can also use the -v for verbose and the -I for interactive. So I will add that to our remove command. rm-rvi new directory 2. Pressing enter, we're asked, do we want to descend into the directory new directory 2? If I press N here, it will not go any further and cancel out of the command, and nothing is changed. So I will press Y and enter. Now it's asking us if we want to remove regular empty file new directory 2 /file5.txt. And that's kind of nice that it tells us that file5.txt is an empty file. I'll press Y for yes. The verbose action is letting us know that it was removed. And then it's going down to the next one. Do we want to remove empty file fileb.txt? Pressing Y. That file is now removed. But doing this for every file in that directory can get a little tedious. So I want to cancel out of this command. I'm pressing Control-C to cancel out of that command. Control-C is a common command for canceling out of things. And we also use the Q for quitting out of things like less and the man pages. So Q and Control-C are good to know. Now we may have canceled out of our command, but we still did delete new directory 2 file5.txt file and the new directory 2 fileb.txt file. Those were deleted before we canceled out. But the new directory 2 file3.txt file, that is still there, as well as all the other files and that new directory 3 directory that's inside the new directory 2 directory. I want to delete out that new directory 2 directory and all the files in there. I want just a single confirmation prompt warning me before removing the entire directory. To do that, I'm going to press arrow up to bring back that last command and move my cursor over to that I. I'm going to change that lowercase I to an uppercase I. Pressing enter. We are now asked, do we want to remove argument 1 recursively? And argument 1 is the new directory 2 directory. We want to do this, so I will press Y and enter. And because we've got the verbose on there, we're seeing all the files that were deleted, that the new directory 2, new directory 3 directory was deleted, as well as the new directory 2 directory itself. In the next video, we'll continue looking at the Linux command line. Before we can talk about links, we need to understand how the Linux file system stores its files. Every file on a Linux system has an entry with a file name and an inode. The inode stores all the information about the file except the actual data, which is written on the disk, and the file name that we see when we type ls. I will type ls-lh, and we see on the left we've got the permissions and then the owner and the group, the size, the date and time. This data is all stored on the inode. And then on the far right, we've got the file name. To see the inode number, I'm going to clear the screen and type ls-lhi. Now we've got the inode number on the far left. When a Linux file system is created, there are a specific number of inodes created, and for the most part, that is more than enough for the number of files on that partition. Occasionally, something will happen that will create a lot of very small files. And when I say something will happen, I mean something happened that has gone way wrong to create that many small files. But it is possible to use up all the inodes, and then no more files can be created, including operating system files. What I'm getting at is it is possible to have a situation where there's plenty of usable disk space on your disk drive, but you cannot create any files because all the inodes are used up. That rarely happens, but it can. So I wanted to make you aware of it. Going back to our listing, I'm looking at the inode for our grocery list.txt, 925474. Now looking at the third column, that is the number of links we have to that inode and the data on the disk. I'm going to create a link to the grocery list.txt file, and to do that, I'll type ln for link, then the name of the existing file that we want to link to, grocerylist.txt. And then the new name will be grocerylist-link.txt. We see this command works similar to the commands we've already looked at so far. We've got the command source file, then destination file, or the command, then existing file, and then new file. I'm pressing enter, and our link is created. I'm going to clear the screen with Control L and type ls-lhi once again. The first thing we notice is that our grocery list and our grocery list-link have the same inode numbers. And notice in column 3, now instead of 1, we have 2. And that's because we have 2 links to the same data in inode. We can see that the permissions, size, date stamp, they're the same for both files because they're getting the data from the same inode. To edit or view the data, we can type in either name. I can type cat grocery list-link.txt and cat grocery list.txt, and it's the same file. So you will not be able to edit both those file names at the same time for the same reason that you can't edit a single file in 2 windows at the same time. Hard links do not have to be in the same directory. I can type ln grocerylist.txt, new directory, grocerylist.txt, typing ls-lhi. Now we see a 3 for the number of links for our grocery list link and the grocery list file. And when I type ls-lhi, new directory, we see in this new directory, we still have the same inode number, the 925.474. We can remove any one of the 3 hard links and the data will remain intact. Actually, we can remove any 2 of the 3 hard links and the file will still be there. I will type rm grocerylist.txt, removing the original file. And to remove the grocery list link, I can type rm, or I can unlink grocerylist-link.txt. Those 2 files are gone, but the data in the inode are still there because we still have the link in the new directory. And I will move grocery list from the new directory to the current directory with move new directory grocerylist.txt, the dot meaning the current directory, and typing ls-lhi shows us that we once again have our grocerylist.txt file with the 925.474 inode. Unlinking this last hard link, or removing the hard link with the rm command, will remove the inode, but the data will still be on the disk until it gets written over. And that's one way that file recovery tools are able to restore a file after it's deleted. There are some limitations to hard links. You can only hard link to a file in the same partition. The reason for this is when you set up a partition, it sets up the inode numbers for that partition, and it's possible for another partition to have the same inode number. And we can't hard link a directory. And the reason for that is because someone could create a hard link to its parent directory, creating a system loop. If we want to link to a directory or a file or directory on another partition, we would want to use a soft link, which is also called a symlink. To create a symlink, I will type ln for link -s for soft link or symlink, then the file name I want to link to, in this case, grocerylist.txt, and then the new link that I want to create, which in this case will be grocerylist-symlink.txt. I'm going to clear the screen and type ls-lhi. There are a few differences we see between the symlink and the file we linked to. First thing we notice is the inode number is different. And that's because we did not link to the file itself, but the file name. In the next column with the permissions, we notice that first letter is now an L for a link. And then the other options we see are D for directory and a dash, which is a regular file. We have 1 for the number of links because it's not linked to the inode and the data. And we see that the stats are different because it is not linked to the inode. The size of this link, notice, is 15. That is also the number of characters in our grocerylist.txt file name. And then the most obvious difference between the two is after the name, we've got an arrow pointing, telling us that it's linking to grocerylist.txt. The thing about soft links or symlinks is if I rename the file that it's linked to, move grocerylist.txt to grocerylist-renamed.txt. Now when I do an ls-lhi, we see the grocerylist-symlink.txt shows up in red on my screen, but I've seen them blink on systems, and that all depends on the system settings. What this is telling us is the link is broken, and the symlink can no longer get to the file it was linked to. If I type cat grocerylist-symlink.txt, we get the message that there's no such file or directory. To fix the symlink, we just need to rename the file back to the way it was. Move grocerylist renamed back to grocerylist.txt. Now when I cat the file, it shows us the data that is inside the file it's linked to. To remove a symlink, I prefer to use the unlink command, and I'll unlink grocerylist-symlink.txt. Typing ls-lhi, we see that our symlink is now removed. In the next video, we'll continue looking at the Linux command line. On Linux systems, there are 2 types of users, privileged users and unprivileged users. The default privileged user is root. We can think of the root user as the super user or admin user. The root user can do anything to any file on the file system. The root user can change or edit any file on the file system. They can run or execute any program or file, and they can change permissions and create and delete any accounts on the system. A few videos back, I mentioned that the / was the root directory. We call that / the root directory because all directories and files for the entire file system are started from there and then get added on as paths grow out with the directories and branches like files and leaves on a tree. Here we see a branch for the home directory and another branch for the Michael directory, and then the files would be the leaves on those branches. The root user has admin or super user privileges to do everything in this root directory. So most likely, that's where the term root user came from. In Linux, when we're talking about root, it can either be the root user or the root directory. They are 2 different things. In the early days of Linux, people would sign in as the root user to do their daily tasks because they may need to do some administrative tasks. They stopped doing this because the root user can edit, change, or delete any files on the file system and often ended up doing just that, accidentally editing, changing, and deleting important system files that they didn't intend to, with unfortunate results. And when a browser is opened as root, now it has root privileges, and any malware or viruses on your system would then have root privileges as well, and that would be bad. The version of Linux Mint I'm using is based on Ubuntu, and Ubuntu requires that a username is given when we install the operating system. After installing the operating system, Ubuntu makes the user account just created a privileged user. Being a privileged user means my user ID can submit root user commands. But a moment ago, didn't I just say it was a bad idea to log in every time as a root user? And it is. So when I log in, my user ID of Michael only has standard privileges. When I need to submit a privileged root command, I will precede that command with sudo. And some people pronounce this sudo, including me at times, and some people call this sudo. But it works the same way no matter how you pronounce it, so you'll hear me pronounce it both ways throughout this series. Now, some people say that sudo stands for super user do, and other people will say it's switch user do. Either way, it allows the user to submit that single command with root user privileges. To show you what I mean, I'm typing ls-lah/root. Pressing enter will return a message that we don't have permissions. That is because at the moment, I'm trying to read this directory with standard or unprivileged user permissions. I'm pressing arrow up and Control A to go to the beginning of the line, and I'll type in sudo ls-lah/root. Pressing enter. Now Linux is asking me to enter my password. And it's telling me that it's looking for the Michael password, not the root user password. Typing in the password, and when I press enter, we see that there are just some hidden files there in the root directory. I'm going to add something into that directory, and to do that, I will type sudo touch root, and then what I'm going to add in there is a text file called Michael added this text file.txt. Pressing enter, and then I will go back to the sudo ls-lah, and notice that those last two commands, it did not ask me to type in my password again. That's because Linux keeps me as a privileged user for about 5 to 10 minutes after typing in my password for a privileged command. The reason for this, like now, once we submit a privileged command, it is likely that we will want to type in a few more privileged commands. And it can be a hassle typing in your password for every privileged command you want to type in. If I want to kill off my privileged user status and go back to being an unprivileged regular user once again, I can type sudo-k. Now, if I want to view the content of my root directory with sudo ls-lah/root, it asks me for my password once again. I'm going to press Control C to cancel out of that. The sudo command allows me to run a single command as root. But what if I have several commands I want to run as root and I just want to switch over to be the root user for a little while and then switch back to my unprivileged user? I can switch to be the root user by typing sudo-i. And why do we use the I to log in as root? When I checked the man page, I saw that L was used by list and G was already used by group. So most likely they pick the I for log in. When I press enter, it's asking me for the password again. Notice my command prompt changes. To the left, instead of saying Michael, it says root. And then to the far right, instead of having a $sign, it has the hashtag. Those two things show that now I'm able to run commands as root, meaning I do not have to type in sudo before running a privileged command. I can type ls-lh/root, and there I see the text file that I just added a moment or two ago without needing to type sudo. Now, as root, I would type in all the rest of the privileged commands I need to type in, and when I'm done, I will type exit. And we see that I'm logged out of root, and my command line prompt is showing that I am Michael, and it has the $sign once again. Typing ls-lh/root now shows me I don't have permissions to read that file. If you typed in a command like that and meant to type sudo but forgot, instead of hitting the arrow up and then Control A to go to the beginning of the line and typing sudo, another thing you can do is type sudo ! And often people will refer to that exclamation point as a bang. So sudo bang bang will add sudo to the last command. And this works for other things besides sudo. I'm going to type ls-lh to see what files I have in this directory. And I've got that grocery list. If I wanted to tail the grocery list, and let's say I forgot the word tail, I just typed grocery list.txt and pressed enter. Oh, that command doesn't exist. I wanted to tail the grocery list. So I will type tail, bang, bang. And that allows me to add tail to the command I just submitted. So bang, bang can be used for other things besides sudo bang, bang. But most of the time, it is used for sudo bang, bang. In the next video, we'll look at how to add users using the Linux command line. To add a new user from the command line on a Linux operating system, you must be a privileged user. We learned about privileged users in the previous video. We're going to look at two commands to add a user account on our Ubuntu-based operating system: add user and user add. We'll start with the add user, since that one comes first alphabetically. To add a new user with the add user command, you would type sudo, because I'm not the root user and add user is a privileged command. Then I'll put a space, then the command itself, which is add user, then a space, and then the username that we want to add. In this case, it is test add user. Pressing enter, I am prompted for the password to submit a privileged command. I'll put in my password and press enter. Now we are prompted to enter a password for our new user, the test user add user. I'll type in that new password, and I need to confirm that. Now it's asking me for the full name of the new user. We can type this in if we like, or just press enter and leave it blank. I'm going to type in some information. I'll put in the full name as test add user. Pressing enter, we're now asked for some information about this new user. Again, we can just press enter and skip it, but I'm going to enter in some values. Room number 123, work phone 555-1212, home phone will be 555-5555. And for other, I will say no other information. Pressing enter. Now it's asking me if this information is correct. It is, so I will press Y. And like most Linux commands, no news is good news. So the new user, test add user, was added. I'm going to check the home directory to make sure the home directory for test add user was created. cd home and ls-lh shows us the home directories, and there's the test add user. I also want to confirm that the configuration files were created when it created that new test add user directory. I can do that with ls-lh test add user. The configuration files are there. That's good. Now, if we really wanted to test out the test add user ID, I would log out and log back in as test add user. For the sake of time, we're going to skip that step and move right on to adding a user with the user add command. I'm going to clear the screen and add in the new user the same way. Sudo user add test user add. Pressing enter, and right away we get the no news is good news response. But it didn't prompt us for a password, and it didn't ask us for any information about the new user. Checking the home directories, we see that no home directory was created for our test user add user. The reason no home directory was created was because when we add a new user with the user add command and no options, this new user is added like a service account. In short, a service account is just an account set up for a specific service, like SSH, FTP, or MySQL. Don't worry if you don't know what those services are right now. A service account is an account for a specific service that is not the root user, because we don't want to give this account root privileges. And it's not a user account of a person that might be promoted out of the department or maybe leave the company. Often a service account does not need a login to the computer, and that is why no password was asked for. We'll see some examples of service accounts in just a minute or so. Right now, I want to create a standard user with the user add command with a home directory. To do that, I will type sudo user add -m test user add m. And the -m option for the user add command means create a home directory. They did not use the -h option for home directory because the -h was already taken for the option for help. So they chose M for home. Pressing enter, we'll check for the home directories with ls-lh. And there's our test user add m is created. And checking for the configuration files with ls-lah test user add m, we see the configuration files are also there. Once our users are created, they're stored in the etc password file. And although I said password, it's actually spelled passwd, so I will pronounce it both ways. Any user on the system can see the etc password file by typing cat etc passwd. This is all the users on the operating system at the moment. And this can look a little intimidating as a whole, but let's take a look at a single record. Here we see the single record for the test add user logon ID. Looking at that record by itself, it still looks a little confusing at the moment, but notice there are some colon separators and some comma separators. Using the colon and comma separators to break things up makes it a little clearer to see what we're actually looking at. We've got the user login ID on the far left. The comma separated text is the information we typed in about this user. We've got the user name, the room, the phone numbers, and the other information. Then we've got the home directory. This will be the directory where the user, test add user, will store personal files like spreadsheets, photos, and music. We've been working in the home Michael directory in this tutorial series, and that is the home directory for the Michael user that I log in as. On the far right, we have what shell to use, and we see we are using /bin/bash, meaning we are using the bash shell. But that's not the only shell Linux has. Other popular shells are the C shell, the Korn shell, the Z shell, or Z shell as our friends in the UK like to call it, Fish, also known as Friendly Interactive Shell. We're not going to look at any of those shells in this tutorial series. We're only going to look at bash commands. So why didn't I just call this tutorial series the Linux bash shell? Because that's more or less what it is. And I did consider calling it that, but it just didn't sound like as much fun to me. And this tutorial series is designed for people new to Linux that want to learn about the Linux command line. And one of the things we learned about is that there are different shells that can be used. But in this series, we're only going to look at the bash shell commands. We have 3 more fields to look at: the password, the user ID, and the group ID. Every user will have a unique user ID and a group ID assigned to them when the user ID is created. Going back to the etc passwd file again, we see that the user ID and the group ID for the 3 users that we just created are the same, but the group ID does not have to be the same as the user ID, and the group ID does not have to be unique at all. All 3 of our new users could have had the same group ID, but the user ID must be unique. And a single user can belong to multiple groups. To see what groups the Michael user ID is a member of, I will type ID Michael. Here we see the user ID of 1000, the group ID of 1000, and then we see the other groups that Michael is a member of: the 4 ADM, 24 CD-ROM, 27 sudo, and there's more there. Earlier in this video, I was talking about service accounts, and we can see that most of the accounts on this operating system are service accounts. Let's look at a couple. The Pulse or Pulse Audio Daemon, that is a service account for the sound and has a user ID of 120 and a group ID of 126. Below that, we've got the HP LIP service account, which has a user ID of 121 and a group ID of 7. This is for my HP printer, and LIP is for Linux Image and Printing. So the first 999 user IDs are reserved for service accounts. The general user accounts start at 1000, and that is what the Michael ID has, the first general user ID that was created when I installed the operating system. That brings us to the password. The password shows as a single X. That's because the encrypted password is not stored in the password file. It is possible to store your plain text password in this file, in this field, but it's really a bad idea to store unencrypted passwords in a file that everyone on the system has read access to. So there's an X in the password field, and the actual password is encrypted and stored in the shadow file. And we'll talk about the shadow file in the next video. In the last video, we were looking at the Etsy password file, and we saw every user ID had an X where the password should be. And I said the actual encrypted password is stored in the Etsy shadow file. You must be a privileged user to view the Etsy shadow file. I will view it by typing sudo cat Etsy shadow and pressing enter. It asks me for my password to submit a privileged user command. Just like the Etsy password file, this one can also look a little intimidating. I'm highlighting the test add user ID so we can see a single record. Even by itself, a shadow file record can look a little intimidating. But notice there are some colon separators and some $ separators. Like the passwd file, we have the user ID on the far left. Next to that, we have the password information broken up into 3 parts, separated by $. The first $sign tells us what hash algorithm is used. If we saw a 1 there, it would be using the MD5 password encryption. We see a 6 there telling us our password is encrypted using SHA 512 password encryption. The next value is the salt value. It's just some random data that is used to combine with the original password. Then the hashed version of the password and salt value is used as the encrypted password. Then we have the long string of nonsense characters. This is the encrypted password. The password is so big, I'm going to replace it with the word password so we can focus on the rest of the Etsy shadow file record. The field after the password field is the last password changed field, which is the date the last time this password was changed. This doesn't look like a date because it's stored in the Unix time format, or the days that have passed since 1970. There have been 18,321 days that have passed since January 1st, 1970. That means the last time this password was changed was February 29th, 2020. The next field is the minimum number of days a user must keep the same password. It's set at 0, so the user can change the password on the same day if they wish. If it was set to 7, we would have to keep that same password for at least a week before we could change it. The next field is the maximum days a user can have the same password before they are required to change their password. 9999 means the password does not ever have to be changed. The warning is a message that your password is about to expire. If the password were set to expire, a message would start showing that number of days before it is set to expire. The inactive number of days is the number of days after the password expiration date before the account will be disabled. There is nothing in this field, so this user's account will never be disabled. The last usable field is the account expiration date. There is no value in this field, so this account will never expire. But if it had a value, the account would expire on that date. There is one more field, and it's a reserved field, but that field is not used. Going back to the Etsy shadow file, we see that the test add user has a password, But looking below that, the test user add and test user add m don't have any password. Instead, we see an exclamation point. And if we look up at the service accounts, they have an asterisk in the password field. Thinking back when we set up these two accounts, test user add and test user add m, we did not set a password for either account. So the exclamation point in this field all by itself is showing us that this user ID cannot log into the system and that there is no password set for this user. And then the asterisk for the service accounts means the same thing. We cannot log into the system with that user ID, and there is no password. I can still switch in to be that user, but we must be a privileged user. And to do that, we use the su command, and we saw the su switch user command when we were talking about the root user. We would type su with nothing after it to switch to be the root user. Here we will switch to the test user add m user by typing sudo su test user add m. And it's asking me for my password to run a privileged user command. When I type who am I, it shows us that I am now the test user add user. I'll type exit and then who am I? And I'm back to the Michael user. The next thing we want to do is set a password for test user add m. Setting a password and changing a password both use the same command, passwd. To change the password for test user add m, I will type sudo passwd test user add m. Now it's asking me for the new password for test user add m. I will type that in and type it in again to confirm it. And the password is updated. And I'll switch to test user add m with sudo su test user add m. And the test user add m can now change their own password just by typing the passwd command. They first need to type in their current password. Then they would type in their new password and confirm their new password. And that goes for any user. Any user can change their own password with the passwd command. I'm exiting out of the test user add m user, and I will cat the etc shadow file again with sudo cat etc shadow. And here we see the test user add m password is set with SHA 512 encryption. In the next video, we'll look at how to change the values on the etc shadow file as well as the etc passwd file. In the previous video, we were looking at the etc shadow file. To view the etc shadow file, you must be a privileged user, and I will view that with the command sudo cat /etc shadow. The easiest way to change the values in the etc shadow file are with the chage command. To see the options available for the chage command, I will type chage-h. And here we see the list of options available. To see the values for a specific user ID on the etc shadow file, I will type sudo, because we need to be a privileged user to run the chage command, then chage-l, the option for list, which will show all the account aging information for a user, and then I will add the user ID of test user add m. And pressing enter, we see the values from the etc shadow file for test user add m, all nicely formatted. Let's change the minimum days before a password can be changed to 14. For that, I will type sudo chage -lowercase m for the min days, and I want that to be 14, and I want that to be for user test user add m. Pressing enter will update the field, and I'm pressing arrow up to go back a couple of commands, and we see the minimum days test user add m must keep a new password is now 14 days. The next thing I want to do is change the date the account expires for test user AddM. I will change that to December 31st, 2020. To do that, I will type sudo chage, then a dash uppercase E for the expire date. And now I'm going to type in the date I want this account to expire. And I will put that in double quotes, 2020-12-31. I'm using the year, month, day format. And then I will put in the user ID I want this change to apply to. And that is test user AddM. Pressing enter, that date is updated, and I will show that by pressing the arrow up to bring back the chage-L. And now we see that the account expires on December 31st, 2020. So that is the basics behind the chage command. But that command won't help us change any fields in the etc passwd file, the other file we looked at when adding a new user. To remind us of what that file looks like, I will type cat etc passwd. To show the values from a single record off the etc passwd file, I'm going to use the getEnt command, getEnt passwd test user AddM. And getEnt stands for get entry or get database entry. Pressing enter shows us the single record for test user AddM off the etc passwd file. I'm going to clear the screen. And the command I'm going to use to update the information in the passwd file is the usermod command. And just like it sounds, the usermod command will help us modify user settings on both the etc passwd file and the etc shadow file. To see what options are available for the usermod command, I will type usermod-h. And here we see a lot of things can be updated with the usermod command. Some of these, like the -e expire date and the -f inactive, can be done with the chage command that we just looked at. So I'm going to skip those. The G's and the append we will look at when we talk about groups. Notice there's a lowercase o that allows using duplicate UID. In a previous video, I said the UID had to be unique, and in most cases, they are. But here we see that it is possible to have duplicate UIDs. I'm going to use the usermod command to change the shell of user AddM. So let's bring back that record with getEnt passwd test user AddM. Here we see the shell is currently set to bin bash. We're going to change that to be for the Z shell, as if we have installed the Z shell. We have not installed the Z shell, but if we had, it would be in /bin/ZSH. So to update the user shell, I'll type sudo usermod-s for the user shell, and I want that to be bin ZSH, and I want that to change for user test user AddM. Pressing enter updated the shell. And to show that, I'll go back to the getEnt command, and we see our shell is now set to bin ZSH. Now I want to change the home directory for test user AddM. To do that, I will type sudo usermod-d for home directory, and then I'll give it the new home directory name I want it to use, /users/test user AddM. And that directory does not exist, just like the Z shell does not exist, so this won't really work, but it will update it. And I want this home directory name changed to apply to test user AddM. Pressing enter, it is updated, and to view the passwd record, I'm going to getEnt passwd test user AddM. And here we see the users test user AddM is the new home directory. Now, because those won't really work because the shell and that home directory don't exist, let's change those back. And this time I'm going to do it in a single command. So I'll start it off with sudo usermod, and we'll first do the shell with -s. And I want to set that back to bin bash. And now I want to change the home directory with -d. And we want that home directory to be /home/test user add m. And we want to apply both of these two changes to the test user add m user. And I spelled test user add m wrong, so let's fix that. Test user add m. Pressing enter. And we can show that record with the get ent passwd test user add m. And now we see the home directory is set back to home/test user add m, and the shell is in the /bin/bash directory. In the next video, we will continue looking at editing user information in the Linux command line. In the last video, we saw how to point a home directory to a new location. Now I want to point that home directory to a new location and move my home directory to that new location, all in the same command. Usually people move their home directories to a new partition or a different hard drive on that computer. One reason to move your home directory to a different partition is so you can remove the current version of Linux off your computer and reinstall it or upgrade it or switch to a different distribution of Linux and keep all of your personal files and directories that are in your home directory to use with the new version of Linux. One reason people move their home directory to a different drive is when their computer has two hard drives. Often there's a smaller, quicker SSD drive that has the operating system on it to get that quick boot up time. Then the home directory is on the larger, slower spinning hard drive with all your music, videos, and photos that would not fit on that smaller SSD drive. Because we have not talked about partitions or multiple hard drives yet, I will create a new directory on this partition called users. Sudo make dir/users. Before we move the directory, let's check the current settings with get ent passwd test user add m. This shows us the settings in the passwd file for test user add m, and the home directory is pointing to home test user add m. And typing ls-lh/home shows us that test user add m's home directory is in the /home directory. To move the home directory, we're going to use the usermod command that we started looking at in the last video. I'll type sudo usermod, and I'm adding the -d to update the home directory just like we did in the last video, and I will update the home directory to be /users/test user add m. Now to actually move the directory, I'm going to add the -m option here, and then I'll type in the user ID that we want to do all this action for, which is test user add m. Pressing enter, we see that no news is good news. To show that home directory was moved, I'm going to type ls-lh/users, and there we see the test user add m directory. And I will also type ls-lh/home to show the home directory, and we see the test user add m directory is no longer there. The last thing I'm going to show is the get ent passwd test user add m, which shows the home directory was updated in the passwd file. Now I'm going to change the login name of test user add m to be Tim, and I'll do that with sudo usermod -l for login name, and then I'll give it the new login name I want it to be, Tim, and I will do this for test user add m, and press enter. To show the updated record, I'm going to type get ent passwd, and then the username, which is now Tim. Pressing enter, and now we see the user login name is now Tim, but the home directory is still users test user add m. I'm going to log out and then log in as Tim. Now while we're here at the login screen, notice the login name of test add user. We'll talk about this in the next video. I just want you to notice how it looks here as test add user with two separate words. I'm going to log in as Tim. I'm opening up a terminal and typing pwd. And we see that we are in the users test user add m directory, and everything seems to be working fine. I'm going to list the files with ls-lh, and we see the file's owner is Tim, but the group is test user add m. I'm going to create a new file with touch test file.txt ls-lh, and again we've got the owner as Tim and the group ID of test user add m. I'm going to type ID Tim, and we see Tim is using the user ID of 1003 and the group ID is 1003 test user add m. We're looking at this now just to get an idea about the UID, the user ID, and the GID, group ID. In a couple of videos, we're going to look at how permissions work, and this will make a lot more sense then. For now, I just want you to make a note that the name on the account does not matter as much as the UID, user ID, and the GID, the group ID. I'm going to log out and log back in as Michael. And I'm going to change the Tim account back to test user add m with sudo usermod -l for login name, then the login name I want it to be, which is test user add m, and I want to apply this for user ID of Tim. In the next video, we will finish our look at editing user information in the Linux command line. I'm picking up from where we left off in the last video. I'm going to update the comment for test user add m with the usermod command. To do this, I will type sudo usermod -c, and the C is for update a comment. Now I will put what I want the comment to be in double quotes. This is a comment. Then we'll add the user ID that we want to update, which is test user add m. I'll type in my password and pressing enter. This shows us that no news is good news. And to show the updated record, I will type cat etc passwd. I'm showing the whole file so we can compare what we have in the comment for the test user add m user ID to what we have in the comment for the test add user ID. Looking at the test add user ID comment, we see it has a name of test add user, two words. Remember in the last video, we saw test add user as two words on the Linux Mint login screen. So if there is a comment name, Linux Mint will display that name as a username on the Linux Mint login screen. That's why I asked you to make a note of it while we were there in the last video. If the comment does not contain a username, the user ID is shown on the Linux Mint login screen. Getting back to the passwd file, we see the test user add m login ID has a comment. This is a comment. But when we look at the comment for the test add user ID, we see the username, the phone numbers, and the other information we added when we created the user ID. To enter or update that same information for another user, we could create a comma-separated comment. That would work, but then we would have to know the order of everything to get it right. A way around that is to use the chfn command. CHFN is short for change finger information. When I type finger test user add m, we get the message command finger not found, but can be installed with sudo apt install finger. So I will copy this and paste it. And now we have the finger command installed. I'm going to clear the screen and show the etc password record for test add user with get ent passwd test add user. And now let's show that same data with the finger command. Finger test add user. Now we can see the user name, the office room and phone number, and the home phone all nicely formatted. The other information is not shown here, but it can be updated using the chfn change finger command. Now let's look at the test user add m record with get ent passwd test user add m. And then finger test user add m. And we see that the name is this is a comment. I'm going to type chfn-h to show all the options available for the change finger command. Let's update the room for test user add m to be 122. To do that, I would type sudo chfn-r for room, then the room number I want it to be, which is 122, then a space, and then the user ID. In this case, we want it to be test user add m. To see the room is now 122, I'll go back to the finger, test user add m, and we see that the office is now 122. Now let's update some more fields for test user add m, all in a single command. I'll start this off with sudo chfn for change finger. I want to change the full name, so it's -f, and we'll make the full name test user add m. Now let's change the home phone with -h, and I'll make that phone number 555-1111. And one more thing we'll change is the other information with -o, and we will call that other information. We want all these changes to be for test user add m, pressing enter, and bringing back the finger command for test user add m shows us the full name was updated and the home phone was updated. We can see the other information by typing get ent passwd test user add m. And there we see the other information was updated as well. When a new user is created, we have to assign a password to that ID to give to the new user so they can log in. It's common to ask the new user to change their password when they first log in, to force a user to change their password on the next login. And this is not just for the first login, but anytime we want that user to update their password, we would type passwd-expire and then the user ID, or we can type sudo chage-last day 1970-01-01 and then the user ID, or we could type sudo chage-last day 0 then the user ID. And then the next time the user ID logs in, they will be asked to change their password. An example of this would be for test add user, you'd type passwd-expire test add user, or sudo chage-last day 1970-01-01 test add user, or sudo chage-last day 0 test add user. And then the next time test add user logs in, they would be asked to change their password. One last note about updating the user information is you can use Nano or VI to edit the etc passwd file or the etc shadow file. But anytime you edit a file in that way, there is a potential of accidentally updating something you did not intend to update. And with these files, an unintentional update could cause bigger problems. So that method will not be shown in this video. In the next video, we will continue looking at the Linux command line. A few videos back, we looked at the etc shadow file and saw that the user account can be locked when the current date is past the account expiration date, or it is past the maximum days a user can have the same password, and it is also past the inactive number of days the user had to change the password after it expired. I don't know if I made this clear in that video or not, but if either one of these two conditions is met, the user account is locked. Another option to lock the account like this is to set the account locked. To lock a user account, we can use usermod -uppercase L, then the user ID, or passwd -lowercase l and the user ID. Both commands do the same thing, and that is they place an exclamation point in the beginning of the password in the Etsy shadow file to prevent the user ID from logging in. Let's look at the Etsy shadow file with the command sudo cat Etsy shadow. And looking at test user add m, we see that the user ID has a 6 for the password encryption, meaning the SHA 512 encryption. Now I'm going to lock this account with the usermod command sudo usermod -uppercase L test user add m, and pressing enter. Now that user account is locked. Let's take a look at that Etsy shadow file again. And here we see the exclamation point in front of the password showing the account is locked. We can also show that the account is locked by looking at the status for this user ID. To check the status, I will type sudo passwd -uppercase s for status, and then the user ID that I want to check the status for, which is test user add m. And here we see the user ID, the uppercase L shows us that the account is locked. Then we also see the last time the password was changed. The 14 is a minimum number of days before a password can be changed. The 30 is the maximum number of days before the password must change. The 7 is the number of days to start showing the warning message before the password expires, and the -1 shows the password is set to never expire. When we unlock this account, the user will be able to log in again with the same password as long as it has not expired. I will unlock this account with sudo usermod -uppercase u for unlock, and then the user ID that I want to unlock, which is test user add m. And pressing enter, that user account is now unlocked. And we can see it's unlocked by looking at the shadow file. We see the exclamation point is gone, and checking the status. And we see the L has changed to a P, and the P stands for the password is set. Now we have 3 different ways an account can be locked, and they all lock the account in the same way. Let's lock test user add m again with sudo usermod -uppercase L test user add m. And locking the account with one of these 3 ways will prevent that user from logging in. But they can still SSH in if they have their key in the system. And we haven't talked about SSH or private keys yet, but we have talked about the switch user SU command, and we can still switch user into a locked account with sudo SU for switch user, and then the account ID that we want to switch into, and that is test user add m. And there we get our warning that our password will expire in 2 days, and typing who am I shows us that we have logged into test user add m, the account that we just locked. I'm going to exit out of that account with exit. To lock the user account and make it unusable, often system administrators will set the user's shell to bin no login. Let's do that now for our test user add m account with sudo usermod -lowercase s for shell, and we're changing the shell to bin no login. And we want to do this for user test user add m. Now when I try to SU into test user add m with sudo SU test user add m, we get our password expiration warning again, but we also get the message cannot execute /bin/no login, no such file or directory. Another popular way system administrators make the account unusable is to change the shell to bin false. And I'll do that now with sudo usermod -lowercase s for shell, and I want to set that to bin false for test user add m. pressing enter. Now when I try to su into test user add m with sudo su test user add m, I still get the warning my password's going to expire message, but I don't get any other message, and it does not allow me to log in as that user. Now, when I did this on my Ubuntu server, I tried to SSH in with my key on the server. I found that when I set the shell to bin false, it would record the login time, even though it would not allow me to log in. And when the shell was set to bin no login, the login time was not recorded. You can see the times and dates a user logged into a Linux system by typing last, and then the user ID. For example, I'll type last test user add m. Another way to lock the account is with the command user chage-e0 and then the user ID. And then if you want to reset or disable the password aging, you can reset the values by setting the minimum password age to 0, the maximum password age to 99999, password inactive to -1, account expiration date to -1. And there's also an interactive mode command by typing chage in the user ID. I'll type that now, sudo chage test user add m. It's now asking me to reset the password age. I'm going to change that to 0, 99999, -1, -1. And for this one, I'll just press enter, since -1 in that brackets is what it will set it to. And here I'll set the account expiration date also to -1. And let's check the status now with sudo passwd-s for test user add m. And there we see we've reset all the default values. So now we've locked the account for a period of time, and we are convinced that the user is no longer needed, and we now want to delete that user. Most of the time, we want to delete the user and all the files for that user. But occasionally there are times when we may want to keep the files for the user ID, but still delete that user account. We'll do this both ways. First, let's delete the user ID and keep the user files and directories. I'm going to delete the user test user add m, but before I do that, let's take a look at test user add m's home directory. To do that, I will type ls-lah/users. Remember, we moved the home directory to the users directory a few videos back. And there we see test user add m's home directory. And let's list out the files in that directory with ls-lah/users/test user add m. I'm making a note that the desktop directory, as well as all the files and directories, are owned by test user add m, and they also all have the group owner of test user add m as well. All except for that ..., directory. That's the users directory, which is owned by root, and we talked about the .. and the .. directories in a previous tutorial. I am going to delete test user add m with the command sudo userdel test user add m. And pressing enter, we get the usual Linux no news is good news. So let's check for test user add m with sudo chage-l test user add m. And we get the message test user add m does not exist in the etc password file. Let's make sure test user add m's home directory is still there by typing ls-lah/users. I misspelled that. Let's bring that back with the arrow up and add the s on the end and run it again. And we see the test user add m home directory is still there, but notice it is now owned by user ID number 1003. And the group is now owned by group ID 1003. And when I list all the files with test autocomplete, we see that the desktop directory, as well as all of the files and directories, are owned by user number 1003 and have a group ID of 1003. So the user and group names were deleted, but the user ID number and the group number were not deleted. Since every file and directory needs to have a user ID and a group ID, Linux just shows the user ID number and the group ID number because there's no longer a name for either one of those. So all our files are still there for test user add-m, which is what we wanted. Now let's delete the user test add user. This time we want to delete the home directory for test add user at the same time we delete the user. We can find test add user's home directory in the home directory. So let's show that with ls-lah/home. And there we see the test add user home directory. I'm going to delete the test add user and the home directory with sudo del user. This time I want to remove the home directory for test add user, so I'm going to add in the option -- remove home. And then we'll add in the username test add user. Pressing enter, it is showing us that it is removing the test add user home directory. And let's show that with ls-lah for the home directory. And we see that the test add user directory is gone. And to show the user is gone, I will type sudo chage -l test add user. And we see that the test add user does not exist in the etc passwd file. In the next video, we will continue looking at the Linux command line. Up to now in this series, we've been using the privileged user that was created when we installed the operating system. I've added some new users with the add user command, and this creates home directories for the users. And I've added 2 users because we're going to look at 2 different methods to make the standard users privileged users. The first thing I'm going to do is open a new terminal by clicking on File, Open Terminal, and I'm going to use the light profile that we created back in video 2 of this series. In this terminal, I'm going to switch to the Mary user with sudo su Mary. And I'll go to her home directory with cd and print that out with pwd. I'm going to try and view the root directory as Mary with ls-lah/root. We get the permissions denied error, so I will add sudo ls-lah/root. And here we see that Mary does not have privileges to view the root directory. To make Mary a privileged user, I'm going over to the other terminal where I'm logged in as the Michael user, a privileged user, and I'm going to make Mary a privileged user by updating the sudoer file. To update the sudoer file, I will type sudo vi sudo. And notice that the vi sudo is all one word. It is not vi space sudo. It's the single word vi sudo. And pressing enter, and this takes us into the sudoers file. But notice on this Ubuntu-based operating system, we're using nano and not vi, even though the command is vi sudo and not nano sudo. We want to add the Mary ID to this file, and we want to add it right below this line here, this user privilege specification line. So I'm going down to that, and that line itself, user privilege specification, is just a comment. We see that hashtag on the left. That means that this is a comment. Below that, we see root all equals all. That's giving the sudo privileges. I'm going to press enter and add Mary right below root. And the rest of this line, I will just type the same thing. All equals left parent all colon all space all. And I'm using all uppercase because they're using all uppercase for the root user. I want to save this, so I'm going to hold down Control and press X to exit, and then Y to save, and Enter to not change that file name. Now let's go back over to the other terminal where we're logged in as Mary. I'm going to press the arrow up and enter. We need to type in Mary's password again. Pressing enter. We can now see the root directory showing us that Mary is now a privileged user. I'm going to exit out of Mary by typing exit. And I'm going to log in as the George user with sudo su George. And I'm going to go to his home directory by typing cd and then pwd. And we see that we are now in George's home directory. I'm going to clear the screen and try and view the root directory with ls-lah/root. Permissions denied, so we'll add sudo ls-lah/root. And we see that George does not have privileges to view the file. I'm going back over to the other terminal where I'm logged in as Michael, and I'm going to add George to the sudo group. I know we haven't talked about groups or file ownership yet, and we will be getting to that shortly. For now, we just need to know that adding George to the group sudo will make George a privileged user. First, let's look at the groups that the user ID Michael has. For that, I will type ID. I can press enter here, or I can add on Michael. Here we see a list of groups that the Michael user ID is in. The one that we're interested here is sudo. This is the group that will give us access to run the sudo command. Note, if you are using Red Hat or CentOS, instead of using sudo for the group, they use the wheel group. And most likely that name wheel comes from someone who is a big wheel or someone important. We are not using a Red Hat-based release here. We're using a Debian Ubuntu-based release, so we are using the sudo group. If you don't know which group your distro uses, you can check that in the sudoers file. I'm typing sudo, vi sudo, and we see right down here, allow member of group sudo to execute any command. Now we also see above that, members of the admin group may gain root privileges. That admin group is only there for backward compatibility. We are going forward and not backward, so we want to use the group sudo. I'm going to exit out of here without saving anything by pressing Ctrl X. And I'm going to add George to the sudo group with the user mod command that we have seen in previous tutorials in this series. I'm typing sudo user mod, then a dash because these are options, and an A for append, then the uppercase G for group, and then the group name that we want to add the user to, which is sudo, and then the user ID, which is George. He should be added to the sudo group. Let's check it out by going over to the other terminal. I'm pressing the arrow up, sudo ls-lah/root, password for George. And we see that George is still unable to view the root directory. The problem is George needs to sign out and then back in to update the root privileges. So I will exit out of the George ID with exit, and then go back in with sudo su George, and go to his home directory so there's no confusion on who we're at. cd pwd. We are in the George home directory. We're logged in as George, and I will type sudo ls-lah/root. We can now view the root directory showing George has root privileges. In the next video, we will continue looking at the Linux command line. When I type ls-lh, we see the files and directories in this directory, and up to now, I haven't really said much about the first, third, and fourth columns that we see here. In this video, we're going to look at what they are and why they're important. We're going to start with the third column. The third column is the user owner of the file or directory on the right. You'll see why I'm calling this the user owner in a moment or two. The fourth column is the group associated with the file or directory. Every file and directory must have a user owner and a group assigned to it. When I type ID or ID Michael, we see the user ID for Michael and the group ID for Michael, and then all the groups the user ID Michael is a member of, and notice they all have a number with the name. Linux uses the numbers. The user ID name and the group name, they're there just to help us humans know that user ID 1000 is for Michael and group ID 1000 is the group for Michael. A few videos back, we deleted a user but kept the files. Since the user ID was gone, there was no name to display as the user owner or the group. So all we saw was the user owner number and the group number. So files and directories must have a user owner and a group. Now that we know what columns 3 and 4 are, let's look at the first column. And I think we discussed this first character of that first column in an earlier tutorial in this series. That tells us what type of file it is. If we have a D, it's for a directory. If we have a dash or a hyphen, it's for a file. And we've also seen the L for a symlink. There are a few others, but those are the three most common. The rest of this first column are the file permissions. Let's look at the permissions for the documents directory. The permissions column is broken up into 4 sections. The first section we just talked about, and that's that first character that tells us the file type. The next section tells us the permissions of the user owner from column 3. And we see these permissions are R for read, W for write, and X for execute. And they use an X instead of an E for execute. So the user owner has read, write, and execute permissions. The third section is the group permissions. If you're not the user owner of the file from column 3, but you are a member of that group from column 4, you have read permissions, and instead of write permissions, you've got a dash, meaning group members cannot write to this file, but they do have execute permissions. The fourth section are the permissions for anyone who is not the user owner of the file. They're not in the group, but they do have access to this file. And in this case, those permissions are the same permissions as the group. They can read the files, they cannot write the files, but they can execute a file. In this case, we're looking at a directory. And just because the directory permissions says they have access to read and execute, doesn't mean they can read and execute every file in that directory. The permissions for a file or directory in that directory have a priority over the directory permissions. When I say that, I mean if there's a file in that directory that has all dashes for the group and other, those no access dashes will override the folder directory permissions. Group and other will not have any access to that file or directory. Although they'll be able to see the file name or the directory name, they will not be able to do anything with that file or directory. A file owner can change or modify the permissions of their files with the chmod command. Chmod is for change mode of a file. I'm going to change the permissions for the nanofile.txt file, and to do that, I will type chmod for change mode, and I want to change the user owner to have read, write, execute privileges, so I will type U for user owner, then equals to assign the permissions of read, write, execute. Now I'm going to place a comma to separate things, and then I'll put a G for group, and I'll put an equal sign to assign the permissions of read and execute. Notice I did not place a dash or a hyphen in there, just the R for read and X for execute. And now another comma, and I will give the other permissions of read only, so O equals R. Then I will add a space and the file name I want to change, which in this case is nanofile.txt. Pressing enter and ls-lh shows us that the nanofile.txt file permissions have been updated. Here you can see why I've been referring to the file owner as the user owner throughout this video. Because when you update the file permissions this way, O is for other and U is for user owner. If we want to give everyone the same permissions, like read only, I can type chmod ugo for user, group, and other, and then the equal sign. That will set the permissions equal to what I place after the equal sign. In this case, it's an R. Then our space and the file name, nanofile.txt, pressing enter, and ls-lh shows the permissions are set for user, group, and other to only have read privileges. Instead of the equal sign, we can use a plus sign to add permissions. Let's say that I want to add execute permissions for the user owner, the group, and other. I can do that by typing chmod u for user, g for group, o for other, plus to add the permission of execute. And because I have user, group, and other, instead of typing ugo, I can use an A. So now I'm using A for all, and I'm adding the execute privilege, and I want to do that for the nanofile.txt. And ls-lh shows us that now we have read and execute privileges for everyone for the nanofile.txt file. We can also take away permissions with the minus sign, and we can do multiple changes in a single command. I will add write permissions for the user owner and take away the read and write permissions for the group and other with the command chmod u for user, and I'm going to add the write permissions with plus W, then the comma, and then G for group, O for other, and I'm going to take away the read execute permissions with minus RX. And this is for the nanofile.txt. And notice there's no space around the comma. When we do multiple changes at a time, there's no space between the changes, just a comma. And ls-lh shows that we've added the write permission for the user owner and taken away the read execute permissions for the group and other. If we're changing the permissions for a directory and we want the same permissions to be applied for every file and directory in that directory, we would need to add the uppercase R option for recursive. I'll type chmod uppercase R for recursively apply these permissions. We'll give the user owner read, write, and execute permissions. The group permissions will be read and execute. And then for everyone else, we will give them read permissions. I will give this the directory name, new directory. And typing ls-lh shows us that the new directory permissions are now set that way. Setting the privileges this way is called alphabetic notation or symbolic notation. They're the same thing depending on who you're talking to. It is when we can see the letters or the symbols. The other notation for setting privileges is called octal notation. We still use the same read, write, and execute for user owner, group, and other, but we use a single number to set the user owner privileges, a different number to set the group privileges, and a third number for the privileges of other. How this works is read, write, and execute each have a value assigned to them. Read has a value of 4, write has a value of 2, and execute has a value of 1. And then no privileges has a value of 0. If we add these up, 4 plus 2 plus 1, we get 7, the highest number we can have. But we can also use 0. So we have 8 different numbers we can use for the permissions, and that's where we get the name octal permissions. Let's look at an example. In this case, the user owner has read, write, and execute privileges. So we have 4 plus 2 plus 1, and we get 7. So the user owner octal privileges is 7. The group privileges are read and execute. 4 plus 1 gives us the octal number of 5. And the other only has read privileges, so their octal number is 4. Then we take that same chmod to change mode of the user privileges with those 3 numbers. Chmod 754 nanofile.txt ls-lh, and we see we updated the privileges using the octal notation this time. If we want to give the user owner full privileges and no privileges for the group or other, I would chmod the file permissions to be 700. And I'll do that with chmod 700 nanofile.txt ls-lh. And now only the user owner has privileges for this file. If you are working on a website or something connected to the internet, it's usually a bad idea to give the privileges of 777. Although you may need to at times, at least temporarily, you should still be careful when and where you do that. If you have a website with 777 privileges available to the general public, you are inviting hackers not only to add malicious code, but also they can execute that malicious code. In general, if you want the public to have write access to a directory, that's okay, but don't give them execute access for that same directory. And the same thing for the execute privileges. If you want the general public to be able to execute files, that's okay too. Just don't give them write privileges for that same directory. In the next tutorial, we'll continue looking at the Linux command line. In the last video, we talked about file permissions for the user owner, group, and other. We were able to change the file permissions for files we are the user owner of without needing to be a privileged user. From here forward, I'm going to refer to the user owner as owner. Standard Linux users cannot change the file owner, but they can change the group for their files, but only to a group of which they are a member. You may be thinking, why can't I give my file to someone else? It's my file. I should be able to share my files with anyone I like. And you can share what's in your files with anyone you like by changing the file permissions as we saw in the last video. But you will need to be a privileged user to change the owner of a file. There are a couple of reasons why you cannot just change the owner of one of your files or directories to another user ID. One reason is you may have a disk quota on your login ID, and if you change the owner of a file, that file would no longer count against your disk quota, and it will count against the disk quota of the user ID you just set it to. Another reason is someone might put some malicious code in a file and then change the owner of that file to your login ID. And then you could be blamed for putting malicious code on the computer. So only a privileged user can change the file owner. An owner can update the group for a file or directory he or she is the owner of, but as I mentioned earlier, it is limited to the groups that user ID is a member. To find out what groups my user ID is a member, I will type groups. If we want to see what groups another user ID is a member of, we would add that user ID after groups. For example, groups Mary shows that Mary is only in the group Mary. Groups Michael shows the username and then the groups that I am a member in. Note the groups plugdev, cd-rom, and ADM. We're going to use those groups in this video. Looking at the file permissions for the grocerylist.txt file, we see it has read and write access for the user and the group, but if you are not logged in as Michael and you are not in the group Michael, you can only read this file. I'm going to change the group permissions for the file grocerylist.txt using the chown or change owner command by typing chown Michael :plugdev grocerylist.txt. Here I'm saying change the owner to Michael, which is changing the owner to what it already is, so it's not really changing anything. Then I'm changing the group to be plugdev, and I'm doing this all for the file grocerylist.txt. Now I'll type ls-lh, and that shows the file group has been updated. To just change the group with the chown change owner command, I can leave off the user owner and start with the colon. Chown cd-rom grocerylist.txt. So nothing to the left of the colon means don't change the file owner, only change the group. And here again, we see the group was updated, but the file owner is still Michael. Another way to change the group for a file is with the chgrp command, which is short for change group. I'll change the group for the grocerylist.txt file with chgrp adm grocerylist.txt. And here again, we see the group was updated for the grocerylist.txt file. To only change the file owner, I will start with sudo, because I will need to be a privileged user to change the file owner. Then we need chown to change the owner. And then I will put in the new user ID that I want to change this to, which is Mary. And I don't need a colon or the group since I'm not changing those at all. I will just add in the file I want to change this for, which is grocerylist.txt. Now, if I placed a colon after Mary with no group, it would also change the group to Mary. But since there's no colon, it will only change the owner. I need to type in my password to submit a privileged user command. I made a typo. I'll type that in again. And then let's show the files with ls-lh. And we see the file owner is now Mary, but the group is still ADM. We can also use the period instead of a colon for any chown change owner command. The period and the colon are interchangeable. I'm going to change the owner and the group back to Michael with the chown command. I need to be a privileged user for that, so I will start with sudo chown Michael. And from here, I can put the colon Michael to change the user and the group to Michael. I can remove the group, but if I leave the colon, that will change the user and the group to Michael. And because the colon and the period are interchangeable for the chown command, I can also change this to Michael, period. And this will change the owner and the group both to Michael. I'll give it the file name, grocerylist.txt, ls-lh. And here we see the owner and the group were both changed to Michael. Using the chown command with just the user ID and no period or colon will only update the owner of a file. Using chown with a user ID followed by a period or a colon will set the owner of that file as well as the group of a file. In the next video, we'll continue looking at the Linux command line. I have added 6 more non-privileged users to the system: Prof. Scott, Prof. Sarah, Dan, Lisa, Ryan, and Brenda. I want to add a new group to this computer, but before I do, I want to see if the group exists. One way to see if a group exists is with the getEnt command. I will type getEnt space group and then the group name. I know that there's a group called sudo, so I will type in getEnt group sudo. Here we see the group name sudo and the group information following it, separated by colons. We see an X for the password, then the group number, then all of the user IDs of the members in this group, Michael and George. The group I want to add is called team. To see if the team group exists, I will type getEnt group team. And we see nothing showing us that there is no group called team. I'm going to add my new group with the group add command, and I must be a privileged user to add a group. So I will type sudo group add team, pressing enter, and our group is added. I'm going to add one more group, sudo group add, and I'm going to call this group delete me. To show the new group delete me was created, I will type getEnt group delete me. And we see the group was created. If I try to add a group that already exists, sudo group add delete me, I just get a warning message. So it's not a problem if we try to add a group a second time. To delete a group, I'll use the group del command. And again, we must be a privileged user to delete a group. I will delete the delete me group with sudo group del delete me. And now the group delete me is gone. And we can show that with get ent group delete me. And to make sure it's gone, I'm going to spell delete me correctly. And there we see it's gone. Now I'm going to change the name of the group team I added earlier to chemistry. This group is now going to be used for the chemistry department of the local university. To update a group name, I will use the group mod command, which stands for group modify. And it works the same way for groups as the user mod command works for users. To check the help for group mod, I will type group mod-h. And here what we want to do is change the name of the group, so we can use the -n option or the --new -name option. So I will type sudo, because we need to be a privileged user to modify a group, then the group mod command. And now I want the option, which can be -n, or I can use the --new name. And then I need to give it the new group name, which we want to be chemistry. And then we want to apply this all to the current group name of team. So we're going to give the new name chemistry to the group currently called team. Linux groups are stored in the file etc group. We can display the content of the etc group file with cat etc group. We do not need to be a privileged user to view the etc group file. It's very similar to the etc passwd file that we looked at in an earlier video in this series. Here we see our group chemistry at the bottom of the file. We see an X for the password. We didn't give it a password. Then we see the group number. And if they had any group members, we would see those group members listed right after that last colon. Just like the etc passwd file has an etc shadow file, the etc group file has a shadow file called etc gshadow. We need to be a privileged user to view the etc gshadow file, just like we need to be a privileged user to view the etc shadow file. So I'll view the etc gshadow file with sudo cat etc gshadow. And we see the content of the gshadow file. Looking at the chemistry group, it has the name chemistry. We did not give it a password, so the password shows as an exclamation point. Then we would see the group administrators, if there were any. And lastly, we would see the group members, if there were any members in this group, which there are not yet. I'm going to add some group administrators and some group members to the chemistry group. To add a group administrator, we can use the gpasswd command. Sudo gpasswd-a prof Scott chemistry. Here we have to use sudo because we need to be a privileged user. The command is gpasswd. Then we've got the -A option, which means set the administrator list. I want to set the administrator list to Prof. Scott, and then the group we want to do this for, which is the chemistry group. Pressing enter shows the standard Linux no news is good news. And to show that Professor Scott has been added to the chemistry group, I will type sudo cat etc gshadow. And we see Prof. Scott there as a group administrator for the chemistry group. Now we want to add Professor Sarah as an administrator on the chemistry group as well. So I will type sudo gpasswd-A for group administrators, and I will add Prof. Sarah, Prof. Scott, and then the group we want this for, which is chemistry. So when we're using that -A option for administrators, we need to give it the complete list of group administrators every time. And now we want to view the etcg shadow file again. And we see we now have 2 group administrators on the chemistry group, Prof. Sarah and Prof. Scott. As a Linux privileged user, I'm going to add Lisa to the chemistry group with sudo usermod -G for group, and we want to add the group chemistry, and we want to add that group to the user Lisa. I'm hitting the arrow up 2 times to view the etcg shadow file again, and we see Lisa was added as a member to the group chemistry. I'm going to add one more member to this group, and that will be Dan. To do that, I will type sudo usermod -A-G chemistry Dan. We're using sudo because we need to be a privileged user. Usermod is a command. The lowercase a means we want to append or add the uppercase G for group of chemistry. We have the chemistry going with the group, and we want to apply this all for the user ID Dan. When we added Lisa to the chemistry group, we did not use that -A to append the group. So in short, we were saying clear out all the members in the chemistry group and set it to a single user, Lisa. Now that we have Lisa in the group, we need to append the group with Dan. Otherwise, it would reset it and only have Dan as a member. I'm pressing enter. And we just added Dan to the group chemistry. Pressing arrow up, we will show what's in the G shadow file. Now we see we've got 2 group administrators, Prof. Sarah and Prof. Scott. And we also have 2 members in this chemistry group, Lisa and Dan. In the next video, we'll continue looking at the Linux command line groups. Picking up from where we left off in the last video, as a privileged user, we added 2 administrators to the chemistry group, Prof. Scott and Prof. Sarah. And we added 2 members, Lisa and Dan. To show what a group administrator can do, I'm going to open another terminal, File, Open Terminal, and make this the light theme. And I'm going to switch to Professor Sarah with sudo su-prof Sarah. As a group administrator, Professor Sarah can now add and remove user IDs from the chemistry group without needing to contact the IT department to have a privileged user add and remove user IDs from her group. Prof. Sarah can add Ryan to the chemistry group by typing G passwd-a Ryan chemistry. The -a is the option for add a member. Then we need to give it the user ID of the member we're going to add, which is Ryan. And then we give the group to which we want this all to apply to, which is chemistry. Pressing enter, we see that Ryan was added to the group chemistry. Prof. Sarah is not a privileged user, so she cannot see what is in the etcg shadow file, but she can view who the users are in the chemistry group with get ent group chemistry. And here we see that Ryan was added to the chemistry group. Prof. Sarah can delete users from the chemistry group with G passwd-d for delete. G passwd-d Dan chemistry. So we're going to delete Dan from the chemistry group. Pressing enter, we see that Dan was removed from the chemistry group. And here we do the get ent again to show that Dan was removed from the group chemistry. Administrative users can also set, reset, or remove a group password. I'm going to set the password for the chemistry group as Professor Sarah by typing G passwd and then the name of the group, chemistry. We're asked for the new password, and I will type that again. And Prof. Sarah has just set a password for the chemistry group. I want to create a directory for the chemistry group, but Prof. Sarah is not a privileged user. She is only an administrator for the chemistry group. So I will switch back to the other terminal where I am logged in as privileged user Michael. And I will create the new directory with sudo make dir srv chemistry. I've made the new directory and I'm going to cd into the srv directory and type ls-lh so we can see the new chemistry directory, file permissions, and ownership. I'm going to change the group for this new directory to be the chemistry group with sudo chgrp chemistry. So we are telling Linux to change the group to chemistry for the directory chemistry. And typing ls-lh, we see that the group was changed to chemistry. I also want to change the permissions of the chemistry directory, so I will type sudo chmod 770 chemistry. And I'll show that update with the ls command. And here we see the root user has full access, anyone in the chemistry group has full access, and there is no access for anyone who is not the root user and not in the chemistry group. I'm going over to the other terminal again, and I'm going to exit out of Prof. Sarah by typing exit. And now I'm going to switch to the user ID Brenda by typing sudo su-Brenda. Brenda is not a privileged user, and she is not a member of the chemistry group. I will show this by typing ID, and we see that Brenda has the GID or group ID of Brenda. As Brenda, I will try to cd to change directory into the chemistry directory with cd srv chemistry, and we see she gets a permissions denied. But if Professor Sarah, who set the password for the chemistry group, gives that password to Brenda, Brenda can temporarily be a member of the chemistry group by typing new grp for new group chemistry. Now she's asked for that chemistry password. She can type that in. And now when I type ID, we see that Brenda has the group ID of chemistry. Brenda can now cd into srv chemistry, and she now has read, write, and execute privileges for anything in that directory. As Brenda, I will type touch new file 1.txt, and the file new file 1.txt is created. Brenda will continue being a member of the chemistry group until she either new groups back to Brenda, types exit to exit out of the chemistry group, or logs out. I will type exit to exit Brenda out of the chemistry group. Typing ID shows once again Brenda has the GID of Brenda, and typing exit again takes us out of the Brenda user ID, and I'm back to the Michael user ID. Now I'm going to switch to the Ryan user ID with sudo su-Ryan. Ryan is a member of the chemistry group. As Ryan, I'm going to cd into the srv chemistry directory. I will add a text file in this directory with touch testfile2.txt. Now typing ls-lh to see the files in this directory, we see that Brenda created her file with a group of chemistry, but the file Ryan created has a user and a group of Ryan. And looking at the file permissions, only Ryan can read and write to this file. There may be times when he wants to do that, but most often he is going to want to collaborate with the other group members in this group. Typing ID shows us Ryan has a user ID of Ryan and a group ID of Ryan, but he can temporarily change that group ID to be chemistry the same way Brenda did by typing new grp chemistry. Now Ryan will create a file, and we will list those out with ls-lh This shows that Ryan's new file has a group permission of chemistry, but Ryan may want to change the group for his testfile2.txt file. He can change the group with chown: chemistry testfile2.txt ls-lh to show that it's updated. And now all the files have the group of chemistry. Ryan's group ID will stay that way until Ryan exits out of the chemistry group or until he logs off. I will type exit, and his group ID is back to the Ryan group ID. I'll show that with ID. Ryan only uses this login for the chemistry group, and he wants to permanently change his group ID to be the chemistry group ID. To do that, we need to contact a privileged user. Only a privileged user can update the group ID. I'll switch back to the other terminal. And to update Ryan's group ID, I will type sudo usermod -g to set the group ID. Then the group ID I want to set this to, which is chemistry. And then the user ID I want this all to apply to, which is Ryan. In the last video, we used the user mod with the uppercase G, which removed all the group members and set the group to have a single group member of Lisa. Then we added member Dan with an uppercase G option, but we also had to use the lowercase a with the uppercase G to add or append Dan as a group member. And if we didn't have the -a, it would have taken out Lisa and made the group members only Dan. In this case, we just want to update the group ID, so we use the lowercase g, and then the group that we want to change it to, and then the user ID we want to apply it to. Pressing enter, that was updated, and we can show that with ID Ryan. Now we see that his GID or group ID is chemistry. And how I remember which G to use and when to use the -lowercase a option is, when we type ID, we see the lowercase g right there for GID. So lowercase g is for the group ID, and we never use the lowercase with a lowercase. So the lowercase a will never go with the lowercase g, and we almost always want to use it with the uppercase G. In the next video, we'll look at more permissions for the Linux command line. In this video, we're going to look at the setuid flag. Looking up what the setuid flag does, we'll find a definition similar to this. Setuid is a permissions bit flag. When the setuid bit flag is set, it allows the users to run an executable with the permissions of the file owner. And then the most common example people use to explain setuid is the passwd command. Every user on the system can update their password with the passwd command. The passwords are stored in the etc shadow file, a file owned by the root user. So when the standard user runs the passwd command, they run that command as the root user, which allows them to update their password in the etc shadow file. To find out what file is being executed when I type passwd, I'm going to type which passwd. And Linux tells us we're executing the file /usr/bin/passwd. So when I type passwd, I'm really saying go to the /usr/bin directory and run passwd from there. To see the permissions of the passwd file, I will type ls-lh usr bin passwd. Here we see an S where we usually see an X or a hyphen for the owner execute permission. That S is showing us the setuid bit is set for the file user bin passwd. The owner of that file is root, so when anyone on the computer executes that file, it is executed as the root user. Running this file as the root user allows a standard user to update their password in the etc shadow file, a file that only root and privileged users have access to. Now that we know the basics of how setuid works, let's try and create our own executable file. I'm going to clear the screen, And I'm going to make a new directory for our setuid test. Sudo make dir srv setuid. Now I'm going into the srv directory with cd srv and showing it was created with ls-lh. We see that the owner and the group are now root. I'm going to change them both to Michael with sudo chown Michael dot setuid. And now we see the owner and the group are both Michael. And the permissions show Michael has full permissions and everyone else has read and execute permissions for this new setuid directory. Inside the new directory, I'm going to create a directory called private with make dir srv setuid private. I'll set the directory permissions to be 700, so only the owner of Michael has access to that new directory. Chmod 700 srv setuid private. And I want to put some super secret files in this new private directory. I will add them with touch srv setuid private super secret files 1.3.txt will create 3 super secret files. And now, because I'm the Michael user, I can see what is in that private directory with ls-lh srv setuid private. And typing ls-lh setuid shows us the owner and the group are set to Michael and that only the owner has access to this directory. I'm going to open a new terminal tab with the light theme that was created early on in this video tutorial series. And in this tab, I'm going to switch to the Mary user with sudo su-Mary. And now, as Mary, I'm going to try to read the directory with an ls srv setuid private. And we see that Mary does not have permissions, which is what we expect. The plan now is to create an executable file to read the private directory and turn on the setuid bit so Mary, or anyone on the system, can run that file and view what is in the private directory. I'm going back over to where I'm logged in as Michael, and I'm going into the setuid directory with cd setuid. Now I'm going to use nano to write a short script in the setuid directory that will read the private directory that only Michael has privileges to read. This is not a tutorial on bash scripting, so explanations will be minimal. Nano ls private.sh. This is a bash script, so I'm ending my file name with .sh. And every bash script starts with hashtag exclamation point or bang, which is often referred to as shebang /bin bash. And then our bash script will have a single line of ls-lh srv setuid private, which will just list out the content in the private directory. Holding down Control X to exit out, save the modified buffer, yes. And I want to keep that same name, so I'm just pressing enter and typing ls-lh to show the new bash script was created. Now we want to enable the setuid flag for this file, and we can do that with the usermod command. I will type chmod u plus s ls private.sh. And the u plus s is setting the setuid flag for the user. Let's take a look at that with ls-lh. And we notice the S in our permissions doesn't look quite right. It's an uppercase S. When we looked at the passwd file permissions, we saw it as a lowercase s. The uppercase S means the set UID flag is set, but the file is not set as an executable file. We can fix this with chmod plus x ls private.sh. Now when I type ls-lh, we see that lowercase s and everything looks correct. Let's try out the executable with the Michael user. To run an executable in the same directory, I can type // and then the file name of ls private.sh, and we see that it runs. Or I can give it the full path name of /srv setuid ls private.sh, and we see that runs as well. Now let's switch over to Mary and see if she can run this as the Michael user. Mary will type srv setuid ls private.sh, and we see she gets a permissions denied. The setuid is not working for a bash script file. Going back over to the terminal where I'm logged in as Michael, let's take another look at that passwd file. I will cat out that file with cat user bin passwd. And we see a lot of special characters, which tells us this is not a bash script, but a compiled program. I'm going to clear the screen with clear. To make this script into a compiled program, I'm going to create a new file with nano ls private.c. This new file is going to be a C program that we're going to compile. I'm going to paste in some C code, but the only line we're really concerned with is a line where we do the ls-lh for our directory /srv/setuid/private. That's the same line that was in our one-line script. I'm going to exit out with Control X, Y to save the modified buffer, and Enter to save the name as it is. I'm typing ls-lh to show that file was created, but now we need to compile that C code. And to do that, I'm going to type gcc ls_private.c-o ls private. And what the GCC stands for is the GNU C compiler, and we have the file name we're going to compile, in this case ls_private.c. Then the -o is for output, and then we give it the output file name that we want for our compiled C program, which is ls_private. Pressing enter, we see it compiled with no problems. Typing ls-lh shows that it was created, but we still need to enable that setuid flag. This time I'm going to set it with the octal method. Normally, when we use the octal method to set a file or directory's permissions, we'll only see 3 digits. We're actually using 4 digits every time, but that first digit is a 0. So 0755 and 755 are the same thing. They both mean no special permissions, just the regular file permissions. To set the setuid flag with the octal method, I'm going to change that first position from a 0 to a 4. So my chmod will look like chmod 4755 ls private, and pressing enter. Now typing ls-lh shows us the user is Michael and the setuid flag is set. So if this works as described at the beginning of this video, when someone runs this command, they will run it as the user Michael and be able to view the contents of that private directory. First, I will run this as the user Michael with the full path srv setuid ls private. And we see it works. Now let's run that as Mary srv setuid ls_private, and she still gets a permissions denied. This still does not work, but we have one more thing that we can do to try and make this work, and that is to change the file owner to be root. Let's go back over to the other terminal tab. To change the owner of the ls private file, I will need to be a privileged user, so I will start with sudo chown root.ls_private. Doing the ls-lh now shows the file owner and group are now root, but we lost the set UID. I need to set that again with sudo chmod 4755 ls_private, typing ls-lh to make sure that was set. We see the S for the user executable bit. So let's try it as Michael/srv set UID ls_private. Still working there. Now let's try this as Mary. Pressing the arrow up. We see that that now works. So now we can update our set UID definition, at least for an Ubuntu-based Linux Mint Mate operating system, to be set UID is a permissions bit flag. When the set UID bit flag is set, it allows the users to run a compiled executable with the permissions of the file owner, and the file owner must be root. In the next video, we'll continue looking at special permissions for the Linux command line. In this video, we're going to look at enabling the setGID flag and the sticky bit. The setGID flag is for set group ID. And to see how this works, we're going to use the chemistry group directory that we created in an earlier video in this tutorial series. To see what users we have in the chemistry group, I'm going to type get ent group chemistry. And we see the users Lisa and Ryan. We updated Ryan's GID to be chemistry, and we can see that when we type ID Ryan. I will type ID Lisa to show that Lisa still has her original group of Lisa. I'm going to open a new terminal tab with the light colored theme that we created back at the beginning of this tutorial series. I'm going to switch to the user Lisa with sudo su-lisa. Lisa is a member of the chemistry group, so she can cd into the /srv/chemistry directory, and she can create a file with touch testfile4.txt. Typing ls-lh, we see that Lisa has the same problem that Ryan had. When Lisa creates a file, it sets her group ID as the new file's group ID. To get around this problem, Ryan changed his group ID to be chemistry, and Brenda used the new grp command to temporarily change her group ID to be chemistry. We don't want to make all the chemistry group members update their GID or make them new grp before making any files in the chemistry directory. That is where the setGID bit comes in. Because we need to be a privileged user to set the GID flag, I'm going back over to the terminal tab where I'm logged in as Michael. I'm going to type ls-lh/srv to show the chemistry directory, user owner, and group have read, write, and execute permissions, while other has no permissions at all. To enable the setGID flag for the chemistry group, I'm going to type sudo chmod g+s/srv/chemistry. And to show the permissions were updated, I will type ls-lh/srv. And we see we have enabled the setGID bit because we see the lowercase s in place of the group execute bit. Now let's switch over to the terminal tab where Lisa is signed in, and I will create a file with touch testfile5.txt ls-lh. And we see when Lisa creates a file now in the chemistry directory, the group ID is set to chemistry. So here we see that enabling the setGID flag for a directory will give new files created in that directory the group of that directory. To disable the setGID, I will need to switch back to the Michael user, and we can disable that setGID flag with sudo chmod g-s/srv/chemistry, and then typing ls-lh/srv shows the setGID flag has been disabled. Going over to the other tab and typing touch testfile6.txt and then ls-lh, we see the new file was created with the group of Lisa. Going back over to the terminal where I'm logged in as Michael, I'm going to enable the setGID flag again, but this time I'm going to use the octal permissions. This is similar to what we saw in the last video, where we added the number 4 before the 770 for setUID. For the setGID, we're going to add the number 2. So I will type sudo chmod 2770/srv/chemistry. Switching over to the other tab, the Lisa user will create another file with touch testfile7.txt, and ls-lh shows us the new file has the group of chemistry. Going back to the terminal tab where I'm logged in as Michael, I'm going to clear the screen. Now we're going to look at how the sticky bit works. When people talk about the sticky bit, the explanation usually starts with the /tmp directory. The /tmp directory is a place where temporary files are stored. These files will be deleted after 10 days or on the next system reboot, whichever comes first. I'm going to type ls-lh / so we can see the /tmp file permissions. The thing to notice here is the file execute permissions for other. We see a lowercase t instead of the lowercase x. That lets us know the sticky bit is enabled. We are going to use the chemistry directory, which we already have set up, to show how this sticky bit works. I'm going over to the other tab where I'm logged in as Lisa, and I'm going to log out of Lisa with exit. And now I'm going to log in as Ryan with sudo su-ryan. I'm going to clear the screen and cd into the srv chemistry directory. Typing ls-lh, we see the 4 files that were just created by Lisa, 2 files with the group of Lisa, and 2 with the group of chemistry. I'm going to type nano testfile7.txt, and Ryan can edit this file. I'm holding down Control X, Y, Enter. And now Ryan will attempt to edit test file 6 with nano testfile6.txt. And we see the message file testfile6.txt is unwritable. Holding down Control and pressing X to exit out. Now Ryan is going to try and delete test file 7 with rm testfile7.txt. And that gets removed without a problem. He's now going to try and remove testfile6.txt. He gets a message here asking him to confirm that he wants to remove testfile6.txt, a file that he does not have access to edit. Ryan will type yes, press enter, and typing ls-lh shows that both testfile7 and testfile6, which he has no access to edit, were both deleted. I'm going back over to the other terminal tab where I'm logged in as Michael. I'm going to clear the screen and check the permissions of the chemistry group with ls-lh/srv. And now we want to set the sticky bit for the chemistry directory. To do that, I will type sudo chmod o plus t. The O is for other. The T is for sticky bit, and we want to do that for the srv chemistry directory. And because there's only one T, we don't need that O. I can say chmod plus T to add the sticky bit to the /srv chemistry directory. Pressing enter, we have set the sticky bit. I'm going over to the other terminal tab. And now Ryan will try and remove the test file 4.txt file that has a group of Lisa. Asking to confirm that he wants to remove that file. He types Y, and now he gets a permissions denied. Ryan will try and remove test file 5. That file has a group of chemistry. Pressing enter, he does not have permissions to remove that file either. Now Ryan's going to try and remove test file 3.txt. Ryan is the user owner of that file. Pressing enter, typing ls-lh, shows Ryan was able to remove a file that he was the user owner of. And that goes for every user in this directory. So the sticky bit works with the remove command, and when that is set, the user owner can only remove their own files. One last thing we need to do is go back over to the other terminal tab and type ls-lh/srv, and we see an uppercase T for the sticky bit. Because other does not have execute access for this file, it is an uppercase T, which is what we want. To remove this sticky bit, I will type sudo chmod -t, and it could be O -t, /srv chemistry. And the sticky bit is removed. I do want to enable a sticky bit again, and this time using the octal method. And with that, the sticky bit is going to be a value of 1. Remember in the last video, we enabled the set UID with a value of 4. Then earlier in this video, we enabled the set GID with a value of 2. And when we have no special permissions, we have the value of 0. So now we have the sticky bit that will have a value of 1. But we also want to enable the set GID flag. So we will want to add the 1 and the 2 together. Sudo chmod 3770/srv/chemistry. 1 is for the sticky bit, 2 is for the GID bit, and when we add them together, we get the 3. Now, typing ls-lh/srv shows us the sticky bit is enabled once again. In the next video, we will continue to look at more Linux Advanced File Permissions. I have added a group called Auditors, and I've added Brenda and Dan as members in the Auditors group. We'll see that by typing get-ent group auditors. And we still have Lisa and Ryan as members in the chemistry group. We'll see that with get-ent group chemistry. I'm going to open a new light tab, as we've done in the previous tutorials. I'm going to switch over to the Lisa user with sudo su-lisa. And Lisa will go into the chemistry directory with cd srv chemistry. Typing ls-lh, we see that Lisa has added 2 new subdirectories in the chemistry directory, one called Auditors Need to Read, and the other called Auditors Don't Need to Read. The problem we have now is we want everyone in the chemistry group to have edit permissions for the chemistry directory and every directory in the chemistry directory. But we also want to give the Auditors group read-only access to the chemistry directory, and then read-only access to the Auditors Need to Read directory. With the file permissions we've looked at up to now, we can't do this because we need one group to have edit permissions and another group to have read-only permissions for that same directory. To give 2 groups different permissions for the same file or directory, we are going to use File ACL permissions. ACL stands for Access Control List. Access Control List is a feature that may be turned off by default in some versions of Linux and may not work at all in other versions of Linux. Also, some of the older file backup programs may not recognize ACL file permissions. So it is possible to restore a file from a backup and have it lose the access control list permissions. The access control list feature is turned on by default on my version of Linux Mint. I'm going back over to the other tab where I'm logged in as Michael, and I'm going to cd into the SRV directory and type ls-lh. Currently, we don't have any ACL file permissions on either directory. I can tell that because files and directories with ACL permissions will have a plus sign to the right of the permissions. We'll see that in a moment. We can see file and directory ACL permissions with the command get FACL, which is short for Get File Access Control List. Then we add a space and the file or directory that we want to see the file access control list permissions. In this case, it's chemistry. And the result of this command shows us the same permissions that we see with the ls-lh command. We see the file name is chemistry, the owner of root, group of chemistry, and we see the set GID and sticky bit are set. Then we see the user and group both have read, write, and execute permissions, and other has no permissions at all. Now I'm going to add ACL permissions for the auditors group to give them read and execute permissions for the chemistry directory. The chemistry directory is owned by root, so we need to start the command with sudo, then the command itself, which is set FACL, which is short for set file access control list or set file ACL. Then what I want to do is modify the ACL, so I'm using the -m option. And I want to modify the group, so I will put a G next, then a colon in the group name, which is auditors, then another colon, and the permissions that I want to give it, which are RX for read and execute, then a space, and the file or directory name I want to apply this for, which is chemistry. Pressing enter, the new file ACLs are set. I'm going to clear the screen and type ls-lh. And now we see that plus sign after the file permissions that I was telling you about earlier, showing that this directory now has added ACL permissions. To see what ACL permissions are set, we'll use that get FACL command again. Get file ACL for the chemistry directory. We now have two new rows added. We now see a group auditors R-X showing the auditors group has read and write access. We also see a mask ::RWX. We're just going to note the mask settings are RWX, and we're going to talk more about the mask in the next video. I'm going to set the file ACL permissions for a user for the chemistry directory, and this is done just like setting the ACLs for a group permission, only we change the G for group to a U for user. So once again, I'll start with sudo, then set FACL for set file ACL, -m for modify, then the U for user, and we will change them for user Michael. I'll give Michael RWX for SRV chemistry. Pressing enter, then typing ls-lh. Doesn't change anything. We see the plus sign that we saw before, but no other changes than that. Typing get FACL chemistry. This shows we added one more row to the permissions. We see we've added user Michael to have read, write, and execute permissions for the chemistry directory. I'm switching over to the Brenda user with sudo su-Brenda. Remember, Brenda is a member of the auditors group. Brenda is going to cd into the SRV chemistry directory. And now she's going to try to cd into the auditors need to read directory. And she gets a permissions denied. I'm switching over to the other terminal tab where I'm logged in as Lisa. And Lisa can change the file permissions for the auditors need to read directory because she is the directory user owner. Lisa will type set FACL for set file ACL. She wants to modify for the group auditors, and she wants to give them read execute permission for the auditors need to read directory. Switching back over to the other tab, Brenda will try to CD into the auditors need to read directory, and now she gets in without any problem. I'm exiting out of Brenda with exit, and I'm back as the Michael user. And as Michael, I'm going to try to CD into the SRV chemistry auditors need to read directory. And this ID does not have permissions. When I gave myself permissions for the SRV chemistry directory, I did not include all the files and subdirectories. I'll fix that now by bringing back that command. And I'm going to add an uppercase R right before the M for modify. So I will set the file ACLs recursively, meaning for all the files and directories in the chemistry directory right now for Michael to have read, write, and execute permissions. Pressing enter, the Michael login ID now has read, write, and execute permissions for every file that is in the chemistry directory right now. Switching back over to the other tab and typing ls-lh, and I forgot the space, so I will do that again, typing ls space -lh. We see plus signs next to every file and directory, showing they all have the ACL permissions we just set for user Michael. Lisa is now going to add a new file and directory in the auditors need to read directory with touch, auditors need to read, and she will touch file1.txt, and she's going to make the directory auditors need to read dir1, listing out the content for the auditors need to read with ls-lh. Auditors need to read shows we have no plus signs next to the permissions, so no ACL permissions have been added. The reason the Michael user does not have any ACL permissions is because the command we ran gave Michael read, write, and execute privileges for every file in the chemistry directory at that time. And after that, we added these files, so they were not included when we ran that command. The auditors group was given read and execute permissions for the auditors can read directory, but we would like to give the auditors permission to the auditors need to read directory and every new file and directory created in the auditors need to read directory. This can be done by setting the ACL default permissions for the auditors need to read directory. Lisa is going to update the ACL permissions for the auditors need to read directory with set facle-d for default, and then we'll do the modify, and then we will add the G for group auditors for the group that we want to modify, then the RX for read execute, the permissions we want to give the auditors, and we want this all for the auditors need to read directory. Pressing enter, Lisa will now add a new file and directory with make directory 2 and touch file 2. And once again, she will ls-lh, the auditors need to read. And we see that directory 2 and file 2 both have ACL permissions added to them, showing the default permissions worked as expected. We'll continue looking at Linux ACL permissions in the next video. Picking up from where we left off in the last video, we're in the chemistry directory and we are signed in as Lisa. Lisa will now look at the file ACL permissions for the auditors need to read directory with get facle auditors need to read. This shows us the permissions that we set in the last video. Starting at the top, we see the file name, owner and group, and then we see the set GID flag is enabled. Then we see the two users. The first one is the permissions for the owner Lisa. The second one is the file ACL permissions for Michael that we gave in the last video. We're going to talk about the mask in just a moment. Let's finish talking about the rest of this list first. Below that, we see Other, which is for everyone that is not the file user owner and not in the group, and we see there are no permissions for them. Then we have the default permissions, and we set these up at the end of the last video. These permissions will be applied to every file and directory created in the auditor's need to read directory. And the thing to note about this is the auditors will get read and execute permissions for every file and directory created in that directory. Now let's talk about the mask. The ACL mask is a way to limit the permissions of the file ACLs without changing the user or group ACL permissions. We're used to seeing a mask that looks like this. It masks the face and allows the person wearing the mask to see. And if this clip art had eyes, you could see that better, but I think you got the idea. Our file ACL mask is going to have 3 holes in it. One for read, one for write, and one for execute. If we cover up or mask the write and execute permissions, the users and groups with ACL permissions can now only read the file, even if they have write and execute permissions, because the write and execute permissions are now hidden behind the mask. Lisa can change the mask permissions by updating the file permissions for that group. For example, Lisa will change the permissions and take away the group write and execute permissions with chmod G for group minus WX for write and execute for the auditor's need to read directory. Now typing get facle auditors need to read, we see our mask has changed to R-, giving only read access to our mask. Looking at the Michael user, Michael still has read, write, and execute permissions, but the mask only allows the read permission to be seen. Over on the right, we see the effective permission is set to read, meaning the Michael user was given read, write, and execute permissions, but the write and execute permissions are unavailable because the mask is hiding them. So the effective permissions for the Michael user is read only. Lisa is going to change the group file permissions for this directory and take away the read permissions and add execute permissions with the command chmod G for group minus R to take away the read permissions and plus X to add execute permissions for the auditor's need to read directory. Pressing the arrow up twice to get back the get facle. Now we see the mask is updated to execute only, and the effective permissions are execute only. Lisa can change the mask back by updating the user permissions again, or just by adding some new file ACL permissions. Lisa will give the Michael user full ACL permissions again with set facle -M for modify, user, Michael, RWX for read, write, and execute permissions for the auditor's need to read directory. Pressing arrow up to get the get facle command again. We now see that the mask is reset to the read, write, and execute permissions, and there is no longer any effective permissions. Now let's look at how to remove ACL permissions. The first one we're going to remove is the default permissions. To remove the default permissions from the auditor's need to read directory, Lisa will type set facle -K. So -K will remove the default permissions from the auditor's need to read directory. I'm pressing the arrow up to get back to that get facle command and then enter. We see we've removed the default permissions. The auditors still have directory permissions of read and execute. That just won't be applied to every new file and directory added to this directory. To remove the Michael ACL permissions from this directory, Lisa will type set facle -X, and the -X will remove the U for user, Michael, and that will be removed from the auditor's need to read directory. Arrow up again. And there we see the Michael ACL permissions have been removed, but the auditors still have read and execute permissions. Let's remove the Michael ACL permissions recursively from the SRV chemistry directory. To do that, I'm going over to the other tab where I'm logged in as the Michael user. We're going to start the command with sudo because this file is owned by root. Then we're going to set facle -R for recursively X the user Michael from the chemistry directory. I have now removed all the ACL permissions for the Michael user from the chemistry directory. I can show that by going back over to the other tab. Lisa will type ls-lh, and we notice all of the files still have that plus sign next to their permissions, showing there is some kind of ACL permissions. Let's take a look at one of these files. I will type get facle test file 4.txt. And we see the ACL permissions for Michael are no longer there, but we still have that ACL mask. To remove all of the file ACL permissions, we need to use the -B option. Going back over to the other tab, I will type sudo set facle -R for recursively. Then I'm using the B option. And then I'm adding the directory name we want to apply this to, which is chemistry. So the -B option will remove all of the file ACL permissions for every file and directory in the chemistry directory, as if they were never added at all. Going back over to the other tab, Lisa is typing ls-lh, and we see that plus sign is gone, showing us that there are no file ACLs for any file or directory in this directory. If we want the auditors to have access to the auditor's need to read directory, we will need to add those permissions back in once again. In the next tutorial, we'll continue looking at the Linux command line. In this video, we're going to look at file attributes. And like file ACLs, file attributes may not work on all Linux file systems. I'm going to bring up the man page for the change attribute command with man chattr. And scrolling down to the bugs and limitations section, we see that C, S, and U attributes are not honored by the ext2, ext3, and ext4 file systems. The Linux Mint Mate distribution I am using right now is using the ext4 file system, so those file attributes won't work on this file system. I'm pressing Q to get out of the man page. This video is not about file systems, but since I brought it up, one way to see what type of Linux file system you are using is to cat the etc fstab file. I'll do that now with cat/etc/fstab. I have the font increased and the lines don't line up perfectly, but if we look closely, we'll see there's a line for the file system and a line for the swap file. We have a comment showing what each field is, and going from right to left, we see pass, dump, options, and then type. Then this first line is going to be the file system. So going from right to left, we see 1, 0, errors equal remount -RO, and ext4. The ext4 is our file system type. And below that line, we have another line, and going from right to left there, 4 fields, we see that is the swap file. The swap file is used to help manage RAM memory. File systems are for another video. Let's clear the screen and get back to file attributes. I'm typing ls-lh to show what files we have in our home directory. And I want to see the file attributes for this bottom file we have, vi-file.txt. Anyone with read access to a file can view the file attributes for a file. I will list the file attributes with lsattr, and then giving the file name, which in this case is vi file.txt. We see a lot of dashes and then an E and then some more dashes. The E is the file attribute for extents, and that's for mapping out the blocks on a disk. We are not going to touch that file attribute, but we are going to look at some other attributes. I'm going to clear the screen again and create a file with the echo command. And I'm going to direct the output of this text into a file called importantfile.txt. To make sure this file does not get changed or deleted, we are going to enable the immutable file attribute. Immutable is just another word for unchangeable. So we're going to make the importantfile.txt file unchangeable with the immutable attribute. Most file permissions can be updated by the file user owner, but file attributes can only be updated by a privileged user. So I'm going to start this command with sudo and then the chattr command for change attribute. And then we need a space and then the attribute we want to change, which is the immutable attribute, and we want to enable it. So I will type plus lowercase I. And we can also think of the plus as add. So we want to add the lowercase I for immutable attribute. Then we need another space, and then the file name we want to change the file attribute for, which in this case is the importantfile.txt. Pressing enter. Now our file is immutable or unchangeable. Let's view the file attributes now with lsattr importantfile.txt. And we see the I for the immutable attribute has been set. I'm going to try to change the text in that file with the echo command, echo updated text, and we're going to output that into the importantfile.txt. Pressing enter, we get an operations not permitted error. And if I try to append some text into that file, we get that same operation not permitted. I'm going to try to remove that file with the rm command. Again, we get the operation not permitted. Let's try that again, but this time I'm going to add sudo remove importantfile.txt. So even as the root user, I'm unable to remove this file as long as it has that immutable file attribute set. I will need to remove the immutable file attribute before we can change or remove any file with the immutable file attribute set. And to remove the immutable file attribute, I will type sudo, because we need to be a privileged user to change the file attributes, then chattr for change attribute, then a space, and then a dash lowercase I, also known as the hyphen or the minus sign or the takeaway sign, to take away the immutable attribute. And then we need to give it the file name, which is importantfile.txt. And let's show that immutable attribute is now removed by typing lsattr importantfile.txt. And we do see the immutable attribute is gone. Another useful file attribute is the lowercase a attribute for append only. I'm going to add the append attribute to our important file with sudo chattr plus a to add the append only attribute. And we're going to do that for the file importantfile.txt. And to show that that's set, we'll type lsattr importantfile.txt. And there we see the lowercase a showing us the append attribute has been set. Now we should be able to add to that file, but we should not be able to change anything that's there or delete the file itself. Let's test out the append only attribute the same way we did the immutable attribute, and that is by trying to echo some text in there with echo updated text. And we're going to put that into the importantfile.txt file. Pressing enter, we see that operation is not permitted. Now let's try to append that data into the important file txt by adding on the extra greater than sign. That one looks like it worked. Let's cat out that file, cat important file.txt. And there we see that we were able to append that file. Let's also try removing that file with sudo remove important file.txt. And again, even as the root user, we're unable to remove this file with the append attribute set. The append only attribute is most useful for like a history file or a log file, where you want to keep the history of what happened in that file, but you want to add new data to that file. I'm going to clear the screen. File attributes can also be applied to a directory. I'm going to create a directory with mkdir, and then we're going to give this directory name chattr test. And now let's add in some files into this directory. So we will touch chattr test, and we'll call these files chattr test file, and we'll create 3 of them. 1.3 in the curly braces, .txt. Now let's make this directory immutable with sudo chattr for change attribute. Then we're going to use the -R, which is the option to recursively apply this command for every file in this directory. Then we're going to press space and the +i to add the immutable attribute. And then we're going to give it the directory name of chatter test. Pressing enter. The attributes are set for that directory. Let's see what that looks like with ls_attr for list attributes for the chatter test directory. And we see all 3 files show as immutable. I'm going to try to add some new files to that directory with touch chatter test files, and this time we'll call them 11 through 13.txt. And here we see that we are unable to add in any files into this directory. And bringing back the ls_attr chatter test command shows us that those new files were not added. I'm going to remove the immutable attribute from that directory with sudo chattr for change attribute, then the R to recursively apply the -i to take away the immutable attribute. And we want to do this all for the chatter test directory. And again, listing the attributes for the chatter test directory, we see that the immutable attributes are gone. The last thing we're going to do in this video is add in the append attribute for a file directory. We'll do that with sudo chattr -R space +a, and then the directory name of chatter test. Show that it's there with the ls_attr chatter test. And we see that we have applied the append attribute to the chatter test directory. Now let's try and add in some files with the touch chatter test files, and we will make these the 11 through 13.txt. Let's check out the status with the ls_attr chatter test command. And here we see we were able to add in these files, but notice the new files do not have the append attribute set. We will have to set the append attribute for those files if we want to make those files append only. But if we try to remove one of those files with sudo rm chatter test file, we'll give it 13.txt because that does not have the append attribute set. When I press enter, we still get an operation not permitted. This is showing us that because we set the directory permissions to append only, we can only add files to this directory and not remove them. In the next tutorial, we will continue looking at the Linux command line. To see the date and time, we can type date and press enter. This gives us the current date and time the computer thinks it is. And we also see the time zone here. This computer is using EDT for Eastern Daylight Time. With all the computers worldwide connecting to one another, they need a common time that all the computers can use. And that is UTC, also known as the Coordinated Universal Time Zone. To see the UTC time and date, I will type date-U. And we see here there's a 4-hour difference between Eastern Daylight Time and UTC. We can also use the date feature to see the date and time yesterday by typing date-D yesterday. And we can see the date for tomorrow with date-D tomorrow. To see the date and time 2 weeks ago, we can type date-D, quote, 2 weeks ago. And we need to put this in quotes because we have multiple values separated by spaces. These can be single or double quotes. Instead of saying 2 weeks ago, we can also use date-D minus sign 2 weeks. And that shows us the same as 2 weeks ago. And to see a date 2 weeks in the future, we can type date-D, quote, plus 2 weeks. And we don't need the plus sign. Typing date-D 2 weeks is the same as the date-D plus sign 2 weeks. We can ask for the date and time 2 weeks and 3 days from now with date-D 2 weeks, 3 days. And we can also have used the time. We could say something like date-D 2 weeks, 2 hours. And that will give us the date and time 2 weeks and 2 hours from now. To find out what day of the week Christmas 2025 lands on, we can type date-D 12/25/2025. And we see that Christmas 2025 lands on a Thursday. And now I want to change the format of how that date shows on the screen. Instead of showing the day in 3 characters, I want to see the whole day of the week spelled out. And I want to see the date in the format year first, then the month, then the day. To see how to do that, I'm going to check the man page. I'm going to clear the screen. Right here at the top, we see the -D option that we were just using. And paging down, we see the -U for UTC time, which we also just looked at. Paging down again, we see format controls the output. And we see that the uppercase A will show the full date of the week, one of the things I was looking for. And scrolling down a little bit, we see that %F will show the full date as year-month-day. Paging down again, we see the lowercase m is for month and the uppercase m is for minute. We also have a %uppercase T for time, and the lowercase y and uppercase y are for the 2-digit and 4-digit year. So there are a lot of choices for formatting the date and time. I'm going to quit out of the man page so we can see how this date formatting works. I'm starting with the date space, as we saw earlier, and to change the formatting, we need to use the plus sign. And then we add the formatting that we want. In this case, I'm going to use the %, uppercase F. And pressing enter shows us our date as year-month-day. I want to add in the full spelling of the day of the week, and I will do that by typing date plus, open quote, %, uppercase A, space, %, uppercase F, end quote. And we need to have this in quotes because we have a space between the formatting values. Now I used double quotes to show that it can be done in single quotes. I will change those to single quotes. And we see it works here as well. Now we can add more text inside those quotes if we like. I can say date plus today is %, uppercase A, space, %, uppercase F, end quote. Now I want to change those dashes in the date to a /, but I still want to keep that year, month, day format. So instead of the F, I'm going to use the uppercase Y for the year, the lowercase m for the month, and the lowercase d for the day. So now my command will look like date, space, +, open quote, today is %, uppercase A, space, %, uppercase Y, /, %, lowercase m, /, lowercase d, end quote. If I want to show the day of the week in double quotes, I might type something like this and add in our double quotes. Here we're going to have a problem because when it gets to the second double quote, it's going to think that it is the end quote. We have two ways to fix this. The first way is to just change the outer quotes to single quotes. But if we change the text just a little bit and want to say today's date is, then we've got a single quote that it will think is the end quote. So to fix this, I'm going to change the outer quotes back to double quotes. And I'm going to add in the escape character before the double quotes around the day of the week. So that escape character, the \, will make the next character, that double quote, part of the string and not the end of string. Pressing enter. And if you need to print out a \, we would just add that in as 2 backslashes to print a single \. I'm clearing the screen. Now, just like we formatted the date into a different format, we can do the same with the time. I'm going to type date plus %, uppercase T. And there we see just the time. I'm going to format the time into hours and minutes by typing date plus %, uppercase H, %, uppercase M. And this time we did not need the quotes, even though we had multiple values, because we did not have any spaces in between the values. So the quotes were not needed. If we want to see the time from a different time zone, we can do that by adding the time zone first with uppercase TZ for time zone. And then we'll put in an equal sign to set the time zone for this command. And then I'll put the time zone in quotes. And I will use the Los Angeles time zone with America /Los _Angeles, end quote, space, date. And here we see our time in Pacific Daylight Time. And then if we want to do any formatting for our time, we would do that after the date. We would add the + for the formatting and put in something like the %T to just have the time show. In the next video, we'll continue looking at the time and date for the Linux command line. For this video, I'm using Ubuntu 2010 to make sure that I'm using the most up-to-date version of Ubuntu Linux. I have turned off the automatic time and date from the settings menu. To see the time and date on this computer, I'm going to type time date CTL. This shows us that the local time is in EDT, or Eastern Daylight Time. Below that, we see the universal time, or UTC time. We talked about that in the last video. Below the UTC time, we have RTC time. And RTC stands for Real Time Clock, which is the clock on this computer. There's a little battery inside the computer keeping the clock running when the computer is turned off. And then we see the time zone. We are in the America, New York time zone, which is EDT for Eastern Daylight Time. Then we see a -sign 0400. That is telling us that the Eastern Daylight Time Zone is 4 hours less than the UTC time zone. And we see that difference up here between the local time and the universal time. Below that, we see System Clock Synchronized is set to No, and NTP Service is set to Inactive. This means that we are not synchronizing the time from the internet. We can update the date and time with the date command that we saw in the last video by typing sudo date-s. The -s option is for set the time and date. And then I'll give it a time and date I want to set it to 2020-08-11. Pressing enter shows us we just set the date to August 11th, 2020. And since we did not give it a time, it is setting the time to 0 seconds, just starting the day. I'm going to arrow up to time date CTL again. This shows us that we updated the local time and the universal time, but the real-time clock was not changed. We can update the real-time clock with sudo time date CTL set time, and then I'll give it the time and date I want to set it to, which is 2020-07-22. Pressing enter shows me that I typed time date CTL wrong. Sudo time date CTL set time 2020-07-22. This time we don't see the time and date was updated. To show the update was successful, I will go back to the time date CTL command. Notice this time the real-time clock date was set to July 22nd, 2020, but it also updated the universal time and the local time. Because we did not give it a time, it set it to 0, just starting the day just after midnight. We see the universal time was set to 4 a.m. because of the 4-hour time difference, and the real-time clock is keeping time in UTC time, and that is shown here at the bottom with the RTC in local TZ equals no. The TZ stands for time zone. Now let's look at the System Clock Synchronized and NTP service. NTP stands for Network Time Protocol. NTP is a way of having your computer go out to the internet to a specific server, and those servers keep the time with an atomic clock, geopositioning, or the like to make sure that those have the most accurate time possible. We're not going to set up NTP in this video. There are some default servers that are already set up, and we're going to use those default servers. To turn on NTP, I just need to type sudo time date CTL set NTP true and press enter. And again, I spelled the time date CTL wrong. Let's fix that. And bring up the time date control again. We see that the local time and the UTC time are now set to the NTP server time. It also updated our real-time clock to the NTP server time. We see that the NTP service is active, but notice the System Clock Synchronized is also set to yes. I'm going to turn off the NTP service with sudo time date CTL set NTP false and bring back up the time date CTL. Now we see the NTP service is inactive. But notice the System Clock Synchronized still shows as yes. To see if the System Clock Synchronized is still enabled, I'm going to type sudo systemctl status systemd time sync d. Now, before we go any further, I need to mention what systemd is, because we're going to see systemd in future tutorials. Systemd is a system made up of modules or services. A lot of the systemd services have to do with starting up a Linux computer. The systemd-timesyncd is one of the services of systemd. Not all Linux operating systems use systemd, but Ubuntu and Red Hat CentOS operating systems do use systemd. And this is our systemd command. It starts off with systemctl. That is telling us that we're using a systemd service. The next part of it is status, because we want to know what is the status of our systemd service. And that systemd service we want to see the status of is systemd-timesyncd. Pressing enter, we see that this service is inactive, dead. But when we look at the time-date-ctl command, it still shows the system clock synchronized as yes, but it's not active. I'm going to press Ctrl-C to cancel out of here and update the date again with sudo date-s 2020-08-11. Bringing back up the time-date-ctl shows I was able to update the local and universal dates, and that the system clock synchronized now shows as no. I'm going to start the system clock synchronized with the command sudo systemctl start instead of status. And then bringing back the time-date-ctl shows that the system clock synchronized is now set to yes, and the NTP time is also active. So these two services work together to keep the time accurate. Now I want to change the time zone, but before I can change the time zone, I need to know what time zones are available. To find the available time zones, I will type time-date-ctl list-time zones. This shows a list of time zones using the less command. And remember, with the less command, we can use the arrow keys to go down and up, and we can also use the page down and page up commands. Here we see the America Los Angeles time zone, and I will cancel out of the less command with Ctrl-C, and I want to update my time zone to be the America Los Angeles time zone. To do that, I'm going to type sudo, because you need to be a privileged user to update the time zone, time-date-ctl set time zone, and then I'm going to put this in double quotes, America/Los Angeles. Pressing enter. And our time zone should be updated. To check it out, I'm going to type ls-l/etc local time. And we see right here that the time zone has been set to America, Los Angeles. Because we are running an Ubuntu operating system, we can also see the time zone with cat etc time zone. And then the other way we can see the time zone is with the time-date-ctl command that we've been using throughout this tutorial. And we see that the Los Angeles PDT, or Pacific Daylight Time, is set to 0700, meaning that it is 7 hours less than the UTC time zone. In the next video, we will continue looking at the Linux command line. When we type ls-lh, we see information about the files in the current directory. When I type ls-lh and a file name, like grocerylist.txt, well, let's clear the screen first. And type ls-lh grocerylist.txt, and here we see information about a specific file. In an earlier tutorial, we talked about inodes and that most of the information shown with the ls command comes from the inode of that file. But that is not all the information stored on the inode. To see all the information stored on the inode, we need to use the stat command. Stat grocerylist.txt. Here we can see a lot of the information for the ls command is the same as the stat command. The ls command starts with the file permissions, and we see them here for the stat command as well. The stat command also shows the octal permissions. The number of links is set to 1 for both the ls and the stat command. Then we have the user and group for the ls command, and it is also seen here in the stat command with a little more detail. Then we see the file size for the ls command and the stat command. We're going to come back to the date and time in a moment. We're going to skip over that and show that the file name is also easily seen for both the ls command and the stat command. Now let's look at the dates. we have one for the ls command, but we have 3 different dates for the stat command. For if you're including the birth date is to show the original creation date of the file, but that is not implemented in Linux. So we only have 3 different dates. We can see here that the modified date is what the ls command is using. But the stat command also includes the time with fractions of seconds and this -500 to the right of it. The -500 and 400 are the time zones for the date. The -500 is for the Eastern time zone when daylight savings time did not apply. The 500 is 5 hours less than UTC time. The -400 timestamps are for the Eastern time zone during daylight savings time. In the spring, clocks are set 1 hour ahead for daylight savings time. So now they're the same as UTC time -4 hours instead of 5 hours. Then in the fall, daylight savings time ends, and the clocks are set back 1 hour, making them the same as UTC time -5 hours once again. Looking at these 3 dates, the dates are all different, and the dates are not even close. They are months apart. So how does each one get updated? Let's start with the modify date. The easiest way to change the modify date is by modifying the content in the file. I'm going to do that by typing nano grocerylist.txt and update this file down at the bottom by adding in the line new item 2. And I'm going to pause this video for a minute or two while I'm editing this file. Now I'm going to save the file by holding down Control and pressing X, then Y, and Enter. I'm going to stat that file again. Notice the access time is a few minutes less than the modify and the change time. That's because the access time is updated when I started Nano. Remember, I paused the video for 2 minutes before saving the file. The modify and change dates were updated when I saved the file. I'm going to pause the video again for a minute or two. And now I'm going to use the change mode command to change the file permissions. Chmod 760 grocerylist.txt. And we'll stat that file once again. And notice now only the change date and time was updated. This is because we did not modify the file content in any way, and we did not access the file content in any way. So only the change date and time was updated. I'm going to open another tab here. Now let's access the file without modifying it in any way. To do that, I will type cat grocerylist.txt. Going back to our original tab, I'm going to stat the file once again. And notice now only the access date and time was updated because we accessed the data, we viewed it, but we did not modify or change it in any way. So only the access time was updated. I'm going over to the other tab once again, and I'm going to cat the grocerylist.txt file once again. Going back to the original tab, let's stat that grocerylist.txt file again. And this time, the access date is the same as the last time. But a moment ago, catting the file updated the access time. This time, it did not. What happened? Why didn't the access time get updated just like it did a moment ago? The reason is the access time was used to keep track of every time the file was accessed until kernel update version 2.6.30. That was released way back in 2011. Most likely this change was made to help system performance. But here's how the access time works now after kernel update 2.6.30. The access time only gets updated on writes and once for the first read after a write. Remember, we updated the grocerylist.txt file, which did a write. Then I used cat to show what was in that file, and we saw the access time was updated. But now it won't update again until we do another file write. If you want to make the access time update after every access, you have to modify the fstab file to set strict datetime. This is going a little bit off topic, but since we looked at the fstab file a few videos back, we'll look at it here too. I'm going to type sudo nano/etc fstab. I'm going to add comma strict A time to the end of my options for my ext4 file system. So I'm going down to my file system right here. Then we see the slash is the mount point. Here's our type ext4, and these are the options. So right here after the O, I'm going to add comma strict A time. And because my font is a little big, it looks a little funny, but this will work. I'm going to press Control X to get out, Y to save, and Enter to write as the etc fstab. Now I'm going to reboot my machine to make the changes take effect. I've restarted the computer, so I will now type stat grocerylist.txt and go over to the other tab where I can cat grocerylist.txt. Going back to the original tab, statting that file again, shows me the access time was updated. But to make sure this works properly, I need to do it at least 2 times. So I'm going over to the other tab, catting the file once again, going back to the original tab, and statting it. Shows once again our access time was updated, so it is working as expected. Now some people just use the stat command to see if a file exists. They'll stat a file and we see how it exists, but if we add something like a 1 at the end, we see, oh, cannot stat the file, no such file or directory, so that's how you would use it to see if a file exists or not. A few videos back, we saw that we could customize the output of the date command. We can do the same type of thing with the stat command. Checking this in the man page, man stat, I'm going to page down, and here we see the valid format sequences for files. The ones I'm going to note here are the %A for access rights in human readable form, the uppercase G for group name of owner, the %N for file name, and the %X time of last access human readable. I'm pressing Q to quit out of the help screen. And to print out the stat information formatted, we need to add printf. So the stat command would now look like stat --printf equals, and %N will show the file name, and we want that for the file grocerylist.txt. And we see it printed that out, but it did not put a line return, so our prompt came right up next to our output. I'm going to press Enter and bring that up again, and I'm going to update that. I'm going to add a double quote and add some text, file, : space, and I also want to add a line return, so I'm going to use that escape character we saw in a previous video, and then the N for new line, and now the end quote. And then we end with the file name of grocerylist.txt. Pressing Enter, we see file is grocerylist.txt. I'm going to add in the other information into the same line. I had the last access time, so I'll say was last accessed on : %x, then the escape character N for a new line has a group of : space, %uppercase G, escape character N for new line, and permissions of %uppercase A. And then we're going to end with the escape character N for new line. Pressing Enter, shows us all the information, but it's kind of jumbled together there. So I'm going to bring that back by pressing the arrow up, and I'm going to end with an extra new line, escape character end for new line, and go to the beginning of this before the file and start with a blank line by adding the escape character new line. Now when I press enter, it looks a little nicer with the blank lines above it and below it. In the next video, we will continue looking at the Linux command line. I have created a new directory in my home directory called LCL for Linux command line. And I'm going to cd into the LCL directory and type ls-lh. We see that I've placed two new files in this directory, one called presidentsbyheight.txt and the other called grocerylist.txt. The grocerylist.txt file is just an edited version of the grocerylist.txt file from video 7 that we've been working with up till now. The presidents.txt file is new. Both of these files can be downloaded from my website. There's a link in the YouTube description to my website where you can download these text files for free. I'm going to type wc space grocerylist.txt. The WC stands for word count, or count all the words in this file, which will also count all the lines and the characters in this file as well. Pressing enter, we see 23, 26, and 187. And then the file name, grocerylist.txt. 23 is the number of lines in this file, 26 is the number of words in this file, and the 187 is the number of characters in the grocerylist.txt file. I'm going to cat out the content of this file with line numbers by typing cat-n grocerylist.txt. And here we see it starts with milk and ends with crackers, and there's 23 lines in this file. And a moment ago, we saw that there were 26 words in this file. We see 3 extra words because we have peanut butter, which has 2 words instead of 1, 3 times in this file on lines 5, 11, and 22. These 3 extra words give us 26 words in this file. If I only want to see the number of lines in this file with the word count command, I would type wc-l and then the file name grocerylist.txt, and then pressing enter, we only see the number of lines, 23, and then the file name. If I want to see the content of the grocerylist.txt file sorted, I will type the command sort grocerylist.txt. And to sort this file in descending order, I would do the same thing. I'm pressing an arrow up to bring back that command, but I'm going to add the -r option, and we see the output is now in descending order. When we use the sort command like this, I want to make sure that it's clear to you that this does not touch the content in the file grocerylist.txt. We're just reading the grocerylist.txt file, sorting it, and printing that sorted output on the screen. I will type cat grocerylist.txt, and we see the original content has not been changed in any way. It still starts with milk and ends with crackers. We can redirect the output to a file like we saw in video 8. I'll do that with sort grocerylist.txt. Then we add the redirect output character, or the greater than sign, and then give it a file name, sorted grocerylist.txt. And pressing enter, that placed the sorted output into the file sorted-grocerylist.txt, and we can see that by catting that file with cat sorted grocerylist.txt. We see that there are duplicate items on our list. We see apples is on the list twice, eggs is on the list twice, and peanut butter is on the list 3 times. To filter out all those duplicates, I'm going to sort this file again, but this time I'm going to use the -u option for unique. So my sorted output will now filter out all the duplicates, leaving only one of each unique item. Sort -u grocerylist.txt, Now we see that eggs is only on the list one time and peanut butter is only on the list one time, but we still have apples on the list twice. The problem is that Linux treats uppercase letters and lowercase letters as different letters. That's why the sort thinks apples with lowercase a is different than apples with an uppercase A. To filter out the matching words with a different case, we'll need to add the -f option. -f means fold each letter to an uppercase character before comparing. I'm pressing the arrow up to bring back that last command. And I'm adding a lowercase f just after the U for unique. So now we're going to sort -u for unique and -f to fold to uppercase before comparing. Pressing enter. Now we have our sorted grocery list file that has apples only once in the list, eggs only once in the list, and peanut butter only once in the list. Now there is also a unique command. Let's take a look at how that unique command works by typing unique UNIQ space grocerylist.txt. We see that it filtered out one of the eggs, but the 3 peanut butters are all still there, and the 2 different apples are still there as well. The unique filtered out one of the eggs because they were right next to each other. To filter out the peanut butter duplicates, we're going to need to sort this file before we can use unique. To do that, we're going to need to use the pipe command. Before we go any further, I want to talk about the different ways we can run multiple commands on a single line and why we might want to do that. Let's start with the semicolon. When we place a semicolon between 2 commands, it means finish the first command, then execute the second command. A time when we would want to do something like this is when we want to run 2 commands one after the other as quick as possible. Doing something like a log file rotation is a good example. To show you what I mean, I'm going to create a file called logfile.txt with touch logfile.txt. And now I'll type ls-lh, and we see our logfile.txt file is out there. And log files are constantly being filled up with data, and log files can get very large, too large to work with easily. To prevent this from happening, what we want to do is move the log file to a backup file, then create a new log file as fast as possible to continue catching all the new log file records. Our command is going to look like this. mv for move the logfile.txt, and we're going to move that to logfile-back.txt. That's our one command. So now I'm going to put the semicolon. And now I'm going to add the next command, which we want to do is touch logfile.txt. So now we have 2 separate commands separated by a semicolon. And we can have more commands too. If we had more, we would just add another semicolon and another command, add another semicolon, another command, and we could keep going on from there. Pressing enter, and then ls-lh shows us we were able to rotate our log file. That semicolon is great for running multiple commands on a single line, but it won't help us out with what we want to do here. We want to take the output from the sort command and use it as input for the unique command. For that, we're going to use the pipe symbol. The pipe symbol works similar to that output redirection that we've already seen and used in this tutorial series. Earlier in this video, we typed sort grocerylist.txt, then added the redirection symbol, that greater than sign, to place the output from the sort command into a new file. The pipe symbol works similar to that. I'm going to replace that greater than sign with the pipe symbol, and then add the unique command. This will take the output from the sort command and pipe it in as input to the unique command. So the unique command will read in that sorted output and then display the output from the unique command on the screen. Looking at this output, you're probably thinking this was no big deal. We just did the same thing with the sort command using the -u option. And that was a lot quicker and easier. And you would be right for this example. But the advantage of using the unique command is that the unique command also gives us the option to see which items were duplicated. To find out which items were duplicated, I'm going to press the arrow up and add the dash lowercase d on the end to show the duplicates. Pressing enter, now we see eggs and peanut butter. This shows us that eggs and peanut butter were on the list more than one time, but it did not find the apples. Remember, one had an uppercase A. We need to tell it to find all the duplicates and ignore the case. So I'm going to press the arrow up, and I'm going to add a dash I at the end. So now we're telling it to only show us the duplicates and ignore the case. Pressing enter. Now we see that apples, eggs, and peanut butter were all on the list more than one time. But this doesn't tell us how many times each item was found. To do that, I'm going to press the arrow up key again and change that lowercase d to an uppercase D. And instead of having the dash I separate, I'm going to put them both together. That doesn't matter. We can have them separate or together. Pressing enter. Now we see the lowercase a and the uppercase A in apples, eggs is on there twice, and peanut butter is on there 3 times. At the beginning of this video, I mentioned there was a file called Presidents by Height. I'm going to cat that out right now with cat Presidents by Height. This file shows us the top 10 tallest U.S. presidents. We see the order in the far left column, making Abraham Lincoln the tallest president at 6'4". Then we have the next 3 tallest presidents, and then we have a 5-way tie for number 5 and a 4-way tie for number 10. The second column shows the presidential order, so that 16 means Abraham Lincoln was the 16th president. Looking down at George Washington, we see that he was the first president. To sort this file in the presidential order, or the second column, we can use the sort command with the K option for key column. Sort -K2, presidents by height. Pressing enter. Looking at this, it looks like something went wrong because we see 16 before 1. But looking a little closer, we see that it really did work. 1/6 is less than 1 space. And a little further down the line, we see 3/6 is less than 3 space. And 3/5 is less than 3/6. So we see that it did work. It just sorted by character order, not numerical order. We're going to have to tell it that we want it in numerical order. I'm pressing the arrow up key to bring back that last command and adding the -N before the K for key column in the number 2. Pressing enter. Now we see it in the sorted order we were expecting. And if we want to sort this file by first name, I'm going to press the arrow up again to bring back that last command. And we're going to change the key column to number 3. And we're going to take off the N for numeric because this time we do have characters. So we're going to sort by key column 3, presidents by height. And now we see they are all in order by first name. In the next tutorial, we'll continue looking at the Linux command line. I'm going to type tree-a LCL. Pressing enter, we get the message command tree not found, but can be installed with sudo apt install tree. So I will type sudo apt install tree. And the tree command is installed. I'm going to clear the screen with clear. And then once again, type tree-a LCL. This shows that I have created 2 new directories to the LCL directory I created in the last video, new directory and new directory 2. And I've added some files in those directories. Most of these just have the file name inside them, so they're not empty files. I'm going to resize this window and move it over to the side here. We are just going to use this window as a reference as needed. Opening up another terminal. I'm going to resize this a little bit so we can easily get to both of the terminals. We are going to start our look at the find command in this tutorial. I'm going to use the find command to search the LCL directory for the file image.jpg.
To do that, I will type the find command and then the directory where I want to search, which is home Michael LCL. This will search that directory and all the directories and files below it. And I'm looking for a file name, so I will type -name, and then the file name that I'm looking for, which is image.jpg. And we see it found it in the new directory. Instead of typing the absolute name, home Michael LCL, I'm going to cd into the LCL directory with cd LCL. And now when I type the find command, I can use the period or dot to search the current directory I am in, as well as all the files and directories below it. Once again, I'm searching for a file name, so I'll type -name. And then I want to find the dirtbike.txt file. And I'll need to put quotes around that because it contains a space in the file name. Pressing enter, and we see that the find command found our file. I also want to note that when we use the absolute path to find image.jpg, the find command returned us an absolute path. And when we use the relative path or the dot, the find command returned us a relative path. Finding files this way works great as long as you know the exact file name. But most of the time, we're not going to know the complete file name we're looking for. We might know only part of the file name. To search for something where we don't know the complete file name, we're going to use wildcards. There are 3 wildcards we're going to use with the find command. We have the asterisk that some people call the glob. That is wild for something or nothing. Something meaning a single character or many characters, and nothing meaning no characters at all. Any of those work in place of the asterisk wildcard. Then we have the question mark, which is wild for any single character. There must be a character. It doesn't matter what that character is, but there must be one single character in place of the question mark. And lastly, we have the brackets, which works similar to the question mark, meaning there must be a single character, but this time that character must also be one of the characters in the brackets. Let's take a look at some examples to see how this works. I will type find dot hyphen name double quote asterisk list asterisk end quote. Pressing enter. Checking this with our tree diagram shows us it found list in the grocerylist.txt file and list in the sorted-grocerylist.txt file in the new directory 2 directory. And we don't need to use double quotes. We can use single quotes. And here we see using single quotes returns us the same result. So it doesn't matter which quotes you use, but it's a good idea to use quotes when working with the wildcards. A common use of the asterisk or glob wildcard is when finding a certain type of file. We'll say we want to find everything that ends with .txt, or maybe everything that ends with JPG. So if you're looking for a specific file type, the asterisk or glob can be very useful. Moving on to the question mark, which is wild for any single character, I will type find dot and then the name dirtbike question mark .txt end quote. And I forgot to type -name, so it found everything. I'm going to bring back that command with the arrow up and add in -name. This time, it only found dirtbike 1 through 4. We see that it did not include dirtbike.txt because there was no character between the dirtbike and the .txt. And now I will add in the brackets. Dirtbike left bracket. We're going to search for 2 or 4 right bracket. Pressing enter shows us this time we only found dirtbikes 2 and 4. We can also add in a dash here between the 2 and 4 and search for anything 2 through 4 And we find dirt bike 3 as well, because 3 is between 2 and 4. I'm going to clear the screen, and I'm going to use the find command to find anything that has dir in it in the LCL directory. So I will type find dot hyphen name quote asterisk dir asterisk end quote. Pressing enter, we see that we found 2 directories and a single file called Gridiron, but it did not find any of the dirt bike files. That's because the find search is case sensitive. To tell the find command I want to ignore the case when we are searching for a name, I will add an I before the name. So now we're telling the find command to search for dir in any case, upper or lower, or any combination in between. Pressing enter. Now we are seeing all the file names and directories that have dir in it. We may want to filter this down to just the files with dir. To do that, I'll press the arrow up to bring that command back and add in hyphen type F for files. Pressing enter, now we only see files that have dir in it. And we can do the same thing for directories by pressing the arrow up key and changing that F to a D for directories. Find anything with D for directories. And now we see only the directories with dir in the title. I'm going to clear the screen again and type in the same as we did earlier, find dot hyphen name quote asterisk list asterisk quote. And we'll remember that we found this in the current directory as well as in the new directory 2 directory. There are times when we may only want to look in the current directory and not include any subdirectories below that current directory. To do that, I'm going to press arrow up to bring back that command and add in the dash max depth option. And we're going to have a max depth of 1, meaning only search the current directory. And we can also do the opposite. I'll press arrow up and we can say find the min depth. And we don't want it to be 1 now. We want to say min depth 2. So now we're telling the find command to go down to the subdirectory or 2 down to start your search. Bringing back that find command, we could also have put in the 2 subdirectories. Find in the new directory. That's the relative directory. And we can also add in the absolute directory /home Michael LCL new directory 2 directory. I've taken out the period, so it will search only those 2 directories. We're going to take out the min depth 2, and we're searching for the name of asterisk list asterisk. And that returns the same results. And notice, because it was in the absolute directory, the find command returned us our result with the absolute directory. This will end our first part of the look at the find command. In the next video, we're going to continue looking at the find command for the Linux command line. In the last video, we used the find command to find files by the file name. But that is not the only way the find command can find things. I'm going into the LCL directory with cd LCL, and I want to find all the files in this directory and the directories below that have been modified within the last 7 days. I'll do that by typing find dot dash mtime -7. And notice this time we're not using dash name at all because we're not searching by the name. This time we're searching by the modified time. So dash name was replaced with dash mtime. And then I'm adding the -7 to find everything that was modified within the last 7 days. And to find everything that was modified more than 7 days ago, I will change that -7 to a +7. And another way to find things that were modified more than 7 days ago is going back to the original -7 and adding dash not. That gives us the same thing as mtime +7. And instead of typing dash not, we can also put in the exclamation point, also known as bang. That also shows us everything that's been modified more than 7 days ago. Instead of the modified time, I want to find everything that has an access time that has been updated within the last 7 days. To do that, I will take out the not and change the M time to an A for access time. And I can do the same thing for the change time. Change that A to a T for changed. And there's everything where the change time has been updated within the last 7 days. We talked about the differences between modified time, access time, and change time in video 32 when we looked at the stat command. We can find everything in the LCL directory and the directories below that have been updated within the last 60 minutes with find dot dash mmin minus 60. And we see nothing has been updated within the last 60 minutes. We can change that by touching a file. I will touch new directory / gridiron.txt. And now I'll go back to that find command. And instead of 60 minutes, I'm going to change it to 1 minute. And we see that new directory gridiron.txt has been updated within the last minute. At times, we may want to view files updated within a range of dates. Let's say we want to find everything that was modified within the last week, but not modified within the last 3 days. To do that, I will type find dot dash mtime minus 7 dash and dash mtime plus 3. I have seen people use a file to hold the start date and end date for the find command. To do that, we'll first create a start date with the start date we want to use. So I will say touch dash dash date, and then in quotes, 1 week ago. And I'm going to store this in my home directory. So I'm using the tilde for that, / start date. And then for our end date, we'll do the same thing. Touch dash dash date 3 days ago. And we'll also put that in our home directory, and we'll call this end dash date. Now we're going to change our find command a little bit. Our find command will be find dot, for this directory and the directories below, dash newer, then the home directory / start dash date dash and dash not dash newer, then our home directory / end date. And that's showing us the same thing as the find mtime minus 7 and mtime plus 3. Now earlier we saw we could replace not with the exclamation point bang. We'll do that again here. But we can also replace and with dash a. And we can do the same thing for or with dash o. We don't have one here, but we're showing it with the and as dash a. And that gives us the same results. If you're mixing your date formats, let's say that for our start date, instead of using the start date, I want to type it out as 2020-01-01. So we're going to make the start date everything for the 2020 calendar year. But instead of newer, we'll need to add on something like MT for modified time. If I left this just as newer, it would show us an error. And there's our result for all the files that have been updated between 2020-01-01 and 3 days ago. When we're creating search criteria, we don't have to stick to a single search criteria. What I mean here is we've got dates. I may also want to just filter this down to just text files. So I'll say dash and dash name, quote, asterisk.txt, end quote. Now we filter this down to just the text files within that date range. And we can do the same thing by changing this to JPG for JPEG. And there's the only JPEG that meets the search criteria.
Another thing we might want to do is filter out a path. Let's go back to just the date range here. And we see that we have the new directory 2 and some in the new directory. Let's filter out the new directory 2 directory. To do that, I will add in dash and dash not dash path. And now in quotes, I'll put in asterisk slash new directory 2 slash asterisk. And we filtered out all the results from the new directory 2 directory. This can also be helpful if you're doing a search and you don't have access to a specific directory. You want to filter out those results, add in the dash not dash path. Sometimes we might be running out of disk space and we want to see what our large files are. I'm going to find in this directory and the directories below all the files with a dash size greater than, so I'm using the plus 1 megabyte. Anything greater than a megabyte in the LCL directory and below, we have one file, the image.jpg. Another thing we can search for is empty files. Let's find in the LCL directory and below with a dot all the files that are dash empty. Other things we can find are items that have a specific user. I'm going to type sudo find, and I'm going to look in the /srv/chemistry directory for everything that has a user. So I'm using dash user of Ryan. And there we see the test file 2.txt. The SRV chemistry directory and files were created in a previous tutorial, and the Michael user was not a part of that group. That's why I need to use sudo before the command to view everything in that directory. We can also find files by a specific group with sudo find SRV chemistry dash group of Lisa. We see that there's one file where Lisa is the owner of a group. And I'll type sudo ls-lh/srv chemistry to show what's in that directory. And there we see that Ryan is the user of the test2 file and that the test file 4.txt file has a group of Lisa. We can also find files with specific file permissions. I'm going to type find all the files in the LCL directory and the directories below that have a dash perm for permissions of 777. And there we see we've got one file, gridiron.txt. Once we have a find result set, like this one here, let's say that we want to delete that. What we do is we create our find command like we have here. And if we add dash delete, it's going to delete everything that was found in that find command. So in this case, it'll be a single file, gridiron.txt. And if I try and find all the files now that have a permission of 777, and we get no results because we just deleted them all. Besides the find command, we can also find files with the locate command. We can do that with locate and then the file name. I'm going to use the name grocerylist.txt. Here we see it's found 3 times. I'm going to copy the grocerylist.txt file and make this grocerylist.txt2. Now if I try and locate those again, our new file is not found because the locate has not updated the database. To update the database, I will type sudo update db. And now if I type in locate grocerylist.txt, it finds our grocerylist.txt too. The locate is very fast, but does not have those filtering features that the find command has. In the next video, we'll continue looking at the Linux command line. In the last couple of videos, we looked at the find command, and the find command works well for finding files, but sometimes we want to find a specific string of characters in a file. And for that, we'll use grep. The name grep goes back to the old days of Unix and stood for Global Regular Expression Print. grep will search through a file or files for a regular expression and then show us the lines where that regular expression was found. I'm going to use grep to search the grocerylist.txt file for a regex.
regex is just short for regular expression. And I'll use both terms regex and regular expression to mean the same thing in this tutorial. I'm going to type grep2 grocerylist.txt. And this is the original grocerylist.txt file from video 7, not the updated grocerylist.txt file from video 33. Earlier I said grep would search for a regular expression, but here I'm just typing in the word to. That's correct. The word to is a very simple regular expression. And that regular expression is just the letters T and O next to each other in that order. We will talk more about regular expressions in the next video. For this video, all our regular expressions will be text characters in an order. And right now, we want to find every line in the file grocerylist.txt where the letters T and O are found in that order. Pressing enter, we see 4 lines where grep found the regular expression to. The regular expression to is highlighted, but the entire line is returned. I will cat the grocerylist.txt file to remind us what is in that file. It's just a list of items you might find on a grocery list, and enter was pressed at the end of each line. Depending on the file that you're grepping, your line of text may be much longer than what you expect. I'm going to grep for orange in my grocerylist.txt file. It's a good idea to put your regular expressions in quotes, even though it's not necessary to do so for these simple regular expressions. It's a good practice to get into. So from here forward, I will put all my regular expressions in quotes. Pressing enter, we see that orange is found once in oranges. But looking over what is in our grocerylist.txt file, we see orange is on there a second time with an uppercase O for orange juice. Grep searches for an exact match, including case. To search for my regular expression and ignore the case, I will add a dash lowercase I, and here we see it found orange twice, once with the lowercase o in the line oranges, and once with the uppercase O in the line orange juice. This works pretty well, but I may only want to find my regular expression when it is a word by itself and not part of a larger word. For that, I will add in the W option. This will search case insensitive and then only return the lines where my regex is a single word and not part of a larger word. Now we only see orange juice. Grep is still returning the entire line, which is why we see orange juice, but orange is a word by itself, meaning with spaces on both sides of it. And oranges is not included because it is a bigger word that includes the word orange. We may want to know what line numbers our regex is found on. To see that, I will add the -N option. I will take out that W option and change it to an N. So we still have our I to ignore the case, but now we have the N to show us the line numbers where it is found as well. And we see oranges is found on line 8, and orange juice is found on line 27. There may be times when we want to filter out the lines where our regex is found, meaning show me the entire file, but don't show me the lines where oranges is found on lines 8 and 27. To do that, we want to grep the opposite or inverse of the grep results. So I will use the lowercase v option to show us the inverse results. I'm still keeping the I in there for the case insensitive and adding the V for the inverse. Here we don't see oranges or orange juice, but since we know the line numbers, we may want to pipe our results out to cat and then add the line numbers with pipe cat-n. Now we can see around lines 27 and going up around line 8, we can see that oranges was filtered out just as we had expected. We may not care where the regex is found. We just want to know how many times our regex is found in that file. And for that, we'll use the C option for count. I'll take off the cat-n, and I'm going to change the V to a C. And we're still using the I for case insensitive. And grep finds the word orange in 2 places. Now I'm going to change my regular expression. I'm going to grep for the word nut. And I'm going to search for that in my home directory and then in the LCL directory. And actually, this will not work as it's set up. I'll press enter and show that. Linux is responding, telling us that we're trying to grep a directory, and we can't do that, but we can grep all the files in that directory recursively by adding a -r to this command. Now we will grep recursively every file in that directory and its subdirectories. And we see that nut is found 3 times in the grocerylist.txt file found in home Michael LCL. And it's found 3 times in the sorted grocerylist.txt file in the home Michael LCL new directory 2 directory. And then it's found a 3rd time in the grocerylist.txt2 file in the directory home Michael LCL. We saw earlier that we could show the lines in our regex by adding an n to the grep command. I'll make this rn. And notice our sorted file shows all the lines are right next to each other. If we don't want to show the path, we can hide the path by adding -h. We still have our line numbers showing because we still have the -n option. If we want to show the path only, we can use the -l option. I need the R to search recursively. That -l option will suppress the normal output and print only the files where the regex is found. And then if we change that lowercase l to an uppercase L, this will show us the opposite of that lowercase l. This lists all the files in the LCL directory that grep does not match the regex. Up to now, we've used grep on specific files and we've grepped a directory, but we can also pipe data into grep, like we have with less and sort earlier in this tutorial series. What I mean by that is, in an earlier tutorial, we used cat, etc, passwd, and that showed us the big file with everything in it. And then I would start speaking about a specific user like Lisa. Well, we can pipe our cat into grep and just select that line. Pipe, grep, Lisa. And now we just see the single line for Lisa. And that works for other things as well. Let's use the ls command. I'll type ls-lh. And again, I'll press the arrow up and add pipe, grep, and we'll grep for anything that starts with gro. Now, it doesn't have to be part of the name. We can grep for anything in the ls command. Let's grep for 2019. And there's all the files that were updated in 2019. Or maybe I want to see all the files with a specific permission, like r-x. And there's all our files with a permission of r-x. In the next tutorial, we're going to get an introduction of regex and how it works with grep for the Linux command line. In the last video, we said that grep comes from the old days of Unix and stood for Global Regular Expression Print. We also said that a regular expression can be referred to as regex. In short, a regular expression is a string of text that allows us to create patterns that help match, locate, and manage text. Regular expressions have been around for years and are used in many programming languages and text editors, sometimes having slight differences. Regular expressions can be quite complex, but we're not going to get that deep into regular expressions. That's why this is called an introduction to regular expressions. Here we will get a basic understanding of how to create regular expressions used with the grep command. We're going to be using that same grocerylist.txt file that we've been using throughout this video series, but I will cat it out once again just to remind us of what's in that file. The first thing we're going to look at is how to use the period wildcard with regex. The period is a regular expression wildcard for a single character. It can be any character, but there must be a single character for each period. This works the same as we saw in the find command a few videos back. I will type grep, quote, S period, 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 R, end quote, space, grocerylist.txt. And that returns sugar and raspberries. We see that both of these have the pattern S, 3 characters, and then an R. Now I'm going to type ls-lh pipe grep quote period txt end quote. And a quick look makes us think our output is correct. But if we take a closer look and look at that top file called a new file 2, we see that those last 4 characters are actually txt. We wanted to search for period txt, but we ended up searching for wildcard txt. To turn off that wildcard feature, we need to add the escape character, which is a backslash. And we'll add that right before the period to make it .txt and not wildcard txt. Now the txt file is not included in our grep output. I've got a list of regex characters we're looking at in this video. We started with the period wildcard, and then we have the escape character. And I will put the complete list of what is shown in this video out on the website. And you can download it for free. I'll put a link to the download in the video description below this YouTube video. The next thing we're going to look at is the caret symbol. For me, it's Shift-6 on my American QWERTY keyboard. And that character means the line of text will start with the following character or characters. I want to create a regular expression to find all the lines that start with the letter C, so my command will look like grep, quote, caret C, end quote, grocerylist.txt. And here we see all the lines in the file that start with the letter C. Adding an H after the C will filter down the output. Now the output will only show the lines that start with CH. Or maybe we want to change our regex to show everything starting with the letter C or the letter H. To do that, we'll add the brackets around the CH. We already saw this one too when we were looking at the find command. And the brackets allow us to search for any single character between those brackets. So in this case, we have the caret at the beginning, which means the line starts with, then we have the brackets, which means any single character in those brackets. So in this case, our line can start with the letter C, or our line can start with the letter H. If we want to search for everything that does not start with the letter C or the letter H, we would add a caret inside of those brackets. And this is where things can get a little tricky. The caret outside of the brackets means the line starts with the next characters, but the caret inside the brackets has a totally different meaning. It means not. So our pattern is now the line starts with anything that is not a C or an H. We can also grep for lines that end with specific text. The end of line symbol is the $sign. So typing grep, quote, S $, quote, grocerylist.txt will show us the lines that end with a lowercase s. The thing to note here is the $sign is on the right of what we are grepping, whereas the caret was on the left or the beginning of the line. And the caret in the brackets as well was on the left. Here, we want the characters we are grepping for to be on the left and the $sign on the right. And it doesn't have to be a single character. I was just using a single character to get more results. Let's add in IE to make that IES. Or I could change that to an entire word, something like chips. And here we see the only line that ends with chips, which is potato chips. Here we see what we've looked at so far. But there is more that I want to include in our introduction to regular expressions, but this is a good breaking point. In the next video, we are going to finish our look at regular expressions for the Linux command line. We are picking up from where we left off in the last video, and I'm going to add some items to our grocerylist.txt file.
I am typing nano grocerylist.txt. I'm going down to the bottom of the file, and I'm going to add the word corn, and then color, and then color again, but this time with the U in it. And I'm going to add color one more time, but I'm going to add 3 U's. And now I will save this by pressing Control X and then Y without Control, and then Enter. Now that we have updated our file, we are going to look at how the asterisk works for a regular expression. We are also going to look at the question mark as well as the plus sign, because these are all very similar but slightly different. Starting with the asterisk, we see that the preceding character can occur 0 or more times. I am going to grep for the word color with the U, and then I'm adding the asterisk right after that U. So that preceding character, the U, can occur 0 or more times. And I'm grepping the file grocerylist.txt that we just updated. Pressing Enter, we see it return the American spelling of color without the U because the asterisk allows for the U 0 times. Then we see color with the single U and the 3 U's because the asterisk also allows for the preceding character to show 1 or more times. Moving on to the question mark, I've highlighted this one because it's an extended regular expression. Extended regular expression just means it's not one of the original regular expressions. So we will have to add a -E to our grep. The question mark allows for the preceding character 0 or 1 time. I'm going to press the arrow up to bring back that previous command, and I'm going to change that asterisk to a question mark. And when I press Enter, nothing is returned. The problem is we didn't have that -E. We didn't get an error because that regex we were searching for was COLOU ? As if we had a backslash before the question mark to escape it. And that is a valid regular expression. So that is why we did not get an error and we did not find anything. I'm going to press the arrow up again and add in the -E for extended regular expression and press Enter. Now we see the words color without any U and color with the single U, but the color with the 3 U's is not included. That's because there is more than one U, and the question mark only returns 0 or 1 occurrence of the character before it. The other special character, similar to the asterisk and the question mark, is the plus sign. And the plus sign will return the lines if the character before the plus sign occurs at least 1 time or more than 1 time. Pressing the arrow up again, I will change that question mark to a plus sign and press Enter. Here we see exactly what we would expect to see. The American spelling of color without the U is not included in the output, but the version with the single U and the version with the 3 U's are showing in the output. Now we can run grep with the -E every time. I'll press the arrow up and go over and change that plus sign to an asterisk. Pressing Enter, we see it runs the same with the -E as it did the first time without the -E. So we can include that -E every time if we like. Some of us are used to seeing an asterisk as a wildcard for anything 0 or more times. But with regex, it's a wildcard for the single character preceding it. So how do we do a wildcard of nothing, single character of anything, or multiple characters of anything? To do that, we can precede the asterisk with a period. Grep, quote, CO, period, asterisk, R, end quote, grocerylist.txt. The period is a wildcard for a single value. The asterisk makes that wildcard good for 0 or more occurrences. Now our grep will work for anything that has CO
followed by nothing, or followed by a character or many characters 0 or more times, then followed by an R. Pressing enter. This time we see corn is also included, as well as those 3 different versions of color. Another extended regular expression I want to talk about is the OR expression. And the OR can be done with the pipe character. Let's grep our grocerylist.txt file for chips or salsa. We will start with grep, and then we'll add the dash uppercase E, because OR is an extended regular expression. Now let's add in our regular expression, which will be, quote, chips, pipe, salsa, end quote, grocerylist.txt. Here we see potato chips and salsa are both on the grocery list. And we can have more than 2 values. Let's add butter to our OR. I'm pressing arrow up, and I will add in pipe, butter, and here we see it found butter and peanut butter, as well as the potato chips and salsa that it found a moment ago. Now, this is also a good example of why we need to put our regular expression in quotes. If we remove the quotes from this regular expression, this time the grep fails. It failed because it thinks we're trying to pipe chips into salsa and pipe that salsa into butter, which makes no sense at all. So I'm going to press Control C to cancel out of that. To grep with and, let's say we want to grep for everything that starts with a C and has 2 vowels next to each other. We could type grep, quote, caret, C, end quote, grocerylist.txt. That's the first part that will find all the lines that start with the letter C. Then we want to pipe that grep into another grep. And then this grep will be for the 2 vowels next to each other. So I'm going to have my opening quote. And to find a vowel, I'm going to use the brackets and type in all the vowels. A, E, I, O, U, closing bracket. And I want another vowel right next to that. So I'll use the open bracket, A, E, I, O, U, closing bracket, and closing quote. Now the first grep will grab everything that starts with the letter C, and the second grep will be 2 vowels next to each other. Pressing enter, here we see we have all the lines that start with the letter C and have 2 vowels next to each other. Now that's not the only way to do this, but I wanted to show that you can grep your grep. Other things we might want to do are grep for the uppercase letters. To grep for uppercase letters, we can use the hyphen inside the brackets to specify a range. I'm going to grep, open quote, open bracket, and I want anything that is in uppercase A through uppercase Z. Ending bracket, ending quote, grocerylist.txt. Pressing enter, we see all the uppercase letters found in that file. We can also add in the numbers. I'm pressing the arrow up to bring back the last command. And this time I want anything uppercase A through uppercase Z or 0 through 9. Pressing enter, we see all the lines with uppercase characters or numbers in it. I have another page here of regular expressions with some character classes. These are all pretty straightforward on what you would expect. The alpha is for alphabetic characters, the digit is for numbers, upper is for uppercase characters, and so on. Let's try one of these. And I will type this in just as we think it would work out from looking at the character classes. I'm going to grep, open quote, bracket, colon, upper, ending colon, ending bracket, and end quote, and then the file name of grocerylist.txt. When I press enter, we see the message grep character class syntax is, and then they show colon space colon within 2 sets of brackets, not 1 set of brackets. We got this message because it was confused. It found the 2 colons, but only 1 set of brackets. So it doesn't know if we wanted a character class or if we wanted a single character from within there that starts with a colon and a U and a P and a P and an E and an R. So we need to add in a second set of brackets to tell it that we're looking for a single character that is in the character class upper. So I would grep for something that is within the character class, upper. That's the end of the character class. And then the ending bracket, ending quote, grocerylist.txt. And once again, we see all the uppercase letters in the grocerylist.txt file. Pressing arrow up, I'm going to add in the digit character class. Now this becomes a little clearer that inside our brackets, we're searching for the upper character class and the digit character class in the grocerylist.txt file. And our output shows that using the upper and digit character classes is doing the same thing as the uppercase A to uppercase Z, 0 through 9, that we saw just a moment ago. In the next video, we will continue looking at the Linux command line. TR is short for translate, and what translate will do is it will take any single character and translate that single character into another character of your choosing. So let's say we want to translate all the lowercase a's in the grocerylist.txt file to @signs. To do that, I would type tr, quote, a quote, space, quote, @symbol, quote, and then we cannot just add the file name at the end like we did with grep in the last couple of videos. When using tr, we need to use the less than angle bracket before the file name. And we've seen this in videos earlier in this series. Pressing enter, we see that all the lowercase a's are now changed to @symbols. This will not update the grocerylist.txt file. The updated output is just shown on the screen. We can redirect the output of tr to a file, and we'll do that later in this video. Another way to get input into the tr command is with cat in pipe. I will type cat grocerylist.txt pipe tr quote a quote space quote @symbol quote, and pressing enter, and we see that works the same way. So both ways give us the same output. I'm arrowing up to the first way again, and I said this works for any single character, but we can do more than one character at a time. I want to translate all the A's to @symbols, and now I'm going to add the U's, and I want to translate them all to a dash. I'm going over to the A, and I will add the U after that. And then what I want to translate this to, I will make that a dash or a hyphen. And actually, I'm going to add in the \hyphen, just to make sure that TR knows that I want the hyphen, and this is not going to be a range. So this command will change all of the A's to @symbols and all of the U's to hyphens. Pressing enter, we see that all of the A's are @symbols and all of the U's are hyphens. And we can add in more than 2 characters. We can put in as many as we like. So what happens if we have more characters on the left than on the right? For example, I'm going to add the letter C in the characters to translate, but I'm not going to add anything on the translate to. Pressing enter, here we see all the lowercase a's were translated to @symbols, all of the u's were translated to hyphens, and also all of the c's were translated to hyphens or dashes as well. So if there are more characters on the left, it just uses that last character on the right over and over for every character that does not have a match. If I add more characters to the left and nothing to the right, they will all be translated to the last character matched, which in this case is a dash. Now, what if I add more characters to the right than on the left? I will add in, we'll make this WQ21. When I press enter, we see that all of the C's are now translated to W, but after that, all the characters don't have matches, so they're just ignored and not used. Let's use the dash range now to make all of the characters uppercase. To make all of the letters uppercase, I want to TR, translate everything that is a lowercase a through lowercase z to be in uppercase A through uppercase Z.
So all the A's will be translated to uppercase, all the lowercase b's will be translated to an uppercase B, and so on and so forth, all the way through Z. And we'll do this for our grocerylist.txt file. And here we see all of the characters translated to uppercase. Now, if we try reversing that order, changing the lowercase a through lowercase z to uppercase Z through uppercase A, we get an error. But we can go back to the lowercase a through lowercase z to uppercase A to uppercase Z, and we can pipe that in to REV for reverse. And here we see that new item 1 becomes 1 meti when, and color becomes ROLOC. We can also use the character classes we are introduced to in an earlier video in this series to make all of the letters uppercase. I'll type TR, quote, left bracket, colon, lower, colon, right bracket, quote. And we want all the lower to be translated to, quote, left bracket, colon, upper, colon, right bracket, quote. And the input will be our grocerylist.txt file. Now let's change all of the line returns to spaces in the grocerylist.txt file. TR, quote, \n, quote, and that stands for the line return. And then we want to change them into a space for the grocerylist.txt file. And now we see our grocerylist.txt file as one single line. And this even took out the final line return after the last character. So I'm going to press enter to get to a new line. I have updated the precedence by height file from video 33, and I've added a header record and made that a CSV file. If you're not familiar with a CSV file, CSV stands for comma separated values. And when we open this file with a spreadsheet program like LibreOffice, the spreadsheet program will read in the data into rows and columns, separating the column fields by the commas. And right here we see that the separator options are tab, comma, semicolon. And it's giving us an idea of what this will look like with the header order by height, presidential number, the name, and pressing OK opens up that spreadsheet program with our CSV file. And we see that all of the fields line up nicely. We saw that spreadsheet will also read in tab-separated values. To create a tab-separated value file, we will read in our CSV file and translate all of the commas to tab separators. And to do that, we will type tr, comma, quote, \t, quote. That will be for our tab values. And we want the input to be the precedence by height.csv file. There we see we've changed all of the commas to tabs, but we need to write this out to a file. And we do that by adding the greater than angle bracket and then a new file name, which will be precedence by height, but I'm going to change this to TSV instead of CSV. And then we can open that with LibreOffice as well. Precedence by height, TSV. And that opens as well without any problems. Earlier in this video, we translated all of the line returns to spaces. If we go back to that command, and then we try to change those spaces back to line returns by piping that output into tr, quote, space, quote, quote, \n, quote, to add back in all of the line returns, we have a problem. And the problem is that some of the items had spaces in them, like new item 1, and that is throwing off our translate back. To make this work, we need to delete all of the spaces from that file before we do our translations. And I'm going to delete those spaces with the tr command. And to do that, I'm going to type tr-d for delete, and then I'm going to use the character class of blank. So what we're going to do is delete all of the blank spaces. And you might think that we want to use the space character class, but the space character class will delete anything that's white space, including line returns, tab characters, and the like, whereas blank will just delete all of the spaces. And we want that for our grocerylist.txt file. Then we can tr all of our line returns to spaces and pipe that into the tr to make all of the spaces line returns. And pressing enter, now we see our items as we expected, without any spaces between them. Translate has the delete option, which we just saw, but it also has a way of removing repeated characters that TR calls squeezing. But let's review the delete option first. So I'm going to type echo quote ABC asterisk @123 end quote, and I'm going to pipe that into TR where I want to delete anything that is a digit. And we see it removed all of the digits with the regex class digits. Now we can also do this with the range of 0 through 9. We don't need to use the character classes. I'm just going to use the character classes to try and keep things simple, because this is more about how the TR delete and squeeze functionality works and not regex. So going back to the classes, I'm going to change the digits now to alpha. And here we see that it removed the alphabetic characters, but we still have those special characters showing. TR has a way of removing everything except the numbers, and that is to delete the complement of the regex, meaning remove everything except what is in the regex. So going back to the digits, I want to remove everything except the digits. So I'm going to add a C after the D, and the C stands for the complement. When I press enter, we see that it removed all of the letters and special characters, including that final end of line return. The way that squeeze works is similar to delete, only it only removes the repeating characters. I'm going to paste in some text here. And this is going to echo in some repeating characters. Then we're going to pipe that into TR with the S for squeeze. And then we're going to squeeze only the digits. And squeeze is going to remove the repeated characters. Pressing enter, we see that we have 1, 2, 3, 1. So when it removes the repeating characters, it means repeating characters right next to each other. The 1 does repeat, but it's not next to the other 1. So the repeated characters next to each other are squeezed. And we can squeeze the complement, meaning squeeze everything except the digits. And we can use delete and squeeze in the same command. Here I want to delete and squeeze. So I'm going to delete the digits, and I want to squeeze the alpha. This deleted all the digits and squeezed the letters. Notice nothing happened to the special characters. Now we can also add in the complement to the delete and squeeze. And when I press enter here, what happens is the complement worked with the digit, and everything that was not a digit was deleted, but there were no alpha characters to squeeze. So to make this work, we need to change our command a little bit. Instead of alpha, the only thing left is digits, so we need to squeeze the digits. And this deletes everything that's not a number and then squeezes the numbers. In the next video, we'll continue looking at the Linux command line. Sed is short for stream editor, and it modifies a stream of input before passing it along to the output. Sed is similar to TR, but Sed has more features and can modify the input in more ways than TR. Like the regex tutorials, this won't be a complete Sed tutorial, just an introduction to Sed, enough to get you a basic understanding of some of the most common Sed functionality. One of the most used features of Sed is substitute. Let's use sed substitute to edit all the lowercase a's to be @ in the grocerylist.txt file, like we did with the tr command. Our command will start with sed, then a space, then a single quote, and then the lowercase s for substitute. Then we'll add a delimiter of a /,
and then the current value that we're searching for, which in this case is a lowercase a, then another delimiter, and then the new value that we want to substitute in, which in this case is the @ sign. Then we have the final delimiter, an end quote, and then we'll add in the file name that we want to use as input, which in this case is the grocerylist.txt file. With sed, we do not need to add in that less than angle bracket before the input file name. Pressing enter shows us the updated text on the screen. We can add in that less than angle bracket. It works the same way. We just don't need to add in that less than angle bracket, like we did with tr. Sed does not update that input file. It sends the edited output to the screen, where we can redirect that output to a file if we like. Using cat, I will show the grocerylist.txt file, and we see that this file has not been updated. If we leave off the file name and just type in the sed command without a file name, sed will expect input from the standard input, which means we just type in our data. I'll type in papaya and banana, and we see here that sed edits each line when enter is pressed. I'm going to hold down Control and press D to gracefully get out of that. We can also hold down Control and press C to cancel out. When we typed papaya and banana here, it's clear to see that sed only updates the first occurrence of that search string. We can change this. If we want to update only the second occurrence, we do that by adding a 2 after the final delimiter. And now we see only the second occurrence is updated. And we see that here in salsa and plantain. And that will work for any number, as long as the search string is found that many times on a line. And we can also use a G instead of that 2, and it will globally edit every occurrence on the line. We see all the A's were changed to @ signs in the words salsa and plantain. And we're not limited to a single letter with sed, like we are with tr. I will type sed, quote, s/yogurt, and we're going to replace lowercase yogurt with uppercase yogurt. And we'll do that for the grocerylist.txt file. We see here that yogurt was updated to uppercase. So the sed substitute works more like the traditional search and replace most of us are already familiar with. Now the delimiter does not have to be a /. We can change the delimiter to be a colon by replacing these slashes with colons. In fact, we can change that delimiter to be anything we like. The delimiter becomes whatever follows the S for substitute. I'm going to make this the letter D for delimiter. Using a D makes things a little more difficult to read, but we do get the same results. When we are doing a substitute, the current value is actually a regular expression. I'm going to type sed, quote, S /, and then I'm going to use a regular expression to find everything that starts with the letter C. And I'm going to replace that with space C, final delimiter, ending quote, for the grocerylist.txt file. And here we see everything that starts with a lowercase c is now indented 2 spaces. Maybe we want to indent the entire file 2 spaces, in which case I'll take out the C's, and now we say add space to every line. Instead of indenting 2 spaces, maybe we want to change the indentation to a tab character. Now we've indented every line with a tab character. Let's change all of the vowels, so I'll want to use the brackets, A, E, I, O, U, closing bracket, and we'll remove that. And we'll change anything that's a vowel to be an asterisk for the grocerylist.txt file. And let's also add in that G to make this edit work globally. Or maybe we want to remove the vowels altogether, and replace them with nothing. We can put multiple sed commands on a single line, but when we do this, we need to add a lowercase -e before the command to tell sed we're going to have multiple commands. If we don't add that -e, sed will think the command is an input file. We can have multiple input files. Sed-e for multiple edits. The first one will be substituting the A for the ampersand, which we've already seen, and we'll do that globally. And then we're going to add in another edit, which will be substitute everything that starts with the letter C for space C, and we'll do that for the grocerylist.txt file. The -lowercase e is for edit. There's also a -lowercase f for file. Maybe you have the same sed command you want to run over and over, or you might have multiple commands that you want to run over and over. And sometimes it's easier just to put those into a file. To create a sed file, I'm going to type nano sedfile.txt. In this file, we'll start it with a comment, and to do that, I'll add a hashtag. This is a sed file. And then we'll add in our command. And here we don't need the quotes because it's in a sed file. To save this, I'm going to press Control X and then Y without Control, and then Enter. And now I will sed-f to use our sed file as input, sed file text, and we'll apply this to the grocerylist.txt file. And it works just the same as it did when we put both commands on one line. Sed can also read multiple files in. I will add in the precedence by height CSV file, and we see that sed processes these in the order that they are on the input. So it did the grocerylist.txt file first, and then the precedence by height.csv file. This is a good breaking point, so we're going to end this video here. In the next video, we're going to complete our introductory look at the sed command for the Linux command line. Continuing on from where we left off in the last video, sed has two special values that can be used in the replacement string. The first one is the ampersand. The ampersand will substitute in the search string value into the replacement string. For example, when I type sed space quote S for substitute, the delimiter, then the word corn, a delimiter, then inside of curly braces, I will put the ampersand, the ending delimiter, end quote, and then the file, grocerylist.txt. Pressing enter, we see that corn now has parentheses around it. For something like this, I could have just typed corn inside of those curly braces instead of the ampersand. This is much more useful when our regex becomes a search string, something like CO wildcard asterisk for 0 or more times, and then the R. Here we see that sed now replaces those curly braces around everything that fits that regex search criteria. The other special value for the replacement string are the escaped with a \number. And this works by breaking up our regex search field into parts with parentheses. To really understand how the numbers parentheses work, I have created a new file, and that new file is called mary.txt. Let's cat that out. And we see that mary.txt is just that Mary had a little lamb nursery rhyme. The replacement field escape numbers work similar to the ampersand, but we can have multiple values, so they're numbered. For example, I will type sed space quote S for substitute and then the delimiter. Now I'm going to press the escape character, which is a \, then the left or opening parenthesis and the word little. Then the escape character again and a closing or right parenthesis. This much right here is the single value that will be like the ampersand. But we want to have two values, so I'm adding in a space, then the escape character, opening parenthesis, I'm typing in lamb, escape character right parenthesis, and then the delimiter. Now I want to add my replacement string to print out the second value first. So I'm going to type escape character 2 space escape character 1. We will then add in our ending delimiter, end quote, and then the file name, which will be mary.txt. The result of this is it writes out the second value first, then a space, then the first value. So our regex searches for little space lamb, and little was in parenthesis, so that became our first value, and lamb was also in parenthesis, so that became our second value. Then in the replacement string, we told sed to print out our second value first, and then our first value, so we reversed the order. Notice here on line 2, the first little lamb did not get switched around. This is because it has an uppercase L, and our regex search was looking specifically for a lowercase l. For the regex to recognize the uppercase L or the lowercase l, we're going to need to update our search. We're going to need to add brackets around our L and add in that uppercase L inside the brackets. So now that letter can be an uppercase L or a lowercase l. Now we see it switch little and lamb the first time it was found on line 2, but not the second one. To make the update in both places, we need to add the G after the delimiter to apply it globally. We can also add in some curly braces or other text. I'm putting in curly braces because we saw that with the ampersand. Maybe Mary did not have a little lamb, but a little goat. We can update our replacement string to show that with, we first want to have the 1 here first because it's little, and then we'll replace this with goat. And this shows we don't have to use all of the values in the output. And if we don't need them in the output, we can remove them from the input, meaning I can remove the parentheses around lamb. We still want lamb in there as part of our regex search string. We just don't need it as a value. And this shows we can substitute part of the regex search value in the replacement value, whereas the ampersand replaces the entire regex search value in the replacement value. When using the -E with this sed substitute, we don't need the escape characters before the parentheses in our search value. I'm typing sed -E, quote S for substitute. Now, instead of using escape parentheses, I'm just putting parentheses around the word tomatoes. And then for my output, I will say canned escape character 1. Ending delimiter, ending quote, and this time I'm going to use the grocerylist.txt file. And here we see tomatoes is now canned tomatoes. And since we're using the extended regex, we can make that tomatoes an or. We can say tomatoes or corn or nuts. And here we see the canned corn, canned tomatoes, and canned nuts. I'm going back to the first substitute command that we saw in the sed part 1 video, where we substituted the letter A's for @ symbols in the grocerylist.txt file. Pressing enter, we see that this prints out all of the lines in the grocerylist.txt file by default. We can turn off the default printing by adding a -n option right after the sed. Now when I press enter, we don't see anything printed because we turned off the default printing, so nothing was printed. To print out only the lines that were updated, we can add P for print after the ending delimiter. Now we see only the lines that were updated. If I remove that -n that turned off the default printing and press enter, here we see all of the lines printed out by default, and then all of the lines that had a substitute are also printed out. So the entire file is printed out one time by default, and the substituted lines get printed a second time. In this example, we're only updating the first occurrence of the A, and we can see that here in Salsa. To switch all of the A's to @ symbols, we'll need to add a G after that final delimiter, and the G is for global. We can put that after the P or before the P. It works the same both ways. We don't need to use the substitute feature when printing out lines. For example, if I type sed P, and this time I'm going to use the Presidents by Height CSV file, we see it prints out every line in the file twice. To print the lines out only one time, we'll need to turn off the default printing with that -N. We see that first record, the header record, looks a little different than the rest of the file. I want to print out only the first record in this file. To do that, I will update this command to print out the first line of the file with 1p. So our command is sed, turn off the default printing, and 1p means print the first line of our Presidents by Height.csv file. And if we want the third line instead of the first, we just change that 1 to a 3. If we want to print the last line in the file, and we don't know how many lines are in that file, we can use a $sign. Now, if we're using the $sign, we need to put quotes around it to let Linux know that we want this to be used as a sed command. We may want to print off all the lines except the header record. To do that, we update our sed command to be 2, $P. So now we're going to turn off the default printing, start in the second line, print all the way to the last line of our Presidents by Height CSV file. Maybe we want to print out lines just 5 through 9. For that, I would change the 2 to a 5, change the $sign to a 9, and there we go, lines 5 through 9. Another thing we might want to do is put a space before that P. So it's lines 5 through 9, space P, and that works as well. Just makes it a little more readable. We can also print out lines that only meet specific regex criteria. Let's print out all of the lines that start with the letter C. To do that, I will type sed-n to turn off the default printing, and then in quotes, I'm going to put my regex to find the lines that start with the letter C, and I want to print them out, end quote, and that's going to be for our grocerylist.txt file. Now this is doing the same thing as grep. Let's say we want to print out a range of records. Instead of starting with the letter C, I want to print out everything that starts with the letter R, and then keep printing until we find a letter C. So I'm going to start with the letter R, add a comma, add our ending regex, which will be lines that start with the letter C, and I want to print those out. So sed will now start printing when it finds a line that starts with the letter R, and continue printing until it finds a letter C. And we see here that it started printing when it found raspberries, and stopped printing when it found coffee, then started printing again when it found rice, and stopped printing when it found carrots, then started printing again when it found red pepper, and stopped when it found crackers. Let's check out the original file with cat grocerylist.txt. Here we see the same thing. We see where this started printing when it found raspberries and stopped printing when it found coffee, then started printing again when it found rice and stopped printing when it found carrots, then started printing again when it found red pepper and stopped when it found crackers. And we can mix our line search. Maybe I want to start on the line 1 and end on the line where I find chicken. Sed has one more thing that I want to comment about, and that is the Q for quit. If I type sed11q grocerylist.txt, it prints out the first 11 lines of the grocerylist.txt file. And if I change that to sed3q, it prints out the first 3 lines. So sed with the Q option works like the head command that we've seen in a previous video. This is not everything sed can do, but enough to get you familiar with some of the main features of SED. In the next video, we'll continue looking at the Linux command line. The cut command allows us to quickly and easily cut out selected portions of a file one of three ways. The three ways of cutting text are by characters, bytes, or fields. In this tutorial, we will only be working with text files, and because each text character is 1 byte, bytes and characters are the same for us. So we are only going to look at cutting characters and fields. I'm going to type ls-lh, and we see that all of the fields line up nicely in columns. So this will work well as a good example to cut fields. We can pipe this ls into cut, but I'm going to put this data into a file, mainly because I want to remove that first line with the total 80K. To put this into a file, I will type ls-lh, and to remove the first line, I'm going to pipe this into a sed command, sed-n, quote, 2, $, space p, quote. And we learned about sed in the last video. I'm going to write the output from here into a file called dir.txt, and I'm using that greater than angle bracket to write out the file. And now I want to cat out that file just to make sure it has what we expect. And here we see the same text as the ls-lh command without the first line and without the highlighting. I'm going to use cut to pull off the file permissions from this file, which will be in columns 2 through 10. That first column is the file type. So the permissions start in column 2 and go through column 10. The cut command starts with cut, then a space, and then I need to tell it what I want to cut, meaning bytes, characters, or fields. I want to cut characters, so I will add -c for characters, and then the fields that I want to cut, which are 2 through 10. And then the file I want to cut this from, which is dir.txt. And here we see we just selected off, or cut, the permissions in columns 2 through 10. We can do the same with ls-lh, and then pipe that into cut-c 2 through 10. But when we do it this way, we get that first line that we removed before creating the file. So I will keep using the file. Let's look at that complete file again. Cat dir.txt. The next field I want to add to my cut fields command is the file owner. To find the column positions of the file owner field, we can manually count over the spaces, but if the field we want is way over to the right, counting all those characters can be a little tedious. To make this easier, I'm going to use wc, the word count command. wc can make this quick and easy, but there is one thing to watch out for. Let's work through an example and see what I mean. I want to find the column position of the first letter of the owner field. So I'm going to select starting over at the first character on the line and select all the way over to the first position of the file owner. I'm going to right click and copy that. And now I'm going to echo that out with echo, quote, and then I'm going to paste in my selected text by holding down Control-Shift-V, add my end quote, and then I'm going to pipe that into WC. This returns us the 1, 3, and 15. 1 is for line, 3 is for words, and 15 is for characters. Characters is the only one that we're really interested in, so I can add the -c for characters after the WC, and we only get the 15 characters. And here's the problem with the number 15. We know that the file permissions ends in column 10. Column 11 is a space, column 12 is a number, column 13 is another space, and column 14 is the number we're looking for. But 15 was returned from word count. The problem is when we use echo. Echo adds a line return at the end, so the prompt won't show right after the echoed text. We saw how tr works a couple of videos back, and we can use tr to remove any non-printable characters. I'm going to edit my command, and I'm going to add another pipe in here. And inside this pipe, I'm going to type tr-dc for delete the complement. And I want to delete the complement of any printable characters. So TR will now remove any non-printable characters before we send it to the word count. Now we get 14, which is the number we want. And to find the last character of the owner name, I'm going to select all the way over to the last character of the owner name. Copy that. Bring back our echo command. Delete out this old text. Paste in the newly selected text with Control-Shift-V. Enter. And we see that that is in column 20. And our cut command will now be cut-C for characters, columns 2 through 10. That will get us our file permissions. Then we want columns 14 through 20 for the file owner. And we want that all from the dir.txt file. Now we see the file permissions and the file owner. They are right next to each other, and that's looking a little too close together. We'll talk more about that in a moment. Right now, I want to pull off that file name too. So let's cat out that dir.txt file again and select from the first character all the way over to the first letter of the file name. I'm going to copy that. Arrowing back to my echo command. Control-Shift-V, enter, and we see that that starts in column 48. So now I want to cut the characters 2 through 10, 14 through 20, and I want to start in column 48 and go through, and notice all our file names are different lengths, but we just want to select all the way to the end of that line. And by not giving any numbers after that 48 dash, it will select everything from column 48 to the end of the line. Pressing enter shows us now we've got the permissions, the owner, and the file name. Now we can do the same thing to cut to a column. Let me bring that back. And I'm going to cut up to column 20, and then from column 48 to the end of the line. And going back to the cut with the 3 fields, I did want to point out that after the commas, there's no space. If we add a space, we get an error. So we can't have any spaces between the numbers we're selecting. I mentioned earlier when we pulled off those fields that they're right next to each other, and we want to put something to separate them. To do that, I will add an output delimiter. And the output delimiter goes right after the characters we're selecting and before the file name. The thing to remember here is we need 2 dashes before typing output dash delimiter. Then we need to add our output delimiter in quotes. I'm adding a comma. Maybe that's still a little too close. Let's add a comma space. Or maybe we just want to have multiple spaces here. So what we put in the output delimiter quotes becomes our output delimiter. I'm going to cat out the precedencebyHeight.tsv file. And the first thing we notice is these fields don't line up in columns like our ls-lh did. So cutting this output by the character won't work. For this file, I'm going to cut the text by fields. And I'll start the command with cut-f for fields. And then I want to cut off the second field, the presidential number. Then I need to add a comma, and I'll cut off the third field, the president's name. And I will cut this from the file precedencebyHeight.tsv. We see the presidential number and the president's name. It pulled off exactly what we expected. I can also pull off columns 2-4 for columns 2 through 4, or maybe all the way up to column 3-3. We'll pull off everything from the beginning of the line to column 3, or 3- we'll pull off everything from column 3 to the end of the line. So we see that cutting by field works pretty much the same way as cutting characters, only it's grabbing those fields. And this is working pretty well with the TSV file, the tab separated values. I'm going to try this with the CSV file, the comma separated values. And pressing enter, we see the entire line. It didn't pull off any fields as we expected. The problem is it was looking for a tab delimiter. That's the default. It didn't find any tabs, so it thinks everything is just one big field and outputs that entire record. To get this to work with a CSV file, a comma-separated values file, we need to tell CUT the input file delimiter is a comma. And we do that after selecting off our fields. Let's make the fields 2, 3 again. And we need to tell it the input delimiter, so -d is a comma. So -d, quote, comma, quote, will tell CUT that the input delimiter is a comma. Now we're selecting off the fields that we expect. And we can change that output delimiter as well, just like we did earlier in this video. I'll add it right after the input delimiter, -- output -delimiter. And we will make that a comma space, presidentsbyheight.csv. And remember that passwd file from the user accounts videos earlier in the series? Cat etc passwd. Those fields have colons separating them. We can use CUT for that file as well. CUT-F for fields. I'll pull off field 1 and field 6. The input delimiter will be a colon this time from the passwd file. And there we have it. We just pulled off the name and the home directory from the passwd file. In the next video, we'll continue looking at the Linux command line. Awk is a programming language, not quite as complete as something like Perl or C, but it is a programming language, and there is a lot to it. So our look at awk will be similar to our look at sed and regular expressions. Not a complete tutorial on the topic, but more of an introduction to some of the main features. The name awk comes from the last names of its authors, Alfred Aho, Peter Weinberg, and Brian Kernighan. I mentioned awk is a scripting language, and it can have many lines of code, but often it is used as a single-line script submitted right from the command line. And that is what we're going to start with here. A typical awk one-line script will start with awk and then have three things: a condition, a code block, and a file name. I'm going to leave off the condition, so this will apply to everything on the file. The code block will go in quotes and then curly braces. And my code will be print. And I'm adding the ending curly brace, ending quote, and then we'll give it the file name of presidentsbyheight.tsv. Pressing enter, that prints out our entire file. The header record is slightly changed from the last time we used this file. Now let's say that we want to pull off only the second and third columns, like we did in the CUT video. To pull off a specific field, we're going to add in a $sign and then the field we want to pull off. I'm pulling off field 2 and then a $3 to pull off the second and third columns. Pressing enter. Notice here we pulled off the second column as expected, but the third column only has the president's first name, not the full name. That's because awk by default uses any white space as a delimiter, meaning tab, space, and line returns. We want to tell awk to only use tabs as the input delimiter, and to do that, I will add a $F for field separator, and then I will add in what I want to use as that field separator, in this case a tab, and I'll put that in quotes. Now when I press enter, we see that presidential number 2 and the full name of the president from column 3. I added a comma between columns 2 and 3. If I take out that comma, we see it prints out the two fields right next to each other, making it look like a single field. If I want to add a comma and 2 spaces between those fields, I'll put it in quotes between the $2 and the $3. And here we see the comma and 2 spaces. Or I could add in the tab character here, and we see it adds in our tab character. So it will add in whatever we put in the quotes between the 2 fields. To print out the number of fields on a line, we can print out the fields NF. and NF stands for number of fields. We see here that all the lines have 5 fields. Let's take off the field separator of tab for the input file. And now we see that some lines have 10 fields, some have 11, and 2 have 12 fields. I want to print off the number of fields and then the entire line to find out why they're so different. To print off the entire line, we print field 0. So $0 will print the entire line. I'll add that right after the NF. Let's add in a quote, space, dash, space, quote, and then the $0 to print out the entire line. Here we see the lines that have more than 10 fields are because they have a middle initial or they have the extra ½ inch in their height. Now let's add a condition to our awk script. So I'm going to add my condition after the single quote, but before the curly brace. And I want it to print out only where the NF, number of fields, is equals 10. And we need to use 2 equal signs for a comparison. A single equal sign is an assignment. So now we have the whole condition, action, and file name. If our condition is true, the number of fields equals 10. We will take that action, which is to print out the number of fields and then that line. And this is for the precedence-by-height.tsv file. And we see it only printed out the lines with the 10 fields in it. Now I want to switch to the Mary.txt file that we created earlier in this series, because that file does not have any tab-separated values. I'm going to start with awk, colon, curly brace, print, NF, quote, space, dash, space, quote, $0, ending curly brace, ending quote for the Mary.txt file. Now I want to print out just the last field on the line, but it changes for each line. Sometimes it's 4, sometimes it's 5, and sometimes it's 6. To print out only the last field on that line, we're going to change this $0 to be $NF. Now, instead of the 0, we're going to put in the 4, the 5, or the 6 that's returned from the number of fields variable. So for the first line, we're telling it to print out $5. For the second line, print out $4. And for the last line, we're telling it to print $6, the value from the NF variable. And here we see it prints out the last field just as we expected. If we want to print out the first to last field, we would do the same thing, but we're going to put in some parentheses, and we'll say NF minus 1. And notice the parentheses do not include the $, just the NF minus 1. Now let's add a condition to print out only the lines that start with Mary. So I will start with awk, quote, and now we want to add our condition, which is $1 equals Mary. And when that happens, we want to print out the entire line with $0. And we'll do that for the Mary.txt file. Now here, if we made a typo and instead of having the 2 equals signs, we only have a single equal sign, we're now changing this from a condition to an assignment. And the first field is now assigned to Mary, so every line begins with Mary. Luckily, awk does not update the file by default. The output is just sent to the screen. I'm arrowing up 2 times here to go back to the working search for Mary, and maybe we can't remember if Mary starts with an uppercase M or a lowercase m. The search is case sensitive, and if I change that uppercase M to a lowercase m, nothing is found. And we might have a situation where we need to search for both uppercase M and lowercase m. For this, I'm just going to leave off the M and change this equals to a tilde. So that tilde will check for the first field to contain ARY, those 3 characters together in that order, anywhere in the first word on that line. We can also use awk just like grep by typing awk and then our regular expression, but our regular expression here will need to be inside of forward slashes, I'm searching for anything that starts with the letter C, and that will be for the grocerylist.txt file that we've worked with many times earlier in this series. If we want to search case insensitive this way with awk, we can't just use the dash lowercase I like we can with grep. With awk, we'll need to use the to lower feature and the tilde, and we'll need to put that all in quotes. I'm going to add in my quote, to lower, and then we'll add in the entire line in parentheses, $0, and then our tilde. And then I'm going to add in Apple as our regex, adding in the ending quote. So what happened is it moved everything to lowercase, searched for Apple, and then prints out the input, whether it's uppercase or lowercase. Awk has another built-in variable called nr for the number of records. Let's use that in the command awk, quote, curly brace, print nr, double quote, space, hyphen, space, double quote, $0, ending curly brace, ending quote, Mary.txt. So nr is number of records, and although sometimes we'll think of the total number of records, and it is, but during the reading process, it's the number of records read so far. So that's why we see the 1 after it reads the first record, and the number 2 after it reads the second record, and so on throughout the file. We can use this as a condition if we add in awk, quote, nr equals 2. Then I'm adding my curly brace, print nr, double quote, space, dash, space, double quote, $0 to print out the record, ending curly brace, ending quote, Mary.txt. And because I spelled print wrong, it didn't print anything. So let's fix that. And now we see that it prints out the second record. Or maybe we just want to skip the first record and print out the rest of the file. We can say where number of record is greater than 2, print out the line. And because I'm saying greater than 2, it did not print out the second line. To print out the second line as well, I need to say greater than or equal to the value 2. Up to now, we've only talked about files with field separators. We can use awk with a file where the fields may not have a field separator, but the fields could be lined up in specific columns, like that dir.txt file that we used in the cut tutorial. I'm going to cat dir.txt, and we can see that I added a new first row to that file. This row shows us where the fields are. Our first field is only 1 character, so I have the 1 there. Field 2 is 9 characters, so I have 2s there. And then the third field is 3 characters, and it works this way until we get up to field 10, which is 0. Then it starts all over again with 1. To read this file with awk, we're going to need to use the awk field widths variable. So I'm going to start my command with awk, and then we need a -v to let awk know that the next value is going to be a variable, and then that variable is going to be field widths, and we're going to assign that variable the field widths that we have noted up above. So our first field width is 1 character, so I'm adding a 1. Our second field width is 9, so I'm adding a 9. The third field width is 3, so I'm adding a 3. And now I'm going to just paste in the rest of this. So we have all the field widths added in, and then we're going to print out fields 1 through 16 of the dir.txt file. And here we see we printed out the 16 fields, and that last field, the file name, they're all different widths. I just used the longest file name for my field width. In the cut video, we only selected off the permissions, the owner, and the file name. And we want to do that here as well. To make it clear which fields we're cutting, I'm going to assign them variable names. So I'm going to change my command. We're going to take off all of the fields here, all the way back to print. And I'm going to add in some variables. We're going to have the permissions, and that we're going to assign the $2 or second field. I'm going to add a semicolon to separate these out. Now I want the owner, and we're going to assign that the value of $4, adding a semicolon, And then the final field we want is the file name. So that will be the name of our variable, and we're going to assign that the value of $16. We need another semicolon to separate this out. And then we want to print out our variables, permissions, owner, and file name. I will add all these files and examples into a download, and I'll put it on the website. This is a good breaking point. In the next video, we'll finish our introductory look at awk for the Linux command line. In the last video, awk part 1, all of the awk examples were submitted as a single command. Awk commands can be placed in a file and then run from that file. Let's review one of the examples from the last video, and then we'll put that command into a file and run it from the file. I will type awk single quote nr for number of records, and I want those number of records to be greater than or equal to the number 2. Now I'm adding my left curly brace, print nr space double quote space dash space double quote, then $0 to print out the entire line, ending curly brace, ending quote, and then the input file of mary.txt. And we see that prints out our file, skipping the first line and printing out the rest of the file. I'm going to select this entire line and copy it. And I want to put that line into a file, so I'm going to open one up with nano. And I'm going to give it the file name of skipfirstline.awk. Here I'm going to paste that command, go to the beginning of the line, and we're going to remove the awk, the single quotes, and the file name Mary. And I will save and exit with Control X, Y, Enter, and that gets me out and saves the file. Now let's run that command from the file by typing awk, then there's a dash lowercase f to let awk know that the next value is going to be a file name, and I want to add that file name, which is skipfirstline.awk, and then I also need to give it the input file name, which is mary.txt. And we see it works. We get the same output whether we ran it from the file or from the command line. I am going to clear the screen. When I cat out the file, precedence by height.tsv, we see those first 3 columns line up nicely, but after that it becomes kind of a mess. I have an awk script created that will print out the precedence by height TSV file, lining up all the fields nicely, and it's called precedence.awk. I will run it with awk dash uppercase F to assign it an input field separator, and I want that input field separator to be a tab. Now the dash lowercase f, because the next value is going to be our awk file, precedence.awk, and then we need to give it the input file name of precedence by height.tsv. Here we see everything lines up nicely. Let's look at that precedence.awk script. I'm going to clear the screen again and cat precedence.awk. Here we see we're checking field 3, the precedence name, to see if it's less than or equal to 8 characters. The title name is only 4 characters, so we will add 3 tabs after printing field 3. Then it checks to see if field 3 has less than or equal to 15 characters. If it does, then it only prints 2 tabs after field 3. And then anything in field 3 having more than 15 characters only gets 1 tab. The purpose of the script was to show you the if, else if, and the length features of an awk script. Let's run this one more time. I have another script that does the same thing with the printf command. I call it precedence-printf.awk. Running that shows all the columns line up nicely, slightly different than the previous example. I'm going to clear my screen, and let's cat out the presidents-printf.awk file so we can look at the code. Here we see a single line with printf. Printf stands for print with formatting. The %-8s here says grab that first value after the double quote, that's this $1, and put it right here as an 8-character string. The next value, field 2, is also an 8-character string. And then this third value here, the president's name, is going to be a string with 23 characters. I'm only using string values in this example, but printf does work well with numbers and decimal points. It will line them all up nicely as well. Let's run this once again. And once again, we see everything lined up nicely. For the next example, I'm going to read in a new file that we haven't seen before called grades.txt. I'm going to clear the screen and cat out the grades.txt file. And this file is just a list of student names and then 5 test scores separated with commas. The awk program is going to read in this file, print out a report header, print out each student name, the 5 test scores, and then calculate an average for those 5 test scores and print that on that same line. And then print out a line at the bottom with the average for each test as well as the average for each of the student averages. The awk program is called findavg.awk, and I will run it with awk-lowercase f, then add the awk file name of findavg.awk, and then I will add the grades.txt file. The result shows the header at the top, then all our lines with the student name, the scores, and then the student average on the right, and then we have the averages at the bottom for each of the tests and for the student average. I'm going to clear the screen, and let's look at that program with less findavg.awk. The first thing we notice in the script is that it's broken into parts. The first part is the begin. Then I have to scroll down a little bit here to see the main section, and then scroll down a little more to see the end section. These 2 new sections, begin and end, we haven't seen before, but they work just how you would expect. It will run the begin section. Once that's complete, it runs the main section till that's done, and then it does the end section. Let's take a closer look at the begin section. The first thing we see is the fs, telling awk the field separator value will be a comma. Then we create a variable called hdrline. We're going to use this variable to build our header line, and we're giving it a value of name. Then we have a for loop with a single line in there. And what this will do is add on to our header line a tab, the word test, and then the number of the times through the loop. So the first time it will be a 1, second time a 2, until it gets to 5. Now, did we need to put this in a loop? Not at all, but I did want to include a loop. After that, we're adding 2 more tabs and the word avg to our header line. And we end our begin section by printing a blank line. We print that header line that we just built, and then we print a line of dashes. Now here in the main routine, we also create a variable and assign it a value of the $1, which is the student first name. Then we clear out the student test total. We set it to 0. And here we have another for loop, but this time we're starting at 2 and going through 6 because the test scores 1 through 5 are in fields 2 through 6. Our first line in the loop is similar to what we did in the header line. We've got our main line and we're adding a tab. And then the $I, so the $I will be $2 the first time and go all the way through 6. We then add that value to the student test total, and then add that same total to the test total in the array of that same value in the for loop. Now don't worry if you don't know anything about loops or arrays. I'm just trying to show that awk has more functionality than grep or sed. After the loop, we calculate the student average by dividing the student test total by 5, and we have this int here. This will force that calculation to be an integer. We then add the student average to the class average total, and then print out that line that we just created. We'll go through that same routine for every student in the file, and then we get to the end routine. First thing we do in the end routine is we create a variable and we assign it avg. Then we loop through 2 through 6 times. Then each time through the loop, we're going to append our average line. And we're going to do a calculation here, taking the total for that test of that number of the array and divide it by NR. Remember that NR is the number of records read, or number of students. After we get through that loop, we print out a line of dashes, we print the average line, and we also calculate the average total for the number of records read, and then print out another blank line at the end. I have one more example here, and this one is a little more unique than the others because it runs like a bash script, only it's an awk script. Let's clear the screen, and I will type ls-lh rectangle.awk. The things to notice here are the permissions. The execute bit has to be turned on for this to run properly, and we see the execute bit is active for the owner, the group, and other. I'm going to run the script with / and then the file name, rectangle.awk. And notice there's no input file with the script. What the script will do is calculate the area of a rectangle. Pressing enter, it's asking me for the height of the rectangle. I'm going to put in a W, and it replies the height must be numeric. Enter the value of height. I'll put in a 3. It likes that. It's asking me for the value of the width. I will put in 5. And the area of our rectangle is 15, which is the height times the width, 3 times 5, giving us 15. Now, before we look at the code, I'm going to type which awk. And we see /user/bin/awk. Now let's look at the code with less rectangle.awk. This first line starts with hash and then an exclamation point, also known as bang. These two characters together on the first line of an executable file are known as shebang. And then we have this user bin awk. That needs to be the value that we just typed in when we typed which awk. Yours may be different than this. And then we have the -f. This single line here is what makes this file run as an executable awk file and needs to be the first line in an executable awk file. The second line below that is just a comment. A quick overall look at our script shows that we have 2 functions and then a begin section. The script starts executing here at the begin section. The first thing that happens is the line enter the value of height is printed, and then the user will type in the value of the height. And then we come to this while loop, and the while loop will pass the value of h for height to check to see if it's numeric. So the check numeric function gets that h, puts it into the value in. The value in is checked to be numeric. If it is numeric, a 1 is returned. If it is not numeric, a 0 is returned. That while loop will keep printing out that height must be numeric line until a numeric value is entered. This whole next section does the same thing with the W or width value. Once we have a valid height and width, we print the area of your rectangle is, and then we call the area function and we pass the height and the width. The area function reads in the height and width and returns the height times the width. This will end our look at the awk command. In the next tutorial, we will continue looking at the Linux command line. When I type wcmary.txt, we see the number of lines is 4, the number of words is 20, and the number of characters is 101. But if I echo out mary.txt and pipe that into WC, we get different results because now WC is finding the word count information from the text mary.txt, which is 1 line, 1 word, and 9 characters, including the final line return the echo command adds in. We want the WC command results of the file mary.txt. To do that, we need to add in the command xargs before we type WC. Xargs stands for execute as an argument, and when the WC command reads in the mary.txt as an argument, it is then able to give us the results we're looking for. And we now see the 4 lines, 20 words, and 101 characters. When I type echo curly brace 1.9 closing curly brace and echo that into xargs,
we see that xargs just echoes out the results, even though we didn't type echo in after xargs. Echo is the default command for xargs, so if nothing is typed after xargs, echo is added. I'll add in echo and run this again, and we see the same results. It's just a little clearer here when we see echo, but it is not needed. We can limit the number of words per line out of xargs, and when I say words, I mean fields separated by spaces. In this case, they're all numbers. I'm going to set the number of words per line to 2 by adding in a -n2 before the echo. And here we see only 2 numbers were printed on each line. And that space between the n and the 2 is not needed. We can make this n2 with no space. We get the same results. There's also a -t option, and T works like verbose. That will show us the command xargs will run for each line of output before it writes out that line. I'm going to clear the screen. The xargs input default delimiter is white space, as we saw, but we can change that. I will type echo quote A:(C:)D:(E:)F end quote, and pipe that into xargs. And xargs sees that as one single field and prints it out as a single field. I'll bring back that command and add in a -d quote colon quote. This will now tell xargs the colon is the delimiter, and we see the output now does not show the colons. And then adding in a -n2 limits the output to 2 words per line. I'm going to clear the screen again. Now that we have the idea of how xargs works, instead of echoing out numbers and letters, let's use output results of the ls command. I will type ls, and we see a list of files and directories. Now I'm going to type ls and pipe that into xargs. And we see the same results without the highlighting, and the results are all on a single line instead of the 3 columns that ls gives us. Let's add in a -n3 to give us 3 words per line. We do see 3 words per line, but xargs isn't really meant to be used to line things up. But it can really help us modify output of an ls command, especially when we pair it up with find or grep. I'm going to change that n3 to n1. And that lines up all of our files and directories in a single column. Before we go any further, I want to mention that none of my files or directories have any spaces in them. We have dashes like presidents-by-height.csv. I'm going to make a new directory with mkdir, and I'm going to call this new directory 3-word directory name. Now when I run the ls into xargs-n1, we have a problem. 3 is on one line, word is on the next, and directory name is on a third line. Xargs saw the space in the directory name and split up that directory name by the space. To fix this, we need to add a -0 onto our command. That will tell xargs to split on null characters instead of any white space. Now we see the 3-word directory name is on a single line. I'm going to clear the screen again. Another option for xargs is the replacement string, which uses the option -I. I will type ls and pipe that into xargs and use the -n1 option. And now I will add in the -I to identify my replacement string, which will be curly braces. And now I want to echo out the file directory name is and put in the curly braces. Now instead of just echoing out the file name, it added our text to every field that xargs echoed out. And note here, we did not need to add that -0 for the 3-word directory name. I used curly braces, but they do not have to be curly braces. I'll replace the curly braces with :repstr for replacement string in camel case. And we see that that works. And I don't need those colons on there either. But if I take them off, we see that it makes it a lot more difficult to see what the replacement string is. But it still works just the same. It's just a little more difficult to read. I recommend always using the curly braces. You'll see that most often, and using anything other than curly braces has potential to cause other problems. I'm going to clear the screen again, and I'm going to make a directory with the mkdir. I'm going to call this xargs_dir. Now in this directory, I want to create a text file for every item on the grocerylist.txt file. And to remind us all of what's in that grocerylist.txt file, I'm going to cat that out. And we see there are a lot of items in that grocerylist.txt file. To create a text file for every item in that file manually would take a lot of effort. But with xargs, we can create this in a single command. I will type cat grocerylist.txt, and then I'm going to pipe that into xargs. And I want to identify a replacement string of the curly braces. And this time, instead of echo, I'm going to type touch. And I want to touch a file inside our xargs.dir. And I'm going to touch a file for everything from the xargs command. And I'm also going to add in a .txt to make it a txt file. Pressing enter, I just created a text file for every item in that grocerylist.txt file. Let's show that they were all created by typing ls-lh xargs_dir. And we see all of the files were created. And we notice here that Michael is set as the owner and the group for every file in this directory. I want to update the group for all of the files that start with the letter S. In an earlier video, we learned that we can only update the group to be a group that we are already a member of. To see what groups I am already a member of, I will type ID. We see I'm a member of the CD-ROM group, so I want to update the group to be CD-ROM for every file in the xargs directory that starts with the letter S. To do that, I will type ls for everything that's in the xargs_dir directory. And we can leave that / or we can remove it. And I'm going to pipe that into grep, where I want to grep out all the file names that start with the letter S. So that will be quote, $s, end quote. And then we'll pipe the output of that into xargs, where I will identify my replacement string as curly braces. And then we're going to change the owner with the chown command. And I'm going to make it michael.cd-rom for every file in the xargs directory that matches our replacement string. We'll see how that worked by typing ls-lh xargs_dir. And here we see that the files that start with the letter S are now updated to have a group name of CD-ROM. That was using grep. Now let's use the find command with xargs. I'm going to clear the screen, and I want to find everything in the xargs directory that has a name, so -name, that starts with a P. Let's make this iname, so it'll be case insensitive, that starts with the letter P. And then I want to pipe that into xargs, where I'm going to identify the replacement string of curly braces, and I want to change the mode, so that will be the chmod command. And I'm going to change all of those files to be 700. And then we need our curly braces there for the replacement string. Typing ls-lh xargs_dir shows us the files are now bold and in a different color because they're now executable files, and only the file owner has access to them. And one last thing I want to do is add something to the file names. We already looked at grep and find, so I'm just going to rename everything in the xargs directory. So I'll start with ls, the xargs directory, and I'll pipe that into xargs, where I want to identify my replacement string of curly braces, and I'm going to move everything in the xargs directory that matches those curly braces, and I'm going to move it to the xargs directory, and I'm going to add LCL45 xargs underscore to those file names. Pressing enter, and let's show what's in that directory. And we see that we've added LCL45 xargs underscore to all of the file names. In the next video, we'll continue looking at the Linux command line. Linux has a lot of options to archive and compress data. In these next few videos, we're going to look at some of the most common tools to compress and archive data for the Linux command line. In this video, we're going to look at compressing a file with the gzip command. And when gzip was created, it was intended to be used with GNU, and most likely that is where the G in gzip comes from. Let's start off by looking at what is in our current directory with ls-lh. To compress a file with gzip, we start with the gzip command and then put in the file name. I will zip up the mary.txt file with gzip mary.txt. Typing ls-lh again shows us the mary.txt file is gone and the file mary.txt.gz was created in its place. If we try and view that file with cat mary.txt.gz, it will cat the file, but since that text is compressed, the output is unreadable. To view a gzip file, we'll need to use zcat mary.txt.gz. And here we see that zcat will read the file, decompress it, and show it on the screen. But the file itself is still compressed. We'll show that with ls-lh. And there we see mary.txt.gz is still compressed. To grep a gz file, we will use zgrep lam mary.txt.gz. And zgrep works like zcat. The results are decompressed and shown on the screen, but the file itself is still compressed as mary.txt.gz. We can decompress a gzip file one of two ways. One way is with gzip, then a dash, the lowercase d for decompress, and then the gzip file name. Typing ls-lh shows us that the mary.txt.gz file is gone and the mary.txt file is back. Let's gzip that mary.txt file again to show the other way to unzip a gzip file. And the second way to unzip a gzip file is with gunzip. Some people call this gunzip, but it's actually gunzip. And then we add in the file name of the gzip file we want to unzip. And typing ls-lh again. And once again, we see that the mary.txt.gz is gone and the mary.txt file is back. If we want to zip up that file and keep the original unzipped version, we can add a -k. gzip-k mary.txt. And there we see we have both the mary.txt and the mary.txt.gz. I'm going to remove the mary.txt file. And I did that to show that the -k option for keep will also work with gunzip -k mary.txt.gz, or we can use it with the gzip -dk mary.txt.gz. These will both work, but I'll just show the one here. And there we see that mary.txt is there as well as the mary.txt.gz. Now I'm going to remove the mary.txt.gz file. And I did that so we can zip it up again. If we want to zip up multiple files,
We can do that in one command, just one file after the other. gzip mary.txt, and we'll also zip up the grocerylist.txt file. And here we see mary.txt.gz and grocerylist.txt.gz. To unzip multiple files with gzip, we can use gzip-d and typing MA, and I'm tabbing to autocomplete the file name. And I'm going to add the grocerylist.txt, and my autocomplete does not work for a second file name. But if I use the gunzip, mary.txt, grocerylist.txt, the tab autocomplete does work with multiple file names with gunzip. These will both work, but I'll just show the one here. gzip also has the lowercase v for verbose option. I'm going to press the arrow up a couple of times to where we gzipped multiple files, and I'm going to add the -v option here and run this again. And here we see mary.txt was replaced with mary.txt.gz, and it gives us the percent the file was reduced. The same thing for the grocerylist.txt file. Gzip has a compression level of 1 to 9. 1 is the fastest speed with the minimal compression, and 9 may take a little longer, but it will give the best compression. To see how this works, I'm going to use the findavg.awk file that we created a few videos back. I'm going to copy the findaverage.awk to findaverage-1.awk, and let's do the same thing with -9.awk. Now let's compress them and add in the compression level to see the difference. I'm going to gzip, adding -v for verbose, and then the 1 for the compression level, and we'll do that for the file findavg-1.awk. We see that was compressed at 64.7%. When we do the same thing with the -9 file, and we want to make this the -9 compression level, we see that compression level 9 did compress that file more. Gzip also has an L option to list out the information of a gzip file. gzip-l findavg-1.awk.gz. And let's do the same thing with the -9. And here we see the compressed and uncompressed file sizes as well as the percent it was compressed. So the compression level 1 started with an 883 byte file and compressed that down to 344 bytes. And the level 9 compression also started with 883 bytes and compressed that down to 326 bytes. And if we type ls-lh, we can see those same file sizes here. The original 883 bytes went down to 344 bytes with the level 1 compression and down to 326 bytes with the level 9 compression. We can zip up all the files in the LCL directory, but first let's see what's inside that LCL directory with ls-lh LCL. We've got a lot of files and a couple of directories. Let's see what's inside that new directory with ls-lh/new directory. We've got 2 files in there. To zip up all the files in the LCL directory with gzip, I will type gzip lowercase r for recursively zip up all the files in the LCL directory. And I didn't have the verbose in there, so we didn't see them all get zipped up. But typing ls-lh LCL shows us all the files were zipped up. They were all zipped up independently, but the directories were not zipped up. And if we look in the LCL new directory, we see those 2 files were zipped up as well. Let's unzip all those files now with gunzip-r and then the directory name of LCL. Typing ls-lh lcl shows us all the files were unzipped. Let's look at what's in our current directory with ls-lh. And we see we've got the mary.txt file still zipped up. I'm going to unzip that with g unzip mary.txt.gz. If we want to gzip a file into a new file name, we'll need to add the -c option. And this C option is to compress the data to standard out. An example will be gzip-c mary.txt, and I want that output to go into mary.back.gz. Typing ls-lh shows us the mary.txt and the mary.back.gz. To view what's in the mary.back.gz, we'll need to use the zcat. We can add another file to our mary.back.gz file, gzip-c precedence by height.csv, and we're going to append that on to mary.back.gz. And zcatting that out now shows the data from both those files are in that single file mary.back.gz. If we want to put multiple files into a single archive file, we'll need to use the tar command. And we'll look at that tar command in the next video of the Linux command line. Tar is short for tape archive. And the idea of the tape archive command is to place multiple files and/or directories into a single file. And then that single file can be moved to a backup or archive device, which in the 1970s, when this command was created, was a tape archive storage device. Most of us don't use tape storage devices today, but we still call it the tar command. The new container file created by the tar command is called a tar file, and some people, including me at times, will call this tar file a tar ball. Tar ball, tar file, they're the same thing. It's just a file created from the tar command. To create a tar file, we will start with the tar command. And I want to create a tar file, so the next thing I'm going to type is -- create. Then I'm going to add -- file equals, and here's where I will give it the new tar file name I want the tar file to be called. And I will call this file bkup.tar. And now I can add in the files that I want to be in this tar file. I will type in the file names mary.txt and find avg.awk. Pressing enter, I see the standard Linux no news is good news, and typing ls-lh shows the new bkup tar file right up there at the top. And we see our original files are still there as well. I'm going to remove the new tar file with rm bkup.tar and type ls-lh to show that it's gone. Now let's recreate that tar file. But this time I'm going to add in --verbose after the --create. Pressing enter now shows us the names of the two files that were placed in the tar file, mary.txt and find avg.awk. I could also have added in --verbose a second time, and that would have shown more details like the file owner, the file group, and the file size, and the like. I'm going to remove that backup file again with rm bkup.tar and type ls-lh to show that it's gone. Now we're going to create that same tar file a third time, but this time using a format we're more familiar with. I'm going to type tar-cvf space bkup.tar mary.txt and find avg.awk. So why did I start showing this command with the long version of --create and --file? I did that because in a few weeks or months from now, when you start typing the tar command, if you have to stop and think, I know there's a dash and some letters, but I can't remember which ones. Hopefully, you'll remember the full words that we typed out just a moment ago, the C for create and the F for file. Those are the only two characters that you really need to create a tar file, the C for create and the F for file. And since they're really required, you don't need to use that dash before the CF. The dash is optional, but I like to keep it in just to be consistent with the other Linux commands. And then we can add in a V for verbose or VV for verbose. Those V's are optional. With the abbreviated version F for file name, we no longer need that equals sign. But now this command is slightly different than the commands that we've been looking at up to now. What I mean by that is, when we learned the CP command for copy, we type CP, then the source or existing file first, then we type the destination or the new file name. And when we use the move command, we have the same thing. We type MV for move, then the source or existing file name, then we type the destination or the new file name. And we use that same format for a symlink. We type in the ln-s, then the source or existing file first, then the new symlink name that we want to create. But now with the tar command, the format is slightly different. We type in the tar command, then we type in the new file name first, then the existing source file name or file names that we want to add into the tar file. And it makes sense to do things this way because we don't know how many files we're going to add into that new tar file. So it makes sense to put the new file name first. We just need to remember that the tar command is slightly different than the other commands we've been working with up to now. Pressing enter, and then ls-lh shows us the new bkup.tar file is created. If we want to add a directory to a tar file, we just add the directory like we do a file. I'm going to press the arrow up to bring back that tar command. And I'm going to change our file name to be bkup-lcl. And then I'm going to add LCL to the end here, just as I would another file name. And notice we do not need to add that dash lowercase r to recursively include all the files and directories in the LCL directory. This is another thing that makes the tar command slightly different than the other Linux commands we've been looking at in this tutorial series. Pressing enter. And notice here in the verbose output that when the tar file is created, it does include the subdirectories, new directory and all the files in that directory, and new directory 2 in all the files in that directory. Typing ls-lh now shows us that we now have 2 tar files. And after some time has passed, we may not remember what we included in those tar files. We don't want to have to extract the tar file to see what's in it. We just want to see what is in the tar file. To do this, we're going to start with the long version of the command. I will type tar-list-file equals bkup.tar. And we see the files mary.txt and find avg.awk. The abbreviated version of the command is tar-tf bkup.tar. And notice here that we use the lowercase t for list. The L's were already used for other options. Pressing enter, we see the same results. And if we can't remember that we're using t for list, you can always type out tar-list-f bkup.tar. Here we're using the mix of the abbreviated and the non-abbreviated command option formats, which works without any problems. If we want to see more file information about the files in our tar file, we can add in the verbose option, tar-tvf bkup.tar. And here we see more details about the files in the tar file. I'm going to create a new directory to extract that tar file into. So I will mkdir to make a new directory, and I'm going to call this directory tar X for tar extract. And now I want to copy one of the tar files we just created into that directory. So I will cp for copy bkup-lcl.tar into tar-x. And now I'll cd into the tar-x directory. and ls-lh to show that we only have the one file in there at the moment. To extract the tar file, I'm going to type tar, then -x for extract, and F for file, and then give it the name bkup-lcl.tar. ls-lh shows the two files, mary.txt and findavg.awk, and we also see the directory LCL. And then typing ls-lh LCL shows us all the files and directories in the LCL directory, and ls-lh LCL/new directory shows us the files in the LCL new directory. This shows that all the files we expected were in the tar file and extracted as expected. This is a good breaking point, so we're going to end the video here, and we will pick it up from here in the next video, tar part 2, for the Linux command line. We are picking up from where we left off in the last video. We're in the tar-x directory where we extracted one of the tar files that we created in the last video. That tar file, bkup-lcl.tar, is in this directory, as well as the extracted files, mary.txt, findavg.awk, and the LCL directory. I'm going to make some changes to the mary.txt file using nano. And I'm going to save these changes with Control-X, Y without Control, and Enter. Let's cat out this file to show the changes are made. If I want to set the file back to the version in the tar file, as well as all the other files and directories in the bkup-lcl.tar file, we can extract that tar file once again with tar-xf bkup-lcl.tar, and typing cat mary.txt again shows all 4 lines are there. So when we extracted those files again, it just overwrote everything that was there with what was in the bkup-lcl.tar file. I'm going into nano again to edit the mary.txt file and saving my changes with Control-X, Y without Control, and Enter. So our changes are back. And I'm also going to remove the findavg file with rm findavg.awk and ls-lh just to show that it's gone. Now I want to keep the changes I made to the mary.txt file and all the other files that are in the tar file, but I also want to restore that findavg.awk file as well as any other files that were deleted that are in the bkup-lcl.tar file. To do that, I'm going to extract that tar file again, but this time I'm going to add the lowercase k option to keep the existing versions of any files in the tar file that are still here. In other words, this will only restore files from that backup tar file if they don't currently exist. tar-xkf bkup-lcl.tar. And here we see a lot of warnings that it could not extract the files because most of the files already exist. Typing ls-lh shows the findavg.awk file is there once again. And typing cat mary.txt shows the file only has 2 lines, so we kept the changes that we wanted for the mary.txt file. We can also extract a single file from the tar file. Let's say we no longer want those changes that we made to the mary.txt file, and we want to just go back to the version that's in that tar file. We can do that with tar-xvf bkup-lcl.tar, and then we put the name of the file that we want to extract, mary.txt, pressing enter, and then catting out the mary.txt file. Shows the file is now the extracted version of the mary.txt file, and that overwrote my updates, and once again we have all 4 lines. I'm going to go up one directory and ls-lh. I want to make a second tar extract directory, so I will do that with mkdir tarx_2. And I want to extract the bkup-lcl.tar file into that new tarx_2 directory from the current directory. I don't want to have to move it into that directory and then extract it. To extract the tar file into a different directory, we're going to start out the same way that we did to extract it into the current directory, meaning we will type tar-x for extract, v for verbose, f for file, and then we'll give it the file name. Now we're going to add a -C. This will tell tar that we want to change the directory before extracting. Then we want to give it the directory name. So I will put in tarx_2. This is the relative path. We can use that, or we can use the absolute path. Let's change this to the absolute path. /home/Michael/tarx_2. Extracts that tar file into the tarx_2 directory, and I'll show that with ls-lh tarx_2. This shows the two files in the LCL directory were extracted, and adding the LCL directory shows us all the files and directories in that LCL directory as well. I'm going to create a tar file of the LCL directory using the full path. tar-cvf bkup-fullpath.tar. And here's where I put in the full path. Home, Michael, LCL. Pressing enter, then ls-lh shows that that's created. I'm also going to create another tar extract directory with mkdir tarx_3. And now I want to tar-extract verbose file bkup fullpath.tar. And I want to change the directory to put that into the tarx_3 directory. Pressing enter, that is done. And when I type ls-lh tarx_3, notice here we see the home directory instead of the LCL directory. And then adding /home to my ls command shows the Michael directory. And doing the same thing, but adding the Michael directory on there shows us the LCL directory. And then adding the LCL directory on there shows us the files and directories inside that LCL directory. What this is doing is keeping the full path of home Michael. None of the files or directories in the home or Michael directories are included in this tar file, just the directory names, which is the path /home/Michael, and then the LCL directory and all the files and directories in the LCL directory are included in this tar file. This is useful if you want to extract a tar file to the exact location it was in when you created it. I'm going to rename the LCL directory with mv LCL to lcl.bak. So our LCL directory is gone. Now I'm going to extract that bkup-fullpath.tar file into the location it was in when we created it by extracting it into the root directory. I'll do that with tar-xvf bkup-fullpath.tar. Now I'm going to add the ~C to change the directory. And I want this directory to be the root directory, so I'm just giving it the /. So this will first go to the root directory, then extract into the home directory, which exists this time, so we don't have to create it, then the Michael directory, which also exists, so we don't have to create that, then the LCL directory, which does not exist, so that will get created, and then all the files and directories in the LCL directory are then extracted here as well. Pressing enter, then ls-lh shows our LCL directory is back, And ls-lh LCL shows all the files and directories are back as well. Now I want to use the absolute path to tar a directory, but this time I don't want the absolute path in the backup. To do that, I will type tar-cvf and the new file name of bkup no abs path-lcl.tar. Now we're going to add the -C to change the directories, and I want to change the directory to be in the home Michael directory. Then I'm going to leave a space and put in LCL. And if I had other file names in the Michael directory I wanted to include in this tar file, I would add them as well. And I'll make another tar extract directory with mkdir tar_x_4. And now I will tar extract verbose file bkup no abs path-lcl.tar. And I want to change the directory into the tar_x_4 directory, and showing the content of the tar_x_4 shows we have the LCL directory, but we don't have the /home/Michael before it. And then adding the LCL here shows all the files and directories in the LCL directory. I'm going to clear the screen and typing ls-lh. Going up a little bit, we have this bkup.tar file. To see what's in that bkup.tar file, I'm going to type tar-tf bkup.tar. And we see we've got two files in there, the mary.txt file and the avg.awk file. We can add another file to that tar file by updating that tar file with tar, u for update, v for verbose, and f for file. Then we add our existing file, which is bkup.tar, and then we add in the file or files that we want to add. In this case, I'm going to add in the grocerylist.txt file. Pressing enter, our grocerylist.txt file was added. If I try and update that tar file again, just by pressing the arrow up and enter, nothing happens. Tar sees the current version of that file is already on the tar file, so it does not add that file. There's nothing to update because it has the same timestamp. If I touch grocerylist.txt and then try adding it in again, we see the grocerylist.txt file does get updated in our tar file. Let's touch that grocerylist.txt file again. This time I'm going to type tar rvf bkup.tar grocerylist.txt. And like the U for update, we can use the R for append. R does not replace anything. And just like the U for update does not overwrite anything. They just add a new version of the existing file by appending a new version into the tar file. We can see this by typing tar-tvf bkup.tar. Here we see all three versions of the grocerylist.txt file. I'm going to make another tar extract directory. I'm going to call this one tar_x_5 for tar extract 5. And I'm going to copy the backup.tar file into tar_x_5. And then I'm going to cd into that directory. And now let's extract that tar file with tar-xf bkup.tar, and ls-lh shows us it only extracted 3 files. So what happened to the other 2 versions of the grocerylist.txt file? The answer is they have the same name, so it restored the first version, meaning the earliest timestamp, then restored the second version with the same name, so it overwrote the first one, and then it overwrote the second one the same way, and that is why we only have one version of the grocerylist.txt file, and it is the one with the most recent timestamp. I will remove all these files with rm find avg.awk, grocerylist.txt, and mary.txt. I'm going to extract this tar file again with extract, but this time I'm going to add the K for keep. And when I press enter, we see that it cannot extract the grocerylist.txt file because it exists. Typing ls-lh shows us this time it extracted the earliest version, and then it could not overwrite the file because we told it to keep a file if it exists. So we have the earliest version of the grocerylist.txt file. If we want to restore a specific occurrence of a file with multiple versions in the tar file, we need to use the -- occurrence option. Pressing the arrow up, I'm going back to the tar. I'm going to take off the K for keep, and then I'm going to add -- occurrence equals 2. And then the file name that I want the second occurrence of, which in this case is the grocerylist.txt file. Pressing enter, and then ls-lh shows that now we have the second occurrence of the grocerylist.txt file. The first occurrence would be the oldest version, and the third occurrence would be the most recent version. In the next video, we'll look at creating a tar file and zipping it up in a single command for the Linux command line. In the last few videos, we saw the gzip command and then the tar command. Before we look at compressing tar files in a single command, there are two other ways of compressing files that I want to look at. The first one is called bzip2. bzip2 is similar to gzip, and the idea behind bzip2 is that it is a different compression method that can create a smaller archive file than the gzip command, but it may take a little longer to run. The bzip2 command follows the same format as gzip. To zip a file with bzip2, we would just type bzip2 and then the file name we want to zip. bzip2 mary.txt. We see that the mary.txt file is gone and mary.txt.bz2 is created. bz2 is the extension for bzip2 files. We can cat a bzip2 file with bzcat. bzcat mary.txt.bz2. We can grep a bz2 file with bzgrep. bzgrep lamb mary.txt.bz2. And we can decompress a bzip2 file with bzip2-d mary.txt.bz2. I'm going to zip that back up with bzip2 mary.txt because I also want to show that we can unzip a bzip2 file with bunzip2 mary.txt.bz2. The other compression method that I want to touch on is xz, and this one works similar to gzip and bzip2. The xz command can make a smaller compressed file than the other two compression methods, but again, it may take longer to complete. Now, you may or may not see a difference between the three compression methods. It all depends on the size, the type of files you're zipping up, and if those files are already compressed or not. To compress a file with xz, I will type xz mary.txt. And this shows that the mary.txt file is gone and mary.txt.xz is there in its place. We can view the content of an xz file with xzcat. xzcat mary.txt.xz. We can grep an xz file with xzgrep. xzgrep lamb mary.txt.xz. And we can decompress an xz file with xz-d mary.txt.xz. And I'm going to zip that up again with xz mary.txt to show that we can also unzip the mary.txt.xz file with unxz mary.txt.xz. Now that we have 3 different ways of compressing files, we want to look at using these 3 methods to zip up a tar file. We can do this in 2 steps. First, create the tar file and then compress that tar file using the methods that we have already seen. This can be done, but there is a way to create a tar file and zip it up using one of these 3 compression methods in a single command. When creating the tar file, if we want to also compress that new tar file with the gzip compression, we would add a lowercase z to the options. So the command would be tar-c for create, v for verbose, and now I'm going to add a lowercase z for gzip. Then I need to add the f for file name, and then I'll give it the file name of bkup.tar.gz. And then we'll add the files and directories that we want to go into this gzipped tar file, and that will be mary.txt, findavg.awk, and lcl. Pressing enter, we just created a tar file that has also been compressed with the gzip compression. To create a tar file with the bzip2 compression, I'll start it off the same way, tar-c for create, v for verbose, but now we want to make this a bzip2 file, so we're going to add a lowercase j. Yes, you heard me correctly. It's a lowercase j that we use to tell tar to zip that up with a bzip2 compression. Then we'll add the lowercase f for file, give it a file name, bkup.tar.bz2, and then we'll add in the files mary.txt, findavg.awk, and lcl. And then to create a tar file with the xz compression method, we follow the same format, tar-c for create, v for verbose, and then we want to use the xz compression method, so we're going to put in an uppercase j. So the uppercase j will tell the tar file to zip up that file with the xz compression method. Then we add on the lowercase f for file name, add on the file name we want to give it, bkup.tar.xz. Then the files and directories we want to put in this tar file, mary.txt, findavg.awk, and lcl. Now we have our 3 different tar files, ls-lh, and we're going to grep this to only show the tar files, bkup.tar. Some time has passed and we have forgotten what is zipped up into those tar files. To see what is in the gzip tar file, I will type tar-t for list, then the lowercase z for the gzip compression, and then an f for the file, and we'll put in the file bkup.tar.gz. Pressing enter, this shows us all the files that are in that bkup.tar.gz file. This method works pretty well, but what happens if I mislabeled the bzip2 file to be gz instead of bz2? Or maybe there's no extension on the compression file at all. If I type tar-tzf bkup.tar.bz2, we get an error that the file is not compressed as bzip2. And one thing I can do is find out what compression method is being used by typing in file and then the file name. File bkup.tar.bz2. This shows us the bkup.tar.bz2 file contains bzip2 compressed data. The other way to get around this is to just leave off the compression method completely and let tar decide which compression method to use. tar-tf bkup.tar.bz2. To extract a zipped tar file, we can do the same thing. We can leave off the compression method in the extract command, and tar will decide which format to use to unzip the file. tar-xf bkup.tar.gz, and for the bzip2 file, tar-xf bkup.tar.bz2, and for the xz file, we'll also type tar-xf, and then the xz file name, bkup.tar.xz. So tar won't complain if you don't give it a format when you're extracting the files. To see the difference between these three different compression methods, I did a simple test of compressing the home/Michael directory on my main computer. I first used the gzip compression method. The original file size was 90 gigabytes, and gzip compressed that file down to 68.1 gigabytes. This took 53 minutes, so just under an hour to compress that data. Then I ran the same test with the gzip2 format. That compressed the data down to 66.2 gigabytes, but that took a little longer. That took 3 hours and 19 minutes, but it did make the file smaller. Then I ran that same test again with the XZ compression method. The XZ compression method compressed that same data down to 61.6 gigabytes. But to compress that data down with the XZ compression method, it took 10 hours and 47 minutes. So the XZ compression method did make the smallest compressed file, but it took way longer to create that compressed data. If you're wondering how I got those times, I used the time command. And the way to use the time command is to just type time before your command. Time, tar, cvzf, bkup-t, tar.gz. Mary.txt, findavg.awk, LCL. And when I press enter, it will zip everything up, and then it shows me the time it took to run. Actually, it shows me 3 times. The top one, the real time, is the clock on the wall time your job took to run. That's the number I used in my calculations. The other times shown are user and sys. The user is the CPU time spent in user mode, and sys is the CPU time spent in system time or kernel mode. In the next video, we'll continue looking at the Linux command line. The tar command is not the only way to create an archive file in the Linux command line. We can also use zip and 7-zip. The zip format is similar to the tar command. To zip files with the zip command, we would type zip space, then the new zip file name. I will type in bkup.zip, then the files we would like to place in this new zipped file, mary.txt, and find avg.awk. Pressing enter, we see that it added the mary.txt file and zipped it to 39%, and the avg.awk file was also zipped to 67% of its original size. I'm going to overwrite that file by typing zip.bkup.zip, and I'm going to add in the files mary.txt and find avg.awk, but this time I'm also going to add the LCL directory. We see that it added the LCL directory, but it did not include any of the files or directories inside of that LCL directory. To include the LCL files and directories, we'll need to add the lowercase -r. Like we've seen before, to tell the zip command to recursively include all the files and directories in the LCL directory. Pressing enter. This time it included all of the files and the subdirectories in the LCL directory. Typing ls-lh shows the new file was created. After some time passes, we may forget what was in that zipped file. We can see what files are inside the bkup.zip file without unzipping it by typing zipinfo bkup.zip. This shows us all the files and directories inside there. We can also type zip-sf and then the file name. This also shows what is inside that zipped file with not as much detail. Another way to view what's inside a zip file is with the unzip-l command and then the file name. And then another way to see what's inside a zip file is with the less command. And here we can see that it's paginating it for us. I'm going to create a new directory to unzip this zipped file into, and we'll call this zip
zipx_1, pressing enter, creates the directory, and I'm going to copy the bkup.zip file into the zipx_1 directory, and going into it with cd zipx1. To unzip a zipped file, I will type unzip and then the file name. And ls-lh shows that it was all unzipped. We can also see the LCL directory with ls-lh LCL. Going back up a directory, I'm going to make another zip directory with makedir zipx_2. And just to show where we're at, I'm going to type ls-lh. And now we want to unzip the bkup zip file into the zipx_2 file without having to move it in there and then unzipping it. So we're going to do it right from here. To unzip a zipped file into a different directory, we will need to add a -d for directory, just like we added the -C to extract a tar file into a different directory. So I will type unzip bkup.zip, and then we want the -d into the directory zipx_2. And to show that that worked, I'll type ls-lh zipx_2, and we will also add the /lcl to show that the LCL directory unzipped everything properly. Creating 7-zip files with the 7-zip command is similar to the way we use the tar and zip command, but it's slightly different. We will start with the 7z command. Then we need to add a a to add files. And we'll give it the file name we want to add those files to. I will call this bkup.7z. And then we'll add the files we want to add into this 7z archive file. I will add in mary.txt, find avg.awk, and LCL. And notice there's no dash before the lowercase a, which we're not used to seeing. Adding a dash before the lowercase a will cause an error. Pressing enter, we see our 7-zip archive file is created. To see the files inside a 7-zip file, we can type 7z and then a lowercase l, again without the dash. The L is for list files, and then the file name of bkup.7z. And we see all the files inside that 7z archive file. I will create a new directory to extract our 7-zip files into, and we will call this new directory 7zx_1, and then copy our bkup.7z file into the new 7zx_1 directory, and going into it, we will show that we have our zipped file in there. And to extract that 7z backup file, I will type 7zx, again with no dash, bkup.7z. It's showing us that everything was unzipped. ls-lh shows that they're there, as well as ls-lh LCL shows our LCL directory was extracted as well. Going back up a directory with cd, and I'm going to make a new directory. We'll call this 7zx_2, and we want to extract our 7-zip file into that 7zx2 directory. To do that, I will type 7z, then the x to extract our bkup.7z file. And then we type -o. And this is telling us to redirect the output of the extract command, and then we'll give it the file name. I'm going to use the absolute path of /home Michael 7zx_2. And that would be for the absolute path. If I want to use the relative path, I would just make it the 7zx_2. And this does look a little funny because there's no space between the -o and the directory name. but that's how the command works. Pressing enter, we see everything looks like it's extracted okay. Let's ls-lh 7zx_2. We did extract the files there, and we also want to check the LCL directory, and those files were extracted as expected as well. There are a lot more options available for the zip and 7-zip commands, including encrypting zip and 7-zip files. I do not use zip or 7-zip to encrypt anything, mainly because a quick internet search of how to open encrypted zip file without the password or how to open encrypted 7-zip files without the password shows a lot of results. Now, I don't know if they work or not. I have not tried any. I'm just suggesting that encrypting files with zip and 7-zip might not be the most secure method of encrypting your data. The last thing I'm going to say about the archive files we've been looking at in this section is that if you're familiar with Vim, Vim can be used to view files in a compressed archive file. When I type vim bkup.zip, we see the files in the bkup.zip file. To quit out of this, I'll type :q. Now let's try vim bkup.tar.gz. It's working again here, and to get out, I will type :q. But when I type vim bkup.7z, the files are still compressed. So Vim doesn't work with everything, :q, but it is pretty good. And if you're already familiar with Vim, it's worth a try. In the next video, we will continue looking at the Linux command line. rsync stands for remote sync and can be used to sync files from one computer to another. But rsync can also be used to sync files from one directory to another. The rsync command works similar to the copy command that we looked at earlier in this series, but rsync has a lot more features. Typical use of the rsync command is rsync source destination. I've created a directory specifically for this video called rsync. So let's cd into that directory right now with cd rsync. And then I'll type ls-lh to show the directory src. This is going to be our source file. To see what's in the src directory, I will type ls-lah_r. And this shows that we have the source directory and then some files inside the source directory, as well as a subdirectory inside this directory, and then 2 images inside that subdirectory. src will be our source directory, and I will make a destination directory with mkdir dst. So src is our source directory and dst is our destination directory. I'm going to rsync the grocerylist.txt file from inside the src directory to the dst directory. To do that, I will type rsync src grocerylist.txt, and then I want to give the destination directory of dst. Pressing enter, we have the standard Linux no news is good news lack of any message, but the file is now synced over to our destination directory dst, and we can show that with ls-lh dst. And there we see the grocerylist.txt file. We can add the -v for verbose option for rsync. That will show a little more information. We see it synced the file grocerylist.txt, and then there's some more information about the command. I like using verbose with the rsync command because it shows us right away what files were synced. Now let's say I want to rsync the entire src directory to the dst directory. But we need to get clear on what we mean by sync the entire src directory. Do we want to rsync the directory called src into the directory called dst? Or do we just want to rsync all the files and directories in the src directory to the dst directory? Let's do it both ways. First, let's just rsync the entire src directory into the dst directory. I'm going to try that with rsync-v src dst. Pressing enter, we get the message skipping directory src. And that will show even without the -v verbose option. And again, we get the skipping directory src. And we've seen this message enough times in this video tutorial series to know that it means we need to add the -r option to recursively rsync everything in the src directory to the dst directory. So I'll add in the R right here to rsync recursively. And now we see that we've synced the src directory, all the files in the src directory, as well as the subdirectory inside that src directory, and the 2 files inside there as well. And then to show that everything was rsynced properly, I'm going to type ls-RA DST. And here we see inside the DST directory, we have the grocerylist.txt file that we rsynced earlier, as well as the src directory. And then inside the src directory, we have the files that were there, as well as the subdirectory. And then inside that subdirectory, we have the 2 images inside of that. I'm going to remove the grocerylist.txt file from inside the DST directory with rm dst grocerylist.txt. And I'm going to recursively remove the src directory from inside the DST directory with rm-r dst src. And now I'm going to show that that directory is empty with ls-RA DST. Now we want to rsync the files and directories inside the src directory to the DST directory. And the first way I'm going to do that is by typing rsync -vr src / and then the DST directory. Pressing enter, we see there's something missing. Do you see what's missing? It's the .myhiddenfile.txt file. Dot files don't get synced when we use the asterisk. To rsync all the files, including the hidden files, we need to leave off the asterisk, but keep that trailing /. That will sync everything, including the hidden files. Pressing enter, here we see the .myhiddenfile.txt, as well as the other files, the subdirectory, and the files inside that subdirectory. You may have heard that rsync does not sync files that are already in the destination directory, and that's true. But if that's true, why did our rsync src / sync everything and not just the missing file .myhiddenfile.txt? Let's remove that .myhiddenfile.txt from the destination directory with rm dst.myhiddenfile.txt. To see what's going on here, I'm going to list out the files in the src directory with ls-lh src. And now I'm going to list out the directories in the DST directory with ls-lh dst. And we see here that the dates are different. The src file has the dates the files were created, and the DST file has today's date, the date the files were synced. In short, the files don't match because the dates are different. There's a couple of ways around this. The first way we're going to look at is by comparing the file checksums instead of the dates. In short, a checksum is a calculated value to verify the integrity of a file. We can have rsync compare the checksum values by adding the lowercase c option. So our rsync command now will be rsync -vrc src / dst. Before I run this command, I want to see what the results of this command would be if I ran it, but I don't want to actually run this command, not yet. For that, I will add on --dry-run. This will show us the results of the command if it would have run without actually running the command. Pressing enter shows us if we ran this command, only one file will be rsynced, and that is the .myhiddenfile.txt file. Now, instead of typing out the whole --dry run, we can just add the N option, and pressing enter here, we get the same results. I prefer the --dry run over the N character just because it's more obvious that we're not actually running the command, but it works both ways. Rsyncing the one file is what I want to do, so I will remove that N and rerun the command. And the .myhiddenfile.txt is now synced as expected, and we can see that by rerunning that dry run command again. And it shows there are no files to sync. Comparing the checksums does require the computer do some calculations. That can be a little slow. It is still quicker than copying large files, but slower than just checking the timestamp. So the other way to make the files match is by syncing the timestamp when we rsync the files. And one way to do that is by using the lowercase a for archive option. I'm going to clear out the DST directory again, but this time I'm just going to remove -r, the entire DST directory, and then add it back in with make dir DST. And now let's sync the files from the src directory with rsync. Then we want the -a for archive mode. We want the V for verbose. And we want to sync the src directory with the / on the end. And we want to sync that to the DST directory. Pressing enter shows us it's syncing all the files, including the .myhiddenfile.txt, the subdirectory, and the files in the subdirectory. So when we're using that lowercase a archive option, that also includes the -r recursive option, so we do not need to include that -r option. Now when I type ls-lah src and then ls-lah dst, we see that the files and the timestamps match. In general, when we're using rsync, we will probably want to use the A for archive option. This is a good spot to break. In the next video, we will complete our look at rsync for the Linux command line. In the last video, all of our rsync examples copied files from the source to the destination, but the files were not really synced. What I mean by that is, if there are more files in the destination directory, they stayed in the destination directory, so it did not really sync the source to the destination. It just copied the source to the destination. If we deleted a file from the source directory and rsynced the directory the way we learned in the last video, the deleted file will still be in that destination directory. And there are times when we want that action to happen, but there are also times when we want the destination directory to be an exact match of the source directory. And if a file is removed from the source directory, we want to remove that file from the destination directory. I'm going to add a few files to our DST directory with touch dst extrafile1.txt and extrafile2.txt. And now I will rsync the source to the destination with rsync -av src dst -dry run. Rsync shows us there's nothing to sync because all the files in the src directory match the files in the DST directory. But we also have the two new files in the DST directory. To truly sync the source directory to the destination directory, after copying the source to the destination, we will also want to delete out any files in the destination that are not in the source directory. We can do that by adding in a --delete to our rsync command. Pressing enter. Now we see it will delete out those two extra files from the destination directory that are not in the source directory. And then removing the dry run and running this command deletes them out. And we'll show this by running the dry run again. And now there are no files to sync. In this tutorial series, we haven't talked about logging into other computers with SSH. But since rsync uses SSH to sync files to another computer, we'll take an introductory look at SSH right now. I have added another computer to my local network. And when I say local network, I mean behind my router to the internet. The computer I set up has a local IP address of 192.168.1.42. I've created a Michael user on that computer.
I have enabled SSH on that computer, and rsync is installed on that computer. I am going to open a new tab, and I'm going to make this a light tab, just so we can keep the two tabs straight. And on this lighter tab, I'm going to SSH into that other computer. To SSH in, I will type SSH Michael at 192.168.1.42. So Michael is the user ID that I created on that computer. And we're telling SSH that the IP address we're looking for is 192.168.1.42. Pressing enter, it's asking me for the password for Michael on the 192.168.1.42 computer. So I'll type that in. And now it shows us that we're logged into the other computer, and that computer is called TEST SRVR. I'm going to clear the screen and type pwd and ls-lh to show that we have no files in the home Michael directory on this computer. Going back to the other tab, I want to rsync the grocerylist.txt file that's inside the source directory to the other computer. To do that, I will start the rsync command just as we've seen, rsync -av src grocerylist.txt. And then for our destination, we need to start that off with the same information we used when we SSH'd into the other computer. So I will type Michael at 192.168.1.42, and then a colon, and then the directory on that computer where we want this to go. That will be /home/Michael. Pressing enter. rsync is asking us for the Michael password on the 192.168.1.42 computer. And it shows us the file was copied. Let's go over to the other tab and type ls-lh. And we do see the grocerylist.txt file did get copied over to this computer. Going back to the other tab, the way we copy the file is called a push. The file was on the same computer that we submitted the rsync command, so we pushed it to a different computer. The other way is to pull a file or files from another computer to the computer I'm running the rsync command on. Typing ls-lh shows us that we do not have the grocerylist.txt file in this directory, so we're going to pull it from the other computer to this directory. I'm going to do that by typing rsync -av. Now I need my server details, starting with Michael, then the @ symbol, and then we're using the IP address to identify that server. So I'll type in 192.168.1.42, then a colon, and now I'm adding the tilde, which we saw in earlier videos, means go to the home directory, and in that home directory, we're looking for the file grocerylist.txt. Now we need to give it a destination directory, and we want to give the directory that we are in. So I'm just going to press the dot or period. So we're telling rsync to log in to the 192.168.1.42 computer as Michael, go to the home directory and find the file grocerylist.txt and sync that to this directory. Pressing enter. It's asking me for the password. And now the rsync command is telling us it synced the file grocerylist.txt, and we can also see that by typing ls-lh. And in this case, we see that it worked both ways, both pushing and pulling the files. In the past, I have had troubles with rsync pulling files, in which case I just logged into the other computer and pushed the files. In other words, what I'm saying is if it doesn't work one way, try the other. I have a larger file in the parent directory that I'm going to move into this directory with move from the parent directory, largerfile.tar.xz, and I want to move that right here. And there we see the larger file. And I'm going to rsync this over to our other computer. To do that, I'm going to type rsync -av largerfile.tar.xz. And I want to rsync that as the Michael user at 192.168.1.42. And I want to put that in the home Michael directory. Pressing enter, it's asking me for the password. And I'm going to cancel out of that. And the reason I'm canceling out is because we don't see how much of that file is being copied over to the other computer. To see how much of that file is rsynced, I'm going to add the uppercase P option to our command. That uppercase P does two things. Number one is progress. It shows us how much of the file is rsynced. And number two is partial. If the rsync fails for some reason, rsync can keep what is partially moved over there and just pick up from where it left off. In other words, if you're rsyncing a large file that maybe took hours to rsync and only has a little bit more to go, if that job fails for some reason, when you restart the rsync command with that uppercase P option, it will pick up from where it left off and just have those last few minutes and won't have to start over from the beginning. So when you're rsyncing large files, you'll want to use that uppercase P option. Pressing enter again, and then putting in my password. And here we see the percentage of the files being copied over to the other computer. Our rsync is done. Let's go over to the other tab and type ls-lh. And there we see the larger file .tar.xz is there, as well as the grocery list.txt. There are many more options for the rsync command that we did not look at in this tutorial. Things like excluding files and directories, or telling rsync to keep the ACL permissions. Going over all the options would be a tutorial series in itself. These two videos on rsync are enough to get you started with some of the most common features of the rsync command. In the next video, we'll continue looking at the Linux command line. In the last group of videos, we looked at making backups and syncing files and directories. The problem is we have to submit those commands every time we want a backup. In this video, we're going to look at how to run those backups or any command or script on a schedule with cron. The first thing I'm going to do is make sure cron is running by typing systemctl status cron. And what we're looking for is this line right here, active running. This shows us that cron is up and running on our machine, and it will be set up and running on most Linux computers. The other thing we want to note here is cron.server regular background program processing daemon. That very last word I pronounced daemon. Some people pronounce it daemon. Both ways are considered correct, but I choose to pronounce it daemon because I don't like the idea of having any daemons in my computer. A daemon is just a program running in the background. For those of you who remember a few videos back, we said a service was a program running in the background. And that is true as well. For the purposes of this video, we're just going to say that most services are daemons that can do a little more than a daemon. And we're going to leave it at that for now. To see what cron jobs are already set up and scheduled, I will type cron tab -L. Cron tab is short for cron table, and the -L is for list. So we're just trying to list out what is in our cron table. Pressing enter, we see nothing because we have not scheduled anything yet. To schedule a cron job, I will type cron tab -E to edit the cron table. Since we have not yet tried to edit the cron table, we're asked what editor we would like to use. My choices are Nano, Vim Basic, Vim Tiny, or Ed. You may have more or less choices depending on what is installed on your computer. I'm going to choose 2, Vim Basic. If we start using this editor and decide we don't like it, we can change it. I'm going to exit out with escape:X. We can change the selected editor by typing select editor. From here, we can choose a different editor or the same one, or just press Ctrl-C and cancel out as I'm doing here. Another thing we can do if we don't like our choice of editor is to remove the hidden file .selectedEditor in our home directory. And here we see the file that holds the selected editor information. Delete that file, and next time you type in cron tab -E, you will get the select editor once again. To edit the cron tab file and use a different editor than the default editor, for this one time only, you can type editor equals, and then the editor you want to use. I'm going to change this to Nano, and then we'll put in the cron tab -E. And we see that we're editing the cron tab file with Nano instead of Vim. I'm going to press Control X to exit out of that, and then type cron tab -E. And we see we're back in the cron tab file using the selected Vim editor. Now we are in and ready to set up a cron job. We see this file gives us some comments about how to set up our cron job. Not all versions of Linux will show these comments. Some versions of Linux may have other comments. Some may have no comments at all. In these comments, we see that each task to run has to be defined through a single line. And we can schedule our command or script to run by minute, hour, day of the month, or day of the week. And then we see use asterisk in these fields for any. We'll talk about this more in a moment. Below that we see, notice the tasks will be started based on the cron's system time. We set the system time and time zone in videos 30 and 31, so you may want to watch those videos again if you need a refresher. In this next section of comments, we're told that the output of the cron tab jobs, including errors, is sent through email to the user the cron tab file belongs to, unless redirected. A quick note about those comments. To send an email, you must have an email server running, either on the same host or in your LAN, and setting that up is outside the scope of this tutorial. Here we have a cron job example in the comments. Let's look at this more closely. The first thing I'm going to do is highlight the different parts of this command. On the far left, we see the pound sign. That is making this line a comment. We will want to remove that pound sign when we want this job to run. Commenting out a cron tab line with a pound sign is helpful for times when we want to prevent a cron from running, but we don't want to delete it out. Then we just need to remove that pound sign when we want to run that line again. Over on the far right, this is our command or path to the script we want to run. We're familiar with the tar command because we looked at it just a few videos back. Notice here that they're ending their tar file with the single extension .tgz instead of the .targz I showed in that previous video. The .tgz is more common, and you'll probably see that format more often than .tar.gz. They have 0 for minutes. The 0 minute is after minute 59 and before minute 1, so that means this cron will run right at the top of the hour. The hour field has 5, so this cron will run at 5 a.m. 1 p.m. will be hour 13, and 11 p.m. will be hour 23. The day of the month shows an asterisk, and earlier we said that an asterisk means any for any day of the month, so this cron can run on any day of the month. And we have an asterisk for the month as well, meaning this cron can run on any month. Then we have the day of the week set to 1, which is Monday. So this cron will only run on Mondays for any month, meaning it will run every month of the year for any day of the month. So there's no limit to which days of the month it can run, but it will run at 5 a.m. at the top of the hour. So how did I get the number 1 to mean Monday? Because in some parts of the world, the week starts on a Sunday. Other parts of the world, the week starts on a Monday. For parts of the world where the week starts on Sunday, Sunday is 0 and Monday is 1. And we go all the way to Saturday, which is 6. For parts of the world where the week starts on Monday, Monday is 1, Tuesday is 2, and we go all the way to Sunday, which is 7. So the number for Sunday can be either 0 or 7. And if you don't like using the numbers for the days of the week, you can also use the first 3 letters of the day of the week as a character abbreviation. For example, instead of typing 1 for Monday, we can use MON. And if we want to run our cron on multiple days of the week, we would separate them with a comma. For example, to run the cron on Monday, Wednesday, and Friday, we would type 1, 3, 5. Or we can use the abbreviated days of the week, MON, WED, FRY. If we want to run the cron Monday through Wednesday and then again on Friday, we would change that first comma to a hyphen, making our days of the week 1-3, 5 or MON-WED, FRY. Months work the same way. We can use the numbers or the first 3 letters of the month. To run our cron only on the months January, May, and September, we would change our months to be 1, 5, 9 or JAN, MAY, SEP. And to run our cron job the months January through May and then again in September, we would set our months to be 1-5, 9 or JAN, MAY, SEP. If we set all our values to asterisk, our cron job will run every minute of every hour for every day of the month for every day of the year. And there are times when we want that, but sometimes every minute is just too much, and we want to run our cron every other minute. To run our cron every other minute, we will update our cron to be minute divided by 2, and then if 2 divides evenly into that minute, it will run on that minute. And if we want to run our cron job every 5 minutes, we would change the minute to be minute divided by 5. And if the minute divides by 5 evenly, that cron will be run. Now that we have the basics of when a cron job will run, let's run one. I'm going to copy their example here and then paste it at the bottom. I'm going to remove that pound sign, making that a comment. And I'm also going to change that day of the week from 1 to be an asterisk. And now it's going to run at hour 5. Let's change that to hour 2. And the minutes, we're now at 48. I'm going to change that to 50. And then I'm going to save this file. And now I want to tail the log file. So I'm going to tail-f/var log syslog. Var log syslog is where Ubuntu writes out the cron log files. Pressing enter. And then I'm going to hit enter a few times just to separate the new lines in the log file from the old ones. So we're seeing that our tar did try to run here, but it's giving us the message no MTA installed, discarding output. No MTA means there's no mail transfer agent installed, so it can't email the output anywhere. We talked about that earlier. There is no email set up on this computer, and setting it up is outside the scope of this video. So what we're going to do instead is to create our own log file and redirect the output of our crons to the log file. To do that, I'm going to create a cron log file with mkdir, cron logs, and then update our cron job to send the output to the cron log directory. Cron tab-e, and going down to our line, we want that output redirected to home Michael cron logs, and we'll call this file bkup home directory.txt. Then we also want to include the error output and the standard output. And we learned about output redirection in video 8. I'm going to update the minutes to be 57 and save the file. Now we just need to go into the cron logs directory with cd cron logs. And as soon as we get to 257, our file should be there. Let's change to 257. Let's ls-lh. Let's check it again. ls-lh. No, it didn't run. Let's check our cron tab and see what happened. And the problem is I spelled cron logs wrong. Now the file should work. I'm going to change the minute from 57 to 59. And as soon as we get to 259, our cron will run. Let's check the logs. ls-lh. There it is. And let's cat this out. And here we see that we could not create the file var/backup/home.tg because we do not have permissions. So we're going to change that command to back up the LCL directory inside the Michael home directory, and then we're going to create a new backups directory to hold our backup. I'm typing cd to go to my home directory, and then mkdir backups to make the directory to hold our backup file. Now let's update our cron tab file with cron tab-e. And what I'm going to do now is I'm going to delete out part of that command there and then just paste it in because I don't want to have any typos in there. And let's update the time. It's now 3. It's 03, so let's make this 04 and save this. And as soon as it hits 3:04, the job will run. Okay, it's 3:04. Let's go into the backups directory. And we're looking in there because in the cron log file, there should be no output. We didn't put the V for verbose to our tar command, so there probably won't be any output there. Checking the backups file. There's our backup. And to view what's in there, I will type tar-tzf LCL backup. And there we see all the files are in there. This is a good breaking point, so we're going to stop here. In the next video, we will complete our look at cron for the Linux command line. Picking up from where we left off in the last video, we had created a cron job to back up the LCL directory. I'm going back into cron tab edit with cron tab-e. Our cron looks pretty good. We have this backup scheduled to run every morning at 3:04 a.m. I'm going to change the day of the week to be 1. So this will run once a week, every Monday, instead of every day. The other thing we notice here is a backup file and the log file will be overwritten every time this cron runs, because we're using the same file name. To make the file names unique, I'm going to add the date the file was created to the file name. That will make each file name unique, and if we have a problem, we can check our log files for that date to find out what happened. I'm going to the end of the file name just before the extension, and I'm going to paste in some text. Let's also add this same text to the cron log file name. So this text I'm pasting in will add the date in year, month, day format. I'm going to test this out by just selecting the command itself, copy, and I'm going to exit out of our cron tab file, and then paste in the command and run it. Let's list out the content of the backups directory with ls-lh backups. And this shows us that the backup file was created with the date added to the file name as expected. So that cron should be good. Now I want to add a cron for the rsync command that we created in a previous video to sync the src source directory with the dst destination directory. I'll do that with cron tab-e. I'm going down to the bottom of the file and I'm going to add in a new cron job, and I'm going to paste this in. This rsync command will run every minute of every day, and it will sync all the files in the home Michael rsync src source directory to the home Michael rsync dst destination directory, and remove all the files in the dst destination directory that are not in the src source directory. I'm going to write this file out. And I'm going to open up a file manager so we can see what's in the source directory. rsync src. Let's shrink this down a little bit. Move this to the upper right here. And I'll need to move our terminal window over so we can see that. And then I'll also add in a file manager, rsync, for the destination directory. Now I'm going to add a file to the source directory with touch home Michael rsync src new file1.txt, And let's add in new file 2.txt. And at the top of the next minute, we should see these files get copied over to the DST directory. And they are. Now I'm going to remove one of those files with rm. Home Michael rsync src new file 1.txt. And again, at the top of the next minute, that file should be removed from the DST directory. And it is. So our rsync cron is working just as expected. I'm going to close this window and then reopen it. When we edit a cron tab file with the cron tab command, you may be wondering, where are the actual cron tab files stored? For that, we need to be the root user. So I'm going to switch to the root user with sudo su dash. And to see all the cron tab files, we need to change the directory with cd var spool cron tabs. And then ls-lh will list them out. Here we see that Michael and Mary both have cron tab files. As the root user, I can update Michael's cron tab file with vim Michael. And we can see this is the same cron tab file I was editing as Michael with crontab-e. I'm going to exit out of this with :x. If I need to update the Michael user's cron tab file, it's better for me to edit that file with cron tab. As the root user, I can edit the Michael cron tab file as Michael with crontab-u Michael-e. So this is telling us to switch to the user Michael and then edit the cron tab file. And notice here, the root user has Nano set up as their default editor. So I'm editing this file with Nano. I'm pressing Ctrl-X to exit out of that. The other cron tab commands work like that as well. crontab-u Michael-l. I'm going to exit out of being the root user with exit and clear the screen. Crontab is set up this way for security reasons, but the crontab-e does do some basic edit checking as well to help us out. I'm going to edit our crontab file again with crontab-e and go down to the bottom. And I'm going to change this first asterisk to be 61. This first asterisk is for minutes, and there's only 60 minutes in an hour. So when I try and get out of this with :right quit, it's telling me that there is a bad minute and asking me if I want to retry the same edit. I will type yes. I will fix these minutes by changing them back to an asterisk. And now I'm going over to the month here, which is the fourth asterisk, and I'm going to change that to 13. There's only 12 months in the year. When I try and right quit this, it is now telling me that there is a bad month. And it's asking me if I want to retry the same edit. I'll type yes, and I'll fix that month to be an asterisk. And everything's back the way it was. So the crontab editor does do a little bit of basic error checking, but crontab will not edit check my command or script in any way. I'm going to right quit out of here and clear the screen. Another thing that privileged users can do is deny a user from updating their crontab file. The privileged user just needs to add the user ID to the cron.deny file in the etc directory. Most likely there will not be a cron.deny file by default, but a privileged user can create one. I will type sudo vi etc cron.deny. And I'll add in the name Michael and right and quit out of this file. Now I'm going to try and edit my crontab file with crontab-e, and I get the message, you, Michael, are not allowed to use this program, crontab. If I want to check to see if I'm on that deny file, I can cat out the etc cron.deny file. And here I see that Michael is on the cron.deny file. So any user can check the cron.deny file to see if they're on the file, but only privileged users can update the cron.deny file. How the cron.deny works is that every user on the system has access to cron tab unless they're on the cron.deny list. Once they're on that list, they can no longer make changes to their cron tab file. The Michael user already has 2 crons set up, and those crons will continue to run even though the Michael user can no longer update his cron tab file. There is also a cron.allow file that does not yet exist. And again, you'll need to be a privileged user to add or update user IDs to the cron.allow file. I will create and update the cron.allow file with sudo vi etc cron.allow. And I will add the Michael user to this cron.allow file. And now I should be able to edit my cron tab file with crontab-e, and I can. The cron.allow file has a priority over the cron.deny file, meaning since the Michael user is on both lists, the cron.allow file has the priority and the Michael user will be able to once again make updates to his cron tab file. The other key thing to know about the cron.allow file is when the cron.allow file exists, only users on the cron.allow file will be able to make updates to their cron tab file. All other users are denied. So if Mary tries to update her cron tab file now, she would be denied because her user ID is not listed on the cron.allow file. I'm going to remove the cron.allow file with sudo rm etc cron.allow. And also let's remove that cron.deny file with sudo rm etc cron.deny. I can list out my crons with crontab-l. And if I want to remove all of my crons, I can do that with crontab-r. Now all my cron jobs are gone, but when I type crontab-e, it still remembers my selected editor, and I still get the comments in the file, but all my crons are gone. In the next video, we will continue looking at the Linux command line. Cron works well to schedule jobs that are running on a server or a computer that is running 24 hours a day. But a lot of our computers and laptops are not running 24 hours a day. We turn them off when not in use. In our last few videos, we created a cron job to run a backup every Monday morning at 3:04 a.m. If the computer was not powered on at 3:04 a.m. on Monday morning, that cron would be skipped. And maybe missing one backup might not be bad. But if that computer is off every Monday at 4:03 a.m., that backup could be skipped for weeks, months, or maybe never run. And that could be bad. So instead of using cron to schedule a backup, we may want to use anacron. Anacron can be used to run a command or script just like cron, but instead of giving it a specific day and time, we give it a more general time frame of hourly, daily, weekly, or monthly. When the computer is constantly powered on, anacron will run the anacron jobs regularly for each time frame of hour, day, week, and month. For computers that are turned off and back on, when the computer starts up, the anacron jobs are checked to see if they need to run at startup. We'll look at what anacron does at startup later in this video. Anacron is a part of cron, so let's look at the cron files in the etc directory with ls-lh etc cron *. The first thing we see is etc cron tab. We're going to come back to this later in this video. The next thing found is the directory etc cron d. The D is for daemon, so the files in this directory are for the cron daemon. We don't want to change anything in this directory, so we're going to leave this directory alone. The next 4 directories, etc cron daily, etc cron hourly, etc cron monthly, and etc cron weekly, all these directories work the same way. When that time frame's anacron is run, all the scripts in that directory are run.
For example, when the daily Anacron runs, all the scripts in the etc cron daily directory are run. So if we want to add a script to be run by Anacron on a daily basis, we would add our script to the etc cron daily directory. And we would do the same thing for the hourly, monthly, and weekly Anacron scripts. We would place our script in the directory for the time frame we would want Anacron to run it. Looking at these files in these directories, we notice a few things about these files. The first thing we notice is they all have an owner and user of root. So we must be a privileged user if we want to set up an Anacron job. The second thing we notice is that none of the Anacron file names have an extension, meaning there's no .sh or .txt added to the end of the file name. That's because Anacron does not allow a period in the file name. The file names can only contain letters, numbers, and the dash. No underscore, no dots, no anything else. Just letters, numbers, and the dash. Looking at the cron daily, cron weekly, and cron monthly directories, they all have a file called 0 Anacron. That file will check to see the date the last time the group's Anacron scripts ran. The hourly Anacrons directory does not need this file. The hourly crons are going to run within the hour anyway, because they are set up to run every hour. Let's check out one of the daily Anacron scripts. I'm going to choose the man-db script and show it with less etc cron daily man-db. The first thing I want to look at is the first line, shebang bin sh. This is different than the shebang bin bash we're used to seeing. Anacron only allows sh or born shell scripts. It does not understand the bash, born again shell scripts we've been working with in this tutorial. The bash born again shell is just an improved version of the born shell and includes more commands and features. And it's these new commands and features that Anacron won't understand. Everything we do in this video will be backward compatible with the born shell. But I wanted to give you a heads up, just in case you're trying some code that is only in the bash shell and not in the born shell. It won't work with Anacron. The first command we see is set-e. What this line does is it tells the script to exit out if any line in the script fails. We want to put this in our Anacron script because if a line fails and it does not exit, it could continue to try and run and continue to use system resources. The very last line of code in our script is exit 0. The exit 0 is setting the exit status to 0, meaning the script ended without any problems. Exit numbers higher than 0 usually mean there was a problem with the script. I'm going to clear the screen. Let's set up an Anacron job. The first thing I'll need to do is switch to the root user. I'll do that with sudo su-. I'm going to create a daily Anacron script with vi etc cron daily Anacron daily test. And I'm going to paste in some code. This script will run daily and just create a file called Anacron daily test with the date and time that file was created. And it'll place this in the directory home Michael Anacron. I'm going to write and quit this. We also want to make this file an executable. I'll do that by pasting in chmod 755 etc cron daily Anacron daily test. Let's also set up a weekly Anacron job with vi etc cron weekly Anacron weekly test. And I'm going to paste in the code here as well. I'm pausing and copying the code here so you don't have to watch me type this all in. And also there's less opportunity for typos. I'm going to write and quit out of here. And we want to make this weekly file an executable as well. Let's exit out of our root user with exit. And now we want to create that Anacron directory that we're going to put the daily and weekly files into. I'll do that with make dir home Michael Anacron. So we have two Anacron jobs that will run, one daily and one weekly. I can pause this video and come back in a few days or weeks and we can check out the results. Or I can log into the test server where I set up these same jobs a few weeks ago to run daily, weekly, and I've even added an hourly Anacron job to that as well. Let's open up a new tab here. And I'm going to make this a light tab just so we know the difference between the one we're working at and the server tab. I'm going to log into the server with SSH 192.168.1.42. And I'm going to CD into the Anacron directory. And let's list out what's in there with ls-lh. Here we see all the Anacron daily test files were created at 6:25 a.m. And all the Anacron weekly test files were created on Sundays at 6:47 a.m. I put the hourly files in a subdirectory because I knew there would be a lot of them. Let's check them out with ls-lh hourly. Here we see all the hourly files are created at 17 minutes after the hour. Let's look at what happens when the Anacron jobs run for a computer that is constantly powered on. To see that, we're going to look at the etc cron tab file. We saw that file earlier and said we'd come back to it. Now's the time. So let's see what's in that file with cat etc cron tab. And here we see the etc cron hourly jobs will run every hour at 17 minutes after the hour. That matches with what we saw on our server. We also see the etc cron daily files will run at 6:25 every day. And that matches with what we saw on the server. And then we see the etc cron weekly files are set to run at 6:47 every Sunday. And that matches up with what we saw on the server. And we didn't set up a monthly job, but those are scheduled to run at 6:52 a.m. on the first day of the month every month of the year. That explains how the Anacron jobs work on a computer that is not turned off. When the computer is turned off and back on, when the computer starts up, Anacron will want to check the date the last time the Anacron jobs ran for each group, daily, weekly, and monthly. The hourly Anacrons run every hour, so they're going to run within 60 minutes anyway. To check the last time the daily, weekly, and monthly Anacron jobs ran, I'm going to cd into the directory var spool Anacron. And let's ls to see what's in here. And here we can see the dates these files were last updated. And most likely those will be the last dates the Anacron jobs ran, but not necessarily. To see the actual Anacron dates, we're going to look inside the files. I'm going to type sudo vi cron daily. And we see a date for the last time the daily Anacron job ran. I'm going to change this date back. So when we restart the computer, we'll force an Anacron run. Let's also do that with the weekly file. We'll set this back to the same day, the first of the month. And we could do that with the monthly as well, but since we don't have a monthly Anacron, we're going to skip that. Let's reboot the computer with sudo reboot. Okay, we're logged back in, and I'm going to check the Anacron directory with ls-lh Anacron, and it doesn't show anything. So why didn't our Anacron jobs work? To find that out, we're going to check out the Anacron tab file with cat etc Anacron tab. Now in this file, the first line's telling us it must be using the Bourne shell with the bin sh. Then we've got a path. We're going to talk about paths in an upcoming video. And then there's some lines letting us know that it must be the root user. And that's all good, but what we're really interested in are those 3 lines at the bottom of the file. Let's start with the 1.5 cron daily line. The 1 is the period in days that Anacron is going to check the date in the var spool Anacron cron daily file, that file we just updated, to see if the date is at least 1 different than today's date. If it is, then we move on to the 5.
The 5 is telling us to wait 5 minutes after the computer reboots and then run the cron daily anacron jobs. And we're waiting 5 minutes just to make sure that there are not too many jobs running at the same time when the computer boots up. So we wait 5 minutes, then do the daily anacron jobs. Going down to the next line with the 710 cron weekly, and the 7 is going to compare the dates just like the first one. Instead of 1 day, we need 7 days between the current date and that date that is in the var spool anacron cron weekly file. We just updated that file to make it more than 7. As long as more than 7 days have passed, we move on to the next value, the 10. And the 10 is telling anacron to wait 10 minutes after the computer boots up to run the cron weekly anacrons. And now we're down to the last line, and that has at monthly instead of a 1 or a 7. The at monthly is to check to see if it's a different month. Instead of going back 30 days, we're just checking the month. So if the last time this ran was on the last day of the month, and today is a new day, it'd be a new month. So this could potentially run 2 days in a row. The 15 is telling us to wait 15 minutes after the computer starts to run the monthly jobs. I'm going to check the anacron file again with ls-lh anacron. And there we see both our jobs have completed. We have our daily test and our weekly test. In the next video, we will continue looking at the Linux command line. Cron and anacron are good for scheduling jobs to run over and over. But if we want a job to run in the future only one time, we can use at, that some people call AT. We call it at because we want to run a job at the time and date we give. To see what jobs at currently has scheduled to run, I will type ATQ for query at jobs. At is not installed on my version of Linux Mint, but I will install it with sudo apt install at. At is now installed, and I'm seeing right here that the at service is called atd.service. I'm going to clear the screen, and let's check the status of the service with systemctl status atd. And we see that it's running. We can stop this service with the command systemctl stop atd. And I'm asked for a password. Let's check the status again with systemctl status atd. And here we see that it's inactive or dead. Let's start up that atd service again with sudo systemctl start atd. And then check the status. And we see that it's running once again. I'm showing you this because not all Linux operating systems work like the Linux Mint Ubuntu operating system I'm working on here. When I installed the ATD service on this operating system, it thinks that I wanted to start the service and that I want to start the service every time the computer boots up. And that is what I want. Some Linux operating systems will only install the service requested when you install it. Then it's up to you to start the service when you want it running, and it will stop when the computer shuts down. Then, if you want the service to run every time the computer starts up, you will have to tell the computer you want that. To tell Linux we want to start this service every time the computer boots up, we would type sudo systemctl enable, and then the service that we want to enable, which in this case is ATD. So enabling it will have Linux start the ATD service every time we start this computer. As I mentioned earlier, on our Ubuntu-based operating system, Ubuntu starts and enables our service when we install it. So these steps were really not needed on this computer. I'm going to clear the screen again. Now that we have at installed and running and enabled, let's type ATQ again. Nothing shows. That's because we don't have any at jobs scheduled. Let's create a job to run at 5 minutes from now. For that, I will type at now plus 5 minutes. This opens a second prompt for me to type in the commands I want to run 5 minutes from now. And when I say 5 minutes from now, I mean 5 minutes from when I pressed enter for the @now plus 5 minutes command, not 5 minutes from when I complete my script. So if it takes more than 5 minutes to create the script won't start because the time to start the script has passed. The other thing to note here is that it is telling us, just like Anacron, that will only allow the sh bourne shell scripts and not the advanced commands that the bourne again bash shell includes. I'm going to add the commands mkdir home Michael AT. And then I'm going to touch home Michael AT, and the file we touch will be @test.txt. Now to write and get out of the secondary prompt, I'm going to hold down Control and press D for done. This has created my script, and it will run in a couple of minutes. Now if I type ATQ, we see we have one job scheduled to run. I'm going to type ls-lh-at, and we see that directory does not yet exist. The 5 minutes have passed. Let's see if our directory is there now. And we see the new file is there, so the directory and the file were both created by the command. If we type by itself and press enter, we'll get the message garbled time. We can put a script in a file and run that with the command. I'll create a script in that new directory with vim at, and we'll call the script at_script. I'm going to add a line in here to touch a file in the home Michael AT directory, and to know we ran it from this script, we'll make that file name at_from_script.txt. And let's write this out. To run the script, we will need to add a -f for file name to our command. I'll type @-f for file. Now we need to give it the file name, home Michael @ and then the script name is @script. And we want this to run now plus 1 minute. The time has passed. Let's see if the file was created with ls-lhat. And there we see the file @test_from_script.txt. I'm going to clear the screen. So far, I've only used the time frame of minutes, but there are more time frame options. Let's run a job next Tuesday with @next Tuesday, and we will have it touch a file next Tuesday. Touch home Michael AT, and we'll call this file next Tuesday.txt. I'm going to hold down Control and press D for done. And we see this is scheduled to run next Tuesday at the time of day I pressed enter for the @nextTuesday command, because I didn't give it a specific time of day. If I want to give it a specific time of day, I will put that time before the day I want it to run, at 2:30 p.m. Tuesday. And we can touch home Michael AT next Tuesday 2:30.txt. And Control D for done. And this will run next Tuesday at 2:30 p.m. For times of day, we also have options like noon, midnight, or tea time. Tea time is 4 p.m. At tea time Tuesday, we want it to touch home Michael AT Tuesday teatime.txt. And once again, holding down Control and D for done. And we saw that we can use now plus 1 minute, but we can also use now plus 1 hour, now plus 1 day, now plus 1 year. And it does not have to be plus 1. You can make that any positive number of days. We already saw how to list out the jobs in the @queue with ATQ. We can also use AT-L, and AT-L is just an alias for ATQ. We'll look at what an alias is in an upcoming video. In short, when we type AT-L, it just runs the ATQ command. I'll clear the screen once again, and I'm going to list out those jobs again with ATQ. Now we have 3 jobs out there scheduled with AT, and we want to remove one of the scheduled jobs, but we don't remember which job has which command in it. To see the commands for an @ job, we can type @-c for cat, and then the job number that we want to see the commands of. In this case, it'll be job number 3. And here we see a lot of information about the scheduled @ job, but when we get down to the bottom, we can see our command. And then there's a blank line after that. We can make that easier to read by piping that into tail-n2. Let's clear the screen, and I'll type ATQ to check our @q, and cat out that file again with the tail-n2. Let's try it again with job number 4, and then again with job number 5. Job number 5 is tea time. Let's remove that one. To remove @job number 5, I'm going to type ATRM5. Now that's not the only way to remove a job. I could also have typed AT-D5 or AT-RM5. AT-D and AT-RM are just aliases for ATRM. So I will use the ATRM5 to remove that @ job. And type ATQ again to show that it's gone. To see where the actual @ jobs are stored, we will need to switch to be the root user. I'll do that with sudo su-. Now we can change the directory with cd var spool cron @ jobs. And typing ls-lh shows us the 2 @ jobs. We can cat those files with cat A00003, and I'm tabbing to autocomplete. And we see this is our @ job to run next Tuesday. And we can pipe that output to tail and only show the last few lines of the file. I'm going to exit out of root with exit. If we were Linux administrators and getting ready to do some system maintenance on a server with multiple users, we might want to send a message out to everyone logged in on the system that the computer will go down at a specific period of time for maintenance. I will create this message in a file, vim at maint message, and I will paste in the message that the system will be going down at 1 p.m. for maintenance. And I'm going to pipe that out to wall, which means send out to everyone on the system. I'm going to open up another terminal here to make sure this goes out to people. This will be an xterm terminal. And let's send out this message with at-f home Michael at maint msg. And we'll send that at now plus 1 minute. That minute has passed and we don't see a message on this terminal. When I switch to the xterm terminal, we do get the message there. The reason we didn't receive the message in this terminal is because this terminal was designed for a desktop computer, which is normally used by a single user at a time. So the terminal does not update the logged in user list utemp. If we want to echo a message out to this terminal, we need to find out a little more about the terminal. We can do that by typing tty. And it gives us /dev/pts/o. So let's try echoing a message out to that with echo hello. And we're going to send that to /device pts0. And there we see hello. So now we can update that maintenance message and get the message on this terminal as well.
And now let's run that job again to make sure it works. And there we see the message in this terminal. Let's check the Xterm terminal. And we got the message there as well. Like cron, at also has deny and allow files, and you must be a privileged user to update those. I'll type sudo vim etc at deny. We see there's a lot of users already in there. I'm going down to the bottom, and I'm going to add in Michael. And now I'll try and create an at job with at now plus 1 minute. And we get the message, you do not have permissions to use at. So just like cron, adding a name to the at deny file denies the users in that list from creating and running at jobs. But all the other users on the system can still create and edit at jobs. Now I'll create an at allow file with sudo vim etc at allow. And I will add Michael in there. And now let's run that maintenance message file again. And we see it works. So the at.allow file and at.deny files work just like the cron.allow file and cron.deny files. In the next tutorial, we will continue looking at the Linux command line. Besides cron, Linux computers running systemd also have the option of scheduling jobs with systemd timer. Systemd timer schedules jobs like cron and anacron, but there are some differences. The biggest difference is that 3 things are needed to schedule a systemd timer. Those 3 things are the script you want to run on the schedule, a systemd service to run that script, and a systemd timer to start that scheduled systemd service. In this first video, we're going to create the script and the systemd service. Then in the next video, we're going to create the actual systemd timer. I'm going to make a directory called systemd and cd into that directory. Now let's create the script we want to run with the systemd timer. Vim scrpt for script for sysd.sh. I'm going to paste in some code here so you don't have to watch me type it in. And this will create a file in the Michael Home systemd directory with the date and time the file was created. I'm going to write and quit out of this file. And we want to make this file executable with chmod plus x for the script for sysd.sh. Let's run this script to make sure it's working as we expect. And view the directory with ls-lh. And here we see the new created by systemd.txt file. Great, we have the first of our 3 things created. The second thing we need to create is a service to run our script. In the last video, we saw how to stop, start, and enable a systemd service. That was included as an introduction to the systemd services. In this video, we're going to learn a little more about systemd services by creating a simple service, and then stop, start, and talk about enabling that service. So let's clear the screen. Systemd services are created in the etc systemd system directory. We need to be a privileged user to create a systemd service. So I will start with sudo, then vim, and the name of our service is going to be scrpt for sysd.service. I'm using the same name as our script. We don't have to, but I'd like to keep things organized. And I'm going to paste in some code. These are the only required lines of code for a systemd service. We'll add more later. For now, we're just adding in the minimum required lines. Service, and then under service, we're telling that service where to find the script we want to run. I'm going to write and quit this. And now we've added our service, but systemd won't see the service until we reload the daemon with the command sudo systemctl daemon reload.
Now that systemd can see our service, let's test it out by starting the service with sudo systemctl start scrpt for sysd.service. And to see if that worked as expected, I'm going to type ls-lh for the directory in my home directory, then systemd. Here we see the new file created, so the service worked as expected. We do see that the file owner and the group are both root instead of Michael. We'll change that in a little bit. I'm going to run this a second time with sudo systemctl start script for sysd.service, and then we'll list out the file contents again. And there we see a third txt file created. So our service is working the way we want it to work, but that's not really how a service works. To show how a service really works, I'm going to update my script with vim, go to the home directory, systemd, and then we want to edit the file script for sysd.sh. I'm going to comment out this line and then paste in some code. And this code I just pasted in is going to run that same touch command, but it's going to put it in a loop and create a file, sleep for a second, then create another file. And this will go on and on while the service continues to run. Since we made the change to my script and not the systemd service, we do not need to reload the daemon. We can just start that service again with sudo systemctl start script for sysd.service. And then looking in systemd in our home directory, we see a lot more files. Listing it again, there's even more files. So we do see that the files continue to create as long as that systemd service is running. Let's stop that systemd service. And let's check that out with ls-lh in the home directory systemd, and the files have stopped being created. And checking it again, we see there's no change, so the files have stopped being created. Things are working well, but what if I had a typo in my script? I'm going to update my script with vim, go to the home directory, systemd, script for sysd.sh. And what I'm going to do is change the s in systemd to a lowercase s. Now I'm going to write and quit out of here and restart our service. Now when we check that systemd folder, we don't see any new files being created. To find out what's wrong, we'll need to check the log files. I'm going to tail the syslog file with tail-f var log syslog. And here we see that we cannot touch the files because there's no such file or directory. Another way to see what's wrong is to look in the journalctl file. I'll do that with sudo journalctl-u for unit, script for sysd, and then f for follow. And here we see the same thing. Cannot touch because there's no such file or directory. I'm going to stop our service. And I'm going to edit our script again with vim, go to the home directory, systemd, script for sysd.sh. I'm going to delete out the 6 files and uncomment our original touch command. Now let's update our service. And there is another way to update the service file. That's with sudo systemctl edit, and then our service name, which is script without the I for sysd. And we do not add the service at the end. We'll put --full. In this file, I want to add a description for our service. So I'm going to put it right here at the top. It's going to be under the unit, and the description is the service will run the script home Michael systemd script for sysd.sh. And then under the service, I'm going to add in a line user equals Michael. This will run the service as Michael, so the file owners will be Michael instead of root. Now there is another section below this, That would be the install section. And under here, we would tell it if we want it to run at startup with wanted by equals graphical.target. Now, we would use this if we had a laptop or a desktop computer that has a GUI desktop that it boots into, and we're saying start this service when we start up that GUI desktop. But if we're on a server that does not have a graphical desktop, we would start this with wanted by multi-user.target. Since we're going to start this script with a systemd timer, we don't want any install section at all. So I'm going to take this out and write this file with Control X. And yes, I want to save the modified changes with the same name. So the advantage of using the sudo systemctl edit script for sysd --full is we do not need to run the daemon reload for our changes to be recognized. And we can see that by typing systemctl status script for sysd.service. And here we see the comment that we just added to our service. Let's run our service with systemctl start scripts for sysd.service. And I didn't add sudo, so it's asking me for the password. And we'll see if that worked by checking our systemd file with ls-lh. Go to the home directory, systemd, and here we see the file is created with a user and group of Michael, just as we expect. This is a good breaking point. We'll pick it up from here in the next video, where we will create our systemd timer for the Linux command line. Picking up from where we left off in the last video, we said that our systemd timer needs three things: a script, a systemd service to run that script, and a systemd timer to tell that systemd service when to run. In the previous video, we created the script and the systemd service. Now we're going to create the systemd timer. Systemd timers are created in the same directory as systemd services. So I will cd into etc systemd system. We have to be a privileged user to create a systemd timer. So I will start the command with sudo, then vim, and I'm going to keep the same name that we used for the script and the service, scrpt for sysd. And then I'll add on the .timer. I'm going to paste in some text. And we see the timer file format is very similar to the service file. We first have the unit that will have the description. Then we have the timer. Remember, for service, it was called service, and here we're in the timer file, so we're calling this timer. In this section, we have the unit, which is the service we want to run, and then we're giving it the time we want to run that systemd service. In this case, I'm using the on-calendar option. Let's take a closer look at that on-calendar format. The on-calendar format starts with the day of the week, then a space, then the date in year, month, day format, then another space, then the time in hours, minutes, and seconds. For example, if I want my calendar systemd timer to run every Monday at 1:15 in the afternoon, I would type on calendar equals MON for Mondays, then a space, then an asterisk dash asterisk dash asterisk for any year, any month, and any day. This part with the asterisk is similar to how cron works, with asterisk meaning any. Then we've got a space, then 13 for 1 p.m. in the 24-hour clock format, and then 15 for the minutes after the hour, and then I've got zeros in for the seconds. Let's look at another on-calendar example. In this example, we want the service to run on the first day of the month at 4 a.m. The first of the month can be any day of the week, but I did not replace the day of the week with an asterisk like we'd expect. I replaced the day of the week with nothing. Systemd timer interprets no day of the week to mean any, so that's why the day of the week is missing. Then we have any for year and month, but we want this to run on the first day of the month, so we have a 1 for the day of the month. Then we have a 4 for the hours for 4 a.m., with zeros for the minutes and seconds.
Going back to our systemd timer file, we want this to run in about 5 minutes. So I'm going to change the time to be 4:33. I'm going to write in quit. Because we made a change to the systemd service, we will need to reload the daemon with sudo systemctl daemon reload. And then I want to start our systemd timer with sudo systemctl start scrpt for sysd.timer. And let's check it out. Make sure everything looks all right with sudo systemctl status scrpt for sysd.timer. We see our comment and we see that it is active and waiting to run. It's going to run in 3 minutes and 49 seconds, and it's going to run our script for sysd.service. I'm going to pause the video and come back after the script has run. Okay, it's past 4:33. Let's check the results with ls-lh home Michael systemd. And here we see the new script was created at 4:33, just as expected. Let's check the status of the timer now. And we see it will run again in 23 hours. And as long as we don't turn the computer off, that will happen. But if the computer is turned off before that runs, our timer will be missed, even if we turn the computer back on before that time. And that's because we have not yet enabled our timer. If we want our service, or in this case our timer, to run at startup, we need to enable it. I'm going to try and enable the timer right now with sudo systemctl enable scrpt for sysd.timer. And I need to spell that correctly. And here we see the message, no installation config wanted by. We talked about this a little bit in the last video. In short, we need to add the install configuration to our timer file. I'm going to edit the timer file with sudo systemctl edit scrpt for sysd.timer --full. Remember, we did this in the last video, but instead of script for sysd.timer, we just left it as script for sysd. If we don't give it the full name, it will default to the service. I'm going to press enter, and going down, I'm going to paste in the install. And here we're saying when the computer boots up, start this timer when the timer daemon starts. And I'm going to hold down Control and X. I want to save the modified buffer with Y and enter. Because we edited the timer file this way, we do not need to reload the daemon, but we still need to enable our timer. We can do that with sudo systemctl enable scrpt for sysd.timer. Now that we have our script enabled, it will run on startup. But if the computer is not on when the timer is scheduled to run, this timer will be missed. It will not run. To make the script run on startup if it was missed, like we did with Anacron, we will need to add persistent to our timer file. Let's edit that file again. And in the timer section, we want to add the text persistent equals true. Let's also change this timer so it will run 5 minutes from now at 4:49. I'm going to hold down Control and press X, Y, enter, and that's saved. Now we should not need to reload the daemon, but I'm going to do that anyway. And I'm also going to start the script again. And let's check the status. We see it's scheduled to run in 3 minutes and 16 seconds. I'm going to power off the computer and power it back on sometime after 4:49, and it should still create our script. I've restarted the computer after the time that script should have run, but I should still have a new file created with a timestamp that is greater than 4:49. Let's cd into the systemd directory and type ls-lh. And there's the file created at 4:51. So adding persistent to our timer file did work. It did make the script run on startup as we expected. Let's create another systemd timer. This one I want to run 7 minutes after the computer boots up. The first thing we're going to do is create the script with vim on boot plus 7.sh. And I'm going to paste in some text. This is almost exactly the same as our other text file, only we've changed the name to on boot plus 7. I want to make this script executable, so I'll type chmod plus x on boot plus 7.sh. Now we need to create the systemd service. Sudo vim etc systemd system on boot plus 7.service. And I'm going to paste in some text. And this text has the description under the unit. And under the service, we've got the script to run. And to run this script as Michael, just like the other service we created. And I'm going to save that with :wq. And now let's create the timer with that same command, but changing service to timer. And I'm going to paste in some more text. And here we see the description under the unit. That's just like we expect. Then we have timer, and under timer, we see the unit that we want to run. But notice the next line isn't on calendar like we used in the other timer file. This time we have on boot sec equals 7min. You may hear people talk about monotonic or real-time systemd timers. When we use the on calendar option, that was the real-time systemd timer because we gave it a specific time to run. Here we're using the monotonic timer, which means we're not giving it a specific time of day to run. We're saying 7 minutes after this computer boots, run the script. And we don't care what time of day that clock on the wall says. I'm going to write and quit. Type sudo systemctl daemon reload. I need to enable this timer with sudo systemctl enable on boot plus 7.timer. Now, every time this computer boots up, it's going to wait 7 minutes, and then it's going to run this script. Let's restart the computer right now and make sure it's working the way that we expect. Sudo reboot. Okay, the computer's been restarted and sitting for 7 minutes. The file should be created. Let's check that out with ls-lh systemd. And here we see at 5:12, it created our on boot plus 7 file. So that worked as expected. The last thing I want to show here is that we can show all our timers with systemctl list timers. To see the timers, we need to go over to the right. Here's our on boot plus 7 timer. We see that it ran 4 minutes ago. We also see our script for sysd timer. That last ran 25 minutes ago, and it's scheduled to run again tomorrow at 4:51 a.m. In the next video, we'll continue looking at the Linux command line. In this group of videos, we're going to look at the Linux processes. And a process is pretty much anything that goes through the Linux kernel, including programs, applications, reading and writing files and output, and any commands run. One way to see what processes are running on a Linux computer is by using the ps command. Some people think that ps stands for process status, but if you check the man page with man ps, we see report a snapshot of current processes. So it's also possible that ps stands for print snapshot of current processes. When I type ps by itself and press enter, it shows 2 processes. The left column is PID, and that is the process ID. Every process will get a unique process ID starting with 1 and going up from there. There is a limit to the number of process IDs, so if and when a process ends, that PID will become available for use again if needed. The next field, TTY, shows what started this process, and in this case, it's the terminal that we are in. For a lot of processes, we're going to see a question mark in this column. When we see that question mark, it means the kernel started the process. Then we see the time it took the job to run, and that time is CPU time, not clock on the wall time. Here, both processes use less than a second of CPU time, so they show as 0 seconds. And the last column is the command used to start this process. When I add -A to the PS command, and then press enter, we see more or less the same thing. Our PS command does have a new PID because this is a new execution of the PS command, and we don't see the bash command in this output. When I type PS space A without the dash and press enter, we get slightly different results. The reason is, going to the man page again, when we type PS without the dash, we're using the BSD options of the PS command. Depending on what we're doing, we may or may not want to use the dash with the PS command. The A option for the PS command stands for all, meaning all of the commands by this user in this terminal. To see all the processes running on this computer by all users, we'll need to add the X option after the A, PS AX. And I'm going to pipe this into the less command so that we can see the column headers. This shows all the jobs running right now by all the users on the system. And as I scroll down a little bit, you'll see that there is a lot of things running at the moment. But looking at this output, we cannot tell who is running what job. I'm pressing Q to quit out of this. To see what user is running what job, we can add the lowercase u to this, making our command PSAXU. More often, we're going to see this command typed out as PSAUX, but the order of the options does not matter. The output will be the same either way, and I'm going to use the format PSAXU. And then I'm going to pipe that into less. Here we see the first column is the user. The second column is the PID that we already talked about. The third column is the percent of CPU used by this process. Then MEM is for memory. VSZ is for virtual memory used. RSS is for resident set size, which is more or less just the RAM memory used. We talked about TTY showing the question mark. These are processes submitted by the kernel. Here they're showing with the user of root. STAT is for the current status of the job. The uppercase S is for a process that is sleeping or waiting for something. The uppercase I means this process is idle at the moment. And a less than angle bracket next to that uppercase I means that this is a high priority task. Then we have the start time, the time that the process started. And the time next to that is the CPU time used, which we talked about earlier. And then on the far right, we have the command that started this process. And notice here that PID1 shows as sbin init for the initialization process. We will also see that PID1 show as systemd, depending on how the output is displayed. I'm going to open another terminal and shrink this down a little bit. And this is so we can compare PS command output. Now, instead of typing PSAXU for user, I'm going to type PSAXL for long format. And I'm going to pipe that into less. Here, the first column is an F for flags. And here we see a 4 for a flag. The 4 means that the job was submitted with root privileges. Then we also see 1s in that flag column. And that 1 means that the job was forked but did not execute. Then we see some have the flag of 5, which means both 4 and 1. And then if we have a 0 in that column, that means there are no flags for that process. After that, we have UID for user ID, which shows us the user ID instead of the user name. We talked about user IDs in video 14, adding new users. Then we see PID, we already talked about that. Then we see PPID, which is the parent process ID. And here we'll notice that these first two PIDs, 1 and 2, the init process and the systemd kernel thread, are the only two processes without a parent process. Every other process will be started from another process. Then we see PRI and NI, which stand for priority and nice values. We're going to look at those in more detail in an upcoming video, so I'm going to leave it there for now. Then the last value that we haven't talked about is wchan. Wchan shows the kernel function in which the process is sleeping. I'm going to quit out of here. And now instead of typing PSAXL, I'm going to type PSAXF. And this is another one where the options are usually shown differently. It's usually shown as PSFAX. But as I mentioned before, the order of the options does not make a difference. And I'm showing it here as PSAXF because here we can see them all together, the PSAXU, PSAXL, and PSAXF. We're using PSAX and just changing that last option. And here the F stands for forest, meaning in a tree hierarchy. I'm going to pipe this into less and press enter. And here on this first page, we see a lot of jobs that have a parent process of the systemd kernel thread. Scrolling to the bottom with uppercase G and then going up a little bit. Here we see the PSAXF command we submitted here, and we piped it into less. And we see that these commands were submitted from the terminal PTS1. And in the other terminal, PTS0, we see the less command from that terminal as well. And then we see a parent process of the Mate terminal, which has a parent process of the Mate panel, and we can keep going up from there. Those were all using the PS command options without the dash. Now I'm going to type PS again, and this time I'm going to add a dash lowercase e. And E is for everything. And I'm also going to pipe that into less. And instead of the dash E, we can also type PS dash uppercase A, and I'll pipe that into less. And that shows that we get the same output. So dash lowercase e for everything and dash uppercase A for all, those both show us the same thing. To see a little more output, we can type PS dash E for everything and then F for full, and I'll pipe that into less. Or we can type PS dash lowercase e uppercase F for extra full format, and I'll pipe that into less. And then another one that's kind of comparable to what we've been looking at is the PS-EL. And L is for the long format, and I'll pipe that into less. With the PS-EF, you may be thinking, how do I see that forest now? Since we already used the F for full, well, here we're going to use an uppercase H for hierarchy, and I will pipe that into less. And this shows the child processes have a space, or they're tabbed over to the right of the parent process. It's more clear when we go down to the bottom and then up a little bit here. And here we see the PS-EFH command that we just submitted. So this does work, but I prefer to see the hierarchy lines. To show those hierarchy lines, I'm going to type PS-EF and then -- forest. And I'll pipe that into less. And here's similar format that we've already seen. Now looking in our other terminal here, we notice that the output is sorted by PID. To change that sort order, we can type PS-AUX -- sort, and I'm going to sort it by the virtual memory size, So I'm going to place a single dash now and the VSZ for virtual memory. And I'm going to pipe that into less. And this is a little difficult to see with the word wrapping or line wrapping, as the case may be. So I'm going to press the dash, uppercase S, and then enter. And here we see the virtual memory starts with the largest on top, and then the next largest below that, and the next largest below that, and it keeps going down. Another common thing we might want to sort by is the CPU. So I'm going to type PSAXU -- sort. And then we need the dash before what we want to sort by. And we want the CPU, but it's got that percent sign to the left of it. So I'm going to type P for percent CPU. And then I'm going to pipe that into less. And again, because of the word wrap, I'm going to press dash uppercase S and enter. And here we can see that there's not much going on with that CPU. The top process is only using 0.6. And then below that, we've got 0.2, 0.2, and 0.1, 0.1. And this works out really well to show us all the processes running at this moment. But this information can change a minute or two later, or even a few seconds later. The most common way to see the processes updated every few seconds on a Linux computer is with the top command. And in the next video, we're going to look at the top command for the Linux command line. In this video and the next, we're going to look at the top command. We can start the top command by typing top in the command line and pressing enter. Top shows a lot of information, almost too much information. When we first look at the screen, it can be very overwhelming. But the screen is broken up into 4 sections. At the top, we have the summary data area, which gives us an overall summary of what is happening on the system right now. We'll take a closer look at this section in a moment. The next section we see is the column headers line, which tells us what fields are below that line. We saw these fields and talked about them in the last video for the PS command. Then the third section is the task information process list. This is showing us information about the processes currently running. And then the fourth section here, where we don't see anything at this moment, is for the messages and prompts. We'll see this in the next video, top part 2. Now that we know the 4 sections, let's look at the summary data area in a little more detail. We will start in the upper left corner where we see top. This is just telling us the name of the program we're in, top. Next to that, we have the time the computer thinks it is in a 24-hour clock format. To the right of time, we have the uptime, or the time since the computer was started or rebooted. This computer has been up for 1 minute. Then we see the number of users on this computer. This is a desktop computer, so there's only one user, me. And the last thing on the top line is the load average with 3 numbers. The number on the left is the current load average. The number in the middle is the load average 5 minutes ago. And the number on the right is the load average 15 minutes ago. And the idea behind showing us the 3 load averages is to help us see trends. For example, in this screenshot, we see 15 minutes ago, the load average was very low at 0.13. Then 5 minutes ago, the load average went up to 0.35, and currently the load average is 0.72. This tells us something in the last 10 minutes has put a bit of a load on the system. If those load average numbers were the other way around, with the 15 minutes ago being the highest load average and the current load average being the lowest, we would think that whatever is causing that load is not a problem anymore. Which brings us to the next question. When is a high load average a problem, or what load average number is a problem for the computer? And the answer is, it depends on the number of CPUs on that computer. When we see a load average of 1.00, that means one CPU is processing everything it can. It is 100% used. On a computer with a single CPU, a load of 1.00 is able to process everything at that moment, and nothing has to wait to run. If that load hits 1.01 or higher, that load is now more than a single CPU can keep up with, and some processes now have to wait to run.
But if we have a load average of 1.00 and the computer has 2 CPUs, a load average of 1.00 is only using half of the total CPU resources. So a load average of 1.00 is not a problem for a computer with 2 or more CPUs. But if that load gets higher than 2.00 for a computer with 2 CPUs, then we have more processes trying to run than we have CPU resources for, and some processes will have to wait to run. Today, most computers have more than one CPU, so a load average of 1.00 is rarely a problem. Going back to our terminal, Top is an interactive program, meaning we can press a key and change the view we're looking at. For example, I will press the lowercase l, and the load average line is hidden. Pressing that lowercase l again brings back that load average line. The next line in our summary data area shows information about the tasks running. Here we see we currently have 165 total tasks running at this time. This is the total of 1 running plus 163 that are sleeping or waiting for input, plus 0 stopped, and then we have 1 zombie process. A zombie process is a process that didn't end properly. They're usually harmless and don't use computer resources. But if the number of zombie processes gets above 2 or 3, you may want to look into what is causing that zombie process. I mention that because if a couple of zombie processes are created each day on a computer that is never turned off or restarted, and every day if more zombie processes are created, you have the potential of running out of process IDs. Now, don't worry too much about that happening. There are more than enough process IDs, and the process IDs are recycled. But if you have many zombie processes being created regularly and the computer is never restarted, there is a potential to run out of process IDs. The next line of the summary data area is about the CPU. This computer has 2 CPUs, but we only see 1 line of CPU information. To see the information for all the CPUs on the system, I'm going to press the number 1. Now we see the CPU information for both CPUs. CPU 0 is the first CPU, and CPU 1 is the second CPU. If there were more CPUs, they would show right here as well. Each CPU has its own line of usage. Let's take a look at each field on that CPU line. The first number is US. That is for user space. This is the amount of time the CPU spends running the processes that a user started. Next to that, we have SY. This is for system space. This is the time the CPU spends running processes the kernel started. The next number, NI, is for the nice value. We're going to talk about the nice value in an upcoming video. This is the amount of time the CPU spends executing processes with a manually set nice value. After the nice value, we have ID, which stands for idle time. And when this screen capture was taken, not much was running on that system. So the idle time was way up at 98.1. Then we have WA, which is the amount of time the CPU spends waiting for I/O to complete. HI is the amount of time spent servicing hardware interrupts. SI is the amount of time spent servicing software interrupts. And the last one, ST, is for stolen time, or the time lost due to running virtual machines. We see that both the CPUs are still showing. I'm going to press the lowercase t. That shows us the CPU usage in an ASCII graph. Not much is going on here now. Let's open up a browser window and see if that helps create some CPU usage. Pressing the lowercase t a second time shows our CPU usage graph in a block graph. Pressing that lowercase t a third time hides the CPU line. It also hides that task line above it. Pressing that lowercase t a fourth time shows the task line and the CPU lines once again. And in this case, we have the Show All CPUs toggled on, so we see both the CPU's information. I'm going to press that number 1 again and toggle off the Show All CPUs information. And we only have the single CPU line once again. The next two lines of our summary data area are the lines for memory. The top line mem is for the standard memory or the RAM memory on this machine. That first number is the total memory 3936.1. That is the sum of the free memory of 2674.4 plus the memory used of 491.5 and the buffer cache memory of 770.2. Below that, we have the swap memory. If the swap memory gets really high very often, you may want to consider increasing the RAM memory. This last value on the right, the available memory, is the memory that's expected to be recoverable from all the caches. Going back to our terminal, I'm pressing the lowercase m. This will show the memory as an ASCII graph. Pressing the lowercase m a second time shows the memory used as a block graph. Pressing the lowercase m a third time hides the memory lines from view, and pressing that lowercase m a fourth time will bring back the memory lines. The memory shows in megabytes by default. Pressing the uppercase E for extended memory scaling will change that memory scaling to be in gigabytes, terabytes, petabytes, exabytes, and then it goes back to kilobytes, and then we're back to megabytes, the default. We can also hide the entire summary data area by pressing the lowercase l to hide the load average line, and pressing the lowercase t 3 times to hide the task and CPU lines, and pressing the lowercase m 3 times will hide the memory lines. But we still have the message and prompts line showing. I'm going to bring back the summary data area by pressing the L key, the T key, and the M key, and we have the summary data area back. This is a good breaking point. We're going to stop this video here, and in the next video, we'll complete our look at the top command for the Linux command line. In the last video, we discussed the 4 sections of the top command and talked in detail about the summary data area here at the top. The second section, column headers, and the third section, task process information, go together, and the output looks a lot like the output from the PS command. I'm going over to a terminal, and I'm going to type the top command. Here we'll see that the data is updated every 3 seconds. We can change the amount of time between screen updates by pressing the lowercase d for delay time. Pressing the D shows us the 4th section, the messages and prompts area, where top is prompting us to give us a time in seconds to refresh the screen. I'm going to change it to 1 for 1 second. Now we see top is updating the screen every 1 second. I'm going to press the lowercase d again and change the delay time to 10. Now we have 10 seconds to look at the data before the numbers change. We can use the down and up arrows to scroll down and up. We can also use the page down and page up to scroll down and up a page at a time. Notice the screen refreshes when we hit the page down and page up with those arrow keys. We can also refresh the screen just by pressing the space bar or the enter key. Pressing the lowercase u brings up a prompt, and it's asking us for what user we want to filter by. I can type in a name, or if I know the user ID, I can type that in here as well. Both work. Pressing that lowercase u again, and then pressing enter without typing in anything, will show us the data for all users once again. If we only want to see 10 lines of output, we can press the N key for number of lines we want to view. I'll type in 10 and press enter. Now we only see 10 lines of output. Pressing that lowercase n again, and then pressing 0 shows us all the lines of output once again. I'm going to press the lowercase q to quit out of top, and then type top again, and go back in, and we see everything is reset to the default values. I'm pressing the uppercase B to toggle off the bold fields, pressing it again toggles those bold fields back on. It's a little difficult to see with the black and white screen, but most of the fields in the summary data area are bold, and the currently running processes are also shown in bold. I'm going to press the uppercase B again to turn off the bold, and then once more to turn it back on. Now I'm going to press the lowercase I key to show only the active processes. The top command, shown in bold, is the only active process running at this moment. To make the running processes stand out a little more, I'm going to press the lowercase b. That will show the processes running in reverse, or I like to think of it as lowercase b showing the background highlighting. Now our running processes really stand out. I'm going to toggle off the active processes by pressing the lowercase I again, and this shows us all the processes once again. I'll also press that lowercase b again to toggle off the reverse background highlighting. When I press the lowercase x, top will highlight the column the output is sorted by. The column highlighted is the CPU column. But again, with the black and white screen, it's a little difficult to tell what column is highlighted. To make that column stand out a little more, I'm going to press that lowercase b to reverse background that highlighted column. This also applies the reverse background to the running job we saw earlier. To turn off the bold for the running job, I'm going to press the lowercase y key. Now just our CPU column, the column the data is sorted by, is highlighted. If we want to sort this data by memory usage, we can press the uppercase M. We can also press the uppercase T to sort by time. To sort by CPU again, we don't use the C like you would think. We use an uppercase P for percent of CPU usage. If we want to sort by PID, we cannot use the P because we just used that for the percent of CPU. So we will use the uppercase N to sort by PID. And notice the PIDs are sorted in descending order, or highest to lowest. To reverse that, I'm going to press the uppercase R. And the lowercase c toggles the command column between process command and the full command line. This is where we can see process ID number 1 shows as sbininit and systemd. Pressing the lowercase z, or Z as our friends across the pond like to refer to it, makes our screen show in color. Now I'm going to press the uppercase P to sort by CPU again, and notice the CPU shows as zeros. That's because we still have the reverse on. I'll need to press the uppercase R again to reverse sort and make our order descending again. Now we see the sorted by percent of CPU shows as expected once again. Pressing the lowercase b still toggles on and off the reverse column. And I would need to press the lowercase y again to show the active jobs running. Pressing the uppercase B still toggles off and on the bold fields. They do stand out a little better with everything in color. And we can turn off that highlighted sorted column by pressing the lowercase x. If we want to change the default colors, we can change them from the screen we get to when we press uppercase Z. This screen can look a little scary if you're seeing it for the first time, but once you know how to read the screen, you'll see that it is a lot more simple than it first looks. The top line is telling us that we are in the Help for Color Mapping page and tells us the current window is 1:DEF. Below that, we have a little setting preview section. We'll see how that works in just a moment. Under that, we see the available toggles that we already talked about. The uppercase B for bold, the lowercase b for reverse bold, and the lowercase z for toggling on and off the color. The line number 1 is asking us what section do we want to change the color of, and the default is the uppercase T. Below that, they show us the 4 choices: S for summary data, M for message and prompts, H for column headers, and T for task information. The number 2 line is asking us what color do we want to make the section selected in line 1. And then they give us the colors 0 through 7 and tell us that we can use any color between 0 and 255. I'm going to press the uppercase S, and we see the current target for line 1 changes from a T to an S. Pressing the uppercase M changes it to M. Pressing uppercase H changes it to an H, and pressing the uppercase T changes it back to the T. So now we're going to change the color of the task information by pressing the number 7. And we see the color in our task preview section change to white. Then I'll press 3 and it will change to yellow. Pressing 5 changes it to magenta, and then pressing 2 makes the area green. I'm going to press the uppercase H to change the header color, and then I'm going to down arrow, and we see the number changes to 2. Pressing that down arrow changes it to 1, then to 0. Pressing it again takes me down to 255. And if I hold down the down arrow, it will keep scrolling down numbers. Pressing the up arrow increases our numbers until we get to 255, and then it starts again at 0. I'm going to scroll all the way up to 47. Pressing enter now will take us back to the top command where I can see the changes we just made. I'm going to quit out by pressing Q and go back into the top command again by typing top. And we'll notice that my color changes are gone. I'm going to press the lowercase z again to turn back on the colors, and then uppercase Z to go back into the help for color mapping page. And we haven't talked about the number 3 area yet. Here we see Q or escape aborts the changes to the window. And when it says abort the changes, it means we just change back to what we had coming into this window. So if I changed the screen color to blue, came in here and we changed to red, pressing the Q would take us back to what we had the blue coming into this window. Then we see the line A or W to commit and change another. Enter to commit and end. Well, we did the enter, so we know how the commit and end works. I'm going to press the lowercase a now. The first thing we notice is the colors in our preview area changed. And looking at the top line, we now see the current window is 2:job. And pressing that lowercase a again changes the colors again. And now the current window is 3mem. And pressing it a fourth time changes the colors, and the current window is 4user. Pressing it again loops us around back to 1. And then pressing the W does the same thing, only backwards. And we can change all those screen colors too, just like we did the one default screen, the one that we started with. To see these screens, we'll need to go back to the top page. So I will press enter. And I'm going to press the uppercase A to show all 4 alternate windows. And notice we crashed here with a Signal 11 SegV. So there is a bug in the top command, and we will talk about what a Signal 11 is in the next video. For now, I'm just going to restart top, pressing the lowercase z to turn on our colors, pressing the uppercase Z to go back to our color mapping page, and I'm going to press the uppercase S to change that summary data area to 2. And I'm going to press the uppercase T to update the task area, make that the color 3 for yellow. Now I'm not going to press the A or W this time, because when you press the A or W, that's what causes the screen to crash when we go back into the top command. So I'm pressing enter to go back to that top output. And I'm going to press the uppercase A again to show us the alternate windows. And with those alternate windows on, look in the upper left corner. It now says 1:DEF instead of top. Pressing the lowercase a takes me down to 2job. Pressing the lowercase a again takes me down to 3mem. And to show that I'm on that screen, I'm going to press the lowercase z, and it colorized our third alternate window. I'm going to press the W, takes me back to the number 2 job, and I don't want to show the number 2, so I'm going to press the minus sign, and our number 2 window disappears. I'm still on that if you look in the upper left corner, and I want to jump down to window 4. So I'm going to press the G key, and it's asking me which field group do I want to go to. I'm going to press 4. And again, I'm going to press the minus sign, and we'll notice now we only have 1 and 3 showing. To view only 2 and 4, I can press the Shift minus or underscore key, and now I see 2 and 4. Pressing the underscore key again brings me back. I want to save these changes. To save them, I'm going to press the uppercase W for write. And we'll notice real quickly it shows us in that message and prompts area where it wrote that file to. I'm going to press the uppercase W again so we can get another quick look at it. And it's written to home.michael.config procps top rc. Now I can quit out of here by pressing the Q or Control C. And when I type top, it takes me back into the top command with the changes that I've already saved. And if I want to change the fields showing on one of these windows, I'm going to go to that window with the A or the W or G to go to that group, and then press the uppercase F. And here we see the fields showing on the page in what order they are in. I'm pressing Q to quit out of there. And the last thing we're going to do is quit out of here. And we're going to change this back by removing the file in the, let's CD into home.michael.config procps. And there we see the top RC file. I'm just going to rename that with the move command. Move top RC to top rc.back. Now when I type top, it shows us the default values. And if I want to see my colored version again, I can rename that file from back to the top RC, and that would restore us back to the customized colors and fields that we've chosen. In the next video, we will continue looking at the Linux command line. I'm going to start top by typing TOP and pressing enter. I've got another open tab here. And in this tab, I'm going to type in the command ddif equals /dev/0 space of equals /dev/null. We haven't talked about the dd command, but it's like the copy command. It's going to take the if input file of dev0 and send that data to the of output file of dev null. In an earlier video, we talked about the /dev/null being like a garbage can or a black hole, where whatever we send to /dev/null is just gone. /dev/0, on the other hand, is an endless stream of random data. So what we're doing with this command is sending an endless stream of random data to nothing. When we run this command, it will stress out a single CPU, and this will continue until we end the process. I've started the command. Let's go back over to the other tab. And right here at the top, we see our dd command using 100% of the CPU or 99% of the CPU. It goes back and forth. I'm going to press the number 1 to show all the CPUs as we saw in the last video. And then I'm going to press the lowercase t to show the CPU usage as an ASCII graph. And we see a single CPU is maxed out. I'm also going to press the lowercase m 2 times to show the memory usage as a solid block. Now let's look at the priority and nice value of the DD process running. We have a priority of 20 and a nice value of 0. So that's our default priority and nice value. I have a chart here that shows the priority on the left and the nice value on the right. In the center on the left, we have a priority of 20. On the center on the right, we have a nice value of 0. This means when the nice value is 0, the priority is 20. And those are the default values for the job we just started. At the top of this chart, on the left, we see a priority of 40, which will happen when we have a nice value of 19. And this is actually the lowest priority we can assign a process. If we set the nice value to 19, we will get the least amount of available CPU resources. The lowest nice value we can assign a process is minus 20. If we set the nice value to minus 20, we are giving that process the most available CPU resources we can assign a process. In other words, if we have an important job that we need to run as quick as possible, we want to give it the most amount of CPU available. So we want to run this job with a nice value of minus 20. And if we have a job like a backup job that we want to run in the background, but we don't want it to slow down other jobs, we might want to give that job a value of 19. Let's change the nice value of the DD process running from 0 to 5. Meaning we will give it a lesser priority. When we change the nice value, it's called renice. So we want to renice the nice value of the DD process from 0 to 5. We can do this without leaving top. To renice the DD command, I will press the lowercase r for renice. Top is asking me for the PID of the process I would like to renice. I can put that PID here, or since the DD process is taking the most CPU, it is set as the default PID. So I will just press enter. And now it's asking me, what do I want that nice value to be? I'm going to type the number 5 and press enter. Now we see the priority shows as 25 and the nice value shows as 5. Let's renice that job again by pressing the lowercase r. And I want to renice that job again, that 3943. So I'll press enter. And I want to give this job the lowest priority of 19, even lower if I can. I'm going to type in 25. Pressing enter. We can only renice to the value 19. So my job is reniced to the highest number I can assign, which is 19. And we notice here that even with the lowest priority, the DD job is still using 99 or 100% of the available CPU. That's because nothing else is running, so 99 or 100% of the CPU is available. If another process was running with a higher priority, that process or processes would have a priority over that DD process for the CPU resources. So let's open up a browser window now. When we do, we should see the CPU for our DD job go down while the browser opens. And we see Firefox has a priority over the DD job. Now I'm going to try to renice the DD command from 19 to 15. I'm pressing R, enter, and I'm going to make this 15. Pressing enter, we get a permissions denied error. The reason is standard users can only renice their own processes. Well, this is our own process. We see the user is Michael, but standard users can only renice their own processes to a higher nice value, meaning a lower priority. To renice a PID to a lower nice number, meaning a higher priority, I'll need to do that as a privileged user. I'm going to press Q to quit out of top. From here, I can either restart top as a privileged user, or I can submit the renice command from the command line as a privileged user. To start the command, I'm going to type sudo to be a privileged user, and then I will type renice for the renice command, and then I want to give it a -n for the nice value that I want to give, which will be 3, and then I need to give it the PID too, so I'll do a -p for PID, and then 3943. Pressing enter. And here we see process ID 3943 had the old priority of 19 and the new priority is 3. I'm going to restart top as a privileged user with sudo top. And there we do see our job 3943 has a nice value of 3 and a priority of 23. Once again, I'm going to press the lowercase r for renice, and then enter for the default process, and then a -25 to see if I can make this lower than the lowest value of -20. Pressing enter, it only allows us to make this -20, which is a priority of 0. Now, looking at some of the other jobs, we see that there are some values less than -20. We see -51, and then we see an RT in there. Those are processes with priorities higher than Linux users can assign. This is to prevent users from stealing all the CPU resources from Linux. The lowest priority we Linux users can assign is -20. The actual priority a process can be assigned is much lower, but those lower priority numbers can only be assigned to processes started by the kernel. And then the priority RT, this is for real time. And you can think of this as like a -100 or the lowest value available. But since -100 doesn't fit on the line, RT shows there instead. Going back over to the other tab, I'm going to hold down Control and press C to cancel out of that DD job running. I want to run that job again, but I want to change the nice value when I start the job. To do that, I'm going to press the arrow up to bring back that previous command. And then I'm going to hold down Control and press A to go to the beginning of that line. Now I'm going to enter nice and add the -n for the nice value I want to give this job. We'll make this 7. And then we've got the command after it. And if I wanted to set that nice value to something less than 0, I would have to add sudo to this command to become a privileged user. I'm going to press enter. And then let's go over to the other tab. And there we see the nice value is 7 and the priority is 27. In the next video, we'll continue looking at the Linux command line. I have the terminal open with 2 tabs, and I'm going to type top in this first tab. And I'm going over to the other tab where I'm going to paste in that same command we've been working with, the dd if equals dev 0, of equals dev null, and press enter. And that is started. We see it over here in top running as PID 2321. In the last video, to stop this job from running, we went into the tab where the job was running, held down Control, and pressed C to cancel out of this job. In this video, we're going to stop this job from running in top, and then we'll stop the job from running from the command line. When we stop a process from running, it's called killing the process. To kill a process while in top, we'll press the lowercase k. Top shows us the message PID to signal kill. Default PID is 2321. Just like the renice command, top thinks we want to kill the job using the most CPU and sets that as the default. And for us, that is correct. So I will press enter. Now top shows us the message, send PID 2321 signal 15 sigterm. It's not asking us for a confirmation of a Y or an N. Pressing enter will confirm this, and pressing escape will stop this request and not run the sigterm to kill the job. I want to kill the job, so I will press enter. And now the job is gone. Standard users can only kill their own jobs. Privileged users can kill their own jobs as well as jobs submitted by others, but not even privileged users can kill jobs started by the kernel. The reason is because killing jobs submitted by the kernel may accidentally or intentionally bring down the computer. And if you want to bring down the computer, you should shut down the computer gracefully. And we will do that at the end of this video. I'm going to the other tab, and I'm going to restart the dd command. Going back over to top, we see that this is job PID 2391, and I'm going to quit out of top by pressing Q. To kill the job from the command line, I will type kill, and then the PID of the process we want to kill. In this case, it's 2391. Pressing enter, the job is killed. To make sure, I will restart top. And we see that that PID is gone. Going over to the other tab, I'm going to submit that dd command once more. Pressing enter, it started. Going back over to our top command, we see that we now have the dd command running with a PID of 2405. And I'm going to quit out of top by pressing Q. Occasionally, a job will not stop when we type kill and the PID, but we still want to kill that job. To force kill that job, we will add a -9 to our command. So our command will be kill -9 and then the PID, which in this case is 2405. Pressing enter, we have killed 9 that job. I'm going to type top, and we see that that DD process was killed once again. We always want to try kill before kill 9 when we kill a job, because the kill by itself tries to terminate the job, whereas the kill 9 just stops that job from running and might leave some files in an improper state after that job was killed. I'm going to quit out of top and clear the screen. To see a list of all the ways that we can kill a job, I'm going to type kill-L. This lists out all the different ways we can kill a job. 2 videos back, it was supposed to be the last video, but it was 2 videos back, we saw that top crashed, showing us it crashed with a Signal 11 SIGSEG V. Here we see that the Signal 11 is a SIGSEG V in this list of signal interrupts. And when I looked up what a SIGSEG V is, I found it means a program tried to access a memory location that was not assigned to it. And that is why top crashed. When we killed the job from inside of top, it showed us it was going to kill the job with a 15 sig term. We see 15 sig term here. And 15 sig term is also what we used when we submitted the kill from the command line. Sig term 15 is the standard termination signal to end a process. The other kill signal we used here was kill-9 or sig kill. This will just end the process and may leave files in an improper state. Other signals we've used in this series are number 2, sig int. Sig int is short for signal interrupt. This is sent when we hold down Control and press the letter C. The other one that we've used in this series, although it was a few videos back, was the sig quit number 3. That submits a quit signal when we hold down Control and press D as in dog. Sometimes we want to kill a process by the job name instead of the PID. To do that, we can use pkill. I'm going to start a Firefox browser. To kill the browser, I will type pkill Firefox. Pressing enter, we see that the Firefox tab is now gone. It is killed. Occasionally, when we use pkill to kill a job, the job will not end properly. So we'll need to force kill it or kill 9 like we used with the kill command. I'm going to restart Firefox, and to force kill it, we would type pkill-F for force kill, and then the application name, which in this case is Firefox. And the job is killed. I'm going to pause this video for a moment or two. I'm back, and now we see there is something using up a lot of memory and a lot of CPU. And it looks like it's all from user George. I'm going to type U and bring up only the jobs used by George. And we can see that he has a lot of things running. I want to kill all the jobs that George is running right now. To do that, I'm going into another terminal, and I'm going to type kill all -U for user George. So I'm going to kill everything that George is running. Pressing enter, we see that nothing is killed because I did not use sudo. We must be a privileged user before we can kill all of George's jobs. So sudo kill all -U for user George. Putting in my password, and now all of George's jobs are killed. And we see that the memory goes down and the CPU usage goes down as well. I'm going to close this little window and quit out of top. And to end this video, I will shut down this computer gracefully with the command sudo shut down -H for halt. And then we need to give it a time, and I want it to shut down now. In the next video, we will continue looking at the Linux command line.
I have a terminal open with 2 tabs, just like the last video, and I'm typing top in this first tab. Going over to the other tab, I'm going to paste in that same command we've been working with, that DD command. And once I press enter, we cannot type anything else in the terminal now because the job we just submitted is running in the foreground. Going over to the other tab, we see that DD job is running with a PID of 2528. We can send this job to the background, but first we need to pause the job. To pause the job, I'm going to hold down Control and press Z as in zebra. The terminal shows us 1 in brackets is stopped and then shows us the command that is stopped. Going over to the top tab, we no longer see that DD job running. It is stopped or paused in this case. I want to continue running this job, but from here, I want this job to continue in the background. To do that, I will type BG for background. When I press enter, we see the message 1 in brackets and then a plus sign and then the command we submitted. But notice now it also has an ampersand after the command. And clicking on the other tab, we see that DD job is running once again. So we have this job running in the background now, but notice we can no longer cancel the job by holding down Control and pressing C. And if this program required input values from us, we would not be able to type in any input values because the job is now running in the background. I want this job that is now running in the background to run in the foreground. To do that, I will type FG for foreground. Pressing enter, we see our command again and without the ampersand at the end. And we don't have any command prompt because the job is now running in the foreground. Going over to top, we see that same PID 2528 is still running. I'm going to hold down Control and press C to cancel out of the process running in the foreground. And I'm going to resubmit this command, but this time I'm going to add the ampersand at the end to tell Linux we want to run this job in the background. Pressing enter, we see it started job 1 in square brackets, and then the job number 2579. And going over to the top tab, we see that our DD job is now running with a PID of 2579. Let's submit a second command in this terminal to run in the background. It's going to be a sleep command. So I'm going to type sleep 3600 ampersand to run in the background. This will run a job that will sleep or wait for 3600 seconds, which is 1 hour. And I've added the ampersand at the end to make this job run in the background. Pressing enter, we see a 2 in brackets and then the job number of 2582. To see this in top, I'm going over to the other tab. I'm going to press U for user and change the user to be Michael, pressing enter, and going all the way down to the bottom. There we see the sleep command of 2582. And it's not taking any resources because it is sleeping or waiting. I'm going back to the top, and then I'm going to press U and enter to bring back all of the users. If I type FG for foreground now, it brings back that sleep command to the foreground. But I want to bring back the DD command to the foreground. So I'm going to pause the sleep command by holding down Control and pressing Z as in zebra. And then I will type BG to continue this job running in the background. To bring the DD command, the first command we submitted, to the foreground, we will need to type FG for foreground, followed by the number 1. Pressing enter, we see it brought our DD job to the foreground. To pause this, I will hold down Control and press the letter Z. It's easy to remember which job is which when we only have 2 jobs running in the terminal. But what if we had 4 or 5 jobs running? We would want to be able to list out all of the jobs running in this terminal. We can do that by typing jobs. This shows us job 1 is our DD command, and it is stopped, and job 2 is our sleep command, and that is running. And if we had other jobs submitted in this terminal, they would show here in this list as well. Let's start job 1 to run in the background by typing BG space 1. And now let's type jobs again, and we will see that both jobs are running. Now notice we see a little plus sign and minus sign by the job numbers. The plus sign is the current default job, and the minus sign is the next in line default job. To take the place of the default job when that one ends, the minus sign will become the plus sign. Default means if we type a command like FG for foreground without giving it a specific job number, that command will be applied to the default, which in this case is the sleep command. Let's add another sleep command by typing sleep 7200 ampersand to run this in the background. Typing jobs again, we now see that the newest job submitted is the default job, and what was the default job now has the minus sign. If we want to see the PIDs of these jobs as well, we can type jobs-L. And there we see the PIDs as well. I'm going to move this over a little bit and take this right tab and move it to the desktop. That just separates the two out. So if we bring this one back up, come over to the other, I'm going to make this smaller so that we can see both. I'm going to close this smaller terminal, and when I do, it's going to kill all the jobs running in this smaller terminal. We'll see that by the DD job ending. And there we see the DD job has been killed. The reason is, when the terminal window is closed, the job running in the foreground will be killed, and then the terminal sends a sig-hup command to all the processes running in the background of this terminal, so they will be killed as well. We can get around this by adding no-hup to the command we want to continue after the terminal window is closed. Let's open a new terminal window, and I'm going to shrink this down a little bit. And now I'm going to add that no-hup and then paste in the command. And we're going to add the ampersand to run this in the background. And now I'll press enter and start that up. Notice we get the message no-hup is ignoring input and appending output to the no-hup out. Pressing enter will just get us back. And when we run this no-hup, it will create a file no-hup. We should be able to see that with ls-lh grep no-hup. And there we see the nohup.out file. There's nothing in it. We see it has a size of 0. And we can delete this file later after the command ends. So now I'm going to close this terminal, and our DD command should continue running. Closing the window. And we see that DD job does continue running even after I closed the terminal window where I started it. I'm going to kill that DD job by pressing K to kill, and I do want to kill PID 2808. And now the job is killed. In the next video, we will continue looking at the Linux command line. In the last video, we looked at running a job in the background, and we added no-hup to our command to allow that command to keep running even after we closed the terminal window. Another way to keep a job running after closing the terminal window is with the screen command. I'm typing in screen and pressing enter, and we see that screen is not installed by default on this computer. But Linux is telling me I can install screen with the command sudo apt install screen. So I'll do that now. Screen is now installed, and I will type screen again. And when I press enter, we see the version of screen, the copyright information, and at the bottom, we see press spacebar for next page, return to end. I will press return or enter, and it looks like I'm placed back in my terminal window where I was before I typed screen. But now I am in a screen session.
To quit this screen session, I will type exit. And we see the message, screen is terminating. Now we are out of the screen session and we ended that screen session. I'm going to change to a different directory with cd lcl. And again, I'm going to type in screen and press enter. We see the information page. I'm going to press enter again. And again, it looks like nothing happened. But we are still in the LCL directory, and we are in a new screen session. To show how this works, I'm going to type top and start the top command. Now I want to disconnect from the screen, but I don't want to end the screen session like we did when we typed exit. To disconnect from the screen, but keep that screen session running, we will want to use a screen command to disconnect. And the screen command to disconnect is pressing the letter D for disconnect. But if I press the D key now, top will think I'm trying to submit the D key to top. So we need to add a prefix to our command to tell Linux the next key I press is going to be a screen command. And the prefix for a screen command is Control A. So I want to hold down the Control key and press the letter A to tell Linux that I'm going to send a screen command. Then I'm going to press the letter D, which is the actual screen command, to disconnect. So the whole command I'm going to use right now is Control A D. And I'm disconnected from the screen, but it is still running in the background. I can even close this terminal window, and the screen session is still running in the background on this computer. I'm going to open up a new terminal window, and to see the screen sessions running, I will type screen-ls. Since we only have a single screen session running now, I can reconnect to that screen with screen-r, and the R is for reconnect. And here we see top is running just how we left it when we disconnected from the screen. I'm going to disconnect from this screen again with Control A D, and I'm disconnected from the screen session. But the screen session is still active and running in the background. As long as this computer is not turned off, that screen will continue to run. Often, screen is used after SSHing into a computer. For example, someone might log into a server from their work desktop, start a screen session on that server, then disconnect from that screen session running on the server. Then they can turn off their work desktop computer, go home to their home computer, SSH back into that same server where that screen is running, reconnect to that screen session, and continue working from there. Let's start another screen session by typing screen and enter again. And I'm just going to run the ls command here and then disconnect from the screen with Control A D. I'm out of the screen session that we just started. Now we have two screen sessions running. I can see that when I type screen-ls. I want to go back into the screen running the top command. We know which one this is because it was in the first ls command when we only had the one screen. To reconnect to that screen that starts with 3688, I will type screen-r for reconnect, and then I need to type in enough of the title to make it unique. So if I type 3688, that's enough to make it unique. Now from here, I can either press enter or I can press the tab key, which will auto-complete the title, and then I can press enter. And we're back in that top screen session. And I am certain we are in the screen session running top, and I want to rename this screen session to have top in the title. To do that, I will hold down Control and press A, and then I'm going to press the colon. If we put a colon after that Control A, that means we're going to type a screen command. And the screen command I'm going to type is session name. And we're going to give this session name top. Pressing enter will complete the command. And I'll press Control A D to disconnect from that screen and type screen-ls. And now we see that the screen number 3688 has top in the title, so we know that's the one that is running the top command. Let's start a new screen session, and I will start with screen. And I want to give this screen session a name. So to do that, I'm going to add a dash uppercase S for screen session name, and I will give it the name Split Windows. Now, before I press enter, we're going to notice that when I give a screen session a name, it skips that screen information page and takes me right into the screen session. Pressing enter, we see we're right into the screen session. In this window, I'm going to type ls-lh, and I'm going to disconnect from this screen right now by pressing Control-A-D, and then clear the screen. I'm going to list out the screen sessions again with screen-ls, and we see that we have 3 screen sessions. One screen session is called Top, a second one has the default name, and the third one is called Split Windows. We don't need the screen session that we didn't rename, and we want to exit out of that. I could reconnect to that screen and type exit to end that screen session, or we could just type screen-xs. Then we want to type in enough of that name to make it unique. I'm going to type in the 3744 and then quit. And that screen session should have ended. Let's check it out with screen-ls. Now we only have 2 screen sessions running. This shows we did end the screen session with the job ID of 3744. Now there are times when you might have a long-running job that you need to run, and you want to run this in a screen. Let's start a screen for that, screen-s, and we're going to give this screen session name long-running job. And the job we're going to run is a sleep command. Let's cat this out. Cat sleep 15.sh. It's just a sleep command that will sleep for 15 seconds. We're going to use this as our long-running job, but we made it short just for the video. We want to run this job in a screen, and then we want to exit out of the screen as soon as this job ends. We're going to start up our sleep command with /sleep15.sh. Then I'm going to put a semicolon, which is a command separator. We talked about this in an earlier video. And then exit. So we want to run that sleep command and then exit out as soon as this sleep command is done. Pressing enter. The sleep command is running. I can disconnect from the screen now is what I would normally do, but we're going to stay here and watch it exit out as soon as we hit that 15 seconds. And here we see that we were exited out of that screen as soon as that job ended. We can also do that same thing without even entering into the screen command. We'll do that by typing screen-uppercase S, long running job, -D-M, and then we'll give it the job to run, which is /sleep15.sh. So this will start up the long-running job screen and then run that sleep 15. As soon as that's done, it should exit us out of that long-running job screen session. Pressing enter starts it up, and I will type screen-ls. Now we see that that long-running job is running. Screen-ls again shows it is still running. And as soon as that 15-second job ends, let's run that screen-ls again. It should be done. And it is. This is a good breaking point, so we're going to end this video here. And in the next video, we will continue our look at screen for the Linux command line. We are picking up from where we left off in the last video, looking at the screen command. After recording the screen part 1 video, I learned that the screen command is no longer supported in Red Hat 8. So in the next video, we will look at screen alternative tmux. Continuing on with the Screen Part 2 tutorial, I'm going to type screen-ls to remind us of where we left off in the last video. We have two screen sessions opened, one called Top and the other called Split Windows. I'm going to reattach to the screen session called Split Windows by typing screen-r split and pressing enter. And I'm back in my Split Windows screen session. I want to create a new window in this screen session. To do that, I'm going to type the screen prefix of Control-A, and then I'll press a lowercase c for Create New Window. Let's change the directory to the LCL directory with cd LCL. To see the windows we have open in our screen session, I'm going to press the screen prefix of Control-A and then the double quote. We see two windows, 0bash and 1bash. Those names are not very descriptive. While on this page, I can use my arrow up and down keys to choose which window I would like to return to. I'm going to put the highlight on the 1bash and press enter. And I'm back in the LCL directory window. Let's rename this window to LCL by pressing Control-A and then the uppercase A. We see Set Window Title down on the lower left, and right now it's showing us the default of Bash. I'm going to press the backspace key 4 times, and then I'll add in the LCL that we want to change this window to, and press enter. To see the windows we have open now, I'm going to press the prefix of Control-A again, and then the double quote. And we now see that window 1 shows as LCL. I'm moving my highlight over the 0bash window and pressing enter to return to that window. I'm going to press Control-A and then C again to create another new window. And in this window, I'm going to type Top. So Top is running. I want to rename this window to Top, so I'll press Control-A, uppercase A, backspace out the bash, and type in Top. Now we have 3 different windows open. To go to the next window, I'm going to press the screen prefix of Control-A and then N for next. I'll do the same thing again, Control-A-N for next. Or I can press Control-A-P for the previous window. I'm going to press Control-A double quote again to show me all the open windows. And we see we've got 3 open windows numbered 0 to 2. To go to a specific window, I can move my highlight over that number like we saw earlier. Or from any window, including this one, I can press Control-A and then the number of the window I want to go to. I will press Control-A2 and go to the top window, and then Control-A1 will take me to the LCL window. So now we have 3 different ways to get around these windows that are open in Screen. Now I want to split this window. To do that, I will type the screen prefix of Control-A and then in uppercase S for split. We see a horizontal line halfway through the screen, so we have split this window horizontally. The top window is the LCL window, and the bottom window doesn't have anything in it at the moment, and the name shows as 2 dashes. To move the cursor to the bottom window, I'm going to use the screen prefix of Control-A and then press the Tab key. So Control-A Tab will move me to the next window. From this new empty window, I can create a new window with Control-A-C for Create. And we see at the bottom, this window is called 3bash. We can make this window one of our other screen windows by typing Control-A and then the number of the window we want this to be. Let's make this window our top window by pressing Control-A2. Or we can make both these windows the same thing by pressing Control-A1. And here I'll type LS. And it shows the same thing in both windows. I'm going to change this bottom window back to the new bash window with Control-A3. Now I want to unsplit the window. To kill the Bash 3 window, I could type exit, but I want to keep the Bash 3 screen window running. To do that, I'm going to make sure that I'm in the split that I want to close, and then I will press Control-A uppercase X. When we unsplit the horizontal window, it worked, but it needs a little cleaning up, so I will type clear. And now it's more clear that we have unsplit that window. If you accidentally pressed the lowercase x instead of the uppercase X, I'll do that now with Control-A lowercase x, you locked up the screen. To unlock screen, you can just type in your Linux login password. Now I want to split the screen vertically. To do that, I will press Control-A and then the pipe symbol. To get to the new split, I'll press Control-A tab, and then I'll create a new window in here with Control-A-C. And we see our new window is called 4-bash. When we split the window, Screen tries to split the window in half. I want this new window to be 3/4 of the screen. To do that, I will type Control-A:, which allows us to type in a screen command, and I'm going to type in resize 75%. And pressing enter resizes my window. Now my new window has 75% of the screen window, and the other side of the split has 25% of the screen window. I can also reduce or increase the size of this window by a number of columns by adding a plus or minus after the resize. I'll press Control-A:, and then type in resize -5, and when I press enter, we reduced our window by 5 columns. If I don't give it a plus or minus and just put in a number, it will make our window that many columns. I'll do Control-A:, resize 60. We'll make this window 60 columns. Pressing enter, we've resized our window. If I want to make all the windows the same size, I can do that with Control-A:, and then type in resize space equals. And now our windows are equal in size. I'm going to add a horizontal split here with Control-A:, S, and I want to make this window 30% of the split. I'll do that with Control-A:, resize 30%. And then if I want to close all the windows except the window I am in, I can type Control-A:, Q. And after closing the other windows, it leaves this one in an odd position. I'm going to type clear to show that we only have the one open. To exit and remove this window from the screen session, I will type exit, and then Control-A:, shows that we have closed the 4-bash window. And then going into the 0-bash window, I will exit out of that, quit out of top and exit out of that window, and then exit out of the LCL screen window. And we have one more open. I'll exit out of that one as well. And we see the message screen is terminated. So we have ended the screen session. In the next video, we're going to look at tmux for the Linux command line. tmux is short for Terminal Multiplexer and is similar to screen that we looked at in the last 2 videos. We looked at screen after talking about background processes, where we wanted a process to keep running in the background even after we close the terminal window. And tmux can do that just like screen did. I'm going to type tmux to start the Terminal Multiplexer, and we see that it is not installed. I'm going to install it now by copying this command and pasting and running it. tmux is now installed. I will type tmux and enter. And unlike screen, tmux lets me know right away that I'm in a tmux session by showing a green line at the bottom of the screen. In the lower left corner, we see 0 in brackets, showing me that I'm in the 0 session.
Next to that is the window. I am in the window 0 with the name bash. And over on the right, we have the name of the computer we are on, and then the time and date. I'm going to type exit, and our green line disappears, letting us know that we are out of the TMUX session. We see exited in brackets, letting us know that we exited out of the TMUX session and that the TMUX session has ended. I'm going to clear the screen, and now I'm going to type TMUX again. And I've started another TMUX session. I'm going to type top to get top running. And I want to disconnect from TMUX, but I want to keep the TMUX session running so that my top command will keep running. The TMUX command to detach from the TMUX session is the D key, D for detach. But if I press that D key right now, top will think I'm trying to send that key press to top. So what I need to do is add a prefix to my command to let Linux know that the next command I give is going to be a TMUX command. The prefix for TMUX is to hold down the control key and press the B as in Bravo key. And then I would press D for detach. So let's do that now. I'm holding down control and pressing B, and now the D key for detach. And we see the green line at the bottom is gone, and we see the message detached from session 0. Now I can close my terminal, and the TMUX session is still running. I'm going to open up a new terminal, and to see any TMUX sessions running, I will type TMUX space ls. Note there's no dash before the ls, just a space between the two. And this shows us that we have a single TMUX session running, and we see the TMUX session 0, then we see 1 Windows, and then the date and time it was created. Since there's only one TMUX session, we can reattach to that by typing TMUX attach. And here we see the top command is still running. I'm going to detach again by holding down Control, pressing B, and then the D key. And I'm now detached from the TMUX session, but it's still running. As long as this computer is still running, that TMUX session will keep running. Often, TMUX is used after SSHing in from a different computer. For example, someone might log into a server from their work computer at their office, start a TMUX session on that server. Then at the end of their workday, they detach from the TMUX session and server and turn off their work computer, go home to their home computer. They can log back into that same server where they started that TMUX session, reconnect to that same TMUX session, and continue working from where they left off. I'm going to create another TMUX session by typing TMUX. Again, I see the green line at the bottom of the screen, and in the lower left corner, now I have a 1 in the brackets, telling me this is the second TMUX session I've started, 0 being the first. And I'm going to run the ls command here. And now I'm going to detach from this TMUX session by holding down Control B and then D. Now we have 2 TMUX sessions started. I can see this with TMUX ls. And we see the 2 TMUX sessions running here with the names 0 and 1. Each has 1 window open, and then we see the time each one was started. The TMUX session 0 is running our top command, and I want to give that session a more descriptive name. To do that, I'm going to type TMUX rename -session space -t, and then I'll give it the old name of 0, and then the new name I want to give it, which is top. And now I'm going to arrow up 2 times, pressing enter. We see that we have TMUX session 1 and TMUX session top. So it's clear which is running the top command. I'm going to reattach to session 1, where we ran the ls command. To do that, I will type TMUX attach. But now I need to tell TMUX which TMUX session I want to attach to. To do that, I will add a -t and then the session name, 1. And I'm back in TMUX session 1. I can see that in the lower left corner where we see the 1 in the square brackets. I want to rename this session to be called ls. To do that, I will start with the tmux prefix of holding down Control and pressing B, and then I'm going to press the $sign. And here we see rename session, and then we have the current name of 1. I'm going to hit the backspace, and then I'm just going to type ls. And pressing enter, we now see ls in that lower left corner in the brackets. Now we could also have typed the tmux prefix, Control B, and then a colon. This brings up an area where we can type up a tmux command. And the command I would type would be tmux rename session-t space 1 space ls. This is the same thing that we typed in the terminal. Since we already renamed the session, I'm going to press escape and get out of that. I'm going to detach from this session with Control B, D, and type tmux space ls. And now we see both of our tmux sessions have names. Now I want to start a new tmux session, and I want to give it a name when I start the session. To do that, I will type tmux new-s so I can assign a session name, and then I'll give it the session name I want to give it, which is Split Windows. In the lower left corner, we see that we are in the new tmux session called Split Windows, but we only see the first 10 characters of our tmux session name. We will fix that later, but not in this video. In this window, I'm going to type ls-lh and then detach with Control B, D. Let's clear the screen and typing tmux ls, and we see we've got 3 tmux sessions currently running. One called ls, another one called Split Windows, and a third one called top. We don't need the tmux session called ls, so I'm going to kill that with tmux kill session-t, and then the name of the session we want to kill, which is ls. Pressing the arrow up 2 times shows us that that session is killed. If we want to kill all of the tmux sessions running with one command, we would type tmux kill server. That will kill off every tmux session we have. I don't want to do that now, so I'm going to press Control C to cancel out of that command. We may have a long-running job that we need to run, and we want to run it in a tmux session, but then we want the tmux session to end once the job completes. To do that, I will create a new tmux session called long-running job with tmux new-t long-running job. And my long-running job is really only 15 seconds. I'm keeping it short for this video. It's a bash script called sleep15, and I will cat that out right now with cat sleep15.sh. And we see that it's just a script with a sleep 15 seconds in there. To run this command, I will type /sleep15.sh. Then I'm going to add a semicolon, and then I'm going to type exit. So this will run the sleep15 script, and then it will exit out. I'm going to press enter and start the job. And from here, normally I would press Control B, D to detach from the tmux session. But since it's going to run so quickly, I'll just stay here where I am, and we will see when it ends, when it kicks me out of the tmux session. And there we go. We are bumped out of the tmux session, and typing tmux ls shows us the tmux session long-running job is no longer running. We can also run a long-running job in tmux right from the command line. To do that, I would type tmux new-d, and the -d is telling us we can run this command detached from the tmux session. Then we're adding in a -s to give this a session name of long-running job. And now we're going to put in the command, and I'm going to put it in single quotes. And this is going to be a shell command, so $shell-c. And then in double quotes, we're going to put the command that we want to run, sleep15.sh, end double quote, end single quote, and pressing enter will start this. Typing tmux ls shows us that the long-running job is now running, and pressing tmux ls again shows that it is still running, and pressing the arrow up again, the 15 seconds should have ended, and it has, so the long-running job has ended. This is a good breaking point. We will continue looking at tmux in the next video for the Linux command line. We are picking up from where we left off in the last video, tmux part 1. I'm typing tmux ls to see what tmux sessions we have open. I see split windows with one window open and top with one window open. I'm going to reconnect to the tmux session split windows by typing tmux attach -t split. We only need enough of the session name to make it unique, and I'll press enter, and I'm back in my split windows tmux session. We see the output of the ls command we ran in the last video. Down at the bottom, we see the green line that has the tmux session name of split windows on the far left. But our session name is cut off after the first 10 characters. We'll look at how to fix that in the next video. After the session name, we have the window name of 0:bash with an asterisk next to it. I want to create a new window. To do that, I will type the tmux prefix of Control B, and then I will press the lowercase c to create a new window. Our screen is cleared, and looking down on the green status bar at the bottom of the screen, we now see our window is 1:bash with the asterisk next to it. The asterisk means we are in window 1:bash, and there is a dash or minus sign next to window 0:bash, letting us know that that was the window we were in previously. Those names are not very descriptive. I'm going to change to the LCL directory with cd LCL, and now I want to rename this window to LCL. I'll do that by typing the tmux prefix of Control B, and then I'm going to press the comma. And now in the status bar, we see rename window bash. I'm going to hit the backspace to take out the bash and type in uppercase LCL and pressing enter. And now we see the window we are in is called LCL. And we know it's the window we are in because it has the asterisk right next to the LCL. I'm pressing Control B C again to create another window. Notice our new window in the green status bar shows as 2:bash, with the asterisk showing us we are now in that window. I'm going to start top by typing top. And notice our window name in the status line now shows as top. I'm going to press Q to quit out of top. And our window name is renamed back to bash. I'm going to type vim test.txt and press enter to edit a new file called test.txt in Vim. And our window name is now updated to Vim. The window auto rename works in this window because we have not updated the window name. We're still using the default window name. The window auto rename will not work when we are in the LCL window because we already gave that window a name. But it will work in Windows 0 because we have not renamed that window yet. So now we have 3 different windows open: 0bash, 1LCL, and 2vim. I'm in the 2vim window now. To go to the next window, which would be the 0bash window, I can type the tmux prefix of Control B and then N to go to the next window. And we're now in the 0bash window. I'll press the Control B N again to go to the next window. We're now in the 1LCL window, and I can press Control B P to go to the previous window. So we can move from window to window with the tmux prefix and then the lowercase n for the next window or lowercase p for the previous window. I can also go directly to a specific window by pressing the tmux prefix and then the window number I want to go to. I'll press Control B2 to take me to window 2, the Vim window.
or Control B1 to take me to the LCL window. So there's a second way to get around the open windows in this session. When I press Control BW, we see all of the open tmux windows. Not just the open tmux windows of this tmux session, but all of the tmux session windows for all of the tmux sessions we have open right now. I'm going to arrow down to number 4, the top tmux session we have open. Below that, we have one arrow showing that we have one window open in that session. If we press Enter on either 4 or 5, it will take us to the only window open in that session. So pressing Enter on either one of these will do the same thing. I'm going to press Enter, and now I'm in the tmux session top, and we see that in the lower left corner. I'm going to press Control BW again to bring back all of the window sessions. I'm going to arrow up to the top and highlight the 0 split windows, and we see a preview of all 3 windows at the bottom of the screen. The LCL window is showing in red because that was the last active window. If I press Enter here, I will be taken into the LCL window. Pressing the arrow down shows me a preview of the split windows 0 bash window. Pressing the arrow down takes me down to the LCL window, and we can see an asterisk next to LCL showing us that that is the current active window. So I'll press Enter here and go back to the LCL window in the split windows tmux session. I'm going to add another window with Control BC, and let's rename this window with Control B, comma. We'll make this name Split Panes. And now I want to split this window into 2 panes. To do that, I will type the tmux prefix of Control B and then the double quote. And my window is split horizontally. We are in the lower pane. To get to the upper pane, I will type the prefix of Control B and then arrow up. And to get back down to the lower pane, Control B, arrow down. To exit out of a split pane and end that session, I can type exit. Let's bring that split pane back again with Control B, double quote. I can also exit out of this pane with Control B, lowercase x. When I use the Control B, lowercase x to exit out, I'll get a confirmation asking me if I really want to close this pane. I do, so I will press the Y to confirm, and my split pane is gone. I can also split the window vertically by pressing Control B, %. I'll do that again, Control B, %, and then one more time, Control B, %. Now I have 4 vertical split panes in this window, but they're not split evenly. I want to make these splits even. To do that, I'll press the tmux prefix of Control B, and then I'm going to hold down Alt and press the number 1. And our panes are all split evenly. Each pane has a number just like our windows. We just cannot see the pane numbers at this time. To see the pane numbers, I'm going to press the prefix Control B and then Q to query those pane numbers. We have to look really quick because those numbers only show for a second or two. But we see that 0 is on the far left, and then 1 and 2, and then 3 is on the right. I want to put a number in each pane to show which pane is which. So I'm going to put a 3 in this pane, and then I'm going to press the prefix of Control B, arrow right to go to the pane on the far left, where I will put in a 0, then Control B, arrow right to take me to pane 1, and then Control B, arrow right will take me into pane number 2. And I'm going to press the Control B, Q again to see if our numbers match up, and they do. And notice the pane that we are in is in a different color. When I press that tmux prefix Q, if I press one of those numbers while those numbers are showing, I can jump right to that pane. Let's try it with Control B, Q1. And now I'm in pane number 1. Those numbers disappear really quick, To make things easier, I want to increase the time those numbers show on the screen. I can do this with a tmux command. So I'm going to bring up my tmux command line with Control B colon, and I'm going to type in the command set-g, and the G is for global, display panes time 4000, which will be 4 seconds. 4 seconds should be plenty of time for me to press the pane number and switch to that pane. I'm in pane 1. I'm going to press Control B Q2, and now I'm in pane 2. And notice once I press that pane number, tmux stops displaying those numbers, so it doesn't have to wait the whole 4 seconds every time. I want to go down to pane number 0, so I'll press the Control B Q0 to get me down to pane 0. And from here, I want to rotate all the panes. To do that, I will press Control B, Control O for rotate. Now notice I'm still in the pane on the far left, but that pane is now pane number 1, and pane 0 has moved where pane 3 was. Pressing Control B, Control lowercase o again, rotates everything again, and I'm still in the pane on the far left, but now I'm in pane number 2. Our pane positions have changed, but notice now when I press Control B Q, the pane numbers are still 0 on the far left, and then 1, 2, 3 going from left to right. So tmux doesn't give the pane a number, it's the position of that pane that gets the number. I'm going to press Control B, Control lowercase o again, and one more time, Control B, Control lowercase o, to set things back to where we started. Now I want to move this pane 1 pane to the right. So I'm going to press Control B, right or closing curly brace. And now my pane 0 is between panes 1 and 2. Pressing Control B, right or closing curly brace again, moves pane 0 between panes 2 and 3. I'm still in pane 0, so to move that back to the left, I'm going to press Control B, left or opening curly brace, and then Control B, left or opening curly brace again, and I'm back where I started. I'm going to move over into pane 1 with Control B, arrow right. And in this window, I want to increase the size of this pane by 1 unit. I can do that by pressing Control B, Control arrow right. And let's do it again, Control B, Control arrow right. And then to make the pane smaller, it will be Control B, Control arrow left, Control B, Control arrow left. So that moves it 1 unit at a time. To make a window larger or smaller by more than 1 unit at a time, I'm going to type a tmux command. So Control B colon to bring up the tmux command line, and then I'm going to type resize pane. And then we need to tell it which way we want to resize. I want to resize to the dash uppercase R for the right to increase this window size. And let's put in the number 7. Pressing enter, it increases our window by 7 units. And then to make this window smaller, I'm going to press the Control B colon to bring up the tmux command line. And I'm pressing the arrow up to bring up the last command. And instead of R, we want to make this one L. So we'll resize the pane to the left 7. And pressing enter, we see that it's resized back 7. Now we cannot test the U and the D for up and down while our screen is split this way. So I'm going to press Control B and then the space bar. And we see our layout changes to show the panes horizontally. Pressing Control B spacebar a second time makes the far left window 0 large, and the other 3 windows are small, showing at the bottom of the screen. Pressing Control B spacebar a third time makes the 0 window large and the other 3 windows small, showing on the right of the screen. And then pressing Control B spacebar a fourth time makes all the windows the same. Now we can also zoom into the window we are in with Control B Z for zoom. And now we're in a single pane. And notice at the bottom on the split panes, we've got an uppercase Z next to the asterisk, showing that we are zoomed in to one of the panes. Pressing Ctrl-B-Z again zooms us back out to view all of the panes once again and removes the Z from the status line. In the next video, we will continue looking at tmux for the Linux command line. When I'm in a terminal and I type ls-lh, sometimes, like right now, the text is more than one screen. And to see something at the top of the text, I'll use my mouse wheel and scroll up. I'm going to start a tmux session by typing tmux. And again, typing ls-lh. We have more than one screen of text. When I use my scroll wheel, it does not scroll up as we expect. That's because the mouse is not enabled for default for tmux. We can enable the mouse in tmux by typing a tmux command. To bring up the tmux command line, I'll put in the tmux prefix of Control-B and then a colon. And now I'm going to type in the tmux command set-G, and the G is for global, mouse on. If you're using a version of tmux less than 2.1, instead of mouse on, you would type in mode-mouse on. But since I'm using a version higher than 2.1, I'm just going to use the set-G mouse on. Pressing enter, and then trying my mouse wheel, I can now scroll up with my mouse wheel just like I did before I started tmux. I mentioned the version of tmux. To see what version of tmux you're using, you can type in tmux space dash uppercase V. And we can see I'm using tmux version 3.0a. So now we have our mouse enabled and we can scroll up and down just like we did before starting tmux. The problem with enabling the mouse this way is when I exit out of tmux and go back into tmux, my scroll wheel does not work anymore. That's because tmux was reset to the default settings. If you have another tmux session open right now, your scroll wheel will still work because you did not exit out of tmux. You just exited out of one tmux session. I only have this one tmux session open right now, so when I exited out of tmux. I want to enable the mouse every time I enter a tmux session. And to do that, we will want to update the tmux configuration file. I'm going to open up a new terminal tab and type pwd to show that I am in my home directory, and that's where we want to put this new tmux configuration file. I'm going to open the new configuration file with vim.tmux.conf. This is a new file, so it's empty. I'm going to paste in that same code that we typed into the tmux command line, as well as a comment before that command to remind us of what that line of code is for. I'm going to save this configuration file and going back over to the other terminal tab. When I try my scroll wheel, it doesn't work. I need to exit out of tmux and then go back in so tmux can reset back to the defaults and then apply the settings in the tmux configuration file. Now when I use my scroll wheel, it works as expected. We're going to make a lot of changes to the .tmux.conf file, and I don't want to have to exit out of tmux and go back in every time I make an update to our tmux configuration file. So I'm going back over to our other terminal tab, and I'm going to paste in some text. And this text is going to bind the lowercase r key, meaning when I press Ctrl-B-R, it will source the .tmux.conf file and then display the message .tmux.conf reloaded. I'm going to save this and go over to the tmux terminal tab. Again, we're going to have to exit out of the tmux session and go back in. so tmux can read the updated configuration file. Now I'm going to try it out by pressing the tmux prefix of Control B and then a lowercase r. And in the status bar, for just a moment, we see the message that we added in the configuration file .tmux.conf reloaded. Now to make sure this worked, let's go back over to our other tab. And I'm going to paste in some more text. This line will move the status line to the top of the screen with set option -G, and the G is for global, status position top. I'm also going to add in the text to change the color of the status line to be blue with white text. And here we're setting the option -G status style, BG for background, to blue, and FG for foreground to white. I'm saving the file and going over to the tmux terminal tab. When I press Control B lowercase r, we see the reloaded message at the top of the screen now, and then the status bar is now at the top of the screen, and it is now blue with white text. So the reload worked just as we wanted it to. Let's go back to the tmux configuration file, and I'm going to comment out these lines, write the file, go back over to the tmux terminal tab, and when I press the Control B R, notice it did not reset the status bar back to the defaults. Loading the tmux configuration file just reads and loads in the new configuration. We did not make any new changes to the status bar line. We just commented out the move to the top screen and the change the color. So in order to change these back to the defaults, we'll need to exit out of tmux and then go back in. And now we see the status bar is back at the bottom of the screen with the default green with black text. And it did this when we entered the tmux session. It set the defaults and then applied the changes in the .tmux.conf file. I'm going to press Control B, Control D to disconnect from this tmux session and clear the screen. Typing tmux-ls shows us only the one session that we have open. And through the magic of video editing, I've created the split windows tmux session that we left off in the last video. tmux-ls will show us now we have two sessions going, and one of them is called split windows. I'm going to reattach to the split windows tmux session with tmux attach -t split. And now we're back to where we left off at the end of the last video. We are in a tmux session called split windows, and down in the lower left corner, we only see the first 10 characters, split wind. To fix that, I'm going over to the other terminal tab, and I'm going to paste in some more code. This code will increase the status bar status left length to be 30 characters. I'm going to write this out and go over to the tmux terminal tab and press the Control B R to reload the configuration file. And now we see the entire length of the split windows session name. Another feature of tmux is that you can share a tmux session, meaning more than one person can be in the same tmux session. To show what I mean, I'm going to move this over a little bit and open another terminal. Typing tmux-ls will show us all the tmux sessions we have open. And I'm going to reattach to the split windows session in this terminal. And I'm also in it in the other terminal that we have over here on our right. I'm going over to the 0 pane in the upper left, and I'm going to type ls. When I go over to the other terminal, we see that the command was executed in both terminals. Now this is pretty good, but I'm still logged in as the Michael user. We can also log in as a different user. I'm going down to the log out screen, and I'm going to switch user. So I'm going to stay logged in here as Michael. So my tmux sessions are going to keep running. Now, instead of logging in as Michael, I'm going to go up. One is Mary. She is a privileged user, so we don't want to log in as her because we know that she can log in as Michael. But going up to Lisa, Lisa is a standard user, so let's log in as Lisa. So Lisa is logged in to the same computer as Michael. Let's open up a terminal. So from Lisa, we need to switch over to the Michael user. So I'll type SU Michael. And it's asking me for a password. This needs to be Michael's password, not Lisa's password. Now I'm logged in as Michael. And we can list out the tmux sessions with tmux ls. And now I'm going to connect to the split windows from the Lisa user. tmux attach-t split. And we see the ls command that we just submitted when we are logged in as the Michael user. So we can share a tmux session from anywhere in the world as long as we are logged into the same server as the same user. Only one person can type at a time, but we can view the same thing on multiple tmux sessions at the same time. This is a good breaking point, so we'll pick it up from here in the next video and complete our look at tmux for the Linux command line. In the last video, we left off logged in as Lisa. I've logged off of Lisa and logged back in as the Michael user, and I've detached from both tmux sessions. But I still have them running, and we can see that when I type tmux ls. I'm going to reattach to the split windows tmux session with tmux attach-t split. And I'm going to switch to the LCL window with Control-B 0. In the last video, we made a change to the tmux.conf file to show the entire session name split windows in the lower left corner. But the lower left corner does not have to be the session name. The session name is just the default. Let's go back over to our tmux.conf file, and I'm going to change the left status to be the output of a Linux command. The Linux command is going to be echo, and it's going to echo out the text status left. I'm going to save this and go back over to our tmux window, and pressing Control-B-R, we now see the lower left corner of our status bar says status-left. I'm going back over to the tmux.conf file, and I'm going to paste in some more text, and this text will show the output of the Linux command who am I. I'll save this, and I'll swap over to the tmux tab, pressing Control-B-R, and now we see Michael, the output of the who am I command, in the status left. Going back to the tmux.conf file, we see that we overwrote the status left output with the who am I output. Let's add some color to this status left. To do that, I'm going to paste in some more text. And we start off with the set option -G. G is for global. Then status left. We've seen that already. Then in the double quotes, we have hashtag symbol, left square bracket, then BG for background color. We're setting that to blue. Then we've got our closing square bracket. Then we've got a hashtag symbol, open square bracket, FG for foreground color, which will be our text. And we're setting that equal to white. And then we've got a closing square bracket. Then we have another hashtag symbol, and then our Linux command in parentheses. The things to note here are the formatting changes go in square brackets, and the Linux commands go in parentheses. And a hashtag symbol is needed before either one of these. I will save this and go back over to the tmux session and reload that tmux.conf file with Control-B-R. And we see our output of the who am I command is now in white text with a blue background. Let's change this back to session name. And I'm going to paste in some text for that as well.
We'll give it a blank line. And we see here, after we change the foreground color to white, we have the word session with a colon and a space following it. That will show as text. I'm not using the Linux echo command here. We don't need that to add text inside these quotes. I was just using the echo command earlier to show the output of a Linux command in the status line. And then we have a hashtag symbol and the tmux variable. And because this is a tmux variable, we will need to change the parentheses that we used for the Linux command to be curly braces for the tmux variable. And where did I get that session name variable, and what other variables are available? For that, I used the tmux man page, and I went down to the format section, scrolling down a little bit. And then we see the variable name, alias, if there is one, and what it will show. Going down to session name, we see it has the alias of a hashtag symbol and an uppercase S, and then the description, name of session. Because this has an alias of a hashtag symbol uppercase S, I can use that in place of the variable name. Back in our tmux configuration file, I will paste in the line here to print out the session name using the alias of hashtag symbol uppercase S, which will be the equivalent of the hashtag symbol session name inside the curly braces. These both work the same. Saving this and going back to the tmux session, I'm going to reload the tmux comp file. And now we see session colon and then the session name in white text with a blue background in the left side of the status bar. Going back to the tmux comp file, I'm going to paste in some text here. So what I've pasted in is the same line as the 2 lines above, only I've split it up into 4 lines. The first line, set option -G, will replace what was in the status left with the BG equals blue. Then the next 3 lines have status GA, which will append onto the status left with what is in the double quotes. And then I'm using the hashtag curly braces session name instead of the hashtag uppercase S to show that they both work the same way. I will save this and switch over to the other tab, pressing Control BR, reloads the tmux comp file, but doesn't change anything at all. So the changes I made were just for readability. Now I want to change the write status to show the time in my time zone. To do that, I'm going to paste in the text. And this is slightly different because I'm using double quotes for my time zone. So I'm using single quotes as my outside quotes. And then I'm using black text with a yellow background to make that stand out a little bit. I will save this, switch tabs, and reload the page. We see the time in the lower right corner with the yellow background and black text. The problem is the seconds are only updating every 15 seconds. To make it update every second, I need to paste in some more text. This line will update the tmux status interval every 1 second. Saving this, going to the other tab, and refreshing the configuration file. Shows the time updating every second. Going back to the man page formats, they show us an example of a conditional, which is also known as an if statement. In their example, they're using the pane in mode. I've created an example here for us, and I'm going to paste in the code. In this example, we will check to see if we are in the left pane. If we are in the left pane, we will see the message, "You are in the left pane," in the same color as the time. If we are not in the left pane, the color will be reversed, showing yellow text on a black background, and will show the message, "You are not in the left pane." I will save this and go to the tmux window, reloading the configuration file. and we are in the left pane because there is only one pane at this time. Let's add another pane with Control B, %, and our message has changed color and tells us we are no longer in the left pane. Pressing Control B, arrow left, puts us back into the left pane, and Control B, arrow right, shows us we are no longer in the left pane. I'm going to exit out of this pane, and once again, we're in the left pane. I'm going to delete the last two lines that we added and then paste in some text, which adds that line back but comments it out. And I've added in another line here that will do another if statement, and my message will change if there's more than one pane open by using the tmux window panes variable. I'm checking that to see if the value of the window panes is greater than the number 1. If it is, we show the message more than one pane is open. Otherwise, we'll show the message only one pane open. So this if statement works the same as the other one, but there's just a little more to it. Let's save this, go back to our tmux session, and refresh the tmux comp file. We see that there is only one pane open. Let's open another pane with Control B %, and we see that our message changes to more than one pane open. I'll exit out, and we're back to having only one pane open. We also have the middle section here, and right now it is justified left. I'm going to center that section by pasting in some code to justify center. And notice that center is not using the US American spelling of center. It's got the RE switched around. Saving that and switching back, refreshing the tmux comp file, and we have now centered that middle section. Now this middle section is meant to show the window information. For example, we see we are in the LCL window because it has the asterisk next to it. And the previous window we were in is the split panes window because it has the dash next to it. But we do not have to show window information there. Switching tabs, I'm going to paste in some text. This will update the window status format to be the output of the whoami command. Saving this and switching tabs, refreshing. And now we see the output of the whoami command 2 times, one for each open window that is not the current window. Going back to the tmux comp file and pasting in some text. And this will update the current window status to be the output of the echo command, which will show current-format. Let's write this out. Swap back over to our tmux session and refresh the page with Control BR. And now we see current format Michael, which isn't very helpful. Pasting in more text. This will change the settings of the current window to be bold with white text, and it will also show the window index, window name, and the window flags. That is the asterisk or the dash showing whether we are in the current window or the previous window. And then for the other open windows, we'll have them underscored in white, and then we'll also have the window index, window name, and then the window flags. Let's save this. And swapping back to the tmux session, I'm going to refresh with Control BR. And there we see the current window is bold and the others are underscored. One last thing I want to mention is that I've been using Control BR as the prefix. We can change that prefix. Going back to the tmux comp file, we can probably get away with just pasting in the line, set option -G prefix, uppercase C-A. C means hold down Control A. So we're basically changing our prefix to be the same as the screen prefix, Control A instead of Control B. But a little better way to do this would be to unbind the current prefix with unbind key uppercase C for Control-B. Then we set the tmux prefix to be Control A, and then we also bind the Control A prefix. I'm going to save this and swap over to the tmux screen. Now, the first time I do this, I'll need to use Control B and then R to reload the tmux comp file. But now if I do Control B R, it prints out the R. But if I use Control A R, it reloads a screen. So now I would need to use Control A %, to split the screen. In the next tutorial, we will continue looking at the Linux command line. Originally, I had no intentions of creating this video, but there were some comments for video 69, tmux.conf part 1, by Google and rs_, that led me to create this video. In video 69, tmux.conf part 1, I ended the video showing how two people from two different locations can log in and share a tmux session. Google points out that the two people are not sharing a tmux session because they're both logged in as the same user. rs_ commented that it is possible to have two different users share that same tmux session if they both share the same tmux socket. So in this video, we're going to look at how that works. Currently, I'm logged in as the Michael user, and I'm going to start a tmux session. rs_ tells us in the comments that if we want to share a tmux session, we should open it in a socket in a location both users have access to, like the /temp directory. So as rs_ suggests, I will type tmux-s/tmp/my-socket. rs_ tells us we must make sure both users have access privileges to this file. So let's check out the file permissions by looking at the my-socket file permissions in the /tmp directory with ls-lh/tmp/my-socket. We see that the user and the group both have read, write, and execute privileges, but the user and the group are both Michael. We want to share this socket with Lisa, so we will give the Lisa group privileges with sudo chown michael.lisa/tmp/my-socket. If you have multiple people you want to share this file with, you may want to revisit videos 23 and 24 about group permissions. Let's make sure those file permissions look good by listing them out again with ls-lh/tmp/my-socket. And here we see Michael, the owner, has read, write, and execute privileges, and Lisa, who is part of the Lisa group, will also have read, write, and execute privileges. So we're good there. One other thing I want to note here is, looking in the lower left corner, we see we are in session 0. Now I'm going to log out as the Michael user and log in as Lisa by going down and logging out and switching user. I'm going to start a standard tmux session as Lisa just to see how that looks. And we see the green status bar at the bottom of the screen showing Lisa does not have any customizations, just the standard tmux look and feel. I'll detach from that with Control B D. And now I want to attach to the shared tmux session with Michael. So I will do that with tmux-s/tmp/my-socket. And we're now in the shared my-socket tmux session. We can tell that by the customized status bar. That is the Michael status bar. This shows that we're in the home directory of Lisa. The Michael user was looking at the file permissions for the /tmp/my-socket file. Looking in the lower left corner, we see Lisa is in session 1. Michael was in session 0. To switch the tmux session, I'm going to hold down Control and press A, and then the S key. I changed my prefix to be Control A instead of Control B in the last video. Now I'm going to use my arrow up key to take me up to session 0 and press enter. And now we see what the Michael user was looking at. I'm going to split this window with Control A %, and then split this one more time with Control A double quote. And now I'm going to switch back to the Michael user with log out, switch user. Logged back in as Michael, we see the changes we just made as the Lisa user are now on the Michael user screen. So we are able to share a TMUX session between two different users if we use the same socket. Thank you, Google, for your comment, and thank you, RS_, for your explanation of how to share a TMUX socket. I learned something new, and I'm happy I'm able to share it with all of you. In the next video, we'll continue looking at the Linux command line. In this video, we're going to take a look at Bash environment variables, aliases, and functions. Environment variables can be used to pass information about the current operating system to programs and scripts. We can see all the environment variables currently set by typing env. This list is over a page, but here we see user equals Michael. I'm going to type env again, but this time I will pipe it into less. Here we see the shell is set to bin bash. pwd, print working directory, is set to home Michael, and the log name is set to Michael. I'm going to press Q to quit out of less and clear the screen. As I mentioned earlier, environment variables are a way to pass information to programs and scripts. To get the value of an environment variable in a script, we will use the $sign. This will tell Linux what we are expecting after that $sign is an environment variable. For example, to echo out the value of environment variable pwd, I will type echo, then a space, then a $sign, followed by the environment variable pwd. So the $sign is not part of the environment variable, but it tells Linux what follows this $sign is going to be an environment variable. We can create our own environment variables. I'll make one here with tfcg equals the frugal computer guy. Note, environment variables should be all uppercase. They don't have to be, but it's a Linux standard to make environment variables all uppercase. And we should try to use Linux standards whenever possible. Pressing enter will create my environment variable. And we can see the new environment variable by echoing out the value with echo $tfcg. Or maybe we want to change our environment variable. I'll change that by just reassigning it. tfcg equals https:// the frugal computer guy.com. And pressing enter will update the tfcg environment variable with the new value. And we can now see that with echo $tfcg. This new environment variable that I just created is only going to be available while this terminal is open. Once I close the terminal, my new tfcg variable will be gone. We'll look at a better way of creating environment variables in the next video. Let's move on to alias. An alias is just a shortcut of a command, sometimes with different command options. I'm going to touch a file called deleteme.txt. And I can delete this file with the rm command, rm deleteme.txt, and the file is gone, which is what we wanted. But I want a warning before I delete a file. So I'm going to press the arrow up again to touch that deleteme.txt file. And I'm going to type rm-i deleteme.txt. Now when I press enter, I get a warning asking me, do I really want to remove this file? I'll press N for no, because I don't really want to remove it at this time. I want to get that warning message every time I type RM to remove a file. To make that happen, I'm going to create an alias. To create this alias, I will start off by typing alias, then a space, and what I want this alias name to be, which is RM. Then we have an equal sign, and then in quotes, I will add the command I want to execute when I type my alias, which will be RM-I. So now, every time I type RM, Linux will send the command rm-i. And I'll try it out with rm deleteme.txt. And it's asking me, do you really want to remove this file? This time I'll press Y for yes. I'm going to clear the screen, and I'm going to type alias all by itself. This shows us all of the aliases currently set. Linux Mint has set up some aliases for me, and at the top we see an alert. An alert just sends a message to the desktop. I'll show this with sleep1 semicolon alert. So it will wait 1 second, and then it will show us the alert. And there in the upper right corner, we see the sleep1. It shows us that sleep1 command. We can make this alert box look a little more like a warning if I type something like, this is a warning, semicolon, alert. This time when I press enter, we get the red warning symbol up there. And then we also get the bash message, this command not found. So this is not a real bash command. That is why we're getting that warning symbol up there. The sleep1 was an actual Linux command, so we did not see that error warning in the alert box. Looking back at the other aliases created for me by Linux Mint, we have L, LA, LL, and LS to use the color option. And at the bottom, we see the alias RM equals RM-I, the one we just created. Now let's say I have to delete a lot of files, and I don't want to have to press that confirm for every file I delete. I want to remove my alias. We can just overwrite it by creating a new alias and type alias RM equals RM. That would work, but that's not really the cleanest way. So I'm going to clear this out. A better way, in my opinion, to remove this alias is with the unalias command. I will unalias the RM alias by typing unalias RM. And typing alias shows the RM alias has now been removed. An alias does not have to be an existing command. It can be anything we want it to be. We can put more than one command in an alias. We just need to separate the commands with semicolons. I'm going to create a new alias with alias, and we'll call this one TFCG, lowercase this time, because Linux is case sensitive. We'll make that equal to, and the first thing I want to do is list out the content of the current directory with the ls command. Then I'm going to type CAL to show us a calendar. And then I'm going to echo out the value, and we'll put this in a double quote. The value of environment variable TFCG is $TFCG. We'll have the ending double quote, ending single quote, and pressing enter created our new alias. Let's test it out by typing lowercase TFCG. And here we see it lists out the files and directories in the current directory. Then we see the calendar. And then we see the value of environment variable TFCG is https://thefrugalcomputerguy.com. Like the environment variable we created earlier in this video, this alias will only last until we close our terminal window. We will look at a better way of creating our aliases in the next video. We were able to get a couple of commands in the alias, but if we really want to run multiple commands by typing a keyword, we will want to create a function. Functions are created by typing the word function and then what we want to call this function, or the name we want to give it. I'm going to give it the name myfunc1. And then we need opening and closing parentheses, a space, and an open curly brace. Pressing enter will give us a new line, and this is where we're going to put our commands of our function. The first thing I'm going to do is list out the files in the home directory with ls tilde, and then I'm going to echo out the value in my tfcg environment variable. We'll keep this function simple and only leave it to these two lines. To end our function, I use the closing curly brace, and our function is created. We can run the function by typing myfunc1. And there we see the content of the home directory, and then we see the value of the variable tfcg is and the value. I'm going to clear the screen again, and I'm going to create another function. So let's start off with function, and I'm going to call this one myfunc2. Then I've got my open and closing parentheses and the opening curly brace. And the first thing I wanted to do in this function is call myfunc1. So functions can call other functions. And we can also add input parameters to our function. So what I'll do in this next line is echo out the first parameter you entered was, and then a $1 will print out the first parameter that we add. I'll put an end quote on here, and then I will echo out the second parameter you entered was $2, which will be the second parameter. I'm going to end this function by adding in the closing curly brace, and let's run our new function. I'll type in myfunc2, and then I'm going to add the parameters, hello, and then space, world. Pressing enter, we see it first prints out what is in the myfunc1, and then we see the first parameter we entered was hello. The second parameter we entered was world. Clearing the screen. When we type in one of these custom commands, an easy way to tell if it's a function or an alias is to use the type command. I will type myfunc2. And here we see myfunc2 is a function, and then it shows us what is in that function. Let's try the type command now with tfcg, the lowercase tfcg. Pressing enter, we see that that is alias to ls semicolon cal semicolon and then the echo. We can also use type with Linux commands like wc. Here we see it's going to run wc from the user bin directory. And I'll try it again. Type with cd. And we see that cd is built into the bash shell. The next thing we want to look at is the set command. I'm going to clear the screen and type set. The set command shows us all the environment variables and functions that are set up for this bash session. And we see the myfunc functions here. To see the tfcg environment variable, we need to grep for that. So set grep tfcg. And here we're grabbing the tfcg environment variable, but we also have tfcg and that echo out from our myfunc1. So that's why we're seeing it twice. We can also unset our functions and environment variables. I will unset the myfunc1 function. And now if I try to run it, myfunc1, command not found. And typing set, we see the myfunc2, but we no longer see the myfunc1. I will echo out the $tfcg to show that it's there. Now I will unset tfcg. It's gone. So when I press echo tfcg, it prints out nothing because it's no longer there. In the next video, we're going to continue looking at the Linux command line. There are two main shell environments that you should be aware of: the interactive login shell and the interactive non-login shell.
The first one we're going to look at is the interactive non-login shell. And to open an interactive non-login shell, I'm going to click to open the Linux Mate terminal that we've been using throughout this tutorial series. This is a non-login shell because Linux already knows who we are from when we logged into the Linux desktop. When I type, "Who am I?" Linux knows that I'm already logged in as Michael, so it doesn't need to log me in now. An interactive login shell, on the other hand, is a shell that requires us to type in our username and password before we can start typing commands. So we need to log in to the shell before we can start using it. One example of an interactive login shell is when we have a keyboard and a screen connected to a server with no desktop. When that computer powers up that server with no desktop, it shows a screen that looks like this. Then I type in my username and press enter, and the shell will prompt me for a password. Once I type in that password, we're logged in to the interactive login shell. We can also see an interactive login shell by SSHing into a server. I'm going to open a new tab, and I'm going to type SSH Michael at 127.0.0.1 to SSH into this computer. And to make this work, I did have to install OpenSSH on this computer. The IP 127.0.0.1 is this computer. So I'm SSHing into this computer that I'm already logged into as Michael. When I press enter, Linux asks me for my password. I'll type that in, and it logs us in. And once we're logged in, it looks just like the Linux non-login shell. We have the same prompt, and it looks the same. So how do I tell if I'm in an interactive login shell or an interactive non-login shell? One way to tell which type of shell you're logged into is by echoing out the number 0 environment variable. We learned about environment variables in the last video. To echo out the number 0 environment variable, we would type echo $0. And here we see -bash. So when we see -bash, we are in the interactive login shell. Going to the other tab and typing echo $0, we see bash without that dash. When we don't see the dash, we are in an interactive non-login shell. So why do we care if we're in an interactive login shell or an interactive non-login shell if the terminals look and act the same? And often they will be the same, but sometimes there will be a difference. When we log into an interactive login shell, it's going to start running the file /etc/profile. I'm going to less into that etc profile with less etc profile. Note the top line. It's telling us this is run when we are using the Bourne shell, which is that bash shell that we've been using throughout this series. If you're using something like the Z shell or something other than the Bourne shell, this will probably not apply to you. This first block of code is looking at the PS1 environment variable. This is for the command prompt. We're going to talk about customizing the command prompt in an upcoming video. The other thing that this file is doing is to source every file in the etc profile.d directory. And then after that, it's going to source the .profile file from our home directory. I'm going to less into the .profile file. If we were using more of a Red Hat distribution, we might see this profile called .bash_profile. But for me, it is called .profile. Now notice the first two lines of this file say this file is executed for login shells, and that this file will not be read if there is a .bash_profile or .bash_login file found in this directory. This file is doing three things. The first one is It is checking for a home.bashrc file. If there is one, that file will be sourced. We will talk about sourcing the .bashrc file in the next video. The second thing it's doing is it's checking for a home/bin directory. If there is one, it will append that directory to our path. We'll talk about the path in the next video as well. And then the third thing it's doing is it's checking for a home/.local/bin file. If there is one, that will be appended to the path as well. I'm going to quit out of the less, but I'm going to edit this file. And at the top of this, I'm going to add the line echo, and then it's going to print out the message home/.profile is sourced. So when this file is sourced, that line will show on our screen. I'm going to save this. And going over to the non-login shell tab, when an interactive non-login shell is started, it only reads one file, the .bashrc file. And the RC stands for resource. So we're loading the bash resource file when we open an interactive non-login shell. Let's look at the bashrc file with less.bashrc. And you may or may not have a .bashrc file. The Linux Mint team did create one for us here and put in some default information. We'll notice here at the very top, the first line shows that this is for non-login shells. So the point here is that non-login shells source the .bashrc file only, and then the login shells source the .profile file only. Now on this computer, the .profile file does source the .bashrc file, but on other Linux, Unix distributions, that may not be the case. They may only source the .profile file. So we need to keep that in mind. I'm going to quit out of this less, and I'm going to edit this file, vim.bashrc. I'm going down to the bottom of this file, where I'm going to paste in some code here, which is the custom environment variables, aliases, and functions that we created in the last video. And notice here I added a line, welcome to the bash shell, that will echo out every time this file is sourced. Often people like to have a custom message they see every time they log into a bash shell. Some people have elaborate ASCII text pictures, and then some people add the date. If you want to add a date, we talked about dates and date formatting in video 30. Another thing to notice here is I added export before my environment variable. Let's go over to the other tab and look at why I would want to do that. I'm going to type envar1 equals lowercase envar1. And then I'm going to create another environment variable, and I'm going to export this one. Export envar2 equals lowercase envar2. Now, when I view these with echo $envar1, we see the value, and echo $envar2, that value is also available. But if I open a new bash subshell by typing bash, and it looks like I did not save my file here yet. Let's save this. Right quit. Going back over, I want to exit out of that subshell. And let's try going back in bash. Now we see the welcome to the bash shell. So we are sourcing our bashrc file. But we're actually looking at the envar1 and 2 right now because we created them. And now I'm going to echo $envar1, and that is not available. But if I echo $envar2, that is available. So using that export allows those environment variables to be passed on to a bash subshell. Now we have that in our bashrc file, which is not really needed because that was sourced, as we see there with the welcome message. But if we're putting environment variables into the .profile file, that is when we're really going to want to use that export so that those environment variables get carried into the subshells. I'm going to exit out of our subshell, and then I'm going to exit out of our SSH that we logged into and clear the screen. I want to SSH back in again. And here we see it sources the home michael.profile as well as sources our bash shell. And if I open a non-login shell, we only see the welcome to the bash shell. So now we know the difference between an interactive login shell and an interactive non-login shell. In the next video, we will continue looking at the Linux command line. In the last video, we updated our bashrc file, and we said that RC stands for resources. So we updated our bash resource file. I'm going to vim into the .bashrc file now, and where we added our aliases, we missed the alias we created to prompt us for a confirmation before deleting a file. I will add that now. Alias rm equals, quote, rm-i, end quote. And I will save this file, wq for write quit. To try this out, I will create a file to delete with touch deleteme.txt. And now I'll type rm deleteme.txt. And it deleted the file without prompting me for a confirmation. I'll add that back by arrowing up twice and pressing enter. We added the alias to our bashrc file, but it didn't work. That's because bash didn't know we made any changes to the bashrc file. The problem here is just like the problem we had with the tmux configuration file a few videos back. Every time we made a change to that tmux config file, we had to reload the tmux config file. We have the same situation here. For bash to know we changed our bashrc file, we need to either close and reopen our terminal, or we need to source our bashrc file. To source our bashrc file, I will type source.bashrc. If I was not in the home directory, I would want to add the ~/ to source the bashrc in the home directory. But since I'm already in the home directory, I just need to type source.bashrc. Pressing enter, and we see the welcome to the bash shell. This is the text that we echo out when we open a new terminal. We see it shows when we source the bashrc file. And when we open a new terminal, the bashrc file is sourced, and that is why we see it when we open a new terminal. And now I'll show the new code we added to our bashrc file is recognized by typing in rm deleteme.txt. And now it prompts me for that confirmation. So that worked. I'm canceling out of that. We also have a shortcut for the source bashrc file, and that is the period by itself. So if I type period or dot space dot bashrc, pressing enter, shows us the welcome to the bash shell. So that also sources our bashrc file. So if you make changes to your bashrc file, most likely you'll want to source that bashrc file with .bashrc or source.bashrc after making those changes. When we type something into the terminal, Linux thinks it's a command. So if I type in some random characters like ADF ADS, when I press enter, we get the message command not found. Linux thinks I wanted to run a command named ADF ADS, which does not exist. That is why we got that message. But where did Linux look for the command? And that is where the path environment variable comes in. Often when people start talking about the path environment variable, they give you the warning that you could really screw things up if you don't do it correctly. Let's echo out the path environment variable with echo $path. And now I'm going to set that path to nothing with path equals empty quotes. Now if I type the ls command, it doesn't work. If I type who am I, that doesn't work. So now we see what people were talking about when they said things could really go wrong if you set up your path incorrectly. I'm going to type pwd, and that command does work. When I type pwd, we see that pwd is a shell built in. That's why pwd and type work. They're both built into the shell, but for commands not built into the shell, we need that path variable. So let's set this path variable back by selecting what we echoed out earlier and setting our path variable equal to this with path equals, double quote, paste, double quote, and enter. Now when I type ls, my command works. And yes, I could have just closed and reopened this terminal to reset the path because my changes are only made in this terminal. So if the path is not set correctly, it could affect a lot of commands. And if you make changes to your path in your bash RC file and you make a mistake, it can be a little tricky to get that fixed depending on what changes were made. So if you are making changes to the path variable, you may want to try those changes in a terminal first that you can close and reopen and reset before adding them to your bash RC file. But I'm getting ahead of myself. We haven't seen how to make changes to our path. Let's look at the path command. I'm going to clear the screen and type echo $path again, showing us what is in the path environment variable. If you're not familiar with the path environment variable, it can look a little confusing, but taking a closer look at this, we see that it is a series of paths separated by colons. The first path is user local bin, and the second one is user local sbin. I'm going to reformat this list of paths and take out the colons so we can see it better. Now we can see the list of paths in order from top to bottom. When we type in a command, bash will first look in the user local bin directory. If the command is not found in user local bin, bash will then look in the user local sbin directory and keep checking each path going down in order until it finds the command. When it gets down to the snap bin, if it's not found in snap bin, then we get the message command not found. In video 44, we created the awk script rectangle.awk, and I have copied that into the directory home/Michael/scripts. And I'll show that now with ls-lh scripts. And here we see the rectangle.awk and a file called cp. When I type rectangle.awk, we get the message rectangle.awk command not found. And that's because rectangle.awk is not found in any of those paths in the path variable. To make this work, I want to add home/Michael/scripts to our path environment variable. To do that, I will type path equals quote $path :home/Michael/scripts. Pressing enter. Now when I type rectangle.awk, bash runs our script and asks me for the height of the rectangle. I'm going to cancel out of that. Inside that scripts directory, we also have a file called cp. I'll cat that out with cat scripts cp. And we see the script will echo out the line, this is run from home Michael scripts cp. When I type cp into the command line, we get the message cp missing file operand, because this is trying to run the copy command and not my version of the cp command. Typing type cp, we see that the command is run from the /bin directory. Looking at our list of files, we see that the /bin file comes before the /home/Michael/scripts directory, which is at the bottom of the list. To run my command, I want to put home Michael scripts at the top of this list. And I will do that by typing path equals, quote, /home/Michael/scripts, $path, end quote. When I echo the path out now, we see that we have home Michael scripts at the beginning as well as at the end of our path. Now, this is really not the cleanest code, but it won't be a problem. There's just a chance that the same directory might be searched 2 times. And this is all in a terminal anyway. So once I close this terminal, the path will go away and opening a new terminal will restore the original path. So now that home Michael scripts is at the top of the path, when I type CP, we now see this is from home Michael scripts CP. So now bash finds my CP script first and will run that instead of the copy command. And the point of all this is that the order of the directories in the path environment variable does matter. In the next tutorial, we will continue looking at the Linux command line. When I hit the up arrow and the down arrow, we see that bash remembers the last commands I typed in, even if the computer has been turned off and back on. So bash must be storing this bash history in a file somewhere, and it is. To see that file, I will type ls-lah pipe grep history. And we see the history file is a hidden file called .bash history. To see what is in that file, I will type cat.bash history. I don't have a lot in my bash history file at the moment because I've recently cleared it out. But looking at the last commands in the .bash history file, we don't see the ls-lah pipe grep history or the cat.bash history commands we just typed. To see those, I will need to type history. Now I see all the commands in the .bash history file and the commands I just typed when I started this terminal session. The reason the .bash history file does not show the commands we just typed is because the terminal session history is held in memory. Then when the terminal session ends, that history is then written to the .bash history file. I can show this by typing cat.bash history. And again, we see that the ls-lah pipe grep history is not in the .bash history file. I'll close this terminal and open a new one and type cat.bash history. And now we see the ls-lah pipe grep history as well as the cat.bash history we typed before closing the terminal. There are times when a command requires a password, or maybe we're typing some commands and we don't want those written to our bash history file for some reason. I will type echo password equals secret password. I don't want this command to be written to my terminal history. One way to do that is to clear out the current terminal history with history-c, and the C is for clear out the history in memory. Now when I type history, it only shows the one command. It does not show us what is in the .bash history file anymore, but catting out the .bash history file shows all the commands are still there. And closing the terminal and opening a new one, and typing cat.bash history shows everything up to and including the history-c command was not saved. But the 2 commands I typed after history-c, the history and the cat.bash history, did get written to the .bash history file. So if we want to wipe out our entire bash history, we would want to first remove the .bash history file with rm.bash history. Then we would also want to remove what is in our current terminal history with history-c. Then close the terminal, open a new one, and typing ls-lah pipe grep history shows our .bash history file is gone. It will be recreated when I exit this terminal and our terminal history is written to the .bash history file, or I can write what is in the current terminal history at the moment to the .bash history file with history-w. Now typing ls-lah grep history shows our .bash history file now exists, and catting out the bash history file shows the two commands, the ls-lah grep history and the history-w command. Commands I type from here forward will again be in memory until I either write them to the .bash history file, clear them out of the memory, or exit out of the terminal, which will write them to the .bash history file. I'm going to pause the recording of this video for a moment to reset the bash history file so we have something to work with. Okay, I'm back, and typing cat.bash history shows I've reset the commands in the .bash history file. And to update this file, I did use the GUI file manager. That's why we don't see any commands in the bash history for this file update. Most of the time when we're looking at the bash history, we are going to want to use the history command and not the .bash history file. Typing history shows a complete history of what is in the .bash history file as well as what is in the current terminal history stored in memory. Looking at this output from the history command, we'll notice a number to the left of the commands. And we will see here that our oldest command is number 1 and our most recent is number 14. Yours may show in the thousands, but the default is usually around 1,000, depending on what version of Linux you are using. So if your last line is 3,000, your bash history may only hold the commands 2,000 through 3,000. We'll talk more about how many lines of history commands are stored in the next video. We can use that number to the left of the command history to rerun a command. For example, that rsync command on line number 9 is really long. I can rerun this command by typing exclamation point or bang and then the number 9. No space between the bang and the 9, so bang 9 will run the command number 9 of the bash history. And notice it shows us the command it's going to run before that command is run. And if we arrow up, it also shows us the entire command, not the bang 9. This is helpful if we want to make a slight change to the command before we run it again. Maybe we want to change our output to DST2. Runs that updated command. If we can't remember what exactly bang 9 does, but we think we're correct and we want to just print out the command without running it, we can type bang 9:p for print. And here we see the command without running it. Maybe that bang 9 was not the exact rsync command I was looking for. I can also grep my history file with history pipe grep rsync. And from here, I see just the rsync commands, and I might want to single out a single command with bang 16:p, so it just prints out the one line. And typing history shows the line before I typed history is the command that I just printed out. And I can run that command now with bang -2, or I could print that out with a :p if I wasn't sure if that's the command I want or not. But this is, so I'll run this with bang -2. And now that -2 will be -3, or it will also be the most recent command, so I can show that command with bang -1:p. And bang -1 is the same as bang bang, the command we've talked about and used many times throughout this tutorial series. Most of the time I use this command is when I need to rerun the same command again, but adding sudo to the command. Like if I type ls root, we get a permissions denied. So I'll type sudo bang bang. Sudo bang bang now shows us what is in the ls root directory. I'll do the same thing, ls/root. It's telling us we need permissions, and typing sudo bang -1 shows us what is in the root directory. I'm going to type history. Now I want to rerun the last time I ran that echo command, meaning I want bash to start at that bottom of the history file and work its way up each line until it finds the last time I ran that echo command. To do this, I'll type bang echo. And if I'm not sure if this is the correct command or not, I can use that :p, and it'll show us echo path, which is in the history line number 12. And now that's going to be added to the bottom of the history file again. So if I type history, and now we see echo is line 27 with echo path as if we had run it, as well as in line number 12. But we can still run the last one, which would now be 27, with bang echo. I'm going to clear the screen and type vim deleteme.txt. I'm going to enter some text. And now I want to cat out the file I just edited. To do that, I will type cat bang $. And what that $sign will do is bring back the argument, in this case the file name, from the previous command. So when I press enter, we see that it did cat out the deleteme.txt file. And now I'll use that $sign to remove the file. So rm bang $. So it will bring in the argument, or the deleteme.txt, from that previous command, that cat command, which brought it in from the command before that, which was the vim deleteme.txt. Pressing enter, I'm being asked to confirm to delete the deleteme.txt file. I will, and it's gone. I'm going to type history again, and looking through this history, we see line number 6 equals https://thefrugalcomputerguy.com. I want to remove that from the history. To remove line 6 from the history, I will type history -d for delete, and then 6, which is the line I want to delete. Now typing history again, and going up to line number 6, we see that the environment variable is gone. What was in line number 7 is now moved up to line number 6, and everything else shifted up one position. This is a good breaking spot, so we're going to end this video here, and in the next video we'll continue looking at the history command for the Linux command line. We are picking up from where we left off in the last video with the history command, and I want to look at the environment variable hist size. To see the value of hist size, I will type echo $hist size. And we see the hist size is set to 1000 on my machine. Your machine may show something different. In the last video, we talked about the history of the current terminal session being held in memory. The hist size environment variable is the number of lines the current terminal history can hold in memory. I'm going to type in a few more commands: ls-lah, cal, cat, grocerylist.txt, cd, lcl, and cd. Now we have some commands in the terminal history that haven't yet been written to our .bash history file. Typing history shows us everything below the hist size command were typed in this terminal session. I'm going to type hist size equals 5 to change the current terminal history to 5, and then type history. Now we only see the 5 most recent commands of the current terminal history. This shows hist size is the number of lines held in memory for the current terminal session. The next thing I want to look at is the environment variable hist file size, and I'll show that with echo $ hist file size. And for me, we see that value is 2000. This is the maximum number of lines the .bash history file can hold. It will keep the most recent 2000 commands and roll off the oldest commands. I'm going to cat out the .bash history file, and we see it has more than one page of commands. I'm going to type hist file size equals 7, and now catting out the bash history, we only see the 7 most recent commands in the bash history file. Now I'm going to edit my .bashrc file and set these values to something a little more reasonable than 5 and 7. vim.bashrc, because I'm in the home directory, I do not need the ~. I'm going to insert mode, and I'm going to paste in some text here. The first couple of lines are just some comments letting us know that below these lines are going to be settings for the bash history file. Then I'm setting the hist size to the value of 10,000 and the hist file size to 1 million. Those numbers should be big enough to keep my entire history, and I've got a large enough disk drive that space should not be a problem. If at some point I do see the bash history file is taking up too much disk space, I can change those settings at that time. I'm going to paste in some more code here for the hist control, and I'm setting the hist control to ignore both. The other 2 options are ignore dupes and ignore space. Ignore dupes will ignore commands typed in repeatedly. Like if I type in the ls command 2 or more times in a row, it will only save it to the bash history file once. If I type in ls and then another command and then ls again, it will show twice. The same command will have to be typed in 2 or more times in a row for that command to be ignored. The ignore space will ignore the command if I start that command with a space. That's there in case I need to type in a password or the like, and I don't want to have to take that extra step of deleting it out of the bash history file. If I just start the command with a space, that command will be ignored and not added to the bash history. And now I'm going to add hist ignore. And this one is pretty easy to understand. It will ignore all the commands I listed in the double quotes, separated by colons. For example, it will ignore the exit command pwd ls or ls-lah. And you'll notice that I do have ls and ls-lah listed separately. You will need to list them separately, otherwise it will only ignore the ls commands. It will not ignore ls-lah. So that's why it's listed in there that way. Other than that, it's pretty straightforward. It will ignore the commands listed in the quotes separated by colons. The last thing I want to add into my .bashrc file is a way for me to add the time and date to my history, meaning I want to know the date and time when I typed each command. To do that, I will paste in the line hist time format. This will show us the date and time I typed the command, and we can decode that formatting I used by checking the man page. Let's open up another terminal, and I'll shrink this down a little, and I'll type man date. Going down a little bit, we see the format controls, and the first one is %B, which will be the abbreviated month. After that, we have the $lowercase d, and $lowercase d is day of the month. Going down to lowercase l is the hour, space padded, same as $I, which we see as the hour. Then we've got the uppercase M for minute, and the lowercase p for AM or PM. I'm quitting out of the man page and closing this window. And let's try out the new format. I'm going to press escape to get out of insert mode, and type WQ for write quit. I will source my bashrc file with .bashrc, and now typing history. And we see since all of the commands were typed in this terminal session, it was able to keep the correct time and date stamps. If you had a lot of history in your bash history file, those would probably be set to the current time and date because bash has no way of accounting for what time and date they were created. In the next tutorial, we will continue looking at the Linux command line. In this video, we're going to change the command prompt. The command prompt format is stored in the environment variable ps1. We can see the value of ps1 with echo $PS1. That looks pretty confusing, but you will understand it all by the end of this video. The first thing I'm going to do is just change the value of PS1 to change my prompt. I will make PS1 equal to, quote, equals, greater than sign, quote. Note there's no space between the PS1 and the equals sign. If there is, when you press enter, you'd get an error. Also notice there's no space after the greater than sign, so the cursor is right up against that greater than sign. I'm going to press the arrow up and add a space after that greater than sign. Now we have a space between the prompt and the next command. So we can make our command prompt say anything we like. I'm going to set mine to be type in your next command. Now that we know how to change the command prompt, to learn more about that default command prompt, I'm going to open up the bash man page with man bash. And I'm going to search for PS1 by typing /PS1 and press enter. This first one is not what I'm looking for, so I'm going to press N to go to the next occurrence of PS1. And pressing N again, and again, and one more time, this is what I'm looking for. I'm just going to scroll down a little bit. This tells us what those backslash characters will show in the command prompt. Looking at our command prompt again, we see a lot of backslash letters. I've highlighted them in red so they stand out. We see the \E, the \H, the \U, the \A, and at the far end, we've got $$. Our man page is showing us that the \A is the ASCII bell character, and the \E is the ASCII escape character 033. Those two have special meaning, and we'll look at them more in just a moment. Right now, I want to focus on the \H, which will show us the host name up to the first dot, the \U, which will show us the username of the current user, and the \W, which will show us the current working directory with the home environment variable abbreviated with a tilde. I need to scroll down a little bit for this last one, and that is the $$, which will switch to the £sign if we're the root user. Otherwise, it will show us a $. I want to set my command prompt to one of these values that is not in the default command prompt. I'm going to choose the @ sign that will show the time in 12-hour format with AM and PM. I'm going to press Q to quit out of the man page, and now type PS1 equals, quote, \@ sign, quote. And now our prompt shows a 12-hour format with AM or PM. I'm going to add a :space at the end. That's okay, but not very helpful. So I'm going to change the prompt again to PS1 equals, quote, and then I'm going to use the characters that we just saw on the man page. I'm going to use the \U for user. And now I'm going to use the @ sign without the backslash, so it will show as an @ sign. \H for the host name. Then I'm going to add a : \W to show us the working directory.
I'm going to add a space and then $$. So that will show as a $sign or a £sign if I switch to the root user. And my end quote. So now we have the username, @hostname, working directory, and the $sign in our command prompt, just like that default prompt. But taking a closer look at our default command prompt, we see that the username and hostname are in there twice. When we were looking at the man pages, we saw that the \E was an ASCII code 33, and that's a special code. When we add the 0 after the ASCII code 33, it means show this in the terminal window title bar, and a / closing bracket that ends the title text. So let's grab this code. I'm going to highlight and copy, and I'm going to add it to my command prompt here. But I'm going to change this title text. Instead of showing the username and hostname that we see up in the title right now, I'm going to change this to say, this is the terminal window. And we'll see that title at the top of this terminal window change as soon as I press enter. And now we see this is the terminal window up in the terminal window title text. So that explains this first section of code. That's setting the terminal window title. This next section of code, we see this Debian_chroot : plus Debian chroot. In short, what this will do is it will display the value of environment variable Debian_chroot in parentheses if Debian_chroot has a value. Let's show this in a new window. I'm going to assign the environment variable Debian_chroot equal to root. And when I press enter, we now see root showing in parentheses to the left of our command prompt. And changing the value of Debian chroot to nothing removes it from the command prompt. So that's all that section's doing. I'm going to close this window. And looking at this last part of the Linux Mint default prompt, we see a lot of 033s. Taking a closer look at this and showing the command prompt right below it, we see that the 01:32M sets the username and hostname to be bold and green. 00M sets the colon to be white. 01:34M sets the working directory to be bold and blue, although it's tough here to tell, but it is bold. And then 0M again sets the $sign to white, as well as the text we type after that. Before we try this out, let's take a look at some of the options we have for the font style. We have 6 different options: 0 normal, 1 bold, 2 dim, 4 underlined, 5 blinking, and 7 reverse. We saw 1 bold, so I'll try the options 7 reverse and then 5 blinking. And then for the colors, I'm showing 8 colors here. If you Google around, you can probably find how to add more colors. I'm just showing the basics here, enough to get you started. And I'm going to try the colors purple, 35, and then red, 31. So I'm going to copy one of these colors and then bring back our cursor by arrowing up. And after we set that terminal message, I'm going to paste in to change the style and the color. Now earlier we said that 033 was the same as lowercase e. So I'm going to change that to a \lowercase e, take off the 33. And I'm going to make the style 7 reverse and then the color 35 purple. And now we'll notice that when I press the arrow up, all the text is purple, not just my cursor. So now what I'm going to do is I'm going to change this text color. I want to make it blink. So I'm going to change that to be a 5 for blinking and change the 35 to be 31, which is red. But before I get to that $sign, I'm going to paste in again the color changing code.
I'm going to take off the style altogether and just make this 00M to change it back to the default white. So there we've got the blinking red text in reverse. It's still reversed because I did not clear that out, but I did clear it with the $sign. So if I press the arrow up again and enter, and that has turned off the reverse. And then to turn off the blinking, I will change that from a 5 to a 0. And now we've got the red text with no blinking. Now to turn on the reverse, we can also just change that from 31 to 41. I'm just adding 10. And the last thing I want to show is the website easyprompt.net. It's an easy way to set your prompt. I'm clicking on username, extra characters, going to @ back to the basic characters, host name. We see a preview of it here, what it will look like. If I want to make it green, I'm going to change the foreground. We see it only changes the host name. It may take a little work to make this the format you really want. So this website isn't perfect, but they do include this status elements, which has error code and get status. That was not covered in this video, but may be of interest to some of you. I didn't think there was a widespread interest, so I didn't cover it. So that's going to wrap it up for this video. In the next video, we will continue looking at the Linux command line. One way to see how much disk space is available on a hard drive or partition is with the df command. df is short for disk file system and will give us a report of the file systems on the computer. Typing df by itself shows 9 lines of output and a header line for this computer. 5 of those lines have a file system of TMPFS. TempFS is short for temporary file system, and these are a combination of RAM and swap disk space that are set up to help Linux run as quick as possible. When we power down the computer, these files will go away, and then in the next system power-up, new TempFS files will be created. We also see a file system type of UDEV. UDEV is for user space devices. It is a Linux subsystem that's running constantly and checking to see if a new device, like a USB drive, is plugged into the computer. We're not interested in either one of those at this time. The line that has mounted on with the /, that's the one that I'm most interested in. That is the Linux root directory on this computer, and the file system is on /dev/SDA1. The /dev is for device, and then we see SDA, which some people will call System Drive A. SD really stands for SCSI device or SATA drive. SCSI is just short for Small Computer System Interface, and SATA is short for Serial Advanced Technology Attachment. These will typically be a spinning hard drive or an SSD drive. Another common file system you might see is /dev/NVMe and then some letters and numbers. That's a hard drive on a card. And that card has a specific slot on the motherboard, so it doesn't use the cables a spinning disk or an SSD use. So it will show up as NVMe and then some numbers and letters following it. Our output shows a system of /dev/SDA2 and /dev/SDB1. The A is given to the first hard drive Linux finds. B is given to the second hard drive Linux finds. /dev/SDA2 is just a second partition on the SDA hard drive. We'll talk more about partitions in future videos. For now, we'll just say that a partition is just a section of the hard drive that Linux treats like a separate hard drive. So that's what the number next to SDA is. The 1 is for partition 1, and the 2 is for partition 2. And your system may even have more than that. Then we also see /dev/SDB1. That's a second hard drive, which in this case is a USB stick. If we plug in another USB stick, it will become /dev/SDC1.
We're not going to focus on the mount points of SDA1 and SDB1 at this time. We're just going to notice that they're both mounted on /media/Michael. And we'll look more into this in future videos. Going back to our /Linux root directory mounted on /dev/SDA1, df shows us how much disk space is available on that partition, as well as how much disk space is used and then how much disk space is still available. These numbers are shown in kilobytes, which makes that hard to read. We do see that we've got 39% of the disk space still available. To make those numbers a little easier to read, we can view those numbers in megabytes by adding the -m option after df. That's better, but still not real helpful. A better way to run this command is with the -h option. This shows us the disk file systems in human readable form. And now it's clear to see that /dev/SDA1 has a partition size of 39 gigabytes. I have used 15 gigabytes, and I have 23 gigabytes still available for use on this partition. You probably noticed that 23 gigabytes available and 15 gigabytes used added together only adds up to 38 gigabytes and not 39. Most likely there's a zombie process running, or maybe some deleted log files that are waiting for the process holding them to release them. This is common and nothing to worry about. When I type df-H, my numbers are larger, as if I just increased my total disk space. The /dev/SDA1 partition just grew from 39 gigabytes to 42 gigabytes. The numbers changed because there are two different ways to calculate gigabytes. Gigabytes can be calculated in base 10 or base 2. df-H uses base 10 to calculate the hard drive space, and that's why we see the larger numbers. Companies that sell disk drives often use base 10 to calculate their hard drive space. That's the reason the box may say you've got a 500 gigabyte hard drive, but when you power it up, there's only 400 and some gigabytes, not that full 500 gigabytes you saw printed on the box. The company used base 10 to calculate the hard drive space, and that's the number they put on the box. Most often, we're going to want to use the h with the df command. Another option we might want to use with the df command is the total option. I will type df-h and then -- total. This total is showing the grand total of all the file systems on this computer, including both partitions on the SDA disk, the USB drive of 7.5 gigabytes, and the TempFS space, which is using swap space and RAM memory. So it is including RAM memory as disk space for the TempFS file systems in this total. If we don't want to include the TempFS files in our df command, we can use the -x option to exclude the TempFS file systems. df-x TempFS. If we only want to see the /dev/SDA1 file system, we could type df-T, and the uppercase T is for file system type. And then we would add on the file system type of /dev/SDA1. This also works when typing in the mount point, df-T/. And if we leave off the /T and just type in df/dev/SDA1, that works as well. The uppercase T is the default. So if we leave off that T, we see the same thing as if we had typed in the T. And this works for the mount point as well, df/. And we would probably want to add in that -h for human readable, and that makes it a little easier to read. If we want to see multiple file systems, we can include them in the command separated by a space. I'll start off df-h, and then I'll add in the / for the root directory. And then I also want to include the /dev/SDA2 to include both partitions on that SDA drive. And we can add the total on there as well, dash dash total. In video 12, we talked about inodes. We can use the df command to see the total inodes on the file system, as well as the inodes used and still available. To see that, I'll type df-i, and the I is for inodes. Then if we want to see the inodes just for a specific file system, we could add that file system to the command, df-i/. Oh, and then we'd want to make that human readable as well, so I'll add the H for human readable. And here we see the total number of inodes on our Linux root partition in human readable format. In the next video, we'll continue looking at the Linux command line. In the last video, we looked at the df command to look at the computer's disk file systems, but that command did not show us any information about disk usage. To see file and directory size usage, we can use the du command, which is short for disk usage. Typing du by itself shows us all the directories and subdirectories that are in the directory where we submitted the command, which for me was my home directory. If you are in the /root directory, it will try and list every directory on the file system. You will probably see a lot of you don't have permission warning messages, and it will take a long time to list every directory and subdirectory on the entire system, and most likely you will want to hold down Control and press C to cancel out of that long-running command. Right now, what we are looking at is every directory and subdirectory in my home directory. Taking a look at these last few lines, we see Mozilla extensions, Mozilla, and videos. And then the last line is the disk space in kilobytes. I'm going to type the du command again, but this time I'm going to use the -a option to include all the files as well as all the directories. Now we see the last line, the line above the disk usage, is a file, not a directory. It is a hidden file for the selected editor, and it is showing as 4. But we're not sure right now what that 4 is. Is it bytes, kilobytes, megabytes? To clear that up, I'm going to add the lowercase h to the command to show me the results in a human readable format. Now we have our answer. The size of the hidden file selected editor is 4 kilobytes. But if I type ls-lah, and I'm going to pipe that into grep to only list the selected editor file. And we see the file size of the selected editor file is only 75 bytes. But the du command is showing it as 4K. The reason for this is the file system sets aside blocks of space for files, even if they don't take up that whole space. So the ls command is showing us the actual file size, and the du command is showing us the number of blocks that file is using. If we want to see the file size with the du command, we can add the option --apparent size. Now we see the selected editor file showing as 75 bytes. We're also going to make a note here that the disk space used in this directory is 745 megabytes. When I run this du command without the apparent size, we see that total space used is 747 megabytes, and that's the actual disk space being used for this directory. Sometimes we just want to know how much disk space is being used by a specific file or group of files. We can do this by adding the files right after the command. For example, du-h, grocerylist.txt, and presidentsbyheight.csv. These are both using 4 kilobytes. I can also check the disk space used by a specific file type or file types by adding an asterisk before the extension. du-h, asterisk.txt, asterisk.csv, and asterisk.mkv. And notice there's no grand total here at the bottom. To show a grand total, I will add --total.
And here we see the total is 291 megabytes for this group of files. Instead of typing -- total, we can use the shortcut for that, which is -C. And I think the C is for count up a total or something along those lines. -C instead of -- total gives us the same results. And I'll move that C over to be with the H. And again, the same results, 291 megabytes. And now I just want to see the disk space used by my home directory. To do that, I will type du/home/Michael. And this lists out every subdirectory in my home directory, which is the same thing I saw when I typed du in my home directory, only now I've got the full path. To see just the disk space used for my home directory, I'm going to add the -S option for summarize, and I'm also going to add in that H for make this human readable. And now I only see what I'm looking for, the 747 megabytes of disk space used by this directory. And for my home directory, I could also have used the ~/. And since I'm in the home directory, I could just type du-sh. And this shows us the same thing again, only this time it's showing the dot for the current directory. If I want to see the disk space used by all the users in the home directory, I will need to be the root user for that. So I will start the command with sudo, then du, then I'm going to add the options S to summarize, H for human readable, and then I want to see the summarized information for all the directories in that home directory. Pressing enter. Here I see all of the users in that home directory and their disk space, but it's sorted by ID. To sort this by disk space, we can pipe this into sort and then sort on -H for sort by human readable. And if we want this in the reverse order, we can add a -R before the H. And now the largest file is on top. To count up a grand total for all of the home directory disk usage, I will take out the R and add the C option to the command. And here we see the total for all the users in this directory is 977 megabytes. I see the Michael user is taking up most of the disk space at 747 megabytes. To see the larger files and directories for the Michael user, I will run the disk usage command with the human readable option and the A for all files. du-ha, and then I'm going to sort this by the human readable file size. Here we see the large MP4 file starting with 4405 in the directory LCL and then subdirectory new directory 2. Subdirectory LCL new directory 2 is showing on this list as well as the LCL directory. So 3 entries on this list are all for the same large file. We can exclude the LCL directory from the results by adding the --exclude option. So our command would be du-ah -exclude LCL, and then we're going to sort this by -H. Now the LCL directory is not included in the du command, and the grand total has dropped to 547 megabytes. There are times when we just want to see what is in the current directory. We don't want to see all the subdirectories listed. To show this better, I'm going to cd into the rsync directory, and let's see what's in there with ls-lh. We've got 2 directories in a file. When I type du-a, it shows us all the files, directories, and subdirectories. I only want to see what is in the current directory. To see that, I will add the max depth option, du-ha-max depth, and we just want to see the one directory. And I will sort that by H. Now we only see the file and the 2 directories in the rsync directory. Now instead of typing out max depth, we can use the D option. And normally that order doesn't matter, but since D has the argument for the number that we want to go deep, we need to make the D last when we group the commands. Or I could add this as -D1. But if we want to group these together, we need to have the D last so that the argument for max depth goes with it. Pressing enter, we get the same thing. And then to go 2 directories deep, we just change that 1 to a 2. And to go 3 deep, we can change this 2 to a 3. And let's also exclude the DST directory. And if we change the max depth option to 0, it shows just the disk usage for that directory. The same thing as if we use the -S for summarize option. I'm going back to my home directory. There is another command for DU that I want to talk about before ending this video. That is NCDU. Now, NCDU is not installed by default on my Linux Mint operating system, so I had to install it typing sudo apt install NCDU. And we see that it is already installed on my computer. NCDU is short for ncurses disk usage, and typing NCDU by itself will give us information about the files and directories for the directory we are currently in. To get out of this, I'm going to press the Q key to quit out, and we can also use the NCDU command with a path /home/Michael. And the output from NCDU is really nice. At the bottom, we can see the total disk usage of 746.1 MIBs. MIB is short for MIBbyte, which just means it's megabytes calculated using base 2 instead of base 10. We talked about that difference in the last video. They're just trying to be clear here that the numbers are in base 2, which is what we want to see for disk space usage most of the time. Then we see the apparent size, which is the actual file size, but not the disk space used on the disk. And then we've got the total items. Up at the top, we see we can use the arrows to navigate, and then we see the directory we are currently in. Below that, we have a little graphic showing us the largest files and directories. And pressing enter on a directory or arrow right will take me into that directory. Pressing arrow left or enter on the ... will take me up a directory. And then the question mark will show me other options available for the NCDU command. In the next video, we will continue to look at the Linux command line. In this video and the next, we're going to look at the standard layout of the Linux file system, which means we're going to take a look at the Linux directory structure to see the suggested directories for what files go where. I say suggested because not all Linux operating systems follow this standard as completely as others. To see these directories on a Linux computer, you can type cd // That takes us to the root directory. Then typing ls lists out all the directories and files in this directory. We're just interested in the directories. I've created a picture to show what I'm talking about. We see the / root directory on the left, then the first level of directories, and if we turn this picture sideways, we see the / is like a root of a tree or a bush, with the directories connected like branches on a tree growing out from a single root. This first level of branches is what we're going to look at in the rest of this video and the next one. I'm going to start at the top with the bin directory, but then I'm going to skip around a little bit because I think grouping similar directories together will make more sense and be easier to follow. Bin is short for binaries, and binaries are just compiled programs. We created a binary file back in video 23. Typing ls/bin shows over a page of commands. Here we see cat, echo, ls, and which.
commands we've already used several times in this tutorial series. So the bin directory stores the binaries for commands standard users use regularly. Now let's jump down to the sbin directory. The S is for system and bin is for binaries. So these are system binaries. The commands in the system binary directory are more for disk management and rebooting. Typing which fdisk, which parted, and which reboot shows all of these commands are in the sbin directory, and all of these commands need root privileges to run. So the bin directory is for binaries everyone on the system can use, and the sbin directory is binaries that require sudo before that command can run. Some operating systems will make the bin directory a symlink of the USR bin directory, and then make the sbin directory a symlink from the USR sbin directory. We'll talk more about the USR directory in a moment. Before that, I want to look at the lib directory. Lib is short for library, so the lib directory holds shared library files that are needed for system commands. Many of the files in the shared lib directory have SO in the title. SO is for shared object, and often there is a version following it. We can see that when we do a find for .so files in the lib directory with find/lib-name quote asterisk .so asterisk end quote. And then taking off that second dot and rerunning the command again shows files ending with .so. You may also see the directories lib64 or lib32 or the like. These are library files for other system variants, libraries that support more than one binary format, requiring separate libraries. The lib directories are also often symlinked from a directory of the same name in the USR directory, just like the bin directories. And the next directory we're going to look at is the USR directory. Most people call the USR directory the user directory, but that's not quite right. It's not much of a user directory when only the root user can update it. Standard users can only read this directory. Only the root user can make updates to the USR directory. USR is actually short for Unix System Resources. Linux follows most of the Unix standards, and this directory name is one of them. Should it be called LSR for Linux System Resources? Maybe, but I don't see that change happening anytime soon. Now that we know that the USR directory is for system resources, it does kind of make sense to have symlinks to the bin and lib directories from here. When they do that, they're grouping all of the system resources into one directory. So then where are the default non-system applications stored? Programs like LibreOffice and Firefox that came pre-installed on Linux Mint. To see that, I will type which LibreOffice and which Firefox. And we see they're both in the user bin directory for my version of Linux Mint. It's possible, even likely, that different versions of Linux will put these files in different directories. Taking another look at the root directory with ls-lh/, and I'm going to pipe that into less. Here we see the bin directories and the lib directories are not symlinked to the USR directory. How can I tell? If we look down at this initrd.img file, we see the dash arrow showing this is a symlink. Also, looking at the first letter in the first column on the left, we see L letting us know that this file is linked with another file. Looking at the bin directory, we don't see the dash arrow. And the first letter in the first column is a D for directory. That is telling us the bin directory for this distro is not symlinked anywhere. That initrd file is linked to the boot directory, and that is the next directory we're going to talk about. The boot directory contains all the bootloader files to boot up this system, including the kernel and the initial RAM files. That symlinked file we were just looking at initrd is a file for the initial RAM disk, which is part of the boot process. That brings us to CD-ROM. CD-ROM is a legacy mount point for a CD-ROM. It's not used very much anymore and not included in all distros. The dev directory is the location for device files. In Linux, everything is a file. So even when we connect a physical or virtual hard drive or a webcam or a keyboard, Linux creates a file for that device and places that device file in the dev directory. When I type ls-lh/dev and then grep for SDA, we can see the device files for the hard drive and the two partitions. The next directory on this list is etc. Some people pronounce this etc. Others call this etc. It's short for etc. The etc. directory is a place for system-wide configuration files. We've already seen a few configuration files in the etc. directory in previous videos. Early on, we catted out the etc. passwd file. And then in the systemd timer tutorial, we looked in the etc. systemd system directory. So the etc. directory is a place where many of the system-wide configuration files are stored. The next directory we see is the home directory, and each user on the system will have their own home username directory. When a user logs into the computer, this is usually their default location. This is a place where the user can keep all their data. Pictures, music, and user configuration settings. Browser customization settings you changed will be saved to your home directory. If you're going to back up a single directory, make it your home directory. Then if the hard drive crashes or goes bad, you can reinstall Linux on a new hard drive, restore your home directory. Then you'll also have to reinstall any programs you installed separately, but after that, you'll be back up and running with all the files and settings from your last backup. Now I want to jump down to the root directory, because the root directory is just the home directory of the root user. If you have a specific alias you like to use and have it in your bashrc file, but it's not there when you've sudoed into the root user, you can just add it in the root.bashrc file. The root user home directory is in a separate directory for a couple of reasons, one of which is security. The other is that often people like to put their home directory on a separate partition to make things easier for backups and system upgrades and the like. We want to keep the root user on the same partition as the operating system. Then if there's any problems connecting to other drives during the boot up, we would still be able to log in as root. This is a good breaking point. We'll look at the rest of the Linux file system hierarchy in the next video for the Linux command line. We are picking up from where we left off in the last video, talking about the Linux file system hierarchy. In part 1, we talked about all of the directories that are now shaded in the orange color. The next directory on this list to look at is the Lost and Found directory. Lost and Found is a place where the system writes information during a system crash. The system will use the files in this directory when trying to recover from a system crash. In general, we don't want to touch any files in this directory. The next directory is Media. The Media directory is where the system typically mounts drives, like a second hard drive, a USB drive, a network drive, or a CD/DVD drive. In video 78, we learned about the df command, and typing df here shows how the second partition for this hard drive is mounted in the dev directory under the file system heading. And we can access those files in the media directory where Linux Mint has created a Michael directory and mounted that second partition for us. So the media directory is where the operating system will mount drives, unless that distro is not following this standard or has interpreted this standard differently. The next directory on this list is MNT, and MNT is short for mount. But we just said the system mounts disk drives in the media directory. The man page says the MNT directory is intended for temporary mounted file systems. Some operating systems will use this location to mount temporary USB drives and even permanent second hard drives. Since Linux Mint mounts my drives in the media directory,
When I manually mount a drive, I will mount them in the /mnt directory. We'll look at an example of this when we get to the SRV directory. Below MNT, we have the opt directory. The opt directory is a directory for optional software packages. Vendors use this when there is an add-on to the system. VirtualBox uses this area for the guest additions files. Some people use the opt directory as a place for programs they manually installed, or for programs and scripts they have created. The proc directory is short for processes, and proc is a mount point for a pseudo file system. When I say pseudo file system, I mean there are no actual files in that directory. Typing ls proc shows us what looks like files and directories, but what we're looking at are actually virtual entries created by the kernel to appear as files. The pseudo files and directories in this directory are information about current system processes. A few files that might be of interest in this directory are CPU info, mem info, uptime, and version. Catting out the proc CPU info, and I will pipe this into less, shows us information about the CPUs. And typing cat proc mem info, and I will also pipe this into less, shows information about the memory. Trying to find information you need quickly here about the CPU or memory will be tricky and time-consuming. If you're trying to debug a problem, you will probably find the top command to be much more useful. When I cat out the proc uptime file, it shows us some numbers that are totally useless to most of us. The uptime command is a lot more useful. And the top command will show us the uptime on the first line, as well as information about the CPUs and memory. When I type cat proc version, it will show us which version of Linux we're using. And that one is easier to remember than uname-a, which shows us pretty much the same information. Typing ls/proc again shows us a lot of numbers in this directory. Those numbers are all process IDs for processes running at the moment. Each process has a directory of information about that process. When a new process starts, a new process ID directory will be created. When a process stops running, that process ID directory will be deleted. When the system shuts down, there will be nothing in this directory because these files are not really files. They are pseudo files. And when the system is off, the kernel is not running to create these pseudo files. New files for the proc directory are created on the next system boot up. We're now at the run directory. The run directory holds information starting with the boot time and startup boot process to the current moment. Tempfs file information can also be found here. The files in this directory are all deleted when the system shuts down, and new files are created on the next system boot. SRV is for serve or server. This directory is used differently by different operating systems. Some operating systems use this for server services. The server services most likely to be used in the SRV directory are Samba, FTP, or NFS. An example would be if a server is hosting NFS files, and NFS just stands for Network File Share. Our server has a directory of files to share with anyone on the network. We'll call this directory NFS, and we will create this NFS directory in the SRV directory on our server. Now I have a laptop on that same network, and I want this laptop to have access to the files on that server in the SRV NFS directory. I will have to add the NFS client service to my laptop, and after that, I can mount the NFS directory to my laptop. When I mount that NFS directory, I'm going to mount it in the MNT directory on my laptop, and I will add it in a subdirectory /NFS. Now, on my laptop, when I add files to the /MNT/NFS directory, they're really going to be added to the /SRV/NFS directory on the server. So in short, if I'm sharing or serving files to other computers, I will place them in the /srv directory. And if I'm manually mounting a disk, I will mount it in the /mnt directory. And we will move on to the sys directory. Sys is short for system. The sys directory is a virtual file system, similar to the proc directory. The difference between sys and proc is that proc shows general kernel data structures, and sys shows kernel data structures that describe hardware. TMP is for temporary files, and it's exactly what you think it is, a place to save temporary files, files that you won't need beyond the next reboot. You might download a file there that you don't intend to keep, and word processors, as well as other programs, may keep temporary files there. Everyone has access to that directory, but access to the files in that directory is limited to the permissions on that file. The var directory. The var directory is for files that will vary in size. The best example of this is in the log files. There are a lot of system log information files, and one of them could get a message that gets printed over and over, and that log file could get very large very quickly. The Apache web server generally sets the default location as var www.html. You'll also find the printer spool files in the var directory. The man page for the Linux file system hierarchy can be found by typing man, HIER. In the next video, we will continue looking at the Linux command line. When I plug a USB flash drive into my Linux Mint operating system, Linux Mint detected that I inserted a USB drive and automatically mounted that drive for me under the /media/Michael2 directory. It also gave the Michael2 user read and write permissions to that USB drive. I'm going to open the command line. I'm going to type lsblk for list block devices. This shows on this computer we have an NVMe drive with 5 partitions, we have an SDA drive with 4 partitions, and we have an SDB drive with a single partition that has 952 megabytes, about 1 gigabyte, and that partition is mounted under /media/Michael2. The SBD drive is the USB 1 gigabyte flash drive that I just inserted. I'm going to unmount the USB 1 gigabyte partition. To mount or unmount a partition, I will need to have root privileges. So I will start my command with sudo, and then we need to give the command to unmount a drive, which is umount. And then we need to give the device and partition /dev/SDB1 and enter, unmounts that partition. We can check to make sure it's unmounted by clicking the arrow up to get back to the list block devices command, and pressing enter shows that SDB1 is no longer mounted to /media/Michael2. We still see the SDB drive and the SDB1 partition, but it is not mounted. Now I want to manually mount the SDB1 partition, meaning I want to mount the partition from the command line. A few videos back, I mentioned when I manually mount a drive, I prefer to mount it in the /mnt directory. So let's go into the /mnt directory by typing cd/mnt and typing ls-lh. Shows there is nothing in this directory. Let's create a directory. So I'll start it with sudo and then mkdir for make directory. And the directory I want to create will be called USB 1GB for 1 gigabyte USB drive. Pressing enter and typing ls-lh again shows our directory is created. I can now mount my SDB1 partition to that directory with the command sudo mount dev SDB1, and I want to mount it on /mnt USB 1GB. Pressing enter, it's now mounted. Now, depending on your version of Linux and who you're logged in as, this may be all you need to type in to start working with that partition. Typing lsblk shows /sdb1 is now mounted on /mnt/usb1gb. Opening a new GUI file browser and changing to the location mnt usb1gb shows the drive was mounted and we have 3 photos on that partition, so we have read access to that directory. Opening another GUI file browser, I'm going to try and move the test.txt file to the USB 1GB partition. When I try that, we get an error. Clicking the Show More Details shows I have a permissions denied error. No problem. We will unmount the SDB1 partition and then mount it again. And when we mount the drive, we will also give my user ID full permissions for that partition. To unmount the USB drive, I will type sudo umount /dev/sdb1. Now let's remount it and assign permissions when we mount it. We're going to start the command off with sudo mount. That part we're already familiar with. We need to give it an option to assign permissions, so we're going to type -o. And when we look up what the lowercase o stands for, we find that the O is for options. So we are literally giving it the options option. Then I'm going to type UID for user ID and equals, and then give the user ID I want to assign the permissions, which in this case will be Michael2, the user ID I'm logged in as. Then a comma, and the permissions I want to give, which are RW for read write. Then we need to give it the device, which is /dev SDB1, and where we want to mount it, /mnt/USB1GB. Pressing enter, I will type ls-lah, and we see the USB 1GB directory has Michael2 as the owner, but the group is set at root. And the group ID has permissions of read execute. We'll look more at that in a moment. Let's first go back to the GUI File Explorer window and make sure we have read-write access to this partition. I am reloading the USB 1GB window, and I will try and move the test.txt file to the USB 1GB directory. And it works as expected. Now let's go back to the command line and unmount that partition with sudo umount /dev SDB1. Now we can mount it again, and this time we'll make the Michael2 ID the group as well as the owner. To do that, I will type sudo mount-o UID equals Michael2, GID equals Michael2. And now to assign the permissions, we're going to use the umask equal to 033. The umask permissions are calculated by subtracting the permissions you want from 777. We can see here that 777 minus 744 will give us 033, which is what I have set for the umask. After setting the permissions we want, we then need to give it the /device SDB1, and the location is /mnt/USB1GB. And pressing enter, typing ls-lh here, shows us the user ID and the group ID are both Michael2, and we've changed the permissions to 744, or full permissions for the owner, and read permissions for the group and other. This will stay mounted with these permissions until we umount the disk or shut down the computer. When we reboot the computer, we will have to mount that disk again. There is a way to have Linux auto-mount a USB drive when we restart the computer, and we'll look at that in the next video for the Linux command line. In the last video, we mounted a USB flash drive using the mount command after the system had already booted up. In this video, we want to mount our USB drive when the system boots up, but it's going to create a problem for us. I'm going to type lsblk, and we see here that the SDB1 drive is now a 3.8 gigabyte partition, and the 1 gigabyte USB drive is now SDC1. The problem is we can't always count on our 1 gigabyte USB drive as being the SDB1 drive. To make sure we mount the correct drive, we need a way to uniquely identify a hard drive, and we can do that with the disk UUID. UUID stands for Universally Unique Identifier. Each hard drive has a UUID. It's like a fingerprint, so we can use the UUID to make sure we mount the correct drive on startup. The first thing we need to do is find the UUID of the disk we want to auto-mount. There are different ways to get the UUID. I'm going to use the command ls-l/dev/disk/by-UUID. We have a couple of disk drives. A way that we can filter this out is by adding pipe grep SDC1. It loses the highlighting, but it filters down the output to just one record. And I can see the UUID is 5CFE-71AD. We can now manually mount that USB drive just like we did in the last video, substituting the UUID for the dev SDB1. Here's the command from the last video, and I'm going to change the dev SDB1 to UUID equals, quote, 5CFE-71AD, and then end double quote. Pressing enter. Should be mounted. Let's check it with lsblk. And there we see SDC1 mounted on /MNT/USB1GB. I'm going to leave this mounted for now. You'll see why in a moment. Now we want to mount that partition when we boot up the system. To do that, we're going to want to update the etc fstab file. fstab just stands for File System Table. The line we're going to add to the fstab file is similar to the command we use to mount the USB drive, but it's slightly different. And there is one more thing we need to know before we can create the line in our fstab file. And that is the file type. We're going to need to know the partition type of our SDB1 partition. We'll talk more about the different partition types in the next video. For now, we just want to know what the partition type is so we can add it to our fstab command. To get the partition type for the SDC partition, I'm going to type df-t/dev/SDC1. This shows us the SDC partition has a file type of vfat. And this command is why I left the partition mounted. I'll unmount it now with sudo umount /dev/SDC1. And typing lsblk shows us now the drive is unmounted. And typing in the df-t command again gives us incorrect information, showing us that the partition needs to be mounted to get the file type this way. We're almost ready to update the fstab file. Before I make any change to the fstab file, I'm going to make a backup of it with sudo cp/etc/fstab and then /etc/fstab.back. The reason for this is if we have a typo or the like in our fstab update, there's a chance of us making the machine unbootable. If that happens, we need to log in with the live Linux distro and restore our fstab file from the backup we just took. Now I'm ready to update the fstab file with Vim. So we'll need to have root privileges. So I'm going to type sudo vim etc fstab. Now we're in the fstab file. We see a lot of comments. Every line that starts with a hash mark symbol is a comment. There is one comment that I want to focus on, And that's the one with file type, mount point, type, options, dump, and pass, because that's the format the FSTab file follows. Let's look at the first line that is not a comment. We see here it starts off with UUID equals and then a very long UUID. No big deal. We know what that UUID is. And this drive just has a very long UUID. Next is the mount point. And the mount point for this UUID is a single /, meaning the root directory. So there's nothing new for us in these first two fields. They follow the mount format that we're already familiar with. The next field is the file type. Here we see it's ext4. We'll talk about that in the next video. But I will mention now that it is a journaling file type. The next three are options, dump, and pass. Let me make this a little longer to fit that line all on one line. We're going to come back to the options in a moment. Let's first look at dump and pass. They're binary options, so they can only be 0 or 1. Dump is an outdated method of backup for cases when the system went down. There's no reason to use this, so we're always going to want the dump value to be 0. The last field, pass, that tells the system whether or not to perform a file system check on boot. So do we want to run an FS check when mounting the drive? In general, no. So why is this one set to 1 here? Well, there are two reasons. Reason 1 is it is our root file system. We know that from the / for the mount point. And reason 2 is the file system is ext4, which I mentioned is a journaling file system. And that FS check can help the journaling file system recover after a system crash. This might not recover the system every time, but it does work pretty well. To make things easy, most of the time when we add a drive, we're going to set the dump and pass both to 0. Now we're back to the options field. Options are special settings for the partition. Like in the last video, when we mounted the USB drive, we wanted to assign special permissions for the user and the group's ID. Those same options work in the FSTab file as well. There are a lot of options. To keep this video from going on forever, we're just going to look at some of the most common options. Let's start with the option for the home directory that has errors equals remount-ro. In short, this option says if there's an error when trying to load this partition, remount it as read-only. The theory behind this is that your hard drive is failing and you don't want to write over anything, and you should probably make a backup of anything you really need off that hard drive as soon as possible. Looking down at the next partition the FSTab file is mounting, this has an option of umask equals 077. And we talked about the umask option in the previous video. This is the equivalent of giving the permissions 700. Often you'll see default as the option, and that's what I'm going to use. Let's take a quick look at the default options, and then we'll update the FSTab file. The default options are RW, which is read and write for this partition, SUID. When this is set, the mounted partition will recognize a SetUID executable. SetUID was covered in video 25. The opposite is no SUID. Dev. Mounting as no dev specifies that the file system cannot contain special devices. It's a security precaution. The default is dev, allowing the creation of character devices. Then we've got exec, no exec, prevent the execution of binaries from the file system. Looking into this a little bit, it looks like there are ways around this, and the usefulness of the no exec option are questionable. Then the last three are auto, no auto. Auto will mount the file system at startup. No auto will not automatically mount the file system at startup. Or when using the command mount-a, you must explicitly mount the file system. No user, only permit root to mount the file system. This is the default. User allows the user to have mounting and unmounting privileges. An important note is that user automatically implies no exec. So if you need to execute binaries and still mount as user, be sure to explicitly use exec as an option. And the order does matter. So if it doesn't work, you might have it in the wrong order. Sync, async. Sync forces writing to occur immediately on execution. Async allows the writing to wait until the system is less busy. Then, when the activity dies down, it will finish writing to that device. Sometimes you'll get a message asking you to wait while the changes are being written to the drive. This is usually the reason. The default is async. Okay, let's add our line. I'm going to start with UUID equals 5CFE-71AD. And we want to mount this on MNT/USB1GB. I'm going to press Tab here and type VFAT for the file type, Tab, and then my options as defaults. And our dump is 0 and pass is 0. Let's save this. After we save the file, we want to run a test mount, and this can be done with sudo mount-a. Actually, I'm going to make an error in our FS tab just to show what one might look like. Let's change the 5C to 5D. Now that is incorrect. So now when we type sudo mount-fav, we see we get an error, can't find UUID 5DFE. And we can do the same thing with sudo mount-a. So it can't find it. Let's go in and fix our problem. Sudo mount-fav. We see it's successfully mounted. And if we do the A as well, we don't get the message like we do with the FAV. So it's mounted, and we can see that with lsblk. And we can also go into it by typing cd mnt USB 1GB. Now our drive should mount every time we restart the computer. In the next video, we'll continue looking at the Linux command line. In these next few videos, we're going to look at working with partitions on a USB drive. In this video, we're going to look at deleting, adding, and resizing partitions of a USB drive using a GUI environment. Because in a GUI environment, it is a lot easier to visualize the process and follow the steps of what is going on. Then in the next video, we're going to do the same thing from a command line environment. The first thing I'm going to do is plug in my 1 GB flash drive. And then I'm going to open up the GUI program Disks. Over on the left, I see 3 hard drives. My 1 GB flash drive is here at the bottom, so I will click on that. At the top, we see model, serial number, size, and partitioning of master boot record. We are going to talk about the master boot record in an upcoming video. In this video, we're only looking at deleting, adding, and resizing partitions. Below partitioning, we see volumes. This shows we have a single partition for the entire drive. The information below volumes shows the single partition has a size of 997 megabytes. The contents or disk format is FAT32. We see the device is /DEV/SDB1 and has a UUID of B0D4-C2F3 and the partition type of Windows 95 FAT32. I want to change the partitions on this disk, and to make any changes, I will need to unmount the drive. Moving my mouse over the square shows the message, unmount the selected partition. We only have one partition, and it is selected, so I will click on the square to unmount the partition. The square becomes a triangle or play button to mount the partition, showing it is unmounted. From here, I can press the red minus sign to remove the partition, or I can reformat it by clicking on these gears for additional partition options, and then clicking on Format Partition. I'm going to click on the red minus sign and delete the partition, and confirm it. And we see now that the volume shows we have 1 GB of free space. My play stop button has changed to a plus sign, and hovering over it shows create partition in unallocated space. I will click that, and I want this partition to take the entire 1 GB, so I will click next. We're going to leave the volume name blank. We're not going to talk about volume names in this video. we're going to leave erase unchecked. That just forces in zeros before creating the partition. And below erase, we see type. And for type, we see the default is for use with all systems and devices FAT. Above that, we have for use with Windows NTFS. And above that, we see internal disk for use with Linux systems only, ext4. Those are the three most common file types for Linux users. So most likely, you'll use one of those three file types, depending on what type of data you're planning on putting on the USB drive, or what file systems you're planning on using it with. But that's not all our choices. If I click here on Other, and then Next, we'll see there are more file systems to choose from. We see XFS, Linux File System, Linux Swap Partition, BTRFS, Copy on Write, Linux File System for snapshots, exFAT, Flash Storage, Windows File Systems used on SDXC cards, and no file system. But the file system options do not stop there. I'm going to open up gparted, another disk tool, and going into the devices, SDB, new, file system types, and we see we have even more options here. I'm going to close this and go back to disks because there's way too many file options in gparted. Disks gives us a good enough variety to look at. We can talk about the difference between the file systems and why we might choose one over another. Let's go back to the previous screen and start with the ext4 file system. ext4 is the fourth generation of the extended file system. It was based on the Minix file system and was able to extend some of the file limitations of the Minix file system. We see ext4 is specific to Linux file systems only. In the last video, we talked about ext4 being a journaling file system, which means it keeps track of the changes not yet committed, and in the event of a system crash, if we have the FS check enabled, it is possible to recover from a system crash on the next system boot. So ext4 is a great file system option for the Linux operating system, but it might not be the best option for our 1 gigabyte USB drive. The next option is NTFS. Linux and Windows computers will have no problems reading the NTFS file system. So if you know you're only going to use this USB drive with Windows and Linux operating systems, NTFS is an option you may want to consider. The third option, FAT, works with all file systems and is the default. That's the one that I use most often for my USB drives because I never know when I might have to read a file off one of my USB drives on a Windows or Mac computer. FAT does have a file limitation size of 4 gigabytes, so if I try to move a single file that is larger than 4 gigabytes to a FAT formatted USB drive, it will fail. This USB drive is only 1 gigabyte, so FAT is what I will use for this USB drive. Now let's look at the other formats. We'll start with XFS. XFS is similar to ext4 in the way that it is a journaling file system and supports very large files and file systems. It is the default file system for most of the Red Hat file-based distributions. There are differences between the two, but most of them are negligible for most of us home Linux users. I think that Red Hat Enterprise Linux, or RHEL, systems use XFS over ext4 because of the file benefits it gets when working with millions of files daily, which some corporations do, situations most of us home users will never even come close to. One difference I did notice between the XFS file system and ext4 file system was XFS file partitions cannot be decreased in size. XFS file partitions can be increased in size, but to reduce an XFS file partition, you'll have to delete the partition and then recreate it as a smaller size. We'll look at increasing and decreasing file partitions later in this video. Next is the Linux swap partition. We talked about this when we were going over the top command in videos 60 and 61. The swap partition is the overflow space for RAM memory. BTRFS, some people pronounce this ButterFS or BetterFS, is a copy on write Linux file system for snapshots. The copy on write is also known as COW or COW, and when you open or view data, you're looking at a copy or a pointer to that resource. Then, when an update is made, it is only saving the change. So a snapshot isn't a backup, but a picture of what the computer looked like at that moment the snapshot was made, keeping only the changes since the last snapshot. It is very quick and easy to restore to that snapshot moment in time if needed. Snapshots are not recommended as a long-term backup solution. Backups and snapshots are two different things. A backup is a copy of your entire file system volume at the time the backup was performed. A snapshot is more of a fancy set of copy-on-write hard links that are limited to that same BTRFS partition. exFAT is a file system for USB drives and SD cards from Microsoft. The advantage of exFAT over the FAT file system is that exFAT can handle files larger than 4 gigabytes. The USB drive I'm using today is only 1 gigabyte, so FAT is a great choice for that. But if I have a USB that is greater than 4 gigabytes, I might consider formatting that as exFAT, just because there's a chance I may want to place a file larger than 4 gigabytes on that drive. And then the last option is no file system. Okay, I'm going to the previous screen and I'm going to format this as FAT for use with all systems and devices. And then clicking Create. And we've created a single file partition using all the space on this USB drive. Let's add in a second partition. To do that, I will need to reduce the size of the current partition and then add in the second partition. Now, if this was formatted as an XFS file system, we would not be able to reduce the size of the volume. We'd have to delete it and recreate it. But this is not XFS, so we're fine. Let's go into the gears and click Resize. Here's the current partition size, 999 megabytes. If I click the minus sign, it goes down to 998, 997. I want to change this by, we'll say 300. Pressing the Tab key resets all those numbers, and I'll have free space of 300 megabytes. So let's resize this. And here we see partition 1 is formatted as FAT, and we've got free space here. So I'm going to click on the free space of 300 megabytes, and I want to create a partition in the unallocated space. I want the partition size to take up all 300 megabytes. Clicking Next. And instead of making this one FAT, I'm going to make this one an ext4 partition. Clicking Create is creating that partition right now, and it's completed. So now we have our single 1 gigabyte USB drive formatted to 2 partitions. The first partition is 699 megabytes of the FAT formatted partition, and our second partition is a 300 megabyte ext4 partition. In the next video, we're going to do the same thing using only the Linux command line. I just plugged in the USB drive we reformatted in the last video, and I'm typing lsblk. We see we have 2 partitions on the SDB drive. I will unmount those 2 partitions with umount/dev SDB1 and umount/dev SDB2. And typing lsblk again shows that the 2 partitions are unmounted. There are 2 popular command line tools for disk partitioning. They are fdisk and parted. In this video, we're going to use parted. We'll take a look at fdisk in a future tutorial. We need to have root privileges to work with the parted command, so I will start the command with sudo and then type parted. Since we did not tell parted which disk we wanted to work with, it defaulted to the first disk it found, which is dev SDA. That is definitely not the drive I want to work with. So I'm going to quit out of this by typing quit. I'm going to clear the screen by typing clear. I'm going to type sudo parted again, but this time I'm going to add on /dev/SDB. And notice I'm not typing SDB1, I'm typing SDB to tell Parted I want to work with the entire SDB drive. Pressing enter. Now I see that I'm using /dev/SDB, and that is the drive that we want to work with. Now I'm in the Parted prompt. I see a little welcome message that says I can type help to see a list of commands. So I will type help. And here I see a list of commands, and a lot of these are what we're going to use in this video. We're going to use the print to display partition information. We're going to use rm number to delete the partitions that are currently there. We're going to use mkpart to create a partition. We will use resize part to shrink our fat partition. And then we will use mkpart again to create our second Linux partition. So we're going to do the same thing we did in the last video, only this time from the command line. We'll start off by typing print, and that shows us some general disk information, and then the two partitions created in the last video. Our FAT32 partition is partition number 1, and our ext4 partition is partition number 2. I'm going to remove the FAT32 partition with rm1, and then I'm going to type print to show that it's gone. Now I'll remove partition number 2 with rm2, and then I'll print that out to show that there are now no partitions on this USB drive. Now I want to create the FAT32 partition, just like we did in the last video, and I'll do that with mkpart for make partition. Now it's asking us for a partition type, primary or extended. What is a partition type? We didn't have this question when we used the GUI partition creator. Well, actually, we did have that option in the GUI screen. Here's a picture of the create a partition from the GUI screen, and we see there is a checkbox for extended partition. We did not check the checkbox in the last video. We made our partition a primary partition in the last video by not checking that checkbox, so I will make this partition a primary partition here as well. We'll go over the difference between primary and extended partitions in the next video. Now it's asking us for a file system type. We want FAT32. And now it's asking us, where do we want to start this partition? We want to start it at the beginning, so I will type in 1 MB. Now it's asking us, where do we want this partition to end? I will use 100%, use up all of the free space on this disk. Pressing enter, and our partition is created. Let's make sure it was created by typing print, and we see our partition right there. We have a single fat partition using all of the space on this USB drive. Now from here, I'm going to type help mkpart for help with the mkpart command that we just used. The first thing that it shows us is that we could have typed all of the options on one line. Since I only typed mkpart, Parted went into interactive mode to help me complete the rest of the command, but I could have typed all the parts on a single line and hit enter. We'll do that when we create our Linux partition. Looking at the next line of help, we see part type, primary, logical, extended. We'll talk about that in the next video. Then we see FS type, and it lists all the types that we can format the partitions to. We are only using FAT32 and ext4 in this video. Then we see start and end for the partition disk locations. We can type a number or the percentage we wanted to use. I'll use both in this video, But while doing some research for this video, I saw some people recommending percentages over the memory locations. Now these last lines of the help are very important. It says mkpart makes a partition without creating a new file system on that partition. What this means is Parted has created a partition, and the partition information says the file system on this partition is FAT32. But inside the partition, Parted has not created a file system. That's something that we, the command line users, will have to do. So let's do that right now. I'm going to quit out of Parted. The command to make a file system is mkfs, but we will need root privileges to use this command. So I will start this with sudo, then mkfs, then a period, and the file system we want this to be, in this case, which is FAT, and then we want to give it the option of uppercase F32 for the FAT32 option. Then we want to give it the partition that we want formatted, which is /dev/sdb1. And pressing enter, it made our file system for us. Okay, let's go back into Parted with sudo parted dev sdb. And I'll type print just to show what we have right now. And we see the single partition, which is FAT32. Now what I want to do is resize this partition to shrink it down to make room for our Linux partition. So I will type resize part, and I want this to be for partition number 1. And I want it to end at, I'm going to make it 300 megabytes. So I want to reduce this one by 300. So instead of 999 MB, I want this to be 699 MB. Now I could also have typed minus 300 MB to free up 300 megabytes, but I chose to use the ending megabytes. It's giving us a warning. Do I want to continue? Yes. And now when I type print, we see that our ending megabyte is 699 MB. Now I want to create our second partition, our Linux partition, on a single line command. And now we know the format that Parted is expecting. So I will type mkpart and then primary. We're making this one also a primary partition, just like we did the last video. We want this to be a file type of ext4. And we want this to start at 699 MB. And we want this to end at 100%. So it will use all the free space available after 699 MB. Pressing enter, it created it. I'm going to type print. And there we see our two partitions. The first one FAT32 and our second one ext4. Now we've created our Linux partition, but we haven't yet created the file system on that partition. So I will need to quit out of here. And now I want to make that file system, the ext4 file system. So I'll type sudo mkfs.ext4/dev/sdb2. Pressing enter. Now it's telling us that it created an ext4 file system on there already, which is interesting since the help screen was telling us that it did not create one. So I'm not sure if the documentation's off or not, but I'm going to proceed anyway and write this ext4 partition over the ext partition that's already there. And now it's creating the file system. Now, it would be preferable if they just would have added that mkfs command as part of the mkpart command, but they didn't, so we had to manually add in the file system. Now, what if in Parted, I said the file system is FAT32, and then I added an ext4 file system in place of that? On a Linux machine, that won't be a problem for the most part. There may be a program or two that does not like that, but for the most part, it should work on a Linux computer. On a Windows computer, Windows will not be able to read that ext4 partition and want to reformat it so it can read it. I'm going to go back into Parted, and type print. And we see our two partitions are created. The first one showing a 699 megabyte FAT32 partition, and the second a 300 megabyte Linux ext4 partition, just like we did in the previous video, only this time from the command line. In the next video, we're going to look at disk label partition table for the Linux command line. In the last video, we looked at parted. So I'm going to open up parted again for my flash drive in this video with sudo parted dev sdb. And I'm going to type help. One of the commands that we did not look at in the last video is called make label make table, and that will create a new disk label partition table. I'm going to type help make label. And parted shows us label type is one of, and then it lists a bunch of label types. We're only going to look at two of the label types in this video, GPT and MS-DOS. GPT and MS-DOS are the most common, and understanding them will give you a good head start if you ever need to use one of the other label types listed here. When we make a disk label partition table, we are reformatting the hard drive and creating a disk partition table that will define how many partitions we can have on that USB drive. It does a few other things that we'll look at later in this video, but for the moment, we are going to focus on the partitions for an MS-DOS disk partition table and the partitions for a GPT disk partition table. The MS-DOS disk partition table will allow up to 4 partitions, which means we can have up to 4 primary partitions or up to 3 primary partitions and a single extended partition. The advantage of the extended partition is that the extended partition can then be split into logical partitions. The total number of logical partitions is 23. An MS-DOS disk partition limit is 26 partitions, which is pretty good. That's a lot of partitions, more than I've ever needed. I've created a little diagram here of what an MS-DOS disk may look like with 3 primary partitions and an extended partition with 5 logical partitions, for a total of 8 partitions on this disk. A GPT disk partition table will allow up to 128 partitions. GPT does not know anything about primary or extended partitions. They're all just partitions, and there can be up to 128 of them. We're just looking at partitions for a portable USB drive, so I was just talking specifically about partitions. To get a better understanding of the difference between MS-DOS and GPT, it might be better to start from the beginning. And when I say the beginning, I mean when we power on the computer. When we power on a computer, the motherboard on that computer has a chip with some software on it called BIOS. BIOS stands for Basic Input-Output System, and it does things like test the memory, sets the system clock. It also configures the keyboard, mouse, and other hardware attached to the computer. After it does all that, it looks for a drive with a bootloader on it, and the bootloader, in our case, is going to have an MS-DOS partition table or a GPT partition table. That brings us to the 2 main types of BIOS on the motherboard, Legacy BIOS and UEFI BIOS. Now I know some of you are thinking, it's not UEFI BIOS, it's just UEFI. I understand that, but for the sake of this explanation, I'm calling it UEFI BIOS. And Legacy BIOS is called Legacy BIOS or Legacy Boot on UEFI computers. On all the other computers, it's just called BIOS. BIOS, now known as Legacy BIOS, Legacy Boot, came first. So we'll start with that one. BIOS was created in the 1980s and would boot into an MS-DOS partition table. The MS-DOS partition table is also known as the MBR partition table. MBR is short for Master Boot Record. It's called the Master Boot Record because there is a 1 megabyte boot sector on the hard drive for the partition table information, and that would be the Master Boot Record. That 1 master boot sector could get corrupt, and you would need to restore it or all the data on that disk would be lost. The MS-DOS MBR partition table has a limit of 2 terabytes, which in the 1980s was huge. But today, hard drives with more than 2 terabytes of storage is common, and the MS-DOS MBR partition table can only use 2 terabytes of that disk. The MS-DOS MBR partition table runs in a 16-bit processor mode. Around 2006, EFI was developed. EFI stands for Extensible Firmware Interface. Shortly after that came UEFI, Unified Extensible Firmware Interface. UEFI uses the GPT partition table. GPT stands for the GUID partition table. So the PT is for partition table, and the GUID stands for Globally Unique Identifier. With the Globally Unique Identifier added, we can now add Secure Boot, which can ensure that only trusted software can be executed on our system. We are no longer limited to a 1 megabyte disk sector. The GPT partition table is copied redundantly on the disk, so if one area is corrupt, the disk can still be read. The limit is now 9.4 zettabytes, which is about the size of the entire internet today. It can run in 32-bit or 64-bit mode. The UEFI BIOS can handle a lot more hardware details for the CPU, memory, storage, and fans. It also supports newer technologies like USB 3.0, NVMe, and PCIs. UEFI is backwards compatible, so Secure Boot can be turned off, and operating systems created before UEFI can be loaded on a UEFI computer. I'm still imparted in the command line window, and I'm going to type print. We see the 2 partitions we created in the last video, and if we look up under partition table, we will see MS-DOS, showing this is a disk partition table of MS-DOS, which we know is also known as MBR, Master Boot Record Disk Partition. I want to change this to a GPT partition table. I'm going to type help to show our options again, and then I'm going to type MKTABLE GPT. I'm getting a warning that the partitions are still mounted, so let's cancel this, quit, and type LSBLK, and then we're going to umount dev SDB1 and umount SDB2 and go back into parted. Let's try the command again. Make table GPT. Now it's telling me that all the data on the disk will be destroyed. Do you want to continue? Yes. I'll type print, and it's showing us now that we've got a partition table of GPT. Let's make a partition with mkpart. And notice now it's asking us for a partition name and not if we want to make this a primary or extended partition. I will give this a name of partition 1. I want to use the entire USB drive, so I will type 100%. And notice it did not ask us what type of file system we plan on adding to this partition. Typing print, we don't see any file system. I'm going to quit out and add a file system. Let's add the file system with sudo makefs. We'll make this a FAT file system, F32 for 32-bit, dev SDB1. It's made. Let's go back in to parted and type print. And there we see we've created a FAT32 file system on our single partition on that disk drive. In the next video, we will continue looking at the Linux command line. In the last video, we talked about disk label partition tables. In this video, we're going to talk about partition labels. Since we're already familiar with parted, I'm going to type sudo parted /dev/sdb. And then I'll type print. We see here that we have an MS-DOS partition table, and we have 4 partitions. The first one is FAT16, the second one is ext4, the third one is an NTFS partition, and the fourth partition is FAT16. I want to label these partitions to show the file system in the partition label. So I'll quit out of here with quit. And I'm going to view the current partition labels as well as some other partition information with the command lsblk-o, and then I want to show the fields name, label, size. I'm also going to show the file system type and the file system version for the device SDB. And we see in that second column label that nothing is labeled. I'm going to create a file partition label for the first partition, and the first partition has a file system type of FAT. So I'll use the FAT label command to update that partition label. I'll need to be a privileged user, so I'll type sudo, then FAT label. Then I want to give it the device dev SDB1, and then the name of the label I want to put on this partition. I'll call this part1 underscore FAT16. There are other ways to rename a FAT file system label. This one just worked best for me. Pressing enter, the partition names on an MS-DOS partition label are limited to 11 characters, and it's recommended to use uppercase. And then pressing the arrow up to bring back that lsblock command shows the FAT16 partition 1 was renamed to part1 underscore FAT16. Our second partition has a file system of ext4, so the FAT label command won't work here. To rename the ext4 partition label, I'm going to use the command sudo e2 label /dev/sdb2, and I'm going to rename this to part2 underscore ext4. And there are other ways to rename an ext4 partition label. Tune2fs is another way, but I'm using the e2 label. Pressing the arrow up again to bring back the lsblock command shows our ext4 partition has a label of part2 underscore ext4. Our third partition is formatted as an NTFS file system. To label an NTFS partition, I will use sudo ntfs label /dev/sdb3, and then we'll call it part3 underscore ntfs. And then arrowing up shows that that label has been updated. And then the last partition is again another FAT16, so I'll type sudo FAT label /dev/sdb4 part4 underscore FAT16. And once again, hitting that arrow up to go back to lsblock command shows all our partitions are labeled. Typing the lsblk command again shows I have another flash drive assigned here as SDC with 2 partitions, SDC1 and SDC2. Typing sudo parted /dev SDC and then print shows this partition table is formatted as GPT. We have 2 partitions. Partition 1 is a FAT32 and partition 2 is an ext4 partition. I'm going to quit out of here with quit and type the lsblk command again. And again, I want the name, label, size, file system type, file system version for device SDC. Once again, we see the partitions do not have any labels in that column 2. For the first partition, It's a FAT32, so I'm going to relabel that with sudo fat label dev sdc1 part1 underscore FAT32. And the GPT disk partition tables can handle lowercase letters in the file name. But as the message says, they might not work properly on some systems. Let's see how it works here by bringing back the ls block, and it looks fine. I'm going to relabel the ext4 partition with sudo e2 label dev sdc2, and we're going to call this part2 underscore ext4. And showing that the labels are created with the lsblk command, and they're both there. From here, I want to look at another disk command called gdisk. To get into gdisk, I will type sudo gdisk. The first thing it's asking for is it's asking me what device do I want to open with gdisk. I will type /dev/sdc. It looks around and tells us that it found a GPT disk partition for the device we requested, and it tells us we can type a question mark for help. So I will put in the question mark. And we can see we can do a lot of things here. The one that I'm interested in is the C, change a partition's name. So I will type C. It's asking us which partition we want to change. I will start with partition number 1. And we're going to call this partition GPT underscore part1 underscore FAT32. While we're here, let's change the other partition name. I'll do that again with C, partition number 2, and we'll give that the name GPT underscore part2 underscore ext4. I'll need to write these changes by typing W. Now I'm getting a big warning here that it's going to overwrite the existing partitions. I don't have anything written on those partitions, so it's okay for me. I will press the uppercase Y. And it lets me know that I wrote a new GUID partition. Let's check the labels now with the ls block command that we used earlier. And there's no change to the partition labels. They did not get updated. That's because gdisk told us it was going to update the partition name, but we still see the partition name as SDC1 and SDC2. So how do we see that updated partition name? Well, there are a couple of ways. One way is with parted. Sudo parted/dev sdc. And then print. There we see the file partition names of the GPT part1 FAT32 and the GPT part2 ext4. I'm going to quit out of here. And another way to see the partition name is to add in to our ls block the field part label. So we're going to have the label, then the part label, then the size, FS type, and FS version. And there we also can see the partition name that we updated with the gdisk command. In the next video, we'll continue looking at the Linux command line. Before we start to look at fdisk, I want to show where we see the labels that we updated in the last video. I've got a GUI file manager window open, and I'm plugging in the USB drive that we updated in the last video. And here we see the 4 different partition labels. We see we've got partition 1 being the FAT partition, partition 2 being the ext4 partition, and so on. Okay, on to fdisk. I'm switching to the command line window, and we need to have root privileges to use the fdisk command. So I will have to type sudo before typing the fdisk command. Sudo fdisk-l. And fdisk lists the disk information about all the disks it finds on this computer. Most of the time, this is more information than we need, and we want to just see information about a single drive. I'm going to clear the screen and arrow up to bring back that fdisk command again and add on /dev/SDB. And now we only see information about the SDB drive, and the output is very similar to what we saw with the parted print commands. We can see that the disk label type is MS-DOS, or just DOS as it is shown here, and then we see the 4 partitions that we created in the last video. To get into fdisk command mode, I'm going to arrow up to bring back that last command, and I'm going to remove that -L. And now instead of listing out the dev SDB drive, I will be in fdisk command mode for the dev SDB drive. We're getting a message that the disk is currently in use. We want to unmount the SDB partitions before we start to work with it. So I will quit out of this by typing Q. We're out of fdisk, and I will unmount the 4 partitions with umount /dev SDB1, SDB2, SDB3, and SDB4. And let's go back into fdisk with sudo fdisk dev SDB. And now we get the standard welcome to fdisk message, and it's telling us that we need to write out the changes before we exit fdisk, or our changes will not be made. And then we see the fdisk prompt asking us what fdisk command we want to run, and it's telling us we can type M for help. So I will type M. We see a lot of information here. I'm not going to go through every single one of these, but we'll look at enough to get us familiar with fdisk. Under the MISC heading, we see M is used to print this menu. So M is for menu. I want to see what is currently on this USB drive, and to do that, I will type P for print the partition table. And we see the same output that we saw when we typed fdisk-l/dev/SDB. We've got 4 partitions, and I want to delete them using fdisk. I'm going to scroll up a bit, and here under generic, I see D, delete a partition. So I will type D. It's asking me what partition I want to delete. I'll delete partition 1. And then I will press D again. This time I'll delete partition number 3. Oh, and let's take a look at what that looks like. I'm going to press P. And now we see that we only have partitions 2 and 4. I'll delete partition number 2. And now when I press D, it doesn't ask us what partition because there's only one there. It deletes it. I'll type P again to take a look at our partition table. And we see there are no partitions, and we have a disk label type of DOS. I want to change this partition table to a GPT disk partition table. I'm going to type M again. And here at the bottom, we see create a new label. And under that, we see G, create a new empty GPT partition table. I will type the lowercase g and then enter. And we get a warning that this device contains a DOS signature and it will be removed. Most of the time, that's what we're going to want to do, to wipe the signatures when relabeling to avoid possible collisions. I will now type W to write out the changes, and those changes were to remove the 4 partitions and then to make this a GPT disk partition table. Now instead of W, if I type Q right now, I would quit out without writing, so those 4 partitions would still remain as they were, and the disk partition table would stay as DOS because we have not written anything out yet. I want to write out those changes, so I am going to use W and press enter. fdisk makes our changes and returns me to the regular command line. I'll go back into fdisk for the SDB drive by pressing the arrow up and then enter. And now I'll press P to print the disk information. We see that we currently have no partitions, and our disk partition table has been updated to GPT. Now I want to add a new disk partition to this disk. To do that, I'll type N for new. And it's asking me what partition number I want to give it. Numbers 1 through 128. I will type 1. And now it's asking for the first sector, meaning where do we want the starting point of this partition to be? It can be a number greater than or equal to 2048, but it must be less than 3915742. The default is that lowest number 2048, so I will press enter, making our starting sector 2048. Now fdisk is asking us for the last sector of the partition, meaning how big do we want this partition? If we want one single partition to take the entire disk, we could type 3915742, or we could just press enter, and fdisk will assume we want to make this a single partition taking up all the free space available. I want this partition to be 1 gigabyte, so I will type plus 1G, meaning add 1 gigabyte from the starting point of this partition. Fdisk is telling me it created a new Linux file system partition, but this partition has a signature of vfat. Do I want to remove that? I'm going to type N for no, because I want to make this a FAT file system. So how do I change my partition type? I'm going to type M to bring up that menu. And under generic, we see T, change a partition type. Typing T, we get the question, what partition type do we want to make this? And we can type L to list all. I'll type L. And here we see a big list. I can scroll down and up using my arrow keys. I want to make this an MS-DOS partition, and we see the numbers 10 through 14 are all Microsoft Windows partition types. Which one should I choose? Well, we talked about this in a previous video. The partition type doesn't really make that big of a difference. It's the file system that we put on that partition that makes the difference. Just the same, I want to make this partition show as a Microsoft partition. So I'm going to choose number 11, Microsoft Basic Data. I'm going to press Q to quit out of the partition type listing, and then I'll type 11 for the Microsoft Basic Data. And my partition type has been updated. Now I want to make a second new partition. So again, I'll type N. I'll make this partition number 2. And now it's showing me the first free sector as 2099200, the default. So I will press enter to have that be the starting position. And the ending position, I'm going to press enter for the default of 3915742. That's that same number we saw earlier. And our partition 2 type Linux file system has been created. And if we want to see what number the Linux file system is, I can type L to list the file types. And we see here that number 20 is the Linux file system. I'm typing Q to go back. And I'm going to type P to look at what we're going to make this drive. We see the two partitions. The first one is a Microsoft Basic Data, and the second one is a Linux file system. I want to write these changes out, so I'm going to type W. And fdisk makes those changes and puts me back into a regular Linux command prompt. Now I still need to make my file systems for the two partitions that we just created. I will make my first file system a FAT32 with the command sudo mkfs make file system .fat, and we're going to make this a -f32, and we want to put this on /dev/sdb1. And now let's make our ext4 file system with the command sudo mkfs make file system ext4, and also for the dev SDB, but this time we want it for partition number 2. Let's check everything to make sure it all looks good with the command lsblk-o, and I want to see the name, label, size, FS type, FS version, for device SDB. And here we see we created a 1 gigabyte partition that has a FAT32 file system and a second partition that is less than a gigabyte but is formatted with the ext4 partition. There's also a command out there called cfdisk. Let's run that right now with sudo cfdisk/dev/sdb. This might be a little easier to work with for some. It's the same fdisk command, only with a nicer format. The C is because it's a cursus-based program. We will still have to write out our changes before we exit, or those changes will not be made, just like the regular fdisk command. I'll quit out of here by pressing enter. In the next video, we'll continue looking at the Linux command line. The dd command is often used to copy disks, and we will do that in the next video. In this video, we're going to take a closer look at the dd command itself. We're going to start using the dd command to just copy a file. Typing ls-lh shows we have a single file in this directory called inputfile.txt. I will cat out that file with cat inputfile.txt, and it shows the text, "This is some test data." I want to copy this file to a file I will call output.txt, and I'll create it with the dd command by typing dd if for input file, then an equals sign, and then inputfile.txt, then of for output file, then an equals sign, and I will type in the output file name of outputfile.txt. Pressing enter shows there's 1 record in, 1 record out, 24 bytes were copied, and we see it took a fraction of a second to run, and it was copied at a rate of 118 kilobytes per second. Catting out that output file with cat outputfile.txt shows the full file was copied as expected. Now let's say we only want to copy the first word from the input file to the output file. We can do that, but we need to make a few changes to the dd statement. Looking at the output from the dd command, we can see that we had 1 record in and 1 record out. The record length will be the block size, and the default block size is 512 bytes. Why is the default block size 512 bytes? Well, when I type sudo fdisk-l/dev/sdb, we see a sector size of 512 bytes, and that is where they get the default block size from. I'm going to arrow up a couple of times to get back to that dd command that we just ran, and I want to set the block size to 1. I can change the block size by adding the option BS equals 1. And BS stands for block size. So I'm setting the block size to 1, and each character is 1 byte. Pressing enter, we see 24 records in, 24 records out, and 24 bytes copied. So this time, each character was 1 record. If I bring back that dd statement again and change the block size to 2, pressing enter, now we only see 12 records in and 12 records out. But 24 bytes were still copied, but because the block size was 2, it read them in 2 at a time instead of 1. Typing cat outputfile.txt shows the entire file was copied over, just as we expected. I'm going to clear the screen and cat out that input file again. And I'm going to bring back that same dd statement, changing the block size back to 1 so it will only read 1 byte at a time again. But this time I want it to stop after reading 4 records, or 4 characters in this case. And that would be the first 4 characters, THIS. To do that, I will add the option count equals 4. So the count equals 4 says read 4 records, then stop. Without count, it will continue reading till it reaches the end of file. Pressing enter, we see 4 records in, 4 records out, and 4 bytes copied. I will cat the output file, and we see this. Then there's no line return because we did not read to the end of the line, so it did not read in that line break. But we did get the first 4 characters, which is what we were looking for. Now let's say we just want to print out the word sum. So we're going to skip 1, 2, 3, 4, 5, 6, 7, 8 characters, or records in this case, and then read 4 records and then stop. I'm going to arrow up to bring back the last DD command, and I'm going to add in the option skip equals 8. So we will skip 8 characters, we will read 4 characters, and then stop. Catting the output file .txt shows the word sum. And if we take off the count equals 4 and rerun the command, it skips 8 characters and then prints out the rest of the file. One thing that I want to mention here about the DD command is that the order does not matter. So if I type DD and I start with BS equals 1 and then skip equals 8 and then the output file, then the count, then the input file, it will not make a difference. Pressing enter and then cat output file.txt still shows sum. So the DD command is just DD space option equals value space option equals value for however many options that DD statement has in any order. A few videos back, I used the DD command to stress a CPU. To do that, I type the command dd if equals /dev/0 and then OF equals /dev/null. Running that command stressed out a single CPU, taking it to around 100% usage. And if we wanted to stress out more CPUs, we could submit that command again for each CPU we want to stress. And that's one way of stressing a CPU. Looking at that command a little closer, we have the output file of dev/null. Now there's not much more we can say about that. When we write to /dev/null, the output is just gone. So it's like sending the output to a black hole. It's gone forever. It does not get written out anywhere. But the input file of /dev/0 could be handy if we want to zero out a file. I'm going to change the DD output file from /dev/null to output file.txt. And then I'm going to add BS equals 1 and count equals 10. Running that shows 10 records in, 10 records out, and 10 bytes copied. Now when I say it's writing zeros to the output file, if I type less output file.txt, you might think we are going to see 10 zeros written in there. When I press enter, we see output file.txt may be a binary file. Do we want to see it anyway? I'm going to type N for no and not less that file. We can see the hex values of what is in that file with the command xxd output file.txt, and we see all the bits are set to 0. To explain this a little better, let's write 10 character zeros to the output file.txt. I'll do that with echo 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros, and we're going to send that to output file.txt. I'll cat that out, and we see the zeros, And when we look at that in hex with xxd output file.txt, we see the hex value for the number 0 is actually 30. And then that last value of 0a is a line return. Now, instead of filling our file with zeros, I might want to fill that output file with some random characters. Bringing back that dd command, I will change the 0 to be urandom. There is also a random. The random feature is said to have some blocking issues, and urandom is said to be for unlimited random numbers. Some systems have random as an alias to urandom, so in those cases, it does not even matter. In general, I use urandom. Pressing enter. Now, if we try and cat out that output file, we see junk. And looking at in hex with xxd output file.txt, we see the random characters placed in the output file.txt. Now you might be thinking, why is this useful? And it is useful if you need to create a file of a specific size. Let's say we want to create a 10 megabyte output file. I'll bring back the dd command and change the block size from 1 byte to 1 megabyte. Pressing enter and then ls-lh, we see the output file has a size of 10 megabytes. If we need a 1 gigabyte file, I'll bring back that command, change the 1 megabyte to 1 gigabyte, and run it again. This time it'll take a little longer to create a gigabyte of data. That was creating a 10 gigabyte file. I had it set to 10, so I canceled out. 1 gigabyte, but we only want to count to 1 to get 1 gigabyte of data. Now I'm running it again and typing ls-lh shows our output file.txt has a size of 1 gigabyte. In the next video, we will continue looking at the dd command with disk images for the Linux command line. In this video, we're going to look at the dd command specifically for copying disks. I will type lsblk to show that I have two 2 gigabyte USB drives in my computer. One of the 2 gigabyte USB drives is SDB, and it has 4 partitions on it. The second 2 gigabyte USB drive is SDC, and that has 2 partitions on it. Before I run the dd command to copy a USB drive, I'm going to unmount both of the USB drives. We may not need to unmount the input file disk, but I prefer to unmount both disks before I use the dd command. And again, I'll type the lsblk to show that they are now both unmounted. I'm now ready to copy the SDB drive to the SDC drive. And in this case, both drives are the same size, 2 gigabytes. They don't have to be the same size, but the output file device needs to be the same size or larger than the input file device, or that image won't fit. To copy a disk, I will start the dd command with dd, then if for input file, and I want the input file to be /dev/sdb, then a space, then OF for output file, then the equals, and /dev/sdc. So this command is going to wipe out whatever is on the /dev/sdc drive. Before hitting enter, make sure to double check your input and output devices. A typo when using this command could be catastrophic. When I press enter, I get a permissions denied message. I did not need to be a privileged user when I ran the dd command in the last video, and that's because in the last video, we were not trying to read or write to any USB devices in the /dev directory. So I'll press the arrow up and bring back that command, and I'm going to add sudo to the beginning of it. And I'm also going to change the block size. I'll change that block size by adding bs equals 1m. And the 1m is for 1 megabyte. I ran some tests with different block sizes, and I found that 1 megabyte worked well on this computer. And then the last thing I'm going to add to this command is status equals progress. Adding status equals progress will show how far along we are in the command. I'll press enter, and our DD statement is running. I'm going to pause the recording until the command has completed. The command has completed, and I want to mention at this time that sometimes the lights are still flashing on the USB drives after the command completes. It's best to wait until the lights stop flashing on the USB drives before doing anything with them. The command is done. We see the number of records in, number of records out, and total bytes. The seconds it took, in this case 409.853, which is just around 7 minutes. It transferred at a rate of 4.9 megabytes per second. I will clear the screen and type lsblk. And we see that the dev SDB and the dev SDC are now exactly the same, which is just what we expected. So that's how we can copy one drive to another drive of the same size. I'm going to clear the screen again and type lsblk. And we'll notice that the SDC drive is mounted again because I unplugged the SDC drive and plugged it back in, so it auto-mounted for me. And then I've added an SDD drive, which is only 1 gigabyte in size, and that is mounted as well. I'm going to unmount those partitions with umount/dev/SDC1, and then we're going to do the same for 2, 3, and 4. We're also going to unmount SDD1. And typing lsblk shows that they are all unmounted. So the SDD drive is only 1 gigabyte and the SDC drive has 2 gigabytes. If I use the DD command to try and copy the 2 gigabyte dev SDC drive to the 1 gigabyte dev SDD drive, we will get an error once the disk runs out of space. The error will tell us that there is no space left on the device. But when I run the DD command the other way and we write the 1 gigabyte drive to the 2 gigabyte drive, it will write as expected, but the space on the 2 gigabyte drive will be limited to 1 gigabyte. Let me run this command right now so we can see what the problem is and how to fix it. Sudo ddif equals dev SDD of equals dev SDC. I want the block size equal to 1 megabyte and the status equals progress. The command is running, and once again, I will pause the video while the DD command runs. The job completed, and I'm going to open up the GUI program gparted so we can get a good look at what the SDC device looks like now. Here we see the device SDC1 is now using only 952 megabytes. The 1 gigabyte image was copied over to the 2 gigabyte drive, but it only wrote out that 1 gigabyte image, meaning it is only using 1 gigabyte of that drive space. We still have 1 more gigabyte of drive space going unused. The easiest way to make the entire disk usable is to resize that partition in gparted. I will click on the partition, and then I'll click in the menu partition, and then click resize/move. A pop-up opens up with a bar showing how much disk space that partition is using. I will click and drag this arrow over on the right all the way over to fill up the entire disk space. I'll click on the resize move button, and it returns me to the home screen. No action's been done yet. Just like the fdisk command, we have to apply our changes or write them out. To do that, I will go under Edit and then Apply All Operations. Clicking the Apply All Operations is giving me a second chance to review my changes before making them permanent. I want to apply these changes, so I will click Apply. And the disk is being updated to use all the available space on that disk drive. I don't need to save the details, so I will click Close. And now our drive looks correct. It is. And that's the easiest way to copy a drive over to a larger drive. Now I want to write a disk image to a file so that I can restore back to that image whenever I like. Now we cannot just copy a disk image to a directory like we did when copying to another USB drive. What I mean to say is, if I type sudo ddif equals dev sdb of equals home Michael disk image backups, this will not work. We would get a failed to open error or not allowed to write a device to a directory. And the reason it won't work here is just what the error would tell us. We cannot write a device to a directory. We can write a partition into a directory this way, but it will not work the way I have this command showing right here. To dd a device into a directory, we will need to write it into a file first. So to write this device to a file, we'll start off the same way with the sudo ddif equals dev /sdb, but I'm going to remove this OF output file, and instead I'm going to pipe this into gzip. And then I'm going to send the output from the gzip command to the home Michael disk image backups directory. And then I'll give it a file name of sdbimage.img.gz. If I want to add the block size or status, I cannot add them to the end because that's not the dd command anymore. This is the gzip command. To add the block size of 1M, I will have to go to the left of the pipe symbol and add it there. BS equals 1M, and I will add status equals progress. I'll press enter to get it going. And once again, I'll pause the video while the command completes. Okay, our dd command has completed. And to see the file, I'm going to type ls-lh/home Michael disk image backups. And there we see the image backup of sdbimage.img.gz that I just created. Now what we've created is an image backup. Our backup is the same thing we have when we download a Linux distribution ISO file. The name ISO comes from a format to create CD-ROM images. The backup we just took can be considered an ISO image. I'm going to type lsblk again, and we'll see that I've just added another 2 GB USB drive, /dev/SDE, that we're going to restore our backup into. The first thing I want to do is unmount that USB drive with umount/dev/SDE1. To restore from our gzipped backup file, I'm going to type gzip-dc. Now the D is to decompress and the C is to send the data to standard out. Then I'll give it the file name I want it to use, which is home Michael disk image backups. And then the file itself is sdbimage.img.gz. And what I'm going to do now is I'm going to pipe that into sudo dd of for output file equals /dev/SDE. Now this input file could be a Linux ISO file. If it's already compressed, we would use that same command. If the ISO file is already unzipped, we would leave off the D and just have -C before the file name. I'm going to press enter to start this restore. And again, I'll pause the video until the command completes. The restore is complete. I'm going to type lsblk to show the disks once again. We're going to be looking specifically at the SDE drive. And here we see that the SDE drive was restored to our backup, which was a backup of the SDB drive. In the next video, we will continue looking at the Linux command line. In this video, as well as the next few videos, we're going to look at LVM. LVM stands for Logical Volume Manager, and it's another way of managing disk storage. LVM makes it easy to add a second disk drive and then expand into that new drive space, or we can create a mirror copy or create a snapshot, all using LVM. And we will look into all of those things in this group of tutorials. Let's first look at what we need to use LVM. The first thing we're going to do is make sure that we have LVM2 installed on our system. It is normally installed on Ubuntu-based systems, but I will check by trying to install it with the command sudo apt install LVM2. And we see here that it's already installed, so I'm good. When using LVM, there are three parts of the Logical Volume Manager that we should be familiar with. They are the PV, physical volume, the VG, which is the volume group, sometimes referred to as the virtual group, and then there's the LV, which is the logical volume. We will see those initials are often used with LVM. So that's why I'm introducing them to you at the beginning of this video. Let's start with the PV, physical volume first. Physical volumes are hard drives. I'm showing a picture of USB drives here to show that we are talking about actual physical hard drives. They can be USB drives, internal drives, SSD drives, any physical hard drive. And notice that the SDC drive has two partitions. With LVM, we can use the full device drives like SDB and SDD, or partitions like SDC1 and SDC2. We will have to run a command to make that physical disk a usable PV physical volume for LVM. We'll do that in a moment. Right now, we're going to continue on to the second thing I said we needed to be familiar with for LVM, and that is the VG, or volume group. In this picture, we can see that the blue area represents a volume group, which is made up of 4 drives, or 5 partitions. The SDC has 2 partitions. You can think of a volume group as a virtual hard drive. That's why VG is sometimes referred to as a virtual group, because it's not a real hard drive, but Linux will recognize this group as a single device. So we can have multiple physical volumes used to create a single volume group. And then we can add more physical volumes or remove them from a volume group as needed. The third thing we need for LVM is an LV, a logical volume. And the logical volume works like a partition, the way a volume group works like a hard drive. In this picture, the orange is meant to represent a logical volume on the blue volume group, which is all on a single SDB physical volume. And we're going to use the rest of this video to show how to set up LVM like this image. I have the image on the left here so we can refer to it as we type in the LVM commands. To see what physical drives I have to work with, I'm going to type lsblk. And we see I have added drives to this computer. SDB, SDC, which has 2 partitions, SDC1 and SDC2, SDD, and SDE. We are only using SDB in the picture on the left, so that's the only drive we're going to use in this video. Before we set up the SDB device for LVM, I want to show some LVM commands. We will need to be a privileged user to use LVM, so I will start all of my LVM commands with sudo. The commands I want to show right now are sudo pvs, which stands for Physical Volume Summary, and since we don't have any physical volumes created yet, nothing shows. The next one I want to show is sudo vgs, which stands for Volume Group Summary. And again, there's nothing created yet. And the last one is sudo lvs for logical volume summary. I'm hoping you see the LVM command pattern here. That's why I started out the video telling you about the PV physical volume, VG volume group, and LV logical volume. It's time to set up the SDB device for LVM, which will be our LVM PV physical volume. The command we will use to set up the PV physical volume is sudo pv create /dev/SDB. And we see the response, physical volume /dev/SDB successfully created. So now we can use this dev SDB device for LVM. I want to make sure this physical volume was actually created. So I'm going to type the physical volume summary command, sudo pvs, and we see here that our device SDB is created with a format of LVM2, physical size of 1 GB, and the entire gigabyte is free. Another command we use a lot in LVM is sudo pv display. And this shows pretty much the same information as the PV summary for the physical volume. I'm going to clear the screen. And now we're on to the second thing I said we need for LVM, the VG volume group. To create the volume group, I will type the command sudo vg create. Then we need to give the volume group a name. Since the picture has a blue volume group, I will call this volume group blue. And then to remind me that this is a volume group, I will add an underscore VG. This is added just for me, to remind me this is a volume group. You do not need to add in the underscore VG. And then lastly, I will need to tell LVM where I want this volume group to be placed. And I want this to go on the /dev/SDB device. That's the one we already set up for LVM. If I wanted this volume group to be on more devices, I could add them here, like /dev/SDC1 and /dev/SDD. And then the blue underscore VG volume group would be the size of the SDB drive, the SDD drive, and the SDC1 partition. And you might say, hey, but you didn't yet format those other two devices for LVM. And you would be correct. When creating a volume group, LVM will just think, you must have forgotten to format that physical volume. So I will format that physical volume for you. So did I lie when I said we had to create the physical volume first? Well, not really. It still gets done first, but steps 1 and 2 are just done together. I'm going to remove the other two devices here. So we just have the one SDB physical volume that we already set up for LVM. Pressing enter, we see our volume group blue underscore VG successfully created. And then typing sudo VGS for volume group summary shows us the volume group name of blue underscore VG. It is on a single physical volume. There are no logical volumes. And the size of the volume group is 120 megabytes. And we have 120 megabytes free. Now typing sudo vg display. This shows us the volume group name of blue underscore VG, the format of LVM2, the volume group access is read-write. One thing I do want to point out here is the volume group size of 120 MB. Then we see the PE size. PE stands for physical extent, which has a size of 4 MB. And then we see the total PE is 255, which is just 1020 divided by 4. This doesn't mean much now, but in future tutorials, we'll see why this is important. I do want to point out that in real life, 1000 megabytes equals 1 gigabyte, and 1024 megabytes equals 1 gigabyte. But for this video and the entire LVM grouping here of videos, I'll try and use the correct word, so please forgive me when I use megabytes and I mean mebibytes. Okay, back to the video. Now we just need to add that third part, the logical volume, and I will create that with the command sudo lv create. And then I'm going to add a dash lowercase l. And that lowercase l lets LVM know that we're going to give it a percent of how much disk space we want to use. I want to use 100% of the free disk space available. Then we will need to tell it which volume group we want to use 100% of that free disk space. And that will be the volume group blue_VG. We also want to give our logical volume a name. So I'll add a dash lowercase n for name, then the space, and we will call this logical volume orange_LV. And again, the _LV is just for me. We do not need this to be part of the name. When I press enter, we get the message logical volume orange_LV created. Just like the other LVM commands, I'm going to check this out with sudo lvs. And we see the logical volume name, the volume group, and the size 1020 megabytes. We cannot yet read or write to our LVM logical volume because we have not yet added a file system to that logical volume. We will also need to mount that logical volume before we can use it. And we will do that in the next video for the Linux command line. In the last video, we started looking at LVM and we said that there are three main parts of LVM: the PV physical volume, the VG volume group, and the LV logical volume. Then we made the device dev SDB an LVM physical volume, and we created a volume group with just that single dev SDB hard drive, and we called our new volume group blue_VG. And we said that the volume group would be recognized by Linux as a single device like a new hard drive. The last thing we did in the previous video was create a logical volume on our volume group. And we gave our logical volume the name orange_LV. And we said that the logical volume acts like a partition. Now we want to add a physical system to the orange LV logical volume. But before I do that, I want to see some information about the logical volume. So I will type sudo lv display. And the line I'm interested here is the LV path. And we see that it is /dev/blue_VG/orange_LV. And we can recognize that format as /dev/volume group/logical volume. We make a file system on the logical volume the same way we make a file system on a standard partition, but instead of the partition name, we give it the /dev/volume group/logical volume. So I will type sudo space mkfs, then a dot, and then the file system we want to use. In this case, I will make this ext4, and then I will add the logical volume file path. Pressing enter, we see that the ext4 file system is now created on our logical volume orange_LV. And now I want to mount that logical volume with the ext4 file system on it, but I have not yet set up a location to mount it. I want to mount it in my /mnt directory, so I will type cd/mnt and ls-lh to see what we have in there, and it is empty. So I will create a directory with sudo mkdir for make directory, and I will call this lvm1. And then an ls-lh to show that it's there. And I see the new lvm1 directory is created. To mount that logical volume to our new directory, I'm going to type sudo mount, and then I'm going to use that same logical volume path that we used to create the file system, /dev/blue_VG/orange_LV, then a space, and then the directory that we want to mount this to, which in this case is /mnt/lvm1. Now, anything we put in the /mnt/lvm1 directory will go on our SDB drive, at least until we unmount that drive or shut down the system. I'm going to clear the screen, and we can see that file system was added by typing df-h. Then we see at the bottom the /dev mapper/blue_vg-orange_lv is mounted on /mnt/lvm1 and is using 986 megabytes. And if we want to mount the LVM volume every time the system starts up, we'd go back to video 83 that shows how to mount a hard drive on startup. We are not going to do that here. And now that we have LVM all set up and working, I'm going to show how to totally remove LVM from the system. And we will start by unmounting the logical volume with the command sudo umount /dev/blue_vg/orange_lv. Now I want to remove the orange_lv logical volume. To do that, I'll run the command sudo lvremove. And then we need to give it the volume group as well as the logical volume name, because we may have multiple volume groups and that same logical volume name could appear on more than one volume group. So I will type blue_vg, then a /, then the logical volume name of orange_lv. Pressing enter, and LVM is asking me to confirm that I really want to remove the logical volume orange_lv in the volume group blue_vg. I do, so I will press Y and enter. And we see the message logical volume orange_lv successfully removed. To show that it's actually gone, I will type sudo lvs for logical volume summary, and nothing is there. Let's show that the volume group is still there with sudo vgs for volume group summary, and we still have one volume group. I will remove that with sudo vg remove blue_vg. And we see volume group blue_vg was successfully removed. Now when I type sudo vgs, nothing shows. And then the last thing we need to do is remove the LVM physical volume. I will show that it's there with sudo pvs. And if I spell sudo correctly, sudo pvs, it should work this time. There we see the single LVM physical volume setup, and I will remove that with the command sudo pvremove /dev/sdb. Typing sudo pvs again shows that there's no LVM on this system. In the next tutorial, we will continue looking at LVM for the Linux command line. In the last video, I deleted the LVM we created, and now I'm realizing that maybe I should not have deleted it quite yet. So I'm going to quickly set up LVM similar to the one that we had. I'm going to start by creating the blue volume group with sudo vg create blue/dev/sdb. And we see two lines here showing that LVM created an LVM physical volume on device dev SDB, and then created a volume group with the name blue on that physical volume. Now I'll set up a logical volume with the command sudo lv create, and this time I'm going to use a -uppercase-L. Last time we used the lowercase l to set a percentage. This time I'm using the uppercase L to tell LVM that I'm going to give it a specific size, and I want that specific size to be 500 megabytes. And that will go on the blue volume group, and then I'll add -n to give this a volume name of orange.
And then we get the message, logical volume orange was created. I want to add a file system to that logical volume. I will do that with sudo mkfs.ext4, and that will go on /dev/blue/orange. And then we want to mount that on the directory we created in the previous videos. So I will type sudo mount /dev/blue/orange. And we're going to mount that on mnt/lvm1. And that LVM1 directory is one we created previously. To make sure that was mounted okay, I'm going to clear the screen and type df-h. And at the bottom, we see dev mapper blue-orange is mounted on MNT LVM1. Now let's create another logical volume with the command sudo lv create. Again, I'll use the -L to give it a specific size of 250 megabytes. I want to put this logical volume on the blue volume group. Then I'll add a -N for the logical volume name, and I will give this volume group a name of red. Notice we get a message here, rounding the size to full physical extent, 252 MB. We'll talk about this in a few moments. And then the other message we see is that the logical volume red was created. I'm going to add a file system to our logical volume red with the command sudo make fs for make file system, and we're going to make this one xfs. And I'm going to make this an xfs file system just to be different than the ext4 that we have on orange. And we need to add in the dev blue red. Now I want to mount this, but first I need to create a directory. So I will type the command sudo mkdir/mnt/lvm2. And then I can mount our new file system to the lvm2 directory with the command sudo mount /dev/blue/red. And then we're going to mount that on mnt lvm2. And to make sure it's mounted okay, I'm going to clear the screen and type df-h. And we see it there at the bottom. Dev mapper blue-red is mounted on /mnt/lvm2. At this point, we have an LVM setup that looks something like this. And I've color coordinated our slide to match the name of our volume group and our logical volumes. We started with a 1 gigabyte hard drive, shown here in this picture as a USB drive. Then we created the blue volume group. LVM also created the LVM physical volume on the /dev/SDB device. Then we created the orange logical volume that uses half of the blue volume group. After that, we created the red logical volume that is the size of about a quarter of the entire volume group, leaving that last quarter free for another logical volume or expansion of one or more of the logical volumes already in this volume group. And I went over that pretty quick because this is pretty much a review of what we did over the last 2 videos. Now we know our LVM looks like this because we just created it and it's fresh in our minds. 6 months or a year from now, we will probably have forgotten what this LVM looks like. So now we're going to use the LVM commands as we would in 6 months or a year from now to recreate this picture. Let's start by looking at the physical volumes. I will type the command sudo pv display. And we see that the physical volume name is dev SDB. The physical volume size is 1 gigabyte, and we have 4 megabytes that are not usable. The PV extent size is 4 megabytes, and we have a total PE of 255. Let's look at these a little closer. The first one, the physical volume name, it's pretty obvious. It is just the physical hard disk setup for LVM use. If we had more drives set up for LVM, they would be listed in that PV display as well. The PV size is showing us that there is 1 gigabyte available for this physical volume, which is the same as 1024 mebibytes. But 4 mebibytes are unavailable, probably used by LVM. So only 1020 mebibytes are available for this volume. The PE size is 4 mebibytes. PE stands for physical extent. So the physical extent size is 4 mebibytes. Physical extents are important because physical extents are what LVM uses to store the LVM data. And all the LVM data is stored on these little 4 mebibyte physical extents. And then we have a total of 255 physical extents, which is the amount of LVM disk storage that the /dev/SDB device has to work with. And you probably already noticed that the 1020 mebibytes divided by 4 mebibytes is 255, the number of physical extents available. We also see on the screen the allocated physical extents of 188 and the 67 physical extents that are still free or available. Now let's look at the volume group information with the command sudo vgdisplay. At the top here, we see the volume group name is blue. If we had multiple volume groups on this LVM, they would show here as well. Other things of interest here are that we have 2 logical volumes on this volume group, and that this volume group is on a single physical volume. We see the VG size of 1020 mebibytes and the physical extent size of 4 mebibytes. Then we see our total physical extents of 255 with the allocated of 188 and the free of 67, which is the same as used 188 and still available of 67. And those are also shown in mebibytes. Now let's look at the logical volume information with sudo lvdisplay. But before I hit enter, I'm going to add a -m to this command to also include the logical volume mappings. This is showing us both logical volumes. Let's go to the top and start with the orange logical volume. And we can tell which logical volume we are looking at from the LV name. We are looking at orange at the moment. We see it's on the volume group blue. Our logical volume has a logical volume size of 500 mebibytes, which is the same as 125 logical extents, which is 500 divided by 4. Each extent is 4 mebibytes. And looking down in the mappings section, we see that the logical volume orange is on physical volume /dev/SDB. And we said that we were using 125 logical extents. And those logical extents are on physical extents 0 through 124 on the /dev/SDB drive. And it's 0 through 124 because with computers, we always start with 0. To see that more visually, let's go to a picture. Back in our picture at the top, we see the logical extents of 0 through 124. And then at the bottom, we see the volume group physical extents of 0 through 124. Now let's look at our logical volume red and the information for that. We'll first start with the logical volume name, make sure we're on red, and we see that's on the volume group blue. And then our logical volume size is 252 mebibytes. Remember a few minutes ago when I requested 250 megabytes for this logical volume? But LVM bumped me up to 252 megabytes and gave me a message letting me know what it was doing. Now we know the reason for that bump of 2 megabytes. LVM wanted to make sure it would use all the disk space. And since LVM stores its data in 4 mebibyte extents, it bumped me up to 252 mebibytes, which is a number evenly divisible by 4. 252 megabytes is the same as 63 logical extents. So then down at the bottom, we see that the physical volume is dev SDB, and that the logical volume logical extents are 0 through 62, and then they sit on physical extents 125 through 187. So now our picture looks like this. Up at the top, we see the red logical extents. There's 68 of them, and they're sitting on logical extent 0 through 67. At the bottom of the picture, we see the physical extents. So the 68 logical extents are on physical extents 125 through 187. And then physical extents 188 through 255 are still available for that volume group. We will expand our volume group and our logical volumes in the next tutorial for the Linux command line. We are picking up from where we left off in the last video, where we have already set up LVM to look like this picture. What I want to do now is double the size of the orange logical volume. But there is not enough disk space on this device, so I'm going to add another device to this volume group. I'm going to check what devices are on this computer with the command lsblk. And we see SDC, SDD, and SDE are all available. I'm going to use the partition SDC1 on the SDC device just to show that LVM can use partitions as well as an entire disk. I want to expand the blue volume group to include partition SDC1. But before I do that, I want to show what physical volumes are currently being used by LVM. So I'll type the command sudo pvs. And we see only one device, dev SDB. Now I will add the dev SDC1 to the blue volume group with the command sudo vg extend blue /dev /SDC1. And we see two messages. The first one, physical volume dev SDC1, was successfully created. We could have done that step manually. And the second message is volume group blue successfully extended. Let's double check to make sure the new partition was added with the command sudo pvs. We see we now have two physical volumes, dev SDB with the volume group blue and a physical size of 1020 megabytes, and dev SDC1 with the volume group blue and a physical size of 496. So it looks like our SDC1 partition was added to volume group blue as expected. Now let's check the volume group with the VGS command, sudo VGS. And we see volume group blue now has two physical volumes and two logical volumes, and a volume size of 1.48 gigabytes. So the volume group was extended as expected. Checking our logical volumes with the command sudo lvs shows logical volume orange is still 500 megabytes and logical volume red is still 252 megabytes. So we have not extended any logical volumes yet. I want to extend the logical volume orange 500 megabytes. I'll do that with the command sudo lv extend -L plus 500m /dev /blue /orange. And I'm using the uppercase L because I want to give it a specific size. And the plus sign before that 500 megabytes is very important. We need the plus sign to say we are adding 500 megabytes to our logical volume. Pressing enter, we see a message that logical volume blue-orange has changed from 500 to 1000 megabytes, or from 125 extents to 250 extents. Then we see that logical volume blue-orange was successfully resized. To make sure the logical volume has resized as expected, I will type sudo lvs for logical volume summary. And we see the logical volume orange on volume group blue is now 1000 megabytes. Now let's confirm the file system size was updated properly by clearing the screen and typing df-h. And we see that file system blue-orange has a size of 452 megabytes. So the file system did not get resized. We had a similar situation in video 90, and I used the GUI application gparted to increase the file system size. In the comments of video 90, YouTuber Creative SRM called me out for using the graphical tool gparted to resize a partition in a command line tutorial series and wanted to know how to resize a partition in the command line. Well, gparted does not work with LVM logical volumes, so I cannot use that GUI partition tool to increase the file system this time. So here we will use the command line. Before I can submit the CLI command to increase the file system, I will have to know what kind of file system we have on that logical volume. A quick and easy way to check that is with the command lsblk-f, and the F is for file system. And here we see that orange is using ext4 and red is using xfs. To increase the size of the ext4 file system of the orange logical volume, I will type sudo resize 2fs dev blue orange. And I'll note that resize 2fs is only used for the ext4 file systems. We'll use a different command for the xfs file system. And to make sure this worked, I will type df-h, and we see here that the disk size of the blue-orange volume group has increased to 921 megabytes. Now let's check that volume group with the sudo lvdisplay-m command. I'll go up to orange, and we see the LV name is orange, the LV size is 1000 megabytes, and the LV logical extents is 250. And then down in the mappings, LVM started adding extents on device SDB. It added extents 125 to 199, on the physical extents 188 to 254, and then it ran out of room. So then it went down to the dev SDC device and added the logical extents 192 to 249 on physical extents 0 to 57. Let's put this all together now with some pictures. We ended the last video, started this video with the logical volume orange at a size of 500 megabytes, the logical volume red with a size of 250 megabytes, and then there was still 250 megabytes available on the blue volume group. We extended the volume group blue another 500 megabytes by adding partition dev SDC1. Then we added 500 megabytes to the orange logical volume, and our image now looks like this. We see LVM was able to add 67 extents, or 268 megabytes, on device SDB, and then it ran out of room, and it added the remaining 58 extents on device dev SDC1 on physical extents 0 through 57. Now let's extend the logical volume red to take up the rest of the free disk space in the blue volume group. I'll do that with the command sudo lv extend -l plus 100% free /dev/blue/red. And here we're using the lowercase l because we're giving LVM a percentage. And again, we need to make sure we have that plus sign before that 100% free to show that we are adding this space. And then we put in the dev volume group of blue and the /logical volume of red. Pressing enter, we get the message that the logical volume red has changed from 252 megabytes to 516 megabytes, and the logical volume blue-red was successfully resized. Typing sudo lvs shows logical volume read has been increased to 516 megabytes. Let's check that file system by clearing the screen and typing df-h. We see here that DevMapper Blue Red is still only at 247 megabytes. To expand the XFS file system on logical volume read, I will type the command sudo xfs_growfs/dev/blue/red. And let's check that file system size again with df-h. And we see it's now at 511 megabytes, so it was extended as expected. Let's check the updated volume group and mappings now with the command sudo lvdisplay-m. And we see that LVM added logical extents 63 to 128 on partition dev SDC1, on physical extents 58 to 123. Let's look at this in a picture. And we see that logical extents 63 through 128 are on device dev SDC, on physical extents 58 to 123. There is one more thing I want to do here before I end this video, and that is to add another 500 megabytes to the orange logical volume. Let's check what devices we still have available with the command lsblk. And we see SDD and SDE. I'm going to use the SDD drive. So I want to expand the blue volume group onto the SDD drive with the command sudo vg extend blue/dev/SDD. And now I want to expand the logical volume orange 500 megabytes, but this time I want to also expand the file system at the same time. To do that, I will submit the command sudo lv extend -L plus 500m/dev/blue/orange. And then I'm adding the -R. And the -R is for resize. Pressing enter. The first one is the size of the logical volume blue-orange was changed from 1000 megabytes to 1.46 gigabytes. The second message tells us the logical volume blue-orange was successfully resized. And the last group of messages tells us the file system at DevMapper blue-orange mounted on LVM1 was also resized. Let's check that out by clearing the screen and typing df-h. And now we see that the disk space of logical volume blue-orange is now 1.4 gigabytes. So it did increase the file system size when the logical volume was extended. In the next video, we'll continue looking at LVM for the Linux command line. Typing sudo lvs shows that we're picking up from where we left off in the last video. And I'm going to remove the logical volumes used in the last few videos with the commands sudo lv remove blue/red. Yes, I really want to remove it. And then sudo lv remove blue/orange. And yes, I want to remove that one as well. We're going to keep the blue volume group, and I want to see what physical volumes make up the blue volume group with the command sudo pvs. We have two 1 gigabyte disk drives, dev SDB and dev SDD. Then we also have a partition dev SDC1 that is 500 megabytes. In this video, we're going to create an LVM mirror, and an LVM mirror is the same as an LVM RAID 1. RAID stands for Redundant Array of Independent Disks. In short, a RAID 1 or a mirror is when we have two disk drives that have the same data on both disks. So they are a mirror image of each other. We can have 3 or more disks with the same image. It would still be considered a mirror or a RAID 1.
You might be thinking, why would we want to have two disk drives with the same data? And the answer is, if one disk fails, we won't have to wait while we restore from the last backup, and we would still have lost any data entered between the last backup and the disk failing. That mirror copy will have all the data and can continue on if one of the mirror disks fails. Looking at the size of our disk drives, we're going to want to have the disks we mirror be the same size. We see that SDB and SDD are both 1020 megabytes, so we'll use them. A gigabyte is 1024 megabytes, but LVM is using 4 megabytes, or one extent, for the LVM. When we set up our mirror, LVM is going to need one extent, or another 4 megabytes, to support that LVM mirror. So instead of making our logical volume 100% of our usable space, we're going to want to make our new LVM logical volume 4 megabytes less than the total amount available. To create my first data set for the mirror, I'm going to use the regular lvcreate command, sudo lvcreate -uppercase L, and I'm going to type in the size 1016M, then a -n for the name, and I'm going to name this LV_mirror. I want to put this on the blue volume group, and I want it to go on the disk dev SDB. We get the warning a signature is detected, and do we want to wipe it? Yes, we do. And we see the logical volume LVMirror was created. Let's see what that looks like by typing sudo lvdisplay-m. And here we see the logical volume name is LVMirror, the volume group is blue, the logical volume size is 1016 MB, and right now we see this has a type of linear. Now let's convert our LVM linear logical volume into an LVM RAID 1 mirror with the command sudo lvconvert-m1 blue/lv-mirror/dev/sdd as in dog. In this command, we see M1. The M is for mirror, and the 1 is for the number of mirrors we want. If we wanted to make 2 disk mirrors, we would make this M2, and then we would add another disk at the end here. I only have one disk this size available in my volume group. And at the end where we have the /dev/sdd, that is the disk that we want to add as the mirror. Pressing enter, it's asking us if we're sure we want to convert the linear logical volume into a RAID 1 with 2 images enhancing the resilience. That is what we want to do. I'm going to press Y and enter. And our volume was successfully converted. Typing sudo lvs shows the logical volume LVMirror is on the blue volume group, has a size of 1016 megabytes, and we can see here that it is 100% synced. Typing sudo lvdisplay-m shows we have the same logical volume name, mirror_lv, the same volume group, blue, the same volume size of 1016 MB. But looking down in the segments, we now see a type of RAID 1. And below that, we see that we have an RImage 0 and an RImage 1 for RAID image 0 and RAID image 1. Typing lsblk shows us that RAID image 0 is on SDB and RAID image 1 is on SDD. Now we'll say we have a problem, or we just want to remove the SDB as in boy drive from the mirror. This would then make the SDD as in dog drive a linear logical volume. And we're going to do that with the command sudo lvconvert. And then we're going to use -m0. We're taking away the mirror. And we want to do that for volume group blue and logical volume LV_mirror. And the device we want to remove is /dev dev/SDB. And I'm asked if I'm sure I want to convert RAID 1 back to a type linear, losing all resilience. I'm going to type yes. And again, I'm going to type sudo lvdisplay-m, and this shows the RAID 1 is gone. Now we just have a linear LVM logical volume, but we move the logical volume to a new device. And now I'm going to remove the LVM logical volume LVMIR with the command sudo lv remove blue/LVMIR. Yes, I want to remove and discard active logical volume, blue LVMIR. And our logical volume is now gone. Now I'm going to create another logical volume, but this time I'm going to use all of the disk space available on that disk drive. Sudo lv create -l 100% free, and this is for the blue volume group -n, and I'll give it the name move me, and I'm going to put this on dev/SDB. So I'm saying use 100% of the free disk space on device/SDB in the volume group blue. And my logical volume was created. Typing lsblk shows logical volume move me was created on device SDB and is using 1020 megabytes, or all of the free space on the drive. Now I want to just move this logical volume from /SDB as in boy to /SDD as in dog. Maybe that drive is old and I just want to move this to a newer device. To move the logical volume, I'm going to use the command sudo lv convert -m1 blue/move me /dev/SDD. Pressing enter. It's asking me if I want to convert this to a RAID 1. Yes, I do. And here's where I get the error. Insufficient free space. 1 extent needed, 0 available. The problem is LVM needs 1 extent to make the logical volume a mirror, but we used the entire disk when we created the volume. We're just going to move this logical volume to another disk and then remove the mirror on the device SDB. So what I'm going to do is I'm going to write that LVM 1 extent to memory. And I'll do that with the command sudo lv convert -m1 -type mirror --core log. And this is for the blue volume group, move me logical volume. And the device we want to put this on is dev SDD. Pressing enter. Let's check these results with lsblk. And we see that image 0 is on SDB and image 1 is on SDD. And they're both 1020 megabytes. I'll also type sudo lv display-m, and we see this time we have a type mirror. And since now we're only moving the data from SDB to SDD, I want to remove the mirror by removing the version on the SDB as in boy with the command sudo lv convert -m0 blue/move me /dev/SDB. Again, the SDB is the one we want to remove. And I have a typo in there. Let's fix this lv convert. And we see that our blue move me was converted. Double check that with the lv display-m. And we're back to a linear on device SDD. Because we were just moving that data, it was okay to store the LVM mirror information in memory. But if we want to set up a mirror for a logical volume that takes up an entire disk, we don't want to store the LVM information in memory because when the computer shuts down and back up, that will be gone. So we want to put that on a disk. Let's check out what disk space is available with sudo pvs. And we see that we have SDC1 in this volume group. And that is where we can store the LVM mirror log information. To store the mirror log information in the blue volume group, I'm going to type sudo lv convert -m1 -type mirror. And then I want the --mirror log to go to disk. And that will be for the blue/move me. Pressing enter. And again, I've got a typo. I spelled move me wrong. And now it's properly converting. It's done. Let's see where LVM placed everything by typing lsblk. And we see image 1 is on SDB, image 0 is on SDD, and the mirror log information is on SDC. In the next video, we will continue looking at LVM for the Linux command line. I'm going to type sudo lvs, and we see the logical volume we used in the last video. I'm going to remove that with sudo lv remove blue move me. Do I really want to remove this? Yes. What we're going to do in this video is to look at how to set up an LVM RAID 0. A RAID 0 is also known as a stripe set or striped volume because it stripes data evenly across 2 or more disks. A RAID 0 has no redundancy, so if any one of the drives fail, the entire RAID 0 is unusable. This works similar to the LVM linear logical volume we set up earlier in this group of videos. We expanded that linear logical volume over multiple disks, and if any one of those disks fail, the entire logical volume is unusable. If you're already using LVM, you are probably going to want to use the standard linear logical volume over a RAID 0. But since LVM does support a RAID 0, we'll take a look at how to set that up. The command to create an LVM RAID 0 is sudo lv create --type RAID 0 --L, and I'm using the uppercase L to give it a specific amount of disk space. In this case, I want it to use 600 megabytes. Then -n to give it a name. I'll call the name LV underscore RAID 0. And then I'm going to add -I2 for the number of stripes. And we're using I for the number of stripes because S, T, and R are already used for other options. And then I want to put this RAID 0 on the volume group blue. And our RAID 0 is created. Let's see what this looks like with sudo lvs. And we see our logical volume, LV RAID 0, was created with the size of 600 megabytes. We can see more details with sudo lv display -m. And here we see the logical volume name is LV RAID 0. It is on volume group blue, has a size of 600 megabytes with 150 extents. And then at the bottom, we see a type of RAID 0, and then the 150 extents are split evenly with 75 extents on RAID image 0 and 75 extents on RAID image 1. I'm typing lsblk, and here we see that RAID image 0 is using 300 megabytes on device SDB, and RAID image 1 is using 300 megabytes on device SDC. And then, as I mentioned earlier, the RAID 0 will write the information evenly over both disks. To remove the RAID 0, I will type the command sudo lv remove blue/lv RAID 0. And yes, I really want to remove this, and it's gone. I'm going to create another RAID 0
And this time I want to tell LVM which disks to put that LVM on, and I also want to use 100% of the disk space available. Let's first see which disks we have available by typing sudo pvs. And we see that devices SDB and SDD are the same size, so I will use them. The command I will use to set up this RAID is sudo lvcreate --type RAID 0. Now I'm going to use the -lowercase l, and I want to use 100% free, and I will give it a name with the -n, lv RAID 0. The number of stripes with the lowercase I will be 2. I'm going to place this on the blue volume group, and I want it specifically to go on disks dev SDB and dev SDD. Pressing enter, and our RAID 0 is created. Let's check it with sudo lvs, and we see that RAID 0 is created on volume group blue with 1.99 gigabytes, just under 2 gigabytes. And typing sudo lv display -m shows most of the same information as our last RAID, but this one has a size of 1.99 gigabytes and 510 logical extents. And following up with lsblk shows us 1020 megabytes used for RAID image 0 on SDB and 1020 megabytes on RAID image 1 on device SDD. In the next video, we will continue looking at LVM for the Linux command line. In this video, we're going to look at the different LVM logical volume options we have and the advantages and disadvantages of each one. The first one we're going to look at is the LVM linear logical volume that we created in videos 90 and 91. In our blue volume group, we created the linear logical volume orange. Then we added another linear logical volume. Then we added more space to the orange logical volume, and we even expanded it onto another disk that was already in our blue volume group. The advantages of using a linear logical volume are the read-write speed is good. It is easy to set up. It is easy to expand the size. The size can also be reduced, but that was not shown in my tutorials because there is a chance of data loss. When adding disks do not need to be the same size as the original disk, and all the disk space can be used. The disadvantage of using a linear logical volume is there is no redundancy, so if the drive fails, all the data is lost. And if the linear logical volume is using multiple disks, if any one of those drives fail, the entire logical volume is unusable. Now we're moving on to an LVM RAID. And RAID is just an acronym for Redundant Array of Independent Disks. I keep saying LVM RAID as if there was another type of RAID option. And there is. It's called an MD RAID or MD/RAID or an MD-ADM RAID, which some people refer to as an MD-admin RAID. A typical MD-admin command would start with MD-ADM and look like this. The MD RAID works outside of an LVM environment, so we're done talking about the MD RAID for the time being. The next thing we're going to look at is the advantages and disadvantages of the LVM RAID 0 that we created in the previous video. RAID 0 is also known as striped data because it has 2 disk drives and the data will be written out or striped in equal amounts to each disk, meaning the first data will be written to one disk and then to the other, then back to the first drive, then back to the other drive again, and this pattern continues for a RAID 0. The idea behind this is that you would get the fastest read and write times when using 2 disk drives instead of 1.
Some people say that was true years ago, but disk drives have improved so much that a RAID 0 is no longer needed. I've not done any testing on this myself, so I have no idea if that's true or not. For now, we're going to say that RAID 0 has better I/O performance, and that will be our first advantage of a RAID 0. The next advantage is that there is no overhead caused by parity controls. We'll talk about parity in just a moment or two. Then all the disk space can be used. And the last advantage is that it is relatively easy to set up. The disadvantages are if one drive fails, all the data is lost. And then all the disks need to be the same size. Moving on to a RAID 1, also known as a mirror, uses 2 or more disks that have the same data on all the disks in the configuration. If one of the drives fails, the other drive or drives, if there's more than 2, can continue on without interruption. The advantages of a RAID 1 are read and write speed is good. A RAID 0 could be better, as we already discussed. Redundant data. If one drive fails, the processing can continue with the data on the other drive or drives. And that there is no overhead caused by parity. The disadvantages are half of the drive space is lost to the redundant copy. All data is written 2 times, and all the disks need to be the same size. Now we're moving up to a RAID 5. A RAID 5 is also known as striping with parity, and it requires a minimum of 3 disk drives. You can have more. When the data is written to a RAID 5, it is striped or spread across multiple disks, similar to a RAID 0. But when it writes the data on one drive, it also writes parity data across other drives. So the data is not duplicated. Parity checksum data is created for the striped data written. Creating the parity will slow down the writing of data to the disk drive. But if one drive fails, the data can be recreated from that parity data on the other drives. So a RAID 5 can continue working if one of the drives fails. With RAID 5, we lose 1 disk drive of disk space for parity, meaning if all 3 disk drives in this example were 10 gigabytes, we would only have 20 gigabytes of usable disk space available, instead of the 30 gigabytes we would have with an LVM linear configuration. That 1 disk drive of parity disk space is split onto all of the disks in the RAID 5, so it doesn't matter which drive fails. The RAID 5 can continue with a single failed drive, which can be replaced, and then after replacing that bad disk, drive speeds might be a little slower while the data gets populated to that new disk, but after that, it will be good as new. The advantages of a RAID 5 are read transactions are fast, it is fault tolerant. We don't say redundant data here because the stripes are written and then parity checksums are written, so it's not a duplication of data. The disadvantages are write transactions are slower because when it writes that data, it must also calculate the parity checksum. You lose one of the disk drives to parity data. You might have a temporary loss of performance after replacing a drive while it's populating that new disk. Now, depending on the disk drive, it could take a long time. If it's many gigabytes or terabytes, that could take days. And then all the disks need to be the same size. There's also a RAID 6. It's like RAID 5, but has double parity. To handle the double parity, it will require a minimum of 5 disk drives. 2 of the disk drives are lost to parity, but the RAID will function normally with a loss of up to 2 disk drives at the same time. The last one we're going to talk about is the RAID 10. RAID 10 is combining a RAID 1 and a RAID 0. So first we would create our RAID 0, then we would make a mirror of the RAID 0. The advantages of this are fast read and write speed for the RAID 0. We have the redundancy of the mirror. The disadvantages are it can be expensive. You need a minimum of 4 disk drives. Half of that storage is going to the redundant data or mirroring. And then all the disks need to be the same size. Now, this is just a short, quick summary of the different LVM logical volume options available. I'm sure there are more advantages and disadvantages that I missed, but I hope I have outlined the different options available to help you make the best choice for your LVM setup. In the next video, we'll continue looking at LVM for the Linux command line. In this video, I'm going to create an LVM RAID 5 logical volume. I will add some data, then remove one of the 3 disk drives and replace it, showing the RAID 5 working as expected throughout the disk drive exchange. The first thing I'm going to do is to make sure I don't have any leftover logical volumes from the previous tutorials by typing sudo lvs. And there's nothing showing, so I don't have any logical volumes at the moment. I also want to see what physical volumes I have set up and what volume groups they're in, so I'm going to type sudo pvs. And we see that I've added dev SDE to the blue volume group, and the dev SDE has a volume size of 1020 megabytes. And now we have 4 disk drives in the volume group blue that we created in one of the previous LVM tutorials. 3 of them are 1020 megabytes. They're actually all 1 gigabyte, but 4 megabytes are used to support LVM. So that's why we see 1020 megabytes instead of the 1024 megabytes. And we have 3 of the 4 disk drives which are the same size, so we can use them for our RAID 5. And if you watched the previous video, you'll remember that we will only get 2 disk drives of space. 1 disk drive of space is needed for the parity checksums, which are stored across all the disks. To create the LVM RAID 5, I will use the command sudo lvcreate, and then I'm typing --type RAID 5, then a lowercase n for the name, and the name I will give it is LV underscore RAID 5 for logical volume RAID 5. Then I will type a -uppercase L to tell LVM how much disk space I want to use for the RAID 5, and that will be 2040. I'm getting that by looking at the free size on the disks. They all have 1020, and I want to use 2 of them for the usable data, and 1020 times 2 is 2040 megabytes. Then I've got a -I to tell LVM the number of usable disks we're going to use, followed by the number 2. 2 usable disks, 2 of the 3 are usable. And the last thing I have on the line is the volume group name of blue. When I press enter, I get the error insufficient suitable allocatable extents. 2 more required. We've seen this problem before. The problem is LVM needs another 4 megabytes from each disk to support RAID. So what I'm going to do is come over here and change this 2040 to 2032. That is 2040 minus 8. And now we should be all set. Pressing enter, our RAID 5 is created. Let's check that with sudo lvdisplay-m. And we see the path is dev/blue/lvraid5. The logical volume name is lvraid5. The volume group is blue. And our size is 1.98 gigabytes, just under 2 gigabytes, which is just what we were expecting. And that 1.98 gigabytes gives us 508 logical extents. Scrolling down, we see that the 508 logical extents are on logical extents 0 to 507, and then each disk has 0 through 253, so they each have 254 logical extents. Times 2 is 508. Let's see what the disks look like by typing lsblk. And we see here that the RAID image 0 is on SDB, RAID image 1 is on SDD, and RAID image 2 is on SDE. And the disk SDC was skipped because it only has 500 megabytes available to the blue volume group. Now let's make a file system on the new logical volume with the command sudo makefs ext4, and we want to put that on dev blue lv underscore RAID 5. And we saw this as the path just a moment ago. Okay, our file system is created. Now let's mount that file system with the command sudo mount dev blue lv underscore RAID 5, and we're going to put that on /mnt/lvm1. And we created this LVM1 back in video 91. I'm going to clear the screen and type df-h. And we see here that our blue-lv RAID 5 is mounted on MNT/LVM1 and has 1.9 gigabytes available. I want to add some data to our new RAID 5, so I will cd into MNT LVM1. Let's see what's in there now. LL. We just have the lost and found, which is automatically created with an ext4 file system. We see in the upper left, I've got some pictures on the desktop. I want to copy those pictures onto our RAID 5. I'll do that with cp home Michael desktop pics, and I'm copying everything, and I want to copy them all here. And I get a permissions denied because I only gave access to root when I mounted the RAID 5. So I will have to type sudo and the same command again. Now I've got some data there. Let's check that out with LL. Now that's not very much data, so let's add some more with the dd command. Sudo dd if equals dev u random of equals new file 1. I want a block size equal to 1 megabyte and then a count equal to 300. So that should give us a 300 megabyte file of random data. Let's add one more. We'll call this new file 2, and we'll make this one only 200 megabytes. Now typing df-h shows we're using about 31% of the disk space available. To see the data, let's open up a file browser. And I want to go to /mnt/lvm1. And there we see some pictures and our 2 files of random data. So that is what is on our RAID 5. Now that we have it up and working well with 3 disks, I'm going to take out a disk. I don't have any USB drives here, so I cannot just unplug a drive. I will have to turn off the machine, take out a drive, and then add a new blank drive and power back on. Before I do that, let's just type sudo lvdisplay-m to remind us all of what we have out there. And I'll also type lsblk just to show everything working as expected, how it looks. I'm going to power off and power back on the machine, so I'll be back in a moment. Okay, I'm back and I've removed one of the RAID 5 disks and I've added a new disk of the same size. The first thing I want to do is make sure that my data on the RAID 5 is still there. I'll do that by opening up the file browser and going to /mnt lvm1. And I did manually mount this drive after restarting. So we see our pictures and the larger files are still there just as we expect. Clicking on one of the pictures. And it opens. Let's see what our RAID 5 logical volume looks like now. We'll do that with the command sudo lvdisplay-m. And right here at the top, we see a warning that one of our devices cannot be found. And that's because I removed it. Let's see what physical volumes are available by typing sudo pvs.
Again, we see the warning that a device cannot be found, and we see that device SDB, SDC, and SDD are still there. But what was on device SDE is now missing or unknown. I'm going to type LSBLK, and here we see that RAID 5 image 0 is on SDB, and LV RAID 5 image 1 is on SDD. Both of those look good. Then we see that the LV RAID 5 RMeta 2 disk is missing. We do have the new drive I added showing as SDE, and because it's new, it has not yet been added to LVM. To add the new disk into the volume group blue, I will type sudo vgextend blue/dev/SDE. We do see volume dev SDE successfully created, and we also see volume group blue successfully extended, but we also see that LVM is complaining that it cannot find the old disk that I had removed. We'll come back to that problem in a moment. First, I want to add a new drive to the RAID 5 logical volume, and I'll do that with the command sudo lvconvert --repair, and we want to repair the blue/LV_RAID 5. Pressing enter. I'm getting a message telling me that the repair requires a full device resync. I'm good with that. I'll press Y and enter. And now I see the message, faulty device in blue LV RAID 5 successfully replaced. Let's check out the RAID 5 logical volume now with sudo lv display-m. And besides the warning at the top, it looks pretty good. I'll also type lsblk. And we see nothing is missing here. The RAID 5 has been repaired as expected, but we still get that warning message when we type just about any LVM command, like sudo pvs. And there we see the warning could not find device and that VG blue is missing device. So to get rid of that message, I'm going to type sudo vg reduce -- remove missing from blue. So we're going to VG reduce, volume group reduce, and we're going to remove the missing from the blue volume group. Pressing enter. Our last line there shows wrote out consistent volume group blue. So we should be good now. Let's test it with that same command, sudo pvs, and we no longer get that warning. And one more thing to check. Let's check out the data on the RAID 5 one more time just to make sure it's still there and working. I'll open back up that file browser and click on a picture. We'll pick waterfall. And it shows our data is still good. So we've successfully removed and replaced a disk in an LVM RAID 5 configuration. In the next video, we'll continue looking at LVM for the Linux command line. In this video, we are going to look at using LVM on an Ubuntu operating system. First, I will install Ubuntu to use LVM. Then I will use the command line to add a new disk and increase the Ubuntu operating system disk space. I've downloaded and powered up into the most recent stable version of Ubuntu, which at the time of this recording is Ubuntu 22.04.4 desktop. And I am at the Try Ubuntu or Install Ubuntu screen. From here, I'm going to click on Install Ubuntu. And at this keyboard layout screen, I'm going to keep the defaults of English, US for both, and click Continue. For the updates and other software, I'm going to select the normal installation, and I will keep the checkbox checked for download updates while installing Ubuntu. And I'm also going to check this Install Third-Party Software checkbox, and then click Continue. On the installation type page, this is the page where I want to make some changes.
I'm going to click on the Advanced Features. Then I'm going to click on the radio button for Use LVM with new Ubuntu installation. And I am not going to click on the Encrypt the new Ubuntu installation. I will click OK and then Install Now. Here it's asking me to confirm I want to write these changes. I do. I'll click Continue. For the time zone, New York will work. I'll click Continue. Now Ubuntu is asking me for my information. I will add in the information. Name, Michael, computer name, LVM Ubuntu, username Michael. I'll add a password. I will require my password to log in. I'm not using Active Directory, and clicking Continue. The install process is started. I will pause for a moment while that completes. The Ubuntu install is complete. I will restart it now. I've restarted the computer, and before I started recording, I skipped past the Ubuntu first boot questions. I've updated Ubuntu and then restarted again. And then I started recording. Now what I want to do is look at how Ubuntu has set up LVM. For this, I'm going to open up a terminal by clicking in the lower left here. And then I see terminal. I'm going to grab that and drag it over and place it into the quick launch toolbar. And click on it to open it up. I'll make this a little bigger by holding down Control, Shift, and the plus sign. Now let's use the LVM commands we learned in the previous tutorials to see what's going on. I'll start with sudo pvs. And we see here there is one disk set up for LVM, dev SDA3, and it is in the volume group VG Ubuntu, which makes sense. VG for volume group, and then Ubuntu. Typing sudo VGS shows us the volume group information. And we see here that we have one physical volume and we have two logical volumes. Let's learn a little more about the logical volumes with the command sudo lvs. And we see we do have two logical volumes, a root logical volume and a swap_1 logical volume. And again, this makes sense. We need swap space. We talked about swap space in an earlier video. It helps the RAM memory. Even if we have a ton of RAM memory, we would still want to set up some swap space. And then the root logical volume is where all the Ubuntu operating system information is and the user information. Typing lsblk. Here again, we see the root file system and the swap file system. And then I'll clear the screen and type df-h and the / for the root file system. And we see that the disk size is 14 gigabytes. We've used 9.3, so we have 3.6 gigabytes available. So 3.6 gigabytes is not a lot of space for everything I might want to put on this computer. And since we're using LVM, I can just add another disk to this and then add it into the volume group, and we can add it to our logical volume. To do that, I'm going to have to power down, add a hard drive, then I will power back up, and we can add the disk drive to our volume group. Before I power down, let's take another quick look at what we have with lsblk. And now I'll power down and add in a new disk. Okay, I've added a 10 gigabyte hard drive and restarted the computer. Let's see what that looks like by typing lsblk. And here we see SDB is our new 10 gigabyte device. Before I add in the new disk, let's see what the current logical volumes look like with sudo lv-display-m. And we see our first logical volume root is on volume group VG Ubuntu, has disk space of 13.87 gigabytes, and is on the volume dev SDA3. And then our swap space is also in volume group VG Ubuntu. It's only 1.59 gigabytes and is also on physical volume dev SDA3. I'm going to add the new disk to the volume group VG Ubuntu with the command sudo vg extend VG Ubuntu /dev/SDB. And we see dev SDB successfully created, VG Ubuntu successfully extended. So it looks like everything worked as expected. I'm typing sudo pvs, and we see the new disk drive I added, dev SDB, with a size of 10 gigabytes, and is added to volume group VG Ubuntu. Now we want to add that new disk space to the root logical volume, and we're also going to want to expand the file system as well. Let's check out the current file system by clearing the screen and typing df-h with the / to show the root directory. And here we see the VG Ubuntu root is 14 gigabytes total. I'm going to add 10 to it, so it should be about 24 gigabytes. Do you remember the command from the previous tutorials to add new disk space to a logical volume? It starts out with sudo lv extend. Then we want to give it the amount of disk space I'm going to extend, and I'm using the -l because I want to give it a percentage. And I need the plus sign because we're adding the percentage. I want this to be 100% of the free space available. And the free space I'm referring to is in the dev VG Ubuntu volume group. And we want to add it to the root logical volume. And I also want to add a -r to resize the file system as well. Pressing enter. It looks like it was resized properly. Let's check that out with df-h /. And now we do see the 24 gigabytes. So that was added properly. Let's check out lsblk. And there we see SDB has been added to VG Ubuntu root. And now let's check out what the logical volumes look like with sudo lv display -m. We see that the size has changed to 23.9 gigabytes. And we'll see that it is now on 3 different segments instead of just one. The original space was on dev SDA3. Then there was some more space on there after the swap space. So that has been added here on dev SDA3. And then also all the disk space from the dev SDB has been added here as well. And then the swap space has not changed. So LVM does work as expected. Even when we're logged into the LVM file system, we were able to add disk space. In the next video, we will continue looking at LVM for the Linux command line. In this tutorial, we're going to look at taking an LVM snapshot. The first thing I'm going to do is make sure that my logical volumes from the previous videos have been removed by typing sudo lvs. And we see nothing, showing we have no logical volumes, which is what I want. Now I'm going to look at the LVM physical volumes available for this computer with the command sudo pvs. And we see we still have the 4 drives we've used in the previous videos, and they are all in the volume group blue. I'm going to set up a 500 megabyte LVM linear logical volume on the volume group blue with the command sudo lv create. Then I'm going to add a -L to tell LVM we want to specify the disk size of 500 M, and the M is for megabytes. I'm going to add this to the volume group blue, And then I'm going to finish with a dash lowercase n for name. And I'm going to give this logical volume the name linear underscore LV. LVM has found a signature from a previous logical volume and is asking me if it's okay to remove that. It is. I will type Y and enter to remove it. And our logical volume is created as expected. Now I will add a file system to this logical volume with the command sudo mkfs.ext4/dev/blue/linear_LV. Our file system was created as expected. Now I want to mount the file system with the command sudo mount/dev/blue/linear_LV. And this will go into the /mnt/lvm1. And we created the /mnt/lvm1 directory way back in video 91. To make sure it's mounted okay, I will cd into /mnt/lvm1 and type ls-lh. We see the default lost and found file that is created by default for the ext file system. So this is telling me that we've mounted the ext4 file system to this directory. What I'm going to do now is create a snapshot of the empty logical volume linear_LV. Actually, I'm going to create two snapshots of the empty logical volume. I'll make one really small and the other really large. To make the small one, I will type sudo lv create and then a dash uppercase L to give this a size, just like we did when we created the LVM logical volume. And I want this snapshot to be the size of 50 megabytes. Now I'm going to add a dash lowercase s to tell LVM this is a snapshot. And then I'll have to give it the logical volume that I want to make that snapshot of, which is dev blue linear_LV. Then I'm adding a dash lowercase n for the name, and I will give this snapshot the name snap1. And this snapshot will go in the volume group blue because that is where the logical volume is. A snapshot must go in the same volume group as a logical volume it is a snapshot of. Pressing enter. And we see when it created the snapshot, it was resized to 52 megabytes because LVM works in 4 megabyte extents, as we discussed in an earlier video. Now for the larger snapshot, I'm going to press the arrow up to bring back the command. I will change the name from snap1 to snap2. And instead of 50 megabytes, I'm going to make this 600 megabytes. And I'm picking 600 megabytes because it's larger than the 500 megabyte logical volume that we just created a moment ago. When I press enter, we see that LVM tells us the maximum usable size is 504 MB, which is the size of our logical volume, 500 megabytes, plus 4 megabytes for LVM snapshot management. I'm going to clear the screen with clear. And to see what our snapshots look like now, I'm going to type sudo lvs. The first thing we see is the linear logical volume, linear LV, and then we see our two snapshots, snap1 and snap2. Then we see the attributes for the snapshots start with S for snapshot. And then we see the snapshot sizes. Snap1 is 52 megabytes and snap2 is 504 megabytes. Under origin, we see the snapshots are both snapshots of the linear LV logical volume. And then under data %, we can see how full the snapshots are. Once a snapshot is 100% full, it becomes unusable. We'll see that in a moment. Let's add some data to our logical volume. I have some pictures on the desktop that we used in a previous tutorial. I'll copy them into our logical volume with the command sudo cp/home/Michael/desktop/ pics, and I'm adding the asterisk to copy everything. And I want it all to be copied right here into the MNT-LVM1 directory, which is our logical volume linear_LV. Let's see what our logical volumes look like now with sudo LVS. And we see that we already maxed out our little 50 megabyte snapshot. We see that the data is 100%. And one of the attributes has changed to an uppercase I for inactive. I'm going to type sudo lv display -m and then go to the top. We see that we're looking at the logical volume name linear LV, which is on the blue volume group, and we see the LV snapshot status has two snapshots. One is inactive, the other is active. And then down under segments, we'll see that linear LV physical volume is on device dev SDB. Going down to snapshot 1, we see that snapshot 1 is inactive and on dev SDB. And then snapshot 2 is active and on device SDD. Now we still have device SDE empty, so we have space for at least one more snapshot. But before I take that, let's add another file or two to our logical volume. I'll add some random data files with the dd command. Test file 1 will be 100 megabytes. And then test file 2 will be 200 megabytes. Let's check out our snapshots again with sudo LVS. Snapshot 2 is about 70% full. Let's take another snapshot because we'll want to restore to a snapshot with data in it. Remember, snap 2 is a snapshot of the empty logical volume. So I'll create a snapshot with sudo lv create -l 600 m-s /dev blue linear_LV, and then we're going to give it a name of snap3. And again, I set the size larger than the current logical volume, and LVM will set our snapshot size to be 4 megabytes over that total logical volume size. And I have a typo in there. I have the lowercase l, which was asking for a percentage, and I need the uppercase L. Let's try this again. Now we have snap3 created. Let's check on the snapshot sizes with sudo LVS. And we see that our new snapshot 3 is 1% full because we just created that one. Let's take a look at what's in our directory with ls-lh. And we see a lot of JPEGs and some MP4s, and then our 2 large test files with random data. These are the files that are in our snap3, and this is what we're going to restore to in the next video. In this video, we saw how to create a snapshot. We said that the snapshot must go in the same volume group as the snapshot's logical volume, so there must be enough space on that volume group for that snapshot. And then we talked about the size of a snapshot. If they're too small, they might run out of disk space, so the bigger the better. In the next tutorial, we'll talk a little more about snapshots. We'll change some data and then restore to this snapshot that we created in this video for the Linux command line. We are picking up from where we left off in the last video, and I'm going to type sudo LVS. This shows us everything we created in the last video. We created the logical volume linear LV with a size of 500 megabytes. Then we created snapshots 1, 2, and 3, and they are all in the volume group blue. We'll notice that the data usage for snap 1 is at 100%, snap 2 is at 70.89%, and snap 3 is right around 0% using 0.01. I'm going to cd into the mnt/lvm1 directory which is the directory where we mounted the linear_LV logical volume. And I'm going to type ls-lh. In here, we see a lot of JPEGs, a couple of MP4 files, and then the 2 test files that we created with the dd command. And all of these files are on our copy on write snapshot, snap3, that we'll restore to later in this video. I'm going to remove the 2 test files with sudo rm test asterisk, and typing ls-lh shows that they're gone. I'm also going to sudo remove everything that starts with a lowercase or uppercase w, and typing ls-lh shows that we've removed a lot of files. I'm also going to paste in the command dd infile urandom outfile test file 3, and it will write out 150 megabytes of random data. So now we've got a test file 3. Let's also make a test file 4 and make this one 175, just to make things different. And typing ls-lh shows we've removed some files, we've added some files. So now this looks nothing like the files that we had when we took that snap 3. I'm going to clear the screen and type sudo lvs once more so that we can take another look at our logical volume and the snapshots for it. We see our logical volume looks good. Snap 2 is looking good at 74.25 data percent. Snap 3 is looking good at 64.79 data percent, but Snap 1 is at 100 data percent and is inactive and useless to us. So let's remove that with sudo lv remove blue snap 1. It's asking me if we really want to remove that. Yes, we do. Y and enter. Snap 2 is showing the data percent of 74.25. I'm going to mount that with sudo mount /dev/blue/snap2. And I'm going to mount that to /mnt/lvm2, which we created way back in video 91 or 92. And let's also sudo mount dev blue snap3. And I'm going to mount that to mnt/lvm3. And I created mnt/lvm3 off camera. Snap 2 is using a data percent of 74.25. Let's see what's on that snapshot by typing ls-lh mnt/lvm2. And all it shows is the lost and found directory, but it has a data usage of 74.25%. How does it have such a high data percent usage when nothing shows when I list the files? And the reason is when we made that snapshot, the logical volume was empty, and the snapshot is holding all the copy on write information to return us to that state where we took that snapshot, which for us is an empty logical volume. Let's see what's on Snap 3 with ls-lh mnt/lvm3. And here we see the files that are in the state they were when we took this snapshot. But this is not a backup. These are copy on write links. The snapshot needs the logical volume linear_LV to be present to return to that point in time where we took that snapshot. Right now, we can copy a file from this snapshot and get the correct file saved to a new location. I'll do that with cp mnt lvm3 waterfront.jpg, and I'm going to copy that to home Michael desktop. And we see the image is restored to the desktop. So what is the advantage of a snapshot over a backup? When we take a backup, it backs up everything. And when everything is lost, we can restore everything from that backup. The problem with backups is that they back up everything, and that can take a lot of time to create a backup or restore from a backup, especially if we have gigabytes or terabytes of data. Snapshots, on the other hand, only store the changes between the current file and the point we want to restore to. So that makes taking and restoring snapshots quick and easy. I'm going to go to my home directory by typing cd, and then I want to unmount our snapshots with sudo umount mnt lvm, and we'll do them both together. We'll do 2 and 3. Now I'm going to clear the screen and remind us all of what we have in the logical volume and the snapshots with sudo lvs. Before I restore from the snapshot, I want to unmount the logical volume with sudo umount mnt lvm1. And to restore from the snapshot snap3, I'm going to type sudo lvconvert --merge dev blue snap3. We have an update that it's 44.44% merged. Now it's 100% merged. We just need to get our cursor back. Okay, it's restored. Let's remount our logical volume with sudo mount dev blue linear LV, and we want to mount this to LVM1. And now let's see what's on LVM1 with ls-lh mnt lvm1. And there we see all the files that were stored in our copy on write snapshot snap3. I'm going to clear the screen and type sudo lvs, and we see that our snapshot snap3 is now gone. Well, it's gone because it was merged into our logical volume. So if we want to restore to this point again, which I do here, I will have to take another snapshot. So I'll do that with sudo lv create -l 600m-s for snapshot /dev/blue/linear lv, and I want to give this a name of snap4. Once again, I'm going to cd into mnt lvm1 and ls-lh. Once again, I'm going to remove some files with sudo rm. This time we'll remove everything that starts with a lowercase w, uppercase w, and a lowercase t. ls-lh shows that those were all removed. I'm typing cd to go to my home directory. Now let's restore to that snapshot snap4 that we just created with sudo lvconvert --merge /dev/blue/snap4. Pressing enter, we get the message delaying merge since origin is open. Did you notice what I forgot to do? I forgot to unmount our logical volume before I did my merge. So let's see what the logical volumes look like with sudo lvs. And we see that the attribute O for origin is now an uppercase O. And it's an uppercase O to let us know that there is a snapshot merge waiting to happen. Now, the easiest way to complete the merge is just to restart the computer. That's no problem. It'll restart. The O will go back to a little o and will be restored to the snap4 data. But there is another way. We just need to deactivate the volume group and reactivate it. And I'll do that now. First thing we need to do is unmount the logical volume with sudo umount mnt lvm1. And I'll deactivate the logical volume right now with the command sudo lvchange --activate n blue/linear lv. Now that n after activate does not have a dash by it because it's a setting. We're setting activate to no or deactivating it. And then to reactivate the logical volume, I'll bring back that command and change that N to a Y. So we're telling it to activate the blue linear logical volume. Now I'm going to remount the logical volume with sudo mount dev blue linear underscore LV to MNT LVM1 and typing ls-lh MNT LVM1 shows that we have restored all the data from Snap 4. In the next video, we will continue looking at the Linux command line. In this group of videos, we're going to look at how to use the ZFS file system on a Linux Ubuntu-based operating system. Non-American English speakers will call this the ZFS file system. I'm an American, so I will call this the ZFS file system. Ubuntu releases 22.04 and higher should come with the complete ZFS utils-linux package already installed. I will check to see if ZFS is installed on this system with the command ZFS-version. And we see ZFS is already installed on this computer. If you did not see anything here and you want to install the ZFS utils-linux package, you can do so by typing sudo apt update and then type in sudo apt install ZFS utils-linux. And we see here that ZFS utils-linux is already at the newest version. And then once installed, you may want to verify the version of ZFS by typing ZFS-version. We have ZFS installed. Now I'm going to look at what disks I have on this operating system by clearing the screen and then listing out the disks we have available by typing lsblk. The SDA is my operating system, and I've added 5 2 GB disks SDB through SDF to work with in this group of videos. The ZFS file system uses storage pools called Z-pools. A ZFS storage pool is a single ZFS container made up of one or more storage devices. The first thing I'm going to do is create a ZFS storage pool, a Z-pool, with the command sudo zpool create, and we will call this first zpool first_zpool. And I want this first zpool to go on the device /dev/sdb. And pressing enter, that's it. We're done. We can now start using this ZFS zpool. If you watched some of my earlier videos, you may remember after setting up the storage unit, we would then have to create a file system, mount that file system, and then if we want that file system to mount on the next system boot, we would then have to update the FS tab file. With ZFS, we don't have to do any of that. ZFS is a combined file system and volume manager. So ZFS takes care of all that for us. I'm going to clear the screen and then type df-h. And here we see our zpool, first zpool is created, and it is mounted in the root directory as /first zpool. Typing cd/first_zpool and pressing enter puts us into the directory first_zpool, which is also the ZFS zpool container first_zpool. To see the file ownership of our zpool, I will type ls-lh/, then pipe grep first. And we see that the owner and the group are both root. To change the owner and the group to Michael, I will type the standard Linux command sudo chown michael /first_zpool. And then going up to that ls command again, we see the owner and the group are now set to Michael, and I can edit this directory. This is a lot easier than what we had to do with the mounted disks in earlier videos. If we wanted to change the ownership, we had to unmount the disk, update the owner in the mount command, and then remount that disk. I have some pictures on the desktop. I'm going to copy those pictures to this ZFS directory with the command cp home Michael desktop pics and the asterisk for everything, and I want to copy them all right here. And then LL will list them out, and we see the files have been copied here. To check the status of my zpool, I will type zpool status. Things I'm looking for here are the name of the pool. In this case is first zpool. Then the state, which is showing online. And then if there are any errors. And here we see no data errors. We only have one zpool at the moment. Let's create a second zpool with the command sudo zpool create. And we will call this one second. And I want this to go on 2 disks this time. We'll use dev sdc and dev sdd. Now let's check that zpool status again with zpool status. And we're seeing both zpools. If I only want to see the status of one zpool, I can type zpool status and then the name of the zpool I want to check the status of. In this case, second. And now I only see the second zpool status. Another ZFS command we may want to use is ZFS list. And we get some information about our zpools. We can also type zpool list. And here we get a little more information about the zpools. I want to add some more disk space to our second zpool. I will do that with the command sudo zpool add, and then we want to add to the second zpool, and we're going to add dev sde to our zpool. And then typing zpool list shows we've increased the size of our second zpool from 3.75 gigabytes to 5.62 gigabytes. The last thing we're going to do in this video is to remove the zpools. I'll remove the first zpool with the command sudo zpool destroy first underscore zpool. And when I press enter, we get an error that we cannot destroy it. And the reason is because we're in it. We can see that we're in the first underscore zpool. So I will cd into the home directory and then bring back that command again. And now it works. And then I'm also going to type sudo zpool destroy, and we'll make this second. And both my zpools are gone. In the next tutorial, we will continue looking at ZFS for the Linux command line. In the last video, we created a single ZFS zpool, and we also created a second zpool with 2 disks, and then we added a third disk to that zpool. The problem with the zpools we created in the last video is that there is no redundancy. So if one disk goes bad, all of the data on that zpool will be lost. In this video, we're going to look at setting up a disk mirror. I'm going to start by creating a single disk zpool, and then we're going to turn that into a mirror. I will create the single disk zpool with the command sudo zpool create. We'll call this one test mirror, and I want the test mirror to go on the disk dev sdb. And we will see what that looks like with zpool status. And we see that the zpool with the name test mirror is created as a single disk zpool. It's not a mirror yet. Let's check the disk size with zpool list. And we see that the disk size is 1.88 gigabytes. To turn this single disk Z-pool into a mirror, I'm going to type in the command sudo zpool attach. And notice here we're typing the word attach instead of add, like we did in the last video. Then I'm going to add the Z-pool name that we just created, test mirror. And then I'm going to type in the currently attached disk drive, which is dev SDB. Now I'm going to add in the new drive that I want to be the mirror device, which is dev SDC. Pressing enter, and our mirror is now created. Let's check that out by typing zpool status. And we see that our zpool with the name test mirror is online, and that test mirror is now a mirror. We see that mirror-0. Now notice in the line right under state, it has scan, and then it says resilvered 178K with 0 errors. Resilvering is a ZFS term that means adding or updating data to a new disk that was just added to a mirror or RAID pool. If you have a lot of data, resilvering could take hours or days if there's a real lot of data. We can still use that Z-pool while it's resilvering. It just might be a little slower until the resilvering is complete. To see the size of the Z-pool, I will type zpool list. And we see that the test mirror is still at 1.88 gigabytes. So that completes the first way we're going to look at creating a Z-pool mirror. I'm going to remove that Z-pool that we just created with the command sudo zpool destroy test mirror, and typing zpool list shows that it's gone. I'm going to clear the screen, and I'm going to create a new zpool mirror with the command sudo zpool create. Then the zpool name that I want to give it, this time it will be called test mirror 2. And now I'm going to type mirror to let ZFS know that I want this Z-pool to be a mirror. And then I will give it the disks I want to use in the Z-pool mirror, which are dev SDB and dev SDC. Pressing enter. Our test underscore mirror 2 is now created. Let's check out what that looks like with zpool list. We see it's using 1.88 gigabytes, and then typing zpool status shows us that the zpool with the name test mirror 2 is online and a mirror. I'm going to remove that zpool with the command sudo zpool destroy test mirror 2, and make sure it's gone with zpool list, and I'm going to clear the screen once again. Now I'm going to create another zpool mirror, but this time I'm going to create one with 4 disks. Once again, I'll start the command with sudo zpool create. Then I'm going to add the name I want to give this. I will call this one test mirror 4 because we're going to use 4 disks. Then I'm adding the word mirror, and then I'm going to add the 2 disks for that mirror, dev SDB and dev SDC. Now I'm going to type mirror again, and then give it 2 more disks, which is dev SDD and dev SDE. Pressing enter, and our zpool is created. I'm going to check the zpool size with the command zpool list. We see that the zpool mirror is 3.75 gigabytes, which is the equivalent of 2 disks. And then typing zpool status shows us the name is test mirror 4, that it's online, and that we have 2 mirrors, mirror-0 and mirror-1. So that's the basics of creating zpool mirrors. In the next video, we will continue looking at ZFS for the Linux command line. Up to now, every time I've created a zpool, I've used the device name, for example, dev-sdb. And that works, but if another disk drive is added and then the computer is rebooted, the device dev-sdb might not be pointing to the intended disk anymore, meaning dev-sdb might be the disk that was just plugged in. And ZFS is looking for zpool data on dev-sdb, but won't find any. So instead of setting up our zpools with the device name, we want to use the UUID. UUID stands for Universally Unique Identifier. And we talked about UUID back in video 83. I'm going to see what disks I have available by typing lsblk-f. And we see the disks SDB, SDC, SDD, and SDE are all in use with the test mirrored for zpool. But we still have dev-sdf available, so I'll use that one. To find the UUID for dev-sdf, I'm going to type sudo ls-lh/dev/disk/by-id. And this shows us the UUIDs for all of the disks. Since we're only looking for device SDF, I will add on grep SDF to the last command. Now we only see the UUID for dev SDF, and I'm going to copy that by double-clicking and right-click copy. Now I'll create a ZFS zpool with a UUID just like I did with the device name. Sudo zpool create, and we'll give this zpool the name test UUID. And then instead of putting dev SDF, I'm going to paste in the UUID for dev SDF. Now this worked for me, but if it did not work for you because it did not find the UUID, you might need to add in the full path name, meaning dev disk by ID before pasting in the UUID. Let's check out our new zpool with zpool status. And here we see the test UUID zpool is using the UUID. But we also see the test mirror 4 zpool, which is still using the device IDs. So we just learned how to create zpools using the UUID instead of the device name, but that's for new zpools. The 4-disk mirror zpool was created in the last video. We might already have important data on that zpool mirror, and we don't want to lose it. ZFS will allow us to change the device disk names to UUIDs by exporting the zpool and then importing that zpool, requesting to use the UUIDs instead of the disk names when we import it. Now, while we're talking about exporting and importing zpools, if you want to move a zpool to another computer, you can do that by exporting the zpool, then move all the disks for that zpool to a new computer, then import that zpool on the new computer, and that will work. Now, I haven't personally tried it, but all the zpool information is stored on the zpool itself, and that's what makes it possible to move a zpool to a different computer. Okay, back to our zpool device name problem. I'm going to export the 4-disk zpool mirror with the command sudo zpool export test_mirror4. And now I'm going to import that same zpool mirror and use the UUIDs instead of the disk names with the command sudo zpool import -d, and the D is for device or search for devices in dev disk by ID. Then we'll give it the pool name test mirror 4, and then I'm going to add on this -f. This will force the import, even if the pool appears to be potentially active. Now when I type zpool status, we see the zpool disks by UUID instead of the device names we saw earlier. And now we can also safely add and remove more disks to this computer without worrying that they may affect our ZFS storage Z pool. UUIDs are better than the disk name, but when using the UUID, it might be difficult to know which disk we're talking about if there are disk errors or the disk is not working. So there are times when we want to give our disks a custom ZFS disk name. Maybe we have multiple storage devices and multiple disks on those storage devices. So we want a custom name to help us find a disk drive quickly and easily if we have to swap out a bad drive. I'm going to give our dev SDF disk drive a custom ZFS ID. Before I can give a custom name, I'm going to need to know the UUID of the device I want to give the custom name. And remember, we got that by typing in ls-lh dev disk by ID grep SDF. And then we copied the UUID. And now I'm going to remove the test UUID Z pool that we created earlier because we want to recreate that Z pool with the custom ZFS name. So I will remove that Z pool with sudo Z pool destroy test UUID. And I'm going to clear the screen. Now I'm going to cd into the directory etc ZFS. And I want to edit the file vdev_id.conf. I'll do that with vim, so the command will be sudo vim vdev_id.conf. I'm going to press I to go into insert mode, and to give our UUID an alias, I'm going to type the word alias, and then I'm going to give it the name that I want to give our disk. I'm going to call this one storage unit 1 underscore disk bay 3. Then I'll need to give it the path of dev disk by ID. And then I'm going to paste in the UUID. I'm going to press escape to get out of insert mode, :WQ to write and quit out of vim. And one more thing I need to do is to type sudo udev adm trigger. And now we can create a Z pool with that new custom disk name. So I'm going to type sudo zpool create -f. Then the name I'll give this Z pool will be custom disk name. And now we'll type in that new custom disk name that we just put in that file. Storage unit 1 disk bay 3. Pressing enter. And our new Z pool is created. Let's see what that looks like with Z pool status custom disk name. And here we see for Z pool custom disk name, it's online. And the disk name is storage unit 1 disk bay 3. So if we ever need to swap out that disk, we know exactly where it is. Storage unit 1 disk bay 3. In the next tutorial, we will continue looking at ZFS for the Linux command line. In this video, we're going to look at the ZFS RAID Z. A ZFS RAID Z is comparable to the LVM RAID 5 we looked at in an earlier tutorial. A ZFS RAID Z is the same as a ZFS RAID Z1, meaning we can lose up to one single hard drive, and the RAID Z can continue on one disk down until the bad drive can be replaced. And then the new disk will be resilvered into the RAID Z Z pool, and the RAID Z will be back up working at 100%. ZFS also has a RAID Z2, where up to 2 disks can be lost at one time, and the RAID Z Z pool can continue on. But the total usable RAID Z2 disk space will be 2 disks less than the total disks in the RAID Z2 Z pool. To see the minimum number of disks required for a ZFS RAID Z, I will type sudo zpool create. Then I will give it the name my RAID Z. And then we need to tell it what type of zpool we're creating, and that will be a RAID Z. And then the disk where we want to store this RAID Z, and that would be dev SDB. And notice with this command, I'm only giving it one disk. When I press enter, I get the message, RAID Z requires at least 2 devices. So there's our minimum number of disks that we need for a ZFS RAID Z zpool, 2 disk drives. I'm going to type this command again, but instead of RAID Z, I'm going to make this RAID Z1. And pressing enter again, we get the same message. So a RAID Z is the same as a RAID Z1. I'll run this command one more time, but this time I will change this to RAID Z2. And here I get the message, a minimum of 3 disks are required for a RAID Z2 zpool. So now we know the ZFS RAID Z zpool minimums. We need at least 2 devices for a RAID Z1 and 3 devices for a RAID Z2. I'm going to clear the screen. And now I will create a RAID Z with 3 disks by typing sudo zpool create, and then I will give it the name 3-disk RAID Z. And then I'll type RAID Z to let ZFS know what type of zpool we are creating. And then I'll give it the disks where we want to store this RAID Z zpool, which is dev SDB, dev SDC, and dev SDD. Pressing enter. And our RAID Z zpool is created. We can check this with zpool status. And we see the pool name, we see it's online, and we see RAID Z1-0 is made up of the disks SDB, SDC, and SDD. I'm going to clear the screen again and type df-h. And we see our 3-disk RAID Z has 3.6 gigabytes of storage available. That sounds about right for 3 2-gigabyte disk drives, which would be 6 gigabytes total. Then we lose 2 gigabytes for one of the 2-gigabyte disk drives, and the other 0.4 gigabyte is lost to ZFS file system support for RAID Z. Now I'll type zpool list. Here we see a size of 5.5 gigabytes for our RAID Z zpool. So zpool list is showing us the total disk space the zpool is using, which is different from the 3.6 gigabytes available we have to use that we saw with the df command. Now I'm going to type ZFS list. Here we see we have 3.54 gigabytes of disk space available. This does not match exactly the amount from the df command, but it's close enough to say that it's likely a rounding error. Now I want to add some data to the RAID Z zpool, but before I do that, I'm going to set the ownership to Michael for the RAID Z zpool with the command sudo chown Michael dot 3-disk RAID Z. Now I will cd into the directory, and I will add in the pictures from the desktop to this directory with cp home Michael desktop pics. We want everything in there, and I want to copy them all right here. Now typing du-sch shows that only 57 megabytes are being used. That's not very much disk space, so let's add another file to this directory with the dd command. This will add a 2 gigabyte file to this directory. It's done. Let's check out how much space is being used now with du-sch. Now we're using 2.1 gigabytes of disk space. Let's run that command again a second time, but change test file to test file 2, and we'll see how much space is actually available. So we see the dd command stopped because it ran out of disk space. Let's check out how much space is being used again with du-sch. And we see 3.6 gigabytes is in use. So there we go. We now know that we have 3.6 gigabytes of storage available for our RAID Z1 with 3 disk drives that are 2 gigabytes in size. I'm going to clear the screen again. I'm going to type zpool status to show that our RAID Z zpool is online and working as expected. What I want to do now is to make one of the disks in the RAID Z zpool unavailable. And I'll do that by writing zeros to one of the disk drives in the RAID Z zpool with the dd command. Sudo dd if for the end file equals dev 0. So we're writing zeros. And the OF out file will equal dev SDB. I'll set the block size equal to 1M and the status equals progress. We've written all zeros to device SDB. Let's see what our zpool looks like now with zpool status. Now mine is showing that device SDB is unavailable. If everything was showing still okay for you, you might need to run the scrub command, and that would be sudo zpool scrub and then the zpool name. In short, a scrub will check the zpool for errors. We'll talk about ZFS scrub in a future tutorial. So we see the zpool status is showing us that it is degraded for the 3-disk RAID Z and that one device, SDB, is unavailable. We see in the status that sufficient replicas exist for the zpool to continue functioning in a degraded state, so it is still working and our data is safe, but ZFS is recommending we take the action, replace the device using zpool replace. To replace this disk in the zpool, I'm going to type the command sudo zpool replace. Then I'm going to give the zpool name that we want to replace one of the disks, and that is 3-disk RAID Z. Now I'm going to give it the bad device name, the one that we want to replace, dev SDB, and then the new device that we want to replace this with, which will be dev SDF. And I showed in an earlier video for the ZFS tutorials, we have disks SDB through SDF to work with in this group of tutorials. And then I'm going to add on a semicolon zpool status to show us the status right away. Let's run this. And here we see the SDB has the invalid label and device SDF is resilvering into the zpool. We see that one or more devices is currently being resilvered, and our recommended action is to wait for the resilver to complete. Should be complete now. Let's type zpool status. And we see the message that 1.77 gigabytes was resilvered into the RAID Z zpool with 0 errors. Let's make sure all our data is there with ls-lh. All our files are still there, safe and sound, and our zpool is back up working with 3 disks once again. A quick note about the dev SDB drive. It's not bad, we just set everything to zeros. So we can use this device in a new zpool or even swap it back into this RAID Z. In the next tutorial, we will continue looking at ZFS for the Linux command line. Up to now, every time I've created a ZFS zpool, I placed it in the root directory. And then I would cd into the ZFS directory with a / and the ZFS directory name. I'm going to create a new ZFS zpool, but this time I want to create it as a subdirectory of the directory /mnt. And I'll do that with the command sudo zpool create. Then I will add a -R. And the -R means to set the following as the root directory. So then I will add what I want to be the root directory, which is /mnt. Then I will type my new zpool name, which will be ZFS Data 1. And then I will add the device where I want to store the new zpool, which is /dev/SDB. Pressing enter, and our new zpool is created in /MNT. We can see that with ls-lh/MNT, and there's our new zpool. And now I'm going to create a zpool the way we've been creating them up to now in the root directory with sudo zpool create, and then I'll give it the name ZFS Data 2. And I'll put this one on device /dev/SDC. Everything's looking good so far, but now I'm going to reboot the machine with sudo reboot now. So I've restarted the computer and logged in. Now I'm going to type zpool list. And we only see one of the zpools I created. And it's the one that we created in the root directory. My first thought is maybe I forgot to create the other zpool. So I'll try that now with sudo zpool create -r/mnt, and we'll call this ZFS Data 1. And I want this to go on /dev/SDB. And when I press enter, we get the message invalid VDEV specification. /dev/SDB1 is part of a potentially active pool, ZFS Data 1. So we see our ZFS zpool is still out there on dev SDB1. It just did not get imported properly. So to import the zpool, I will type sudo zpool import -R/MNT ZFS Data 1. And it looks like it's imported okay. Let's check it out again with zpool list. And now we see they're both out there. And the ZFS dataset 1 is mounted in /MNT with the alternate root. So this looks like a bug in the version of ZFS I'm using. Let's see which version of ZFS I'm using with ZFS version. And we see I'm in ZFS 2.1.5-1, Ubuntu 6, 22.04.04. There's also ZFS-KMod 2.1.5-1, Ubuntu 6, 22.04.3. So that's the version with the problem. Hopefully they'll get this fixed in the next version of ZFS. But if you want to have an alternate root, we just need to remember to run that import command when we log in. We might want to put that in our .bashrc file to run when we log in. Or else we could run the option to import the zpool using systemd when the computer starts up. If you don't know how to do that, you might want to visit the Linux command line video 58, where I show how to run a job when the computer starts up. In the next video, we'll continue looking at ZFS for the Linux command line. I will type zpool list, and we see one of the zpools we created in the last video. We're going to use that zpool in this video. And notice we have 1.87 gigabytes free to work with. Typing ls-lh/pipe grep ZFS shows root as the current owner and group. I'm going to change the owner and group to Michael with the command sudo chown michael /ZFS data 2. Now I can create a new subdirectory in that zpool with the make directory command. mkdir ZFS data 2 Michael. And to show that worked, I will type ls-lh/ZFS data 2. And here we see the Michael directory created inside the Z pool called ZFS data. The problem with creating a directory in a Z pool this way is that we cannot use any of the ZFS tools in that directory. I'm going to make another subdirectory in the ZFS data 2 Z pool, and this time I'll use the ZFS tools. Sudo ZFS create ZFS data 2 / Michael2. Note here that I'm using the ZFS create and not the Z pool create that we're used to seeing. We will also note that there is no / before the Z pool name. Pressing enter, my new Michael2 directory is created, and we can see that with the ls-lh command. And this shows us that the owner and group of the Michael2 ZFS directory is root. I'll set the owner and group to Michael with the command sudo chown michael dot / ZFS data 2 Michael2. And here we see the directory owner and group was updated to Michael. I'm going to clear the screen and type df-h. Here we see the Z pool directory, ZFS data 2, but we also see the ZFS directory Michael2. And we'll note that both have 1.8 gigabytes available. We will also see both directories show up when I type ZFS list, but not when I type Z pool list. We only see the one Z pool directory. And that's because the ZFS data 2 Michael2 directory is a directory and not a Z pool. So I mentioned we can use the ZFS tools on a ZFS directory. One of the most common things people like to do for a ZFS directory is to set a directory quota. I will set a quota on the Michael2 directory with the command sudo ZFS set quota equal to 250 M for megabytes, and we'll make that for the ZFS data 2 Michael2 directory. And I'm going to type clear again. And now I want to see that the quota was properly set, and I'll check that with df-h. And here we see that the ZFS data 2 / Michael2 directory now only has 250 megabytes available for it. Typing ls-lh / ZFS data 2 reminds us that we have two directories in that ZFS data 2 directory. If I try to assign a quota to the other directory in the ZFS data directory, I get the message dataset does not exist. Since it was not created as a ZFS dataset, quotas cannot be assigned to it. So the Michael directory cannot be assigned a ZFS quota, but it could potentially use up all the disk space in the ZFS data 2 directory, leaving no space for the Michael2 directory. We don't want that to happen. We gave the Michael2 directory a quota of 250 megabytes, and we want to make sure that that directory has access to all 250 megabytes. We can do that by reserving 250 megabytes for the Michael2 directory with the command sudo ZFS set reservation equal 250 M for megabytes. And that will be for the ZFS data 2 / Michael2 directory. And I accidentally got an uppercase A in there. Let's fix that. Now the Michael directory cannot use any of the 250 megabytes available for the Michael2 directory. I'm going to clear the screen again. Another useful ZFS directory tool is compression. If you have a lot of large text files, you may want to consider turning on compression. Some files are already compressed and cannot be compressed anymore, in which case trying to compress them a second time will not help anything, and in some cases will take up even more resources trying to compress them a second time. In this video, we're going to test out two different ZFS compression tools. The two we're going to look at are gzip7 and zstandard. I'm going to make two new ZFS subdirectories, one for each compression method that we're going to test. The first one is sudo zfs create ZFS data2 /gzip-7 underscore data. And the other one will be the same, but we're going to call this zstandard data. Before I do anything else, I want to change the owner and group to Michael for these two new directories with sudo chown michael dot / ZFS data2 gzip-7 underscore data. And let's do that with the zstandard as well. Now that we got the data set set up, let's check the compression. And we do that by typing ZFS get compression. And we see that compression is turned off for all the ZFS directories. I'm going to set the gzip-7 compression tool for the gzip-7 data directory with the command sudo zfs set, and we want to set the compression equal to gzip-7, and we want to set that for the directory ZFS data2 / gzip-7 underscore data. And we'll do the same thing for the zstandard compression method. And we want to set that for the zstandard data directory. If we want to see all the compression methods available, we can try setting the compression method to something that doesn't exist. And here we see all the compression methods in the warning that the compression must be one of on, off, or one of the methods shown. Now that compression is set up, let's check out the compression again with the command ZFS get compression. And here we see the gzip-7 underscore data directory is using compression method gzip-7, and the zstandard data directory is using compression method zstandard. With nothing in the files, I will check the compression ratio with the command ZFS get compress ratio. And it looks like I got an extra S in there. Let's take that out and run this again. And we see that all of the compress ratios are set at 1.00x, meaning nothing is being compressed because nothing is in those folders. I have a 100 megabyte text file on my desktop, and the text file is made up of uppercase letters A through Z, just randomly put into the file. I'm going to copy that text file to both of the compression directories with the commands cp home michael desktop test file 100m.txt, and we'll copy that to ZFS data2 gzip-7. And that one's taken some time. And we're also going to copy that to our zstandard. And that went a little quicker than the gzip-7. And now I will get the compress ratio again with ZFS get compress ratio. And we see that the gzip-7 underscore data has a compression ratio of 1.57. And the standard underscore data has a compression ratio of 1.67. So in this case, it looks like the zstandard compression method is better because it compressed that 100 megabyte text file quicker and gave us a better compress ratio. Now let's add the pictures from the picture file on the desktop to both directories with cp home michael desktop pics all and we want them to go into the ZFS data 2, gzip7, and into the Z standard. We see that the compression for the directory gzip7 has dropped down to 1.31, and the compress ratio for the Z standard has dropped down to 1.35. This tells us that the pictures and the videos in that file were already pretty well compressed. I have one more file that I want to try moving in. It has some random data that I created with the DD statement. Let's copy that in with cp home Michael desktop dd random, and we will copy that into ZFS data 2 gzip7. And we'll also copy that into the Z standard. Getting that compress ratio again shows us that the compress ratio has dropped off even more. So the pictures and the DD random file were already compressed pretty well. But when we use the plain text file, we did see some benefit to the compression. So if we have a lot of text files, maybe log files, we could see a benefit to using compression for this directory. But for files other than plain text files, the ZFS compression might not help very much. Another ZFS tool people talk about applying to their datasets is the dedupe. At the time of this recording, I just don't see a valid use case for setting up ZFS dedupe on Linux. From what I've seen, it takes some time to set up, takes a lot of memory, and doesn't give that much of a benefit to the average Linux ZFS user. So we're going to skip that one. In the next video, we will continue looking at ZFS for the Linux command line. In this video, we're going to look at ZFS snapshots. I'm going to create a new ZFS pool with the command sudo zpool create myzpool /dev/sdb. And I'm going to update the owner to Michael with the command sudo chown Michael myzpool. Now that we have the zpool created, I will check to see if any snapshots exist for this zpool with the command zpool get list snapshots myzpool. And we see that ZFS is telling us that snapshots are not turned on for myzpool. It shows the value equals off. I'm going to set list snapshots on with the command sudo zpool set list snapshots equals on for myzpool. Now when I get the list snapshots, we see the value is set to on. We create the snapshot with the command ZFS snapshot. Then we give it the ZFS file name. In this case, it is myzpool. Then we add an @ symbol and we'll give it a snapshot name. First snapshot. Pressing enter, and our snapshot is taken. We can see the snapshot we just took with the command ZFS list, and we see the snapshot right under the zpool. If we want to see just the snapshots, we can type ZFS list-t for type, and then snapshot, and we see only the snapshots. If we have multiple zpools, and we only want to see the one zpool, we can add the zpool name after it, myzpool. And if we want to only see the name, we'll say snapshot-o name, comma, and then the zpool name. And there we see the zpool snapshot name. And we see that new snapshot is taking up 0 bytes of storage because at the moment it is the same as the myzpool ZFS zpool. I'm going to cd into myzpool, and I'm going to paste in a command to create a file. Let's cat out that file I just created. And we see that it's test file 1, and it has test file 1 inside. I'm going to take a snapshot, sudo zfs snapshot, and it's going to be for my zpool. And then the name I'll give it is test file 1. So we'll know that this snapshot has test file 1 in it. Oh, and if we want to see the list of snapshots, we can check that with ls-lh myzpool.zfs/snapshot. So we've got our snapshot test file 1. I'm going to remove test file 1.txt, and we'll check that with ls-lh. It's gone. And now I'm going to roll back to the most recent snapshot to get back test file 1 with the command zfs rollback myzpool at test file 1. And typing ll shows the file is back. Catting out that file shows it does have the right data inside that file. Now I'm going to remove test file 1 again, and I'm going to paste in the command to create a test file 2. Let's cat out test file 2, and we see it's there. And now I'll take a snapshot, and we'll call this test file 2. And I'll paste in another command to create test file 3. And I'll create a third snapshot. Now I'm going to list out my snapshots with ZFS list-t snapshots. And I typed ZFS list-t snapshots with an S, but we need it without the S. Even though we're looking for multiple snapshots, the command is snapshot. So we see we've got 4 snapshots out there, our first snapshot, and then the 3 test file snapshots. I want to return to the snapshot with test file 1 in it. So I will type in sudo zfs rollback myzpool at test file 1. And we get the message cannot roll back to more than the most recent snapshot. Use -r to force deletion of the following snapshots. And then it lists our 2 snapshots, test file 2 and test file 3. In this case, I'm okay deleting the 2 other snapshots. So I will type sudo zfs rollback -r myzpool at test file 1. Actually, before I roll back, let's see what's in this directory with ls-lh. And we see test files 2 and 3. Now I'll run the rollback. And typing ls-lh again shows us that test files 2 and 3 are now gone and test file 1 is back. And catting that out shows that it is the data that was in file test file 1. Typing ZFS list-t snapshot shows that snapshots test file 2 and test file 3 were both deleted. So ZFS had to delete them to make test file 1 the most recent snapshot because it can only restore the most recent snapshot. There is a way to get data off an older snapshot, and we will talk about that in the next video. Let's create some data sets in our zpool with the command sudo zfs create myzpool project 1. And I'll create another one. We'll call this one dataset 1. And then I'm going to update the owner of both of these, sudo chown michael dot myzpool project 1 and dataset 1. Let's add test file 2 into project 1 with the command echo test file 2 into myzpool project1 testfile2.txt. And let's add test file 3 into the dataset1 directory with the command echo test file 3 into my zpool dataset1. Now I'll take a snapshot of project 1 with the command sudo zfs snapshot my zpool project 1 at snap1. And let's check out our snapshots with zfs list-t snapshot. There we see our new dataset project 1 snapshot, snap1, just as we expected. Now, if I want to take a snapshot of the zpool and all the datasets inside that zpool all at the same time, we can do that by taking a zpool snapshot with a -r for recursively take snapshots. Sudo zfs snapshot -r my zpool at, and I will call this rsnap1. And we can list these out with zfs list-t snapshot. And we see that there are now 3 snapshots that were made called rsnap1. One for the zpool, my zpool, one for the dataset, dataset1, and one for the dataset project1. In the next video, we're going to look at ZFS clone for snapshots for the Linux command line. We're picking up from where we left off in the last video. I'm going to type ZFS list, and we see the ZFS zpool, my zpool, as well as the 2 ZFS datasets, dataset1 and project1, and the snapshots we took in the last video. I can show just the snapshots with ZFS list-t snapshot. In this video, we're going to use ZFS snapshot clone to recover data from a snapshot that is not the most recent snapshot without deleting the most recent snapshots. I'm going to cd into my zpool project1 and type ls. We see a single file there called testfile2.txt. I will cat out that file with cat testfile2.txt. And we see it says testfile2 with some @ symbols above and below the text. I'm going to take a snapshot of this with the command sudo zfs snapshot my zpool project1 at, and then we will call this snapshot testfile2. And then typing ZFS list-t snapshot shows our snapshot testfile2 is created. I'm going to clear the screen, and now I'm going to add a new file into our project1 ZFS dataset with a command I'm going to paste in. Typing ls-lh shows the 2 files, and we realize we don't need testfile2.txt anymore, so we will delete it with rm testfile2.txt, and the file is gone. Now I'll take another snapshot. Sudo zfs snapshot my zpool project1, then we're going to add the @ sign, and the name we'll give this snapshot is very important data. Everything's going well now, and we realize we really need the file testfile2.txt, but it's not the most recent snapshot. And we don't want to remove the most recent snapshot because it has some really important data in it. So I'm going to look at the snapshots I have for project 1 with ZFS list-t snapshot grep project 1. And here we see the snapshot we want to roll back to. That one is testfile2. So I want to clone the test file to snapshot, and I will do that with the ZFS clone command. Sudo ZFS clone my zpool project1 at testfile2, and then we need to put this clone in the same zpool as the snapshot, which will be my zpool. And then I'll create a name for my new clone. I'll call this one clone test file 2. I'm going to cd up a directory and then type ls-lh. And we see clone test file 2 was created just as we expected. Typing ls-lh clone test file 2 shows us our testfile2.txt file. From here, I can copy the testfile2.txt file into the project1 directory with the command cp clone testfile2 testfile2.txt, and we want to put that into project1. I'll make sure it's there with ls-lh project1. Our testfile2.txt file is back in project1, which we wanted. So we no longer need the clone testfile2, and I can remove that with sudo zfs destroy my zpool / clone testfile2. And typing ls-lh shows the clone is no longer there. I'm going to clear the screen again and type ZFS list. This shows all our snapshots, including the recursive snapshot that we made in the last video. We can see just those snapshots with ZFS list-t snapshot grep r snap1. When we cloned the testfile2 snapshot earlier in this video, we said that the clone had to go in the same zpool as the snapshot. Can we clone our recursive zpool snapshot into the same zpool? And the answer is yes. I would say as long as there's enough space here, but the snapshot is already taking the space up. So as long as we don't add any files to that clone, it won't take up any more space. To clone the zpool snapshot, I will type sudo zfs clone my zpool at r snap1, and we'll put that in my zpool / and we'll call this clone r snap1. Typing ls-lh, we see the clone r snap1 clone, and I will list out what's inside with ls-lh clone snap1, and it looks like everything's there. We see the file, testfile1, and the 2 datasets. I want to make sure the files in the project1 dataset were restored, and I'll check that with ls-lh clone snap1 project1. And we see there are no files in there. To see the data in the project1 dataset, we will need to clone the recursive zpool snapshot taken for project1, which is the snapshot my zpool project1 at rsnap1. I'll clone that now with sudo zfs clone my zpool project1 at rsnap1, and we will clone that into my zpool clone rsnap1 project1. And typing ls-lh shows the clone rsnap1 project1, and ls-lh clone snap1 project1 shows us that the testfile2 file is in that clone. So now we see why we needed to create the recursive snapshot to keep the subdirectory data. I will mention that you can use ZFS promote to replace an active ZFS file system with the clone of that file system, but that's outside the scope of this beginner's tutorial. In the next tutorial, we will continue looking at ZFS for the Linux command line. In previous videos, I talked about ZFS RAID pools. I will do a quick review of a ZFS RAID 1 for those that missed that video, and a reminder for those that did watch it. We said in a ZFS RAID 1, we would lose one disk space of storage, meaning if we have 3 2 gigabyte disks in our RAID 1, using 6 gigabytes of data, our RAID 1 would only have 4 gigabytes available for data. But if any single drive in that ZFS RAID 1 fails, our RAID 1 could continue until that disk could be replaced. We then talked about how data is stored on a ZFS RAID to handle a disk loss. And we learned that it is not data copied around to all the disks as we might think, but instead checksum information is available on the disks to recreate the data if one of those disks fails. The advantage to having checksum information on that disk is that when we read data from our ZFS RAID pool, ZFS compares that data to the checksum information for that data. And if that data read does not match the checksum, ZFS can correct that data before it passes that data on. So what would cause the data on that disk to go bad? The most common reason for data loss is bit rot. Bit rot happens when you have data sitting on a hard drive. Maybe you have a photo that you haven't looked at in years, and then you try and open it, and it doesn't show properly or doesn't open at all because some of the bits on that hard drive, where your photo is, have gone bad. With ZFS, when we open that picture with some bit rot, the data gets compared to those checksums and gets corrected, so our photo will open as expected. Data that gets accessed frequently gets compared to the checksums frequently. But what about the data that does not get accessed frequently? That is where a zpool scrub comes in. A scrub will compare all the data in the zpool against their checksums and repair any data that does not match up. I'm typing zpool list, and we see no zpools available. And I'll type lsblk to show what disks we have available. We see we've got the 5 2 gigabyte disks, SDB through SDF, available for ZFS. I'll create a ZFS RAID 1 zpool by pasting in the command sudo create my RAID 1 RAID Z on the disks SDB, SDC, and SDD. And let's check the zpool status, and everything looks good. I'm going to clear the screen. I want to force a zpool scrub right now. To do that, I'll type in sudo zpool scrub, and then the name of the zpool that I want to scrub, which in this case is my RAID 1. And we can check the status with zpool status. Our scrub completed and repaired 0 bytes of data, and since the zpool is so small, only 6 gigabytes, it finished pretty quick in 1 second. To see what it looks like running, I will append on the zpool status to our scrub command. And that's what it looks like when it's running. Bringing up the zpool status again shows that it completed with no errors. Here's a picture of a zpool status showing some disk errors. We see here that our middle disk shows a faulted with too many errors. Under our status, we see that 1 or more disks are faulted and that sufficient replicas exist for our zpool to continue functioning in a degraded state. Then the suggested action is to replace the faulted drive or use zpool clear to mark the device as repaired. So ZFS doesn't tell us we need to replace that disk, but it does warn us that we might want to replace that disk. If you see a message like this and you have important data on that disk, and that disk is 5 or more years old, you should probably swap out that disk in question for a new one. Now, I want to point out that scrubs can be resource intensive. You probably want to schedule the scrub to run at night or during low activity hours. If you started a scrub that will run a long time, then you realize that you're about to go into a busy part of the day, you can stop that scrub by adding -s to the scrub. sudo zpool scrub-s, and then the zpool name. It is suggested that we run a scrub at least once a month or more, depending upon how you feel about your data and how long that scrub takes to run on your machine. ZFS does have some default crons that run. They can be found in etc cron d ZFS utils-linux. Let's less into that file with sudo less etc cron.d ZFS utils-linux. We see on the first Sunday of every month, ZFS will perform the trim command. The trim command will look for all the free space in a zpool and reclaim that free space. Then on the second Sunday of the month, a scrub is run. Another thing I should mention is that ZFS does like to use memory, so the more memory you have, the better. I have heard people say that if you don't have a lot of memory, it doesn't matter, it will just take longer to run. Well, if you only have a couple of gig in your zpool, you can probably get away with a small amount of memory. But if you're using terabytes of data, you will probably want to have as much memory as possible. If you only have 4 or 6 gig of memory and you want to work with terabytes of data, you may want to consider using LVM instead of ZFS. LVM can get by with a lot less memory than ZFS, but you do lose out on that data integrity that you get with ZFS. Now, you may have heard that you need to use ECC memory with ZFS. ECC stands for Error Correction Code. Yes, it's better to use Error Correction Code memory if you have it, but it's not required for ZFS. Wrapping up this video also wraps up this group of videos looking at ZFS. In the next tutorial, we'll continue looking at the Linux command line. In this video, we're going to look at the disk tool SmartMon Tools. SMART stands for Self-Monitoring, Analysis, and Reporting Technology. And it has 2 different utilities. The one we'll spend the most time on in this video is the SmartCTL, which we will run from the command line. And then there is the SmartD utility, which is a daemon that can be used to schedule the SmartMon tool. The first thing I'm going to do is to install the SmartMon tools with the commands sudo apt update and then sudo apt install SmartMon tools. We see it is already installed on my computer. I'll note here that the disk drive must have SMART capabilities for this tool to work. Not all disks will have SMART capabilities, especially if you have an older disk drive. Fortunately, most of the disks in today's computers will have SMART capabilities. So we've got SmartMon tools installed. I'm going to see what disks I have available on this computer with lsblk. And we see the disks I have are dev SDA and MMC BLK0. I'm going to check to see if SmartMon Tools is activated for dev SDA with the command sudo smartctl-i/dev/SDA. And I'm looking at the bottom 2 lines here where we see Smart support is available and Smart support is enabled. If the Smart support shows as not enabled, we can enable it with the command sudo smartctl-s on dev SDA. The S is for Smart, and then the value we're sending it to is on for the device dev SDA. Besides showing us whether or not the Smart tools are enabled or not, the information section shows us a few other important things, like the model family, the device model, and the serial number. The user capacity, we see this disk is 1 terabyte, and the form factor showing this disk drive is 2.5 inches. And there is other useful information about the drive as well. SmartCTL has a short test and a long test. But before we get to that, I want to show that we can see all the disk information available by typing sudo smartctl-a for all, and then the device/dev/SDA. Pressing enter shows there's quite a lot of information there. So I'm going to run that command again and pipe this into less. Here at the top, we see the information section that we just looked at. Below that, we have the Start of Read Smart Data section. And scrolling down a bit, we see the short self-test estimated at 2 minutes and the extended or long self-test estimated at 160 minutes. This is for a 1 terabyte disk. If you have something larger than 1 terabyte, it may take significantly longer to run that extended or long test. Scrolling down a bit more, we see the Smart Attributes data structure, and then the vendor-specific smart attributes with thresholds. The good thing about these attributes is that the attribute name and ID will be consistent across manufacturers and models. So attribute 1 will always be raw read error rate. The bad thing about these attributes is that the numbers for these attributes will vary by manufacturer. It's kind of like when you buy a shirt that fits you really well from one company, and then you buy that same size from another company, and the shirt is either way too big or way too small. So that's one of the things that's going to make it a little difficult to know when it's time to replace your disk or not. The other thing to note here is that the number of attributes showing on the screen, we see 23 of them here. For a different disk drive, it's likely to have a different number of attributes showing. Even if it was the same number of attributes showing, it is likely that at least some of those attributes will be different. So the attributes showing is limited to the attributes the manufacturer decided were important for that disk drive. A couple of things that we might want to note right away are things like the number of hours the disk drive has been powered on. We see that here as number 9, power on hours. This one has 1,420 hours, which is not very many hours. I've seen some disks working just fine with 50,000 hours on them. Another attribute we might want to look at is the 190 airflow temperature Celsius. There is usually a min and max for this number, and as long as we're somewhere in the middle, we should be good. And the number I'm looking at is that raw value of 32. The min is 27, and the max is 50. So we're good here. This disk drive also shows a temperature Celsius. Now this one is unique because for some Seagate disks, the worst value is the highest lifetime temperature recorded. So for this drive, the highest temperature recorded is 52 degrees. You might think that this is kind of bad, but if it only happens once in a while and only for short periods of time, we should be okay. I'm going to press Q to quit out of here, and let's run a self-test. The SmartCTL utility has 4 different types of tests. The first one is a short self-test. This is a quick test, usually under 5 minutes, checking the most common disk problems. The second is a long self-test. It's a more accurate version of the short test and can take hours to complete. Then we have the conveyance self-test. This is meant to check for damage after transporting the device. It will only take about 10 minutes and is only available for ATA devices. And then we've got the select self-test. This is meant to check a specified range of LBAs, logical block addresses, and is only available for ATA devices. ATA stands for Advanced Technology Attachment. SATA stands for Serial ATA. SATA is one of the most common disk drives used today. Before we run a self-test, we might want to check how long the self-test will take to run. To see how much time that self-test will take to run, I will type sudo smartctl-c/dev/SDA. And we see it takes about 2 minutes to run the short self-test and about 160 minutes to complete the long self-test for this disk. And if you're thinking, didn't we just see this in the smartctl-a command? Yes, we did. The A is for all the smart data available. To run the short self-test, I will type sudo smartctl-t for test, short, /dev/SDA. And if we want to run the long test, we would just replace the short here with long, and it will run the long or extended test. Pressing enter gets the test going. To see information about a running self-test, I will type sudo smartctl-l self-test/dev/SDA. This shows how far along our self-test is. We still have 90% of the self-test to go. Arrowing up and pressing enter again shows we're now down to 60%. And it's going to keep going down until it gets to 0, and then the self-test will be complete. I do want to mention that running the long and short self-tests will not harm any data on that hard drive. I'm running this one on my Raspberry Pi just so I can test some bigger disks that I don't have in computers, and I can run that test for hours without tying up any resources on my main computer. So we see that our self-test is complete. To see the quick results of the self-test, I will type sudo smartctl-h/dev/SDA. And we see the overall health of our self-assessment test shows we passed. Now, does this mean our disk is really healthy? Well, maybe. But as I mentioned earlier, there's a lot of inconsistency between vendors. So a self-test result of pass does not guarantee that your disk is all that healthy. So let's go back to those attributes we were looking at earlier with the sudo smartctl-a dev SDA, and I pipe that into less. And then we go down a bit till we bring up the smart attributes. One of the values here that I want to pay special attention to is number 5, the reallocated sector count. This is the count of sectors on the block drive which cannot be used correctly. When a sector like that is found, it's remapped to one of the available spare sectors of storage, and the data is reallocated. If this number is something greater than 0, and then the number on this line I'm looking at is the raw value, which we see here is 0. If that raw number value is something greater than 0, this may be an indicator that our disk is having problems. Another attribute that I want to pay specific attention to is number 197, current pending sector. The current pending sector attribute is the count of bad sectors that are still waiting to be remapped. If we have some sectors still waiting to be remapped, we may want to back up that important data from this disk drive. And the number we're looking at for this attribute is under raw value, which again we have 0, which is a good sign. One other one that I might want to look at is number 10, spin retry count. This is the number of retries during disk spin up. A growing number may be a sign of an upcoming mechanical failure. And again, I'm looking at the raw value of 0. And then we also have the temperature values that we already talked about. Even if all these things look okay, there's still no guarantee your drive is good. Sometimes disks just die with no warning. There's also a GUI for SmartMon tools. It's called gsmartcontrol and can be installed with the command sudo apt install gsmartcontrol. And we see here it's already installed. To open it, I'm going to go down to System Tools, gsmartcontrol. There's our 2 disks. This is the one we're looking at, SDA. Most of this is what we've already seen. We've got the general, we've got the attributes, we can look at the self-tests. And to view a self-test, we would click View Output. And there's the output from the self-test. The last thing I want to mention in this video is the smartdconf file. I will less into that file now with sudo less etc smartd.conf. And to find the line we want to uncomment, I'm going to go down a little bit. And here we go. This line right here, we could uncomment that and then change this device to the one that we want to test. In this case, it is SDA, so I would just remove that hashtag. So I haven't looked into the SmartMonD tool very far, but I know that it can send you an email alert after it runs if there's any warnings, but you will have to have an email service set up on that computer to send out emails if you want to receive those email alerts. In the next video, we will continue looking at the Linux command line. In this group of videos, we're going to look at LUKS, and LUKS stands for Linux Unified Key Setup. LUKS is based on the kernel module dmcrypt. The DM stands for Disk Mapper, and we'll see what that's all about in a moment. In short, LUKS is a disk encryption tool for Linux devices, like disks and partitions. Can LUKS be used on Windows? Maybe. I don't think so. At least not easily used on Windows. LUKS is mainly for Linux operated systems. It's in the name, Linux Unified Key Setup. I know this is a Linux command line tutorial series, but to show how LUKS works in this first video of a group of videos on LUKS, we're going to do everything in this video using the Linux GUI. This is to make sure that we understand how LUKS works. It's easier to see what's going on using the Linux GUI. Then, in the next video, we'll do the same thing as this video, only in the Linux command line. To start things off, I've got the Disks app opened, and then I have a USB drive plugged into my computer. It's this one here, the 1.0 gigabyte thumb drive. I have selected that drive, and to secure this drive with LUKS encryption, we will have to reformat it, meaning we will lose everything currently on that drive. I don't have anything on this drive at the moment, so I can safely wipe this drive. I'm going to click here on this gear and then select Format Partition. It's asking me for a volume name. I don't have to type anything here, but I'm going to type in LUKS. Then I'll choose this radio button for internal disk for use with Linux systems only, ext4. And I'm also going to click this checkbox, Password Protect Volume with LUKS. And now I'll click Next. It's asking me for a password. I'll type in a password and confirm that password and click Next. I'm getting a warning that everything on this volume will be lost. So I'll double check, make sure that I'm on the 1.0 gigabyte thumb drive, and it is dev SDB. So I've double checked everything. I'm good with that. So I will click Format. It will take a moment or two to format the encryption. My disk is small, only 1 gigabyte, so it's formatted pretty quick, but it is a 1.0 disk. That's why it's taking some time. If you have something a lot larger, like in the terabytes range, it could take a long time to complete. The LUKS encryption formatting is complete, and now our volume looks odd. It looks like we have two partitions on the drive, one on top of the other. The partition on the top is showing a little lock, and that shows as unlocked. The partition on the bottom does not have a lock. I'm clicking on the top device, the one with the lock, and we'll notice it shows as device SDB. That's our actual LUKS encrypted USB drive plugged into this computer. When I click on the lower device, it shows as dev mapper LUKS, and then a bunch of numbers, letters, and some hyphens. Remember earlier when I said LUKS was based on the dmcrypt kernel module? Now we see where the DM comes from. It's dev mapper. This dev mapper device that I'm on is a virtual unencrypted or decrypted version of our LUKS device. And this virtual device is created by the kernel. It's done this way so we don't have to worry about encrypting and decrypting data every time we want to read or write something from the encrypted device. So we just read and write everything from the virtual unencrypted dev mapper device. Then when we're ready to encrypt everything, we can click the lock or eject the device, and Lux will encrypt that data. I'm going to open the File Manager and go to the Lux drive. And then I'm going to open another window from the File Manager for some pictures. And I'll add these into our encrypted Lux drive. So now I've copied that data to our unencrypted virtual dev mapper partition. I'm going to click on the Lux SDB version and watch what happens here on the left. Our stop or unmount button becomes a lock. I'm going to click this lock. And Lux encrypted our data and wrote it out to the Lux partition. So our Lux device is now closed and our data is securely encrypted. So if I lose this flash drive, no one can read what I have here unless they plug this into a Linux computer and they know my password. It is important to mention that when the unencrypted dev mapper device is available to me, that data is unencrypted, so it's just like any other unencrypted file on my computer at that time. Right now we see our Lux partition is closed, so we do not see that dev mapper device anymore. Over here on the left, our lock has become an unlock, and I can click this and unlock the selected encrypted partition. I'll click on it, and I'm prompted for the password. I'll click unlock, and we see it is decrypting my data and creating that dev mapper unencrypted virtual drive again. Clicking on the File Manager, and then our Lux device. We see the images that I copied in there. And our device does show as Lux. That's that name I gave it when we created that partition. I'm going to close this dev mapper drive again, this time by clicking the eject button in the File Manager. And then close the window. We see that we've ejected the disk and the drive shows as no media because it's already ejected. I'm going to close disks and pull out my USB drive. Now I'm going to put the USB drive in again. And we get a login pop-up window. This one's giving me 3 choices: forget password immediately, remember until I log out, or remember forever. Remember forever means I will type in the password one time now, and then every time I plug in this USB drive to this computer, I won't need to type in the password. Linux will just auto-mount this drive. Remember until I log out means I can unplug and plug in this USB drive as many times as I like without having to type in my password until I log out or shut down the computer. Then I will get this login pop-up screen once again. And forget immediately means ask for the password every time I plug in this USB drive. Different versions of Linux will offer different pop-up login options, but almost all Linux computers will recognize Lux. Here I'll use the default remember password until I log out. And I'll type in the password and then click connect. And it opened up my Lux secured files. In the next video, we'll look at creating a password-protected Lux partition using the Linux command line. In this video, we're going to set up a USB drive secured with Lux encryption using the Linux command line. The first thing I'm going to do is make sure Lux is installed on my computer by typing sudo apt install crypt setup. And we see it's already installed and at the most recent version. Now I'm going to type lsblk to see what drives are on this computer. We've got an SDA and the SRO is the DVD drive. And I'm going to insert a standard Windows formatted USB drive into this computer. We see the File Manager opens it up in a window and we see there's nothing on this USB drive. I'm going to type lsblk again,
And we see our USB drive shows up as SDB and is mounted on Media Michael. I want to unmount the SDB drive, so I'll do that with sudo umount dev SDB. And typing lsblk again shows that our SDB drive is unmounted. I'm going to clear the screen. And now I'm going to format our device for Lux with the command sudo crypt setup lux format dev SDB. And if I had a partition here, I would add that partition number after the SDB. But I'm encrypting the entire device, so we're just leaving it with SDB. I also want to make a note here that when using Lux, we see that I'm starting with sudo crypt setup. That will be pretty much the standard for the Lux commands. Then our actual Lux command will follow standard camel case, which means the first word is all lowercase. Then every word that follows that begins with an uppercase letter. So the word Lux is all lowercase, and the word format starts with an uppercase F. Then the last part is the device we want to apply this command to. Pressing enter. Now Lux is checking with us, letting us know that we're going to overwrite a VFAT superblock signature, and that it will overwrite everything on this disk. We already saw that there's nothing on this device, so I'm good with that. Lux wants us to confirm that we're okay with all this by typing yes in all uppercase letters. So I'll do that. Now Lux is asking me for a passphrase, meaning it's looking for a password that's longer than a normal password. That's why it's saying passphrase. I'll create a password, and I will verify the password. Now it takes a moment or two to reformat the disk for Lux. We now have our prompt back showing us that the Lux format is complete. I'm going to open up disks now to show you we have formatted our Lux device. We now see a lock in the lower right corner showing that our device is secured by Lux. We also have this unlock here that when I hover over shows us unlock selected encrypted partition. I'm not going to click that because we're doing this all in the command line. I'm just showing that for visual reference. Now what I want to do is open up our Lux partition to the dev mapper. For those that watched the last video will remember that Lux creates a virtual drive as a dev mapper device. And we're going to do that now in the command line. To do that, I'm going to start off the command like we already talked about with sudo crypt setup. Then what we want to do is open the Lux partition. So our camel case command will be Lux open. And then the device we want this to be on is dev SDB. And I still have one more thing I want to add to this command, and that is the name we want to show in the dev mapper. And the dev mapper name I want to give this is Lux Mapper. Now Lux is asking me for the password we just created. I'll type that in now. And we just created our dev mapper unencrypted version of our Lux drive. We can see that by typing ls-lh dev mapper. And there's the Lux mapper that we just created. Now we can also see this in disks. And now what we see are, it looks like two partitions. The top one has a lock, the bottom one without the lock. Clicking on the top one with the lock, we see that this is device SDB, and that is the actual Lux encrypted device. Clicking on the lower one shows this one is the dev mapper Lux mapper. This is our unencrypted device. The one important thing to note here is that we don't have a file system on that partition. We'll take care of that right now by adding a file system to our dev mapper device with the command sudo makefs for make file system. Then I'm adding a period, and we want this to be an ext4 file system. We want this to go on dev mapper Lux mapper. And then I want to give this partition a label. So I will add a dash uppercase L, and I'll just call this Lux. And pressing enter shows us that it's making the file system for us right now. Going back to the Disks app, now we see a file system, ext4. So we've created our file system. Now what I want to do is close the dev mapper. And I'll do that by typing sudo crypt setup lux close lux mapper. And checking disks again shows us that our disk is now secured and locked up. I'm going to unplug the drive now and plug it back in. And Linux is now asking me to authenticate the USB drive with the password. I'm going to change the radio button to forget password immediately and type in my password, clicking connect. And Linux opens up a window with the dev mapper unencrypted content of that drive. Let's move that over here. And then I want to add in some photos, just like we did in the last video. Let's grab these pictures and put them onto the new drive. And we get an error. The error is permissions denied. Let's check out what's going on here. I'm going to clear the screen. I'm going to type df-h, and that will show us where the Lux drive is mounted, and we see it's mounted on Media Michael. So I will grab this, copy, and CD to that. And let's check out what the permissions are with ls-lh. So now we see what the problem is. When I created the Lux partition, I created it as the root user, so only root has access to this partition. I'm going to update the partition owner right now to Michael with the command sudo chown Michael : and the colon will change the owner and the group to Michael. And that will be for media Michael Lux. There we see I'm the owner, so we should be able to move these files in now without a problem. And we can. I'm going to eject the Lux drive. It's telling us it's writing the data. Now I can remove the USB drive. I'm going to plug it back in. It's asking for my password. And it should open up the window. And there are my photos just as we expect. In the next video, we will continue looking at Lux for the Linux command line. In this video, we're going to look at adding, changing, and deleting Lux passwords. I have the Lux encrypted password USB drive that we created in the previous video, and I'm plugging that into my computer. I get prompted to authenticate the Lux encrypted USB drive. You can type in the password here, but you don't have to. When adding, deleting, or changing passwords, it doesn't matter if the dev mapper drive is created or not. I am not going to type in the password. I'm just going to click the X to close the authentication window. We can see the number of Lux passwords assigned by typing sudo crypt setup lux dump /dev/sdb. Scrolling up a little bit, we can see all of the output here, but the part I'm interested in right now is the key slots section. That shows us the number of password keys in use. Here we see a 0 under key slots. That's the only password key assigned at this time. This is the password I created in the last video when I created the Lux encrypted partition. I'm going to add a new Lux password key with the command sudo crypt setup lux add
key on device SDB. Lux is asking me to confirm that I know the current key before I can add a new one. I will type in the password key that we created in the last video. Now Lux is asking me for the new password, and I will add a new password. And I will type in that new password again to verify it. And our new password has been created. I will run the Lux dump command again. And scrolling up a little bit, we see we've got two password keys. We have the 0 that was already created, and now we have the 1 key slot as well. So when we created the new password the way we did, it just placed the new password key in the next slot available, which in this case was key slot 1. We can pick a specific key slot to assign a password. I'll choose key slot 5 by adding a -S5 to the end of the add key command. I need to enter any one of the existing passphrases. And now I'll type in the new password for slot 5. And we have just added a password to slot number 5. Let's check that with the Lux dump command. Here we see slot 5 has been created, and scrolling up, we see slots 1 and 2 are still there as well. So now we see keys in slots 0, 1, and 5. I'm going to add a key to key slot 9 with the command Lux add key. I have the -S, and I'll make this a 9. I'm going to enter in one of the existing passphrases. Now it's asking me for the password for key slot 9. And what I'm going to type in here is the same password as I used for key slot 1. So Lux will allow us to type in the same passphrase for different key slots. Let's check to make sure it was added okay by going back to the Lux dump. And there we see key slot 9 was added, and I typed in the same password as key slot 1. Now we're going to look at how to remove a key that we no longer want. We can do that with the sudo crypt setup Lux remove key dev SDB. Lux is asking me for the password for the key slot I want to remove. I'll type in the password, and remember this password is the same password I used for key slot 1. Okay, the password has been removed. Let's go back to the Lux dump, and we see that Lux 9 is still there. And then scrolling up a bit, we see key slot 5 is still there, and key slot 0 is still there, but key slot 1 is missing. Remember, I made the key slot passwords for 1 and 9 the same, so Lux just removed the first occurrence of the password it found, which in this case was key slot 1. Now let's say we've forgotten a password for a key slot. If we have forgotten the password key or don't know it, we cannot use the Lux remove key command. We can still remove the key. Instead of using the Lux remove key command, we can use the Lux kill slot command. I'll use the Lux kill slot command to remove the passphrase from key slot 9 by typing sudo crypt setup Lux kill slot dev SDB, and I want to kill slot 9. I'll type in one of the remaining passphrases. Now going back to the Lux dump command, we see the key slot 9 is gone. leaving us only with key slots 0 and 5. We have not changed a password yet. Let's do that now for key slot 5 by typing sudo crypt setup lux change key for dev SDB. Lux is asking us for the passphrase we want to change. I'm going to type in the passphrase for key slot 5 and then give it the new passphrase. And now our password for key slot 5 is changed. In the next video, I have one more video about Lux for the Linux command line. In this video, we're going to look at using Lux to protect against someone single booting into your computer. Now, this will have to be done with a new install of an Ubuntu derivative, in this case, Linux Mint. Let's first take a look at how someone can single boot into your Linux system as root. The first thing the single boot attacker has to do is get physical access to your Linux machine. I'm going to restart the machine to show how someone can single boot into your Linux computer as root. I'm pressing the right shift key, which brings up the grub screen. From here, I'm going to make sure I'm on the Linux Mint 22 Mate, which I am, and then I'm going to press E to edit the commands. Now I'm using the down arrow to look for the line that begins with Linux. There it is. I'm going to use the right arrow now to get to the end of this line. And just past here where it has RO, quiet splash, I'm going to add in single. And then I'm going to press Control X or F10 to boot. I'll press F10. Here we see at the bottom of the screen, press Enter for maintenance, or press Control D to continue. I'm going to press Enter. Now we see I am root at Lux. Lux is the name of this computer. And then we see the pound sign or hashtag symbol showing us that we are logged in as root. To see what users are on this computer, I'll type ls-lh/home. And we see there's only one user on this computer, Michael. Since I'd be an attacker in this case, I would not know the password, so I will change the password for the Michael user to something I know. I'll use the command passwd Michael to change the password for Michael. I'll type in a new password that I know and retyping that password. Great, the password's updated. Now I want to reboot so I can log in as the Michael user. I can just go in now and look at the different files in the folders, but I want to get the full GUI experience. That's why I changed the password. And now we're at the Linux Mint login screen where I can type in that new password that I just set it to. We are now logged in as the Michael user, and we have total control of this computer. Now, there are multiple ways to prevent against this type of attack. The way we're going to do that in this video is to install Lux when we install a new Ubuntu derivative. So let's look at that install process right now. We're going to do a fresh installation of Linux Mint. I'm going to right-click and open the Install Linux Mint. I'm going to use the default of English and click Continue. And the keyboard layout of English US,
I'll continue on those defaults as well. I want to install the multimedia codecs. Continue. This is the screen that we want to make some changes. I'm going to click on the advanced features. And now I'm clicking on Use LVM with the new Linux Mint installation. And we've already looked at LVM in videos 91 through 101, but you won't need to know anything about LVM to use it. And then I'm going to click the checkbox to encrypt the new Linux Mint installation for security. You will choose a security key in the next step. So I'll click OK. And then Install Now. I'm now at the screen where we need to choose a security key. And this will be a different password than the Linux Mint password. So I'll share that password with you so you'll know exactly which password I'm typing when we come to the password screens. This security key password I will call LuxPass1. And I'll confirm that. LuxPass1. Then it's asking us if we want to enable a recovery key. I'll check that. And we can take a look at the key. It's a bunch of numbers. If we want to change those numbers, I can click this here. It gets us a new password. Or I can type in our own password. I'll type in my own, and we'll call this my Lux Recovery Pass. And I'll type that again on the next line. My Lux Recovery Pass. And Linux Mint is going to write this password in a file in home mint recovery.key. We can change that location if we like, clicking here. We have a warning: if we lose this security key, all data will be lost. So we'll try not to lose those keys. We do not want to overwrite the empty disk. That'll take too long. Let's install now. We're asked if we want to confirm these changes. We do. I'll click continue. New York for the time zone is good. I'll click continue. We're asked for a name. I'll type in my name, Michael. The computer name will be Lux Encrypted. And then we need to give it a password. And I said I'd share this password with you as well so we know which password we're typing where. So this password will be Linux Mint Pass 2. And I'll confirm that. Linux Mint Pass 2. We will continue. And now it will install Linux Mint. I'll pause until it completes installation and we'll pick it up from there. Linux Mint installation is complete, and now we're asked if we want to continue testing or restart now. I want to click Continue Testing because we want to cat out our recovery key. So let's open up a terminal, and I'll type ls-lh, make this a little bigger. There's our recovery key in home mint, just as they told us. Let's cat out recovery key. And there it tells us it's my Lux Recovery Pass. We may want to save that file to a USB drive or the like. Since we typed in our own key, we should be able to remember it. Once we restart, this recovery key will be gone because it's in the home mint directory, which will disappear when we restart. Let's close this and restart. Now we've restarted and Linux Mint is asking me for the Lux key. I'll type that in. That was the password we set as LuxPass1. We see that crypt is set up successfully. We typed in the correct password. After we type in the Lux password,
we go to the grub screen, so Lux Password will prevent someone from being able to single boot into our system. Now we're at the Linux login page where I will type in our Linux Mint password, which was Linux Mint Pass 2. And now we're logged into a new Linux Mint operating system protected by Lux. So that recovery key that we saved, we can type that in instead of that Lux Pass 1. Basically, that recovery key is just a second Lux password key. And we learned about Lux password keys in the previous video. This is the last video in the group of Lux videos, and this is also the last video in the Linux command line series. Thank you all for watching. I hope you learned a lot, and I'll be back next time with a new video tutorial series on something that is not Linux related.